SolidWorks is the most important software for mechanical engineers who want to transform their career from production to design engineers. This software helps in creating 3D models of the equipment, simulating its performance, testing the safety and durability, and optimizing the design efficiency and productivity. If you want to learn complete SolidWorks software, then this video is for you. So let's learn. Hello everyone. So today we'll start with SolidWorks Basics. In basics, we will see line command, how to apply relations to line command, and how to see whether the sketch is completely defined or not. So to start with, I will click here File, New, and say Part. As soon as we enter in SolidWorks, this is the introduction part. So first, at lower right side, you can see the unit setup. From lower side we will see first one is IPS inch pound second, second is millimeter gram second, third is CGS centimeter gram second, and fourth is MKS meter kilogram seconds. So the selection of unit depend on the type of object or size of object. So now at lower left side you can see UCS, user coordinate system. It is used to define the direction of the working plane. At left side this area is nothing but model tree, in which whatever sketch you do, whatever feature you apply, everything is saved and you can access and change or modify the features or sketches here. So this is called as model tree area. The terms are very important here. Which one is model tree, which are the tabs, where is the unit selection and all. Now to start with the sketch, first we will say activating the plane. Now there are three types of plane given here: front plane, top plane, and right plane. And center of all plane is origin. So we'll start with front plane. To activate the plane, click on this symbol here. You can see one icon appearing here, C-type icon with star mark. You just have to click on this icon and your plane is activated and your origin is also highlighted. So whatever drawing we are going to draw here, any sketch, we will start with from origin only. We have to give references from origin. So we'll start with line command first. There are total three types of lines. First is regular line, second is construction reference or center line, third one is midpoint line. So we'll start with regular line command. Now we'll start with origin as discussed. You can see a vertical line here. How we can decide that line is vertical? One relation is being appeared here in yellow color showing that line is vertical. If I drag the line in inclined position, that relation is gone. Again, when you make the line vertical, the relation is there, showing that line is vertical. Same with horizontal. Now the relation is not there, but whenever I make this line horizontal, at exact 180 or 0 degrees, it will show the yellow color icon showing it as horizontal line. Drawn one line here, but the end point of line, you can see the color is blue. It is showing that line is not constrained or fully defined. That's why the line is moving. Now our motive will be here to completely define these sketches. Whatever the sketch it may be line, rectangle, circle. You just need to completely constrain or fully define these sketches. So for fully defining these sketches, I'll put up some relations and dimensions here. First we will see dimensions, how to define the sketches with dimensions. So for giving dimension, one command is given here, that is smart dimension. Select the smart dimension command. This dimension command is used for giving radius, diameter, linear lengths, angles, and all type of annotations. Only one single command is given here. So I'll select the line command and put up the value. I'll say it as 200 mm. Now you can see the line is constrained or fully defined. It is shown here that line is fully defined. Suppose if I drag this line now, it will not move. It is fixed now. Suppose if I draw this line other than origin at any place, then the rule will be first to give the length of the object, whatever object it may be, then to give ordinates from origin so as to refer the line or position of line from the origin. So I'll give the line length first. Then I'll put up the ordinates values as x and y values from origin references so as to constrain the position from x and y distances. As the plane is two-dimensional, the sketch will move in x and y direction. You can see the line is moving x direction, but now it will not move in y direction because I've given the value here, vertical distance. Now to constrain the horizontal distance, again I will do same thing, that I will smart dimension it again by giving horizontal value, that is x value. Now the sketch is completely constrained. So by seeing, you can observe here that when I have drawn the line from origin, I only needed one dimension to constrain. But other than origin, I needed three dimensions to constrain the same line. First one was its own dimension, second was x dimension, and third was y dimension, so as to constrain the movement from x and y directions. Now the line is completely defined, or we can say the line is fully defined. In this way you can define the sketches, whether it may be circle, rectangle, same thing we are going to repeat, that is giving the object dimensions first and then referring the x and y dimensions from origin so as to constrain the movements in two dimensions. Now if I draw the same line in inclined way, I'll put up the first length, that is its own length. Now you can see two lengths are being appeared here. First one is linear, second one is align length. So align length only will give the actual value of the line. So I'll put up the align length here. I'll say it as 350 mm. Now to constrain it from origin, I'll put up the x and y values as we have done previously here. So I'll put up the x and y values from origin. You can select any one point to define. First I will give horizontal value here. Second I will give vertical value. But still the line is not defined. So if anything is not defined in sketch, you just need to pick one point, underdefined point, and drag it. Now this movement will show that line is rotating, means an angle is needed to define the sketch now, to lock this rotational movement. But for giving angle, I need one reference line also here. So I'll draw center line, second type of line, center line, from the fully defined point. You can see this point was defined as we have given dimensions x and y to this point. So I'll draw a line from this point only, as it is the fixed point now. So I'll draw one line, center line from fixed point, and now I will put up the angle value here. You can see I'm putting the angle as 45 degrees. Now the line is completely defined. Your sketch is showing as fully defined. You have to notice one thing, that we have not given length to this line. When construction line is drawn, only the position of line is needed. There is no need to give length to this line to define the sketch. Even if this length is not given, the sketch is shown as fully defined. Now suppose I want to give relations to line and define the sketch. I will start with relations now. So for giving relations, I'll again draw one line here. I will intentionally draw it inclined, but now if I want to make it vertical, I will select the line and one chart will pop up here showing some relations here. So if I want to make this line vertical, I'll say it make vertical. Now whenever you will click the line, you will show this relation, that is vertical relation, and it defines that line is make vertical now. Now if I want to merge these 2 points or coincide these 2 points, I can give relation in between 2 points also. So the relations depends on selection of types, such as if you select line and line, the kind of relation will appear only for lines only. But if I select point to point, then the relations that are possible between 2 points will appear on left side. So I'll select first point and origin point. Now you can see at left side the possible relations are being appeared here. So we can see here that if I want to make coincide, I'll say the points as coincide. Here you can see the relation, third number. Now you can see that points are merged, or we can say that points are coincide. I'll undo the relation. The second relation I'll see here is vertical. I'll say the relation vertical. Now you can see that points are in alignment as vertical. Means there is a vertical alignment between 2 points by giving the vertical relation. I will again undo the command and again apply the other relation. The last relation is horizontal. If I say the line is horizontal, then these 2 points will appear horizontal in orientation. So these were the relations. So I can see by clicking on the line that there are total 2 relations here. First one is vertical for the line and second one is between points, showing that these 2 points are in horizontal orientation. When the relation is applied as horizontal, if I drag the line at downside, it will not come at downside. This relation will restrict the y degree motion here. That is downward motion here. And even I can drag it here because the length is here not given. So I will define the length also here. I will say it as 600 mm. Now to fully constrain the line, I will see the relation. I will see the movement again here. I will drag the line. Now you can see the line is being dragged in horizontal direction. So we will put up the horizontal dimension here and put up any value here. I will put 300 mm here. Now you can see the line is fully constrained again, fully defined line. Now we will see some more relations here. I will draw 2-3 lines here. First this line, in second this line, and third, and then the last line. I'll say it horizontal relation, and now I'll put up the relation between point and line. So the selections will be point and line. For multiple selection, it is compulsory to hold the control key and then select the entities. So it will take multiple selections, or else it will take only one selection at a time if you don't hold the control key and then select. So it is compulsory to hold the control key and then select the multiple entities. Now the relations appearing here which are possible between point and line are midpoint, coincide and fix. We'll ignore this fixed relation here and see midpoint relation first. As soon as I click the midpoint, the line gets grasped at the midpoint of this line. I'll undo the relation and now again I'll see the relations between that point and line and say as coincide. Now you can see this line is grasped on this line but at random point, not at midpoint. So coincide will just connect the line with point and midpoint will connect the line with point only but at midsection, at midpoint of the line. So this was the difference between midpoint and coincide relation. That was possible only between point and line. It is very important that what we are selecting, whether it is point or line to line sketch relation, that is important. Now we'll see some more relations. Suppose I want to make this line parallel to this line. I will select both the lines. I will select the whole button and say this 2 line selection. Now you can see whatever the possible relations are appearing on again on left side. I will say it parallel. Now both the lines are parallel to each other. I will again draw one more line here. And now I will say perpendicular relation by holding this line and control press again holding this line, selecting this line. Now you can see perpendicular relation is being appeared here. I will say it as perpendicular. You can see both the lines are perpendicular to each other now. Now if I want to merge these 2 points, we have seen coincide relation first. Now again see similar kind of relation one here, that is merge relation. So I'll select control point and again second point. Now you can see the relation here. First we have seen coincide, now we'll say it as merge. Merge will also act same as coincide relation. It will merge both the points and combine the object. Now if I draw 2 lines here, first one is vertical line on left side and other on right side of this constraint line, and I'll say this constraint line relation as construction. So you can make solid line as construction line by clicking this option here, and again you can make the line solid by clicking same option again. So I'll make this line center line here, as we are going to see symmetric relation. Now what symmetricity means is, if I place these two lines on both sides of center line, so I'll give the relation by selecting all the three lines. I'll select all the three lines, left side line, center line is must, and then right side line. And now I'll say the relation as symmetric. Now both the lines are symmetric to center line. It means if I drag left side or right side line, both the lines will be dragged at equal distance from center line. It is shown that the lines are symmetric. This symbol is showing here the symmetric relation. Now suppose I give the value here. I'll give the value here as 200 mm. You can see other line also get placed at 200. And if I change the value, suppose I'll say 350 mm. The other line also will move at 350 mm distance only, same distance only. So this is the symmetric relation. Now, if I want to make all the base orientation same at horizontal position, I'll select all the three line endpoints and say all the lines as horizontal. You can see all the orientation of base is at horizontal position now. Now I'll select this line and delete. You can select and directly say delete button so as to delete the lines. Here you can say undo. Again that lines will appear. Again I'll select and delete it. Still the sketch is showing underdefined. So I'll define the sketches by giving the value here. I'll say it as 600 mm. But still this line is not defined. So I may need to give dimension to this line also. But one smart thing I can do here is by adding relation. Suppose I make one relation that's saying that this line is equal to this line, then I don't need to put up the smart dimension here also. So I'll say selections of both lines and the relation I'll say is equal relation. As soon as I say equal, now this length 600 is implemented on this line also. Suppose if I drag this line, it will not move as it is of same length with the right hand side length. So I change the value again here and say 800 mm. You can see the length of this line also changes similar to this line. Again I'll say 200 mm. The change is appeared here also and it is also 200 mm now because of this equal relation being applied here. So it is smart way to work with relations, as you don't need to change every time the dimension. You just have to need one time change and all the dimensions will apply with the same length if the relation is given as equal. So relations are very helpful here, and most of the design engineers suggest that if you work with sketch, you have to work with relations. So it is easy to define or edit these sketches. Some more things here. Suppose if I press the cursor and drag it, the plane will get tilted. Now again, to normalize the plane or to bring back the position of plane, I'll select this sketch and say normal to command. Here you have to remember the name. The command name is normal to. Symbol is an arrow at vertical side. You can apply this symbol from here also. In view orientation, this option is given here as normal to. Again, the plane is normal here. So if you are having problem with tilted plane, you have to normalize the plane, then select normal to, and you will have the orientation same as earlier. Now if you want to exit this sketch, if you are overworking with this sketch, you can exit the sketch here. This icon is showing the exit sketch symbol. I'll click on this blue icon, and now we are out of this sketch. You can see in model tree, sketch 1 is here being highlighted. If I click on the sketch, it will be highlighted in sky blue color here. So if I want to again activate this sketch or edit this sketch, I will select this sketch from model tree, or else I will click here and say again edit sketch. Now this sketch is again activated. Now we will see the last line type, that is midpoint line. As the name suggests, it will start from midpoint of the line and symmetric on both sides. I have drawn this line from origin, so I just need to give one dimension only here. so as to define the line. So I'll give it as 3000 mm, and now the line is fully constrained or fully defined here. So this was our first session showing the line command, how to apply relations, how to constrain the lines, and you have to remember that all the methods we have seen so as to give relation and constraint, that will not only apply for line but for other geometrical entities also. So we will end this session here and continue with other session in next lecture. Thank you. Now in session 2 we are going to see circle command, rectangle command and slot command. To start with commands and sketches, we will activate the plane first. We will activate our front plane and say sketch. Now after activating the sketch, I will select the circle command and draw one circle here. I'll put up the value as 68 diameter. If the circle is complete 360, it will by default take diameter, and if it's partial circle then it will take radius. So I've given here diameter, and the circle is defined only by giving one diameter as it was drawn from origin itself. We'll again draw one circle here at its side and give it relation as equal. So for giving relation, I will hold Control key, select both the circles and say as equal relation at left side. Now both the circles are equal, but you can see the color difference. This circle is showing in black color and this one is in blue color. It indicates that this color is underdefined or circle is underdefined. Now so as to define the circle, you have to apply the relation here, or you can apply one line also here, but I will go with relation. The relation will be horizontal so as to make the orientation of both the centers horizontal. So I will select both the centers now and say them as horizontal relation. Now this vertical movement is locked, but still horizontal movement is on. Now to lock this horizontal movement also, we will go with smart dimension. Select both the centers. Apply one dimension here as 100 mm. Now both the circles are completely defined. Now we will see the second type of circle, that is perimeter circle. In this circle, as the symbol indicates at left side, that we have to give 3 points here. The first 2 points will be by default tangent to 2 selections, and third point will be for placement. So I'll start with circle, perimeter circle, and I'll select first point on left circle, second point on right circle, and put up the position by third point. Now all these points are given and circle is completed. So we'll put up the smart dimension value here. I'll say it as 84 diameter, means the radius will be 42, half of the diameter. Now for trimming the circle, I'll go on trim command and drag over the circle. Now the circle is been trimmed here. You can place this value here, and it will not show an arc here if you put it here like this. So you have to place this value in this position. Now you can see the arc has been developed here. Again we will go with the same command, perimeter circle. Click on the 2 circles to get tangency on 2 circles. Then third point will be for positioning the circle. It may take some time. I will click the third point here and put up the value here. Again I will put the same value here, 84 diameter, and trim the extra circle. Also trim the internal portions here. Now you can see one profile has been created here, and while clicking on the circles you can see the relations we have put together here. We have given here tangent relation and equal relations. We have also given horizontal relation here so as to make the orientation of circle horizontal. Now we will see some more relations here. I'll make one more circle here. Put up the value, and to define it with origin, We'll put up the ordinates value also, x ordinate and y ordinate, so as to define the sketch. Now the position of the circle is also locked here, and we have also given the diameter here. Now we will draw two circles here. First, and beside that second circle also, and give them relation as equal. Now to match their alignments as horizontal, I will put up the relation between 2 points as horizontal. You can also add the relation tangent here now. For tangency, you have to select both the circles and say them as tangent. Now both the circles are tangent to each other, but we have not defined the diameters here. We'll put up one value for diameter, and similar value will be applied for this circle also, as we have given equal relation. Now the circles are fully defined here. Now if I want to make concentric circle, then I'll make one circle here and give and add concentric relation by selecting both the circles and saying them as concentric. Concentricity will apply a common center for both the circles. But still you have to define the diameter here. So I'll put up the value for diameter as 300 mm. Now the diameter is also defined and sketch is completely constrained. Next, you can add lines here. For that I'll make one circle. Say it as equal relation now again. And constrain it by giving horizontal and vertical value, so as to fully define the sketch. Now I want a line here tangent with both the circles. When we start line, we have to avoid this quadrant points. You can see quadrant points here in yellow color, 4 quadrant points. You just have to avoid that points and then start the tangent line. Similar for ending the line also, you have to avoid this point. As if you place this line on this point, it will take coincide relation and will not be added tangency relation here. So avoid these points and put up the line here. Now it has been taken by default tangency relation. You can see here. We'll add one more line here. Suppose if I draw a line in this way, it will not take by default tangency. At that time you can manually add the tangency between two objects. Tangency can only be added between two selections at a time. So I'll select the line and circle and say them as tangent. Now this line is tangent, but there is extra line here. So for that extra line, I'll trim it. For trimming, you just have to select the command and drag it over the extra portion so as to trim them and say them OK. Again, we'll draw one circle and sketch here so as to understand the line and circle command. So I've put here one circle with diameter of 70. One more internal circle here. Make it concentric by adding the relation and set the value as 28. On the other side, on lower side, we will also add two more circles here and make the circles symmetric from center by adding one line and saying both the center points of side circles as symmetric with this line. We'll add equal relation to them also here and give them value as 36 diameter and center to center distance 84 mm. Also we'll provide the vertical distance over here, that is 72 mm. And now we'll draw two lines here. First and second on left and right sides, and make sure to put the relation here as symmetric. so as to equally define the distances from center, and connect with these two lines by adding one more line here and saying it as merge. Same on the other side. I draw this line from quadrant only. Now we'll trim the extra entities and put up the distance here. I'll say it as 30 mm. Now you can see this line is underdefined here. You just have to drag and see what portion is remaining to be defined. Now I can say that this quadrant point should be connected by the line's endpoint. So I'll make line again with quadrant point only and say it as horizontal relation, and make sure to trim it. Now the extra portions are trimmed. We'll connect it from lower side also by quadrant to quadrant. Now your sketch is completed here. Suppose if you want to add fillets here, you can go with perimeter circle. First point, second point and third point for orientations. First, second and third point, and then trim the extra entities and put up the values here for radius. I'll put 8 mm radius here and say equal to other arc also. Now we'll trim the corners and the center entity. So you can see we have made one profile here. In this way you can work with circles and lines. So this was circle command. Now we will start with rectangle command. To start with rectangle, there are total 5 types of rectangle given here. We will see each one by starting corner rectangle. So the first rectangle is corner rectangle. As the name suggests, it will start from corner point. To define the sketch, we have to give height and width of the rectangle. The sketch is completely defined now. To change the value, you just have to double click and change the value required. Make sure that your num lock is on and then change the value. Second type of rectangle we will take is center rectangle. As it starts from center point, that's why it is referred as center rectangle. We have drawn the rectangle. We'll put up the dimensions here. Same dimensions, height and width. After assigning dimension, you can see that rectangle is still underdefined. So to define the rectangle, we'll repeat the same thing as previously done. That will originate the dimensions from origin to center point of the rectangle, so as to constrain its x direction as well as to constrain its y direction, which is not constrained now. So we'll put up the y value also, that is vertical value, and your rectangle is constrained. The advantage of corner rectangle over center rectangle is that it can be started from corner and can be drawn at one side, but in center rectangle you can draw the rectangle at symmetric sides. Mostly center rectangles are preferred. After that, we'll go for third type, that is 3-point corner rectangle, and fourth 3-point center rectangle. Both rectangles will start and end with 3 points. First type will have corner starting point and second type will have center as a starting point. We'll see first point, second point and third point. As it started from corner point, that's why it's called as 3-point corner rectangle. The rectangle is 3-point center rectangle. It will start from center point, start point and end point. So this rectangle is symmetric on both sides. Now what is the importance of this rectangles is that you can draw inclined rectangles. By using corner and center, you cannot draw inclined rectangles. You have to use corner rectangle, 3-point corner or 3-point center to draw inclined rectangles. Last one is parallelogram, in which all sides of rectangle are parallel to each other, but main difference is that other four rectangles were having adjacent sides angle as 90 degree, but in parallelogram you can adjust the angles between adjacent sides. It is not fixed as 90 degree. You can manipulate the values here. I'll say it as 135 degrees. Now to define these inclined rectangles, you just have to put the smart dimension again and say the values from origin so as to locate the rectangle's position first. We will say this corner point from origin as horizontal distance first, then the second distance as vertical distance, then put up the aligned values of its own sizes, that will be its width and height. But still the rectangle is not defined. So if the rectangle or any sketch is not defined, simplest way to understand that why it is not defined is to move the entity. You can see there is rotational movement. So to lock this movement, you can draw a construction line here and give it an angle here. So I'll draw one construction line here and put up one angle here. You can draw horizontal or vertical, any line you required, and we'll say it is 80 degree. Now this rectangle is completely constrained. Same procedure is for defining this rectangle also. Now the next command we are going to say is slot command. There are total 4 types of slot given here. First one is straight slot. So to draw straight slot, you just have to select the option, start it from origin, drag on whatever side you require. I'm dragging it on horizontal side. Click on the point and again second click to define the slot. Now to constrain the dimensions, you have to give center to center distance first, and then you have to define any one side of radius. Now the slot is being fully constrained here. You can see it is showing fully defined. The other type of slot, second type of slot is center point straight slot. So as the name suggests, it will start from center point and will be dragged on both sides symmetrically. Put up the center to center distance again here. I'll say it as 250 mm and any one side radius so as to fully constrain the object. I'll say it as 100 only. Now the slot is defined. Suppose I make this slot other than origin, then again you have to do same things, that constrain it from origin by giving vertical and horizontal dimensions, and then by giving its own dimension, that is center to center distance and one side radius value, and your slot is completed now. The other two types of slots are also there, that is 3-point arc slot and center point arc slot. We will start with center point arc slot. For that, select on the origin, that will be the center point of the slot, first point, then give the start point as a second point and third point for ending the slot. Now just you have to drag the slot and click on other side. For defining slot, you have to give the center arc radius, then second you have to give is side arc radius, but still the movement you can see here, the ends of the slot are not defined. For defining that slots, we'll put up here 3 lines, 3 construction lines here. First, second, and the third line here. Now, by mistake, I have drawn this as a solid line. You can convert this line into construction by clicking on the line and saying as make construction. We'll give relation to this line as vertical and put up the angles for 2 lines with the reference of center line. We'll see first angle as 45 degrees and other angle as 60 degrees. I'll undo and again put up the value here. So it is at 60 degrees. Now to stop this movement, angular movement, you have to constrain this point by giving coincide relation on this line. Select the point and line and say coincide. Same on the other side, you have to select the center point and line and say coincide. In this way you can define the arc slots. 3-point arc slot is similar, but only one thing is there, that here the center point is not in a control to position. So we'll start with 3-point arc slot. We'll say first point on this line, second point on this line, and third point we'll say for the positioning here. Now you can see that center point is not in your control, first, second and third, and then slot. To define the center point from origin, we'll put up the values here, one horizontal and one vertical, and going for this radius, side radius, and then center radius, center arc radius. And now your slot is completely defined. As we have already referred this line, so we did not need to make any further lines again. So this was the center point arc slot and 3-point arc slot. In 3-point arc slot, the difference was we have to define the center point position also. So this was the circle command, rectangle command, and slot command. We will continue next commands in other sessions also. We'll stop here. Hello everyone. So today we'll start with session 3. Previously we have seen in session 1 line command. In second session we have gone through rectangles, circles and slots. Now we will start with arc command. In arc we will see all the 3 types of arc. So to start with arc, first we will see center point arc. So to start with center point arc, you have to select origin as a center. As the name suggests, it will start from center point. Then we have to give start point as a second point and third point as an end point. So the 3 points were center, start and end. Now to define the sketch, we will draw 3 construction lines here, as we have done in arc slots also. We will draw 3 lines here. We'll make this line as construction. Now the center line is not defined, as the color of the line is not coming as black color, so we can say that it is underdefined. So we'll select the line and say as relation make vertical. After making the line vertical, we'll go for the angles. Now you can see by mistake I have selected the end point or midpoint of the line. So it is not possible to give angle between line and point. So you have to avoid this kind of errors. Again I will escape and select the line command for the second selection and put up the angle as 30 degrees here. Do same for the second line and I'll put up the value as 60 degrees here. Now to define this radius, first we have to give the value here. We'll see the radius as 90. But still the endpoints of the arc are not defined. You can see the color as blue. So that's why we have made these lines. We will put up the relation here between point and line and say as coincide. Again, same thing we'll do here also. We'll put up the relation between point and line and say as coincide. So the arc is completely defined. In center point, there is an advantage that you can control the center point location. The second type we are going to say is 3-point arc. In 3-point arc, the drawback is we can control the 3 points, first, second and third. But the center point here, we cannot control the position of center point. So we have to define it from origin only. So I'll define it from origin. I'll say vertical distance first, and then apply the second horizontal distance, that is x distance. Now after putting the x and y values, I'll put up the radius value for the arc. I'll say it as 120 mm. And now you can see the 3-point arc is completely defined. We will see one more sketch here. We will draw one circle. Again one more circle here. Put up the values here. First I'll put the outer circle diameter as 400 and then the second circle as 300. There is 100 mm difference here, and I will draw two lines from quadrant points of both circles. First this line and second from the internal circle's quadrant point, and I will connect both the points here and provide one distance also. I'll say the smart dimension distance for the upper line as 600 mm. Now the sketch is completely defined. I'll put up and trim the entities here. Okay. Now you can use arc here to provide one fillet or sharp radius here. So to put up the value, so put up the arc, I'll go for 3-point arc. And first point I will get on line, second on circle, and third on mid portion so as to orient the arc. And then I'll put up the tangencies at both the ends of arc. I'll select arc and circle first and say tangent. Then again second selection I'll take it as again the same arc and line, again tangent. You cannot put all the three entities at one time for tangency. You have to use the pairing option, that is first you have to pair it with line, then you have to pair it with arc. After that we have to give radius here. Provide one radius also here. I'll say it as 60 and then I'll trim the entities here. Now you can see we have utilized 3-point arc here to make this profile in such a way. So this was 3-point arc command. Other command in arc types is tangent arc. For tangent arc, we'll take one line here and at the end point of line, after giving the length, we'll start with tangent arc. So I'll put up the length as 600 mm and go for tangent arc here. In tangent arc, you have to select one endpoint. It is compulsory to start with endpoint only. You cannot start it from blank space here. So I'll first click on this endpoint and drag the arc. Now I'll put up the relation here as horizontal so as to define the endpoint of the arc here. After putting the value, I'll put up the value first. You can see that arc is completely defined. And the advantage of taking tangent arc is that when you start the arc from any point, endpoint, it will by default take tangency here. You can see here that this arc is tangent with line. So this was arc with tangency or tangent arc. So the next command we are going to see here is polygon command. We'll start with polygon command here. You have to decide the number of sides you want. I'll take it as 6 only here. Then there are two types of polygon, inscribe and circumscribe. I will go with inscribe circle first. So I'll start with clicking on the origin point, then clicking on the other side. To define this polygon, I have to give the diameter of the circle first. I'll put up the diameter as 300. And then to stop this rotational movement, I'll give one relation here. Depending on orientation of polygon I require, it may be in horizontal at upper side or at pointed side. So I'll take a horizontal upper side and put the relation on this line as horizontal. Now you can see that polygon is fully constrained by giving one dimension and only one relation to any side of the polygon. Now to understand the difference between circumscribe and inscribe, again I will make one more polygon here with same diameter, but this time I will take polygon as circumscribe and number of sides 6 only. After making the polygon, I will define its origin position first. I will say horizontal from origin here, and then x distance, as y distance is 0, I will put 400 here as a x distance. Now the position is completely defined. You just have to put up the diameters here. I will say equal diameters for both the polygons. I'll add equal relation here, and then I'll stop this movement also. Same as previous, I will set this line as horizontal. Now both the hexagons are made, but you can see the difference between size here. As we were having 300 diameter for both the circles, still the polygon sizes are different. It is because in inscribed circles or inscribed polygons, the distance of this radius, as the diameter is given, the distance of the radius is measured from center to side. We'll measure the distance again. You can see here, this distance is coming as 150, half of this diameter. But in circumscribe, this distance is not measured between point and side, it is measured between point and corner. You can see here the distance 150 is coming between side and corner, not between side and side. So this is the main difference between inscribe and circumscribe, whether you want to make polygon with center to side distance or we have to make polygon from center to corner distance. The next command we will see here is fillet and chamfer. For that I need one rectangle here, so we'll draw center rectangle here. While putting the dimensions for rectangles, it is better to give the dimension between sides instead of line. I'll put one value here for width as well as for heights, and I'm going to put these values between sides. Instead of selecting lines, it is better to select sides to give the values. It is such because if you trim the corners, still the sides are fully defined. They don't become underdefined here. Now to put up the fillet, go for fillet command and select, either you can select point or sides. I'll select the point and put up the fillet value here as 80 mm. I'll increase the value here. We will say as 200 mm. And also select the other point here. Now there are two options here, keep constraint corners and dimension each fillet. I'll go with keep constraint corners here first and say it as OK. Now you can see one fillet is here at both the ends. The value for the fillet given is 200 radius. So if I want to change the radius here for this side, on right side, I'll say it as 300. But you can see both the values are changed for both two fillets. It is because we have not selected that dimension each fillet option. Now we'll go for that option also here. Again we will go for fillet and select this option here, dimension each fillet, and then put up the values here and say OK. You can see individual dimensions appeared for both the fillets. We can update individually now. I'll say this value as 400 and it will not affect the other side fillet. This value is updated, but still this value is remaining 200 here. But on the other side, if I update this value as 100, the second side fillet will also get updated. This was difference by putting on the option as dimension each fillet. After fillet, we will go for chamfer command. We'll delete this rectangle now and start with another rectangle here, and we'll say center rectangle again. Put up the dimension here, width and height in between sides only now. So I'll put this as 3000 mm, and here also I'll say it as 3500. Now there are two types of chamfer here. We'll go for chamfer command. First one is angle and distance, second is double distance command. So we'll go with angle and distance command here, and we will put first the distance, the value of distance. I'll put it as 120 mm, and then I'll go for angle. I'll put the value as 30 degrees. So in similar order we will select the lines. So whatever first selection I'll make, the distance value will apply here, and for the second selection only the angle value will be applied. It is compulsory for all softwares to go with this order only. So I'll select the first line here as vertical line. So the distance 120 will apply on this line, and then for angle I'll select the horizontal line. Now zoom out this. You can see here the distance is applied for 120 from vertical line and angle on horizontal line. It depends on selection. Whatever first selection we will make, distance will be applied, and second selection the angle will be applied. I will undo and again select the lines. I will select the horizontal line this time first and then the vertical line. So you can see distance is applied on horizontal line and then angle on vertical line. Second selection will be for angle always. So I'll say OK now, and now this chamfer is complete by using angle and distance method. Now we'll go for double distance method. Again we'll select the chamfer command and say double distance, and of this equal distance now, so as to put different distance values here. So for distance 1 d1 I will say it as 200, and for distance 2 I will say at 350 the values. Now as soon as I select the lines, for distance 200 I will select the line vertical. Whatever line I will select first, the distance 200 will be applied there. Distance d1 will be applied for that. And on the other side I will select this horizontal line, and distance 350 will be applied on this line. You can see here 200 and 350. So whatever selection we make, first d1 will be applied for the first selection and d2 for the second selection. You can undo here and put up the values again. Now again I will select the d1 here for vertical and then d2 for horizontal. You can see the difference. Now the values are flipped. Here the vertical is 200 and horizontal is 350. We will see says that OK. Now the third type in chamfer, we'll select the chamfer command again and put on the equal distance value here and say the value as 300 or 350 here, and just click on the point here. You can see the chamfer is been made by equal distances. Here the red colored symbol is showing that both the distances are equal for chamfer, and we'll say OK here. This was the chamfer command. Either you can go for angle distance, or you can go for double distance or equal distance. Now we'll go for offset command here. So for making offset, I will draw two lines here, first and second. I'll give one relation here, make it as vertical and put up the length here as 500. Now I'll put up the same value by saying equal relation for the other line also. Now go for offset command and select the line. As soon as you select the line is appearing in yellow color, showing that this is the offset line here, and the offset distance is taking as 30 mm. I will put the 50 mm value. Now for chain selection, I will select the option chain, select chain. Now you can see both the lines are getting offset by the 50 mm. Suppose if you want to reverse the direction, you can go for reverse direction. Suppose if you want to offset both the lines on both first and second direction, you can go for bi-directional option. We will see the bi-directional option here. Select the lines and say bi-directional. The off only one sided will be get offset, and you can reverse the side by clicking the reverse option here on both sides. You can close the ends of the lines by selecting cap ends and closing it by arc either or by lines. Both the options are available here to close the object so as to make them extrude and all. Other than this, you can make the base geometry as construction by clicking on this option. So the base geometry will convert into construction line. Suppose if I off this option and make offset as geometry, then this offsetted line will be get converted into construction line. So it is optional. If you want to use the construction line also, you can go for that and say OK. If you want to change the value here, double click on the value and say, I'll say it as 100 mm now. So this offset distance becomes 100 here. You can update the values later also. Next command we are going to see here is ellipse command. So we'll start with origin. We'll click the second point here and third point here. By clicking these 3 points, you can draw the ellipse. To give the dimensions, you have to give major and minor axis here. So I'll put up one major axis and one minor axis. Also we need to give relations here so as to stop this rotating movement. So to stop this movement, I'll give relation between origin and horizontal point. The relation will be horizontal here. I will undo the command, and again I can put here the relation as vertical by selecting the points horizontal and origin and saying them vertical instead of horizontal, so as to have this kind of orientation. Then one more possibility is that you can make this ellipse inclined. So for inclination, you have to put two lengths here. I'll put the two construction lines here, first and second. Put up the angle. I'll take the angle as 50 degrees here. and then coincide this point on the line. You can see the ellipse is made inclined by 50 degrees with origin. Second type of ellipse is partial ellipse. We'll start with partial ellipse by clicking on center point, then second point and third point it will start, and you can end at any point you require. The method will be same for defining this ellipse also by giving major and minor axis. So I'll give the major axis first, then put up the minor axis. Then apply the relation here. You have to apply both vertical and horizontal relations here. So I'll start with vertical and horizontal. Then again giving these 3 points as vertical. You can see the ellipse is defined. This was the ellipse command. Now the next command we are going to see here is spline command. So to start with spline command, I will select the command, give the start point, and then we will just click on the points and complete the spline. So whatever points we have clicked here, you can control the positions of splines by dragging these points. You can also control these splines by these ordinate points. You can see a diamond point. One line also there has been appeared, so you can give the relations to that lines so as to constrain it in vertical or horizontal positions. Other thing for controlling these splines you can do is right click on the spline and say display control polygon. Here you can control the positions of spline by dragging these polygon points. You can also convert these splines in style spline by right click and saying them to convert to spline. Say yes. And now these splines are converted into style splines. The next type, the second type of spline you can see here. You just have to control the points of the lines here, and we'll not have the splines as a grip points. So we'll only control by these points here. No grip point will appear on spline here. This was the spline command. It is used in guide curves as well as in making intricate shapes for surfacing. Now we will see the trim command. For that I have drawn some sketches here. So to start with trim command, I will select command and say power trim. In power trim, you just need to drag the sketches you want to trim, and it will trim till it get intersected by any other entity. Even the last portion you can trim here. If the single line also remains, you can trim that line also here. Next, second option given here is corner trim. So for corner trim, we'll draw one sketch here. Then select the sides of the sketch, and you can see that these extra lines will be trimmed. I'll select corner trim here, and then select the sides. The extra corners will be trimmed. You can also trim in a simple way as we do in AutoCAD by using trim to close command. After applying trim to close command, you just need to click on the objects you want to trim. Instead of dragging, we will click on the objects and the objects will get trimmed. Next option here is extend command. So for extend command, I will draw one line here. Now I need to extend this line till this support. So I'll go for extend command and just click on the line at once. You can see that this line is extended till support. Again when you click, it will extend till next support. But further there is no support. Then if I click on this line, one note will appear showing that the element cannot be extended any further. Say OK. Now this was trim and extend command for you. We'll end this session here. Thank you. Now we will start our session 4 by text command. So to activate the text command, I will select the option and type the required text here. Whatever text you want, you can type here. You can see that text is appearing from origin. Now I'll select the text and say it as bold and italic for editing. You can increase and decrease the height of the text by using this option here. So you just need to put off this option, go in font. There are two options given to increase or decrease the size. I'll go with points and increase the value by 50. You can also change the text style here and say OK. Now you can see the text style as well as size is increased here. After that, we will go for this curve option. For that, we'll say it OK and draw one 3-point arc here. First, second and third point. We'll give it a relation here as horizontal. And now mount this text on this arc. For that, you have to double click on the text and go on curves option and say curve. You can see the text is aligned here on this arc. Now you can align it by placing it at center align, left align or right align. You can also distribute this text on the arc. I'll say it middle align. You can also flip the text around the curve as well as mirror the text. I'll keep it normal and then mirror it again. Now say OK. Before saying OK, there are two options more here. Suppose if you want to increase the width of the text, you can increase by this option. You can also increase or decrease the gap between two letters by using this option at left side. Then I'll say it OK. Later you can delete this arc also. I'll select and delete the arc. Now this text command will be used in wrap command for typing the name or wrapping or embossing the name on the objects. Next command here is point command. So for point command, I'll select the option, place the point where required, then go for smart dimension and position the point by giving X and Y values. Now I'll say one relation here as vertical. You can see the point is fully positioned and there is a color difference between 2 points. This point is underdefined, that's why it is looking in blue color. And this one is in black color, that is fully defined. Now again, I'll position these 2 points also by giving the dimension vertical and horizontal. You can utilize this point to connect any sketch. So I'll give dimensions to this third point also here. One vertical dimension also. After putting up the values here, you can directly connect all the 3 points by using line or arc command. So I'll go with line command here. Select first point, second point and third point. In this way you can utilize the points also here. You can see the sketch is fully defined now. Next command we will see here is mirror command. So for using mirror command, I'll draw one sketch here. I'll draw one rectangle and define it by giving width and height. Suppose if your object is underdefined, then when you mirror the object, it will also come underdefined on the other side also. So it is better to define the object than mirror. Put up the values from origin also to constrain the X and Y directions. After constraining the object, I require one line so as to say mirror against this line. So I'll make this line as a construction line and say mirror option. In first box you have to select the entities to mirror. I'll select all the 4 entities here. And then in mirror about you have to show the line against which you want to mirror the object. Here I'll show the line here and say OK. You can see the object is fully defined and mirrored here. Again, select the mirror command, select the entities you want to mirror and select the line about which you want to mirror and say OK. This was the mirror command. Now the next commands we will see here is linear sketch pattern and circular sketch pattern. So for linear sketch pattern, I will draw one entity here. I will draw one circle here. Put up the value and constrain the circle here. I'll say it as 200 diameter. Next, we'll go for pattern command. Now you can see directions are being shown here. In X direction is the horizontal direction and Y direction will be referred for vertical direction. You can refer this UCS for the directions. Now first you have to select the entity to pattern and then apply the distance and number of entities you require in X and Y direction. So first we will put up the entities required. So in X direction I'll say I want 5 columns here. And center to center distance for each column I will provide here. I'll say it as 300 mm. Now I'll go for Y direction, that is vertical direction. I'll put up the number of entities I require here. I'll say this one also has 5 mm, 5 only. Next, center to center distance, I'll put up here also as 300 mm. Now you can see there are total 5 columns and 5 rows. The center to center distance between each row and column is 300 mm on both sides, X and Y direction. Now you can flip the directions also here. If I want to reverse the X direction, if I want to reverse the Y direction, I'll select this option here. Suppose I want to make this pattern by giving angle, so we can put up the angle also here. I'll say 45 degrees angle for the pattern. I'll again make it 90 here. There is one more option here that you can skip the instances you require. So I'll skip the instances here. Now in this box, select the instances you need to skip here. Suppose I want these circles back, then I will clear the selections here. You can see the circles are back. So if you want to skip any entity, you can use this option here. Now say OK. Now we just need to define the pattern. For that I'll go for smart dimension. And first I will define this second number entity. And third I will define this entity above the second number entity. So one by one we will define it by giving dimensions from origin. First the second entity and then the above entity of the second. I'll go for smart dimension again and say the values from origin. Horizontal and vertical value. Now all the entities are defined here. So there is need of 3 entities to be defined here. First, this one second and this one third. Next we will go for circular sketch pattern. For that I'll draw one circular entity here and say it as PCD. PCD means pitch circle diameter. I'll put up the diameter here as 3000. Then convert it into construction circle so as to make it PCD, pitch circle diameter. Then we will draw one entity also here. We'll make one slot, straight slot, first point, second point and then slot. You have to give center to center distance here first to define this slot. Then give one radius at any point. I'll say it as 150 radius. Now as the entity is defined, we will pattern it in circular position. So we'll go for circular sketch pattern. Now in this first box, select the center point. And at last, you have to select the entity you want to pattern. And then give the required number of entities you require in 360 degrees. Suppose I want to make them in 180 degrees only, then I will change the angle and say here as 180. So all the entities will come in 180 degrees here. You can flip this option side also by clicking this reverse direction and say OK. Before saying OK, I'll again complete it as 360 degrees only and say then OK. Now for defining all these slots, you just need to give one dimension from origin to any one slot. I'll say vertical and horizontal value here. Now all these slots are defined, you can see here. So for defining all the entities, You just need to define any one entity from the origin after making pattern. So this was the circular pattern. Now we will start with some editing commands here. For that I will draw one rectangle, corner rectangle, and then I will constrain the rectangle by putting up the values here. Now as the rectangle is constrained, it is not possible for us to move it directly. So we'll move here by using the move entities command. Select the entities you require to move here. Then you just have to keep off this option so as to avoid the constraints taken here by rectangle. Then give the start point here and then move the object. By keeping off the keep relations option only you can move the object here. After that we will go for copy entities command. So for copying entities, again I will select the entities you require. I'll give one base point or a start point here and then copy the entities at whatever position we require. After copy entities, we will go for rotate entities. In rotate entities, select the entities you require to rotate it. I'll select all the entities here. Give a base point and also provide one angle here. This base point will act as a hinge point so as to rotate the object around it. So I'll put up one angle here as 45 degrees. Now you can see the rectangle is rotated by 45 degrees here. I will say it OK and exit. After rotate command, we will go for scale entities. Before using scale entities, you have to make sure that object is not being annotated here. Because if you give annotations and then scale, it is not possible to scale the object. We will select the entities here to scale. We'll provide one base point also here and then put up the scale value. Now for 100% size, the scale value is considered as 1. Suppose I want to double the size, then I will take the scale value as 2 and double the size of the object. Suppose I want to make half of the size, then I will take the scale factor as 0.5. In this way, you can provide the scale factors. Now suppose again I want to increase this size by 20%. So I will take the scale factor as 1.2. As it is 100% and again I want to add 20%, so I will take the scale factor as 1.2. I will go with scale command, select the entities, put up one base point here and say the scale factor as 1.2. Now the size is increased by 20%. This was the scale command. After that we will go for stretch command. Now for stretch command, I'll select all the sides other than one fixed size and then give a base point here. I've left one side as fixed here and then I'll put a base point here and drag the entity here. So you can see the rectangle is being stretched here. So these were the editing commands: move, copy, rotate, scale and stretch. So this was the end for Sketcher. We will continue for part modeling in next lecture. That will be session 5. So we'll put up the end on this lecture now. Thank you. Hello everyone. In previous sessions, we have completed all the Sketcher tools and now to practice them, we will go through some exercises. So to begin the exercise, I'll refer this one. In this exercise, you can see 2 diameters given. So we will start with these 2 diameters first. Go on SolidWorks software, select 2 circles here and provide the diameters first. We'll go for smart dimension and say it as 108. Second diameter is of 90 as the radius is given 45. Again smart dimension, select the value. We will say it as 90. Next, after putting up the values for circles, we'll go for its upper side, that is one rectangle given here. Width of the rectangle is 134 and height is 10 mm. And the centers of rectangles are matching with centers of circle. We can go for center rectangle here and draw one rectangle. You can also refer corner rectangles. Then put up the values 134 by 10. Now to match the centers, we will give one relation here as vertical with center of rectangle. And now we need to constrain this motion so as to define the position of rectangle. We'll refer this sketch. The distance given here is 62 mm. So put up the value as 62 here. Now we will start with two lines from quadrant and it should intersect the lower side of rectangle. After that we will go for this radius. So on these two corners the radius is given as 4 and on these two other corners the radius is given here as 8. We'll go with fillet command first and provide radius 4 on both the ends and say it OK. Then we'll cancel the command or we can change the value directly here in fillet and again provide the radius between these two lines. Say yes. Again between these two lines also. You can see if you go and select the fillet command for these two intersecting lines, it is trimming the lower side of the rectangle. So we'll undo it and again we'll go for other option, that is perimeter circle, so as to avoid the trimming of this line. This is the alternate for fillet command. We'll put up the value here as 16 as we are defining the diameter, but the radius was given 8. It is equal only. Now trim these entities and we can directly mirror this fillet. So to mirror, I'll draw one center line and then mirror this fillet of radius 8. Mirror about this line. Now I have to trim this line also here. After completing the upper portion with fillets, we will arrange the dimensions in such a way that the sketch is visible in proper size. Next, we'll draw two circles by referring of 45 line. Draw one line here with 45 degrees. Select two lines and provide the angle as 45. Here you can see this line's endpoint is matching with this center and the angle here given is 45. That's why I have taken the construction line here. Now we'll put up the circles here. I'll make these two circles. First one diameter is given as 18 and other one is 10. So put up the values here. First one of 18, outer circle, and inner circle the diameter will be of 10. Now to define the position, I will make sure to make the coincide relation with this 45 degrees line of center circle. Then also to provide a distance here. Providing the distance, you can see a reference from inner side quadrant is given as 40 mm distance till the center. So we'll draw one reference line and say it as angle of 90 degrees to make it adjacent with this line. You can see that line is not defined, so we'll give one relation also here. Between point and line, we have to say here is coincide. After making the line coincide, we will offset this line to 14 mm distance. So we'll go for offset command, put up the value for offset as 14, select the entity to offset and say OK. We'll convert this line to construction only as it is a reference line. Then we'll put up the relation between 2 points and line as coincide. It is over defining. So we'll drag and see. Point and line say coincide. Now it is completely constrained. While drawing, you have to make sure that each and every sketch is completely constrained. We'll trim the extra entities here. And now we will mirror these two circles to the bottom side also. For that again you will need one line of angle 135 as this line was at 45 degrees. So in opposite quadrant the angle will be 135. So as to mirror these two entities here. So again select the mirror command, select both the circles, say mirror about this line and OK. We'll trim the extra entities here. Again OK. Now we will hide the dimensions here by using this tab, hide and show items. You can off the dimensions here. Now we can see the upper side of this profile is completely made. We'll go for the lower side now. To start with lower end, we will go for the rectangle first. Here you can see one rectangle is given. The width of rectangle is 178 and height is 16. We'll draw corner rectangle here as the rectangle is not symmetric from the center. We'll put up the length first. This one is 178. Here the distance is given as 16. We'll refer one dimension from origin to its corner. This distance is given here as 76. We'll put up the value here. And then provide the distance from center to the top side of rectangle. This distance is given as 60 mm here. Now the rectangle is completely constrained. This extension line may disturb the sketch and we may not understand whether it is line or extension line. So we will drag in such a position that it would not interfere in between the sketch. Next we will provide one center line. And now we need to offset this center line. The distance of offset is given here as 20 mm on right side as well as 20 mm on the same other side. We'll go for offset command and say bidirectional with 20 mm distance. Select the line and say OK. Now these lines are not matching to the circle. So we'll extend these entities by using extend command. Select the required line. After that we have to provide two fillets here. The first fillet will be of radius 2 and the second will be of radius 4. Now we cannot apply direct fillet command as it may trim the extra lines here. So we will go for perimeter circle. We'll select perimeter circle. Select the first entity, then second, and here we need to provide diameters only because perimeter circles cannot be defined by radius. So we'll provide the diameter as 4. The radius we require here was 2. That's why I've given diameter as 4. Now trim the extra entity. Same goes on the other end, but the radius here given is radius 4. So we'll draw perimeter circle of diameter 8 here. Provide the value of diameter here. Again trim the extra entities. At upper side also, we'll go with radius of 4. We'll take small radius, we'll provide as diameter 4. The radius will become 2. Then trim the entities and say OK. Now you can see when you properly place the dimension, this arc will automatically get removed. It is nothing but extension of the arc due to position of the dimensions. And now for the bottom side profile here, the distance of the starting point for this profile is given as 26 mm and the end point of this profile is given as 37 mm. So we'll go for the lines command, construction line or center line. We'll make one line here from this reference line and set the offset command of 26 mm distance here. Make sure that the geometry is offset geometry and say the reverse direction. After that again we will say one offset of 37 to the offsetted new line, say reverse direction, and again put on this offset geometry option here, say OK. Now we will start this geometry here. We have to make this profile. These two lines are inclined with 78 degrees and one horizontal line is provided. After that we have to take at top side one horizontal line of distance 20 mm from offset and again 12 mm offset line parallel to the inclined line. So we will draw this profile here, first, second and third. We will provide the height and angle here. The height is given as 31 mm and the angles are equal on both sides to make the profile symmetric. So we will put the values here 78 degrees. The end distance will be coincided with this line of 37 mm. Now we have to make one more horizontal line here and set the distance as 20 mm. Then again we will offset this line by 12 mm as it is given here. These two lines are parallel. These two lines were also parallel. Again we will provide the offset distance of 12. Select the line, say it as reverse direction and put off the offset geometry as we require the solid line here. Then I will extend these entities to the base. Drag this line so as to this line will intersect on this horizontal line. Again use extend command for that and then trim the extra entities. Now we'll go for fillets. Here you can see the fillet is given as 13 and on these two sides the fillet is given as radius 7. So we'll go for fillet command. Select the radius, put up the value here as 13 mm. Say OK. Next fillet 7. Select these two corner points and say OK. Again one more fillet is needed to be provided here. That will be of radius 8. For that we will use perimeter circle. We will put up the value as 16. As the radius was 8, so diameter will become 16. Then trim the entities. And now this profile is also completed here. We'll place this dimension here to avoid that extra curve. After completing this profile, we will go for this pattern now, the mid portion pattern. For that, I will make the line of 30 mm here. We'll select the line command, start it from origin, and we'll provide the length this line as 30 mm. Also, we'll make one more line with the same length and one more line that is normal to the horizontal line. For the same length, I will provide relation as equal here. After drawing all the three lines, we have to make pattern here. We'll use circular pattern, and the number of entities we require here are 8. First, second, third, fourth, and these 4 entities. Total number of entities we will require is 8 entities. So I'll put the value here as 8. And then select the entities we require. These 3 lines, first, second, and third. And say OK. So now this pattern portion is also complete here. Now to avoid the jumbling, to read the diagram, we'll hide these dimensions here by using this command, that is view sketch relations. We can put off the option here. You can see all the dimensions are hidden now. Again, we'll make 2 profiles here. At left side you can see one line and arc is provided. We'll go for this portion now. That will end the diagram here. So for that, I'll make one line from quadrant, straight line, perpendicular to this line, and then provide one arc. We can also go for fillet. We'll go here for 3-point arc now. And in 3-point arc, we'll select first point on this line, second point on the horizontal line, and third point for the orientation. Then we'll provide the radius here as 8. Now you need to tangent this arc to this vertical and horizontal line. For that, select the arc, press Ctrl and select the line. Go for the relation as tangency. Same on the other side also. Select the arc, press Ctrl and select the horizontal line, say tangent. We'll trim the extra portions here. Again hide the dimensions here. Now you can see this profile is completed. We can also see that we have made this profile completely fully defined and constrained. It doesn't matter if the construction lines are underdefined here. We just need to define all the solid lines so as to position each and every line and entities. So this was the exercise showing maximum commands of sketches here. Now we will start with part molding in leg structure. We'll stop here. Hello everyone. In previous lectures we have seen all the sketcher tools, and now we will start with part molding in session 6. For that, first we will see the interface again here. So this is the unit setup here. We will select mmgs millimeter gram seconds. After that, here you will see UCS, user coordinate system. This is the model tree area in which every feature and sketch will be saved. So you can access any feature and sketch as required and edit it. For editing, you can use model tree area here. So we'll start with plane selection. Now this time orientation of the object matters while plane selection. So you have to recognize which plane is appropriate for the particular orientation. So we'll select here top plane and say sketch. Now we'll go for rectangle. We will take center rectangle here. Now for any feature, maximum features we require, the sketch should be enclosed so as to extrude boss or extrude cut. So now the sketch is enclosed one. We'll make some dimensions here. I'll say it as 420. And the second value we'll put here is 220. Now I'll make this sketch little bit inclined so as to recognize the direction of extrude. Then we'll go for feature command and then we will say first extrude boss feature. Now you can see in extrude boss feature, the first option coming here is direction. So here are the end conditions given. Some of the types of end conditions are given here. We'll go for blind. So in blind, it is up to user at what depth he want to extrude the part or feature. So I'll extrude this one as 180 here. You can see that extrusion has been taken place at upper side. Suppose if you want to reverse the direction of extrusion, say it as reverse. Again, if you want to reverse, click on the same option. Now suppose if I want to take this value 180 on both symmetric sides equally, then I can go for the change in end condition and say it as mid plane option. So in mid plane, this 180 value will be symmetrically divided on both the sides. I'll say it OK. Now the top plane is coming at middle of the part. It is very helpful in assemblies and features for mirroring. So it is better to keep this reference plane at center of the part. That's why it is preferable to take mid-plane option at first extrude boss. Suppose if you want to edit the feature again, say it as edit feature. I will again say it as blind option. Now we will go for direction 2. In direction 2, you can again extrude the item at other side of the sketch. I'll put here different value. I'll say it as 60 mm. So if you want the extrusions to be made on both sides but with non-symmetric extensions, so you can go for direction 2. I'll say it OK. Next we will go for extrude cut option here. For that we have to make one sketch. So we'll say the face as sketch instead of saying plane, because these faces are nothing but planes only. So I'll go for this face and say sketch. After activating plane, I'll draw one sketch here. It is compulsory to define all these sketches. So I'll constrain this sketch by giving the values here. I'll say the height as 125. This length as 60 and 50 here. The last one as 50 only. And now the sketch is completely defined. So go for features command and then say extrude cut. I'll make this cut as 150 mm here. All the options in extrude cut will be similar to extrude boss command. Instead, it will cut the material. I'll say it OK. Now the material is been removed by using extrude cut feature. So all the features you can see are being saved here. This was boss extrude 1 and this was the cut extrude we have made right now. Next, there are multiple end conditions also given. So we will go one by one. For that, we'll make one sketch here on this face. We'll say it corner rectangle. Apply one dimension to define the sketch. Go for extrude boss. Select the end condition here. Now we will select up to vertex here. For that you need to show one vertex point. I'll show this vertex point here. So this extrusion will come up to level of this vertex point. Next option here, we will say it as up to surface. For up to surface, you need to show one surface here. So I'll show one surface as this one. So extrude boss will cover up the surface here. You don't need to give any value, it will level up by the surface again. Next, we will say offset from surface. I'll select this surface here. You have to provide one value, I'll say it as 25 mm. Now, we have not given this extrusion value as 25, but we have given the difference value of this face and this face. So I'll say it OK. Now to check whether the difference was correct or not, I'll select both the faces by pressing Ctrl key. You can see the normal distance being appearing here as 25 mm. So this was the option offset from surface. Next, there are similar options in extrude cut also. For that, we'll make one sketch here. I'll make one corner rectangle again. Fully define the sketch by giving the values. It is compulsory to constrain these sketches. You can either constrain it from origin or you can constrain it by selecting the edges of the body and then you're applying the dimensions. Now as the sketch is constrained, I'll go for extrude cut. Now in extrude cut, I'll say it through all. So the extrusion will come through all the body and when complete cut will be made throughout the body. You can see here. I'll undo this feature here and again I'll go for extrude cut for other end conditions. So I'll say it up to next. Up to next will also appear as through all. Up to next means it will take the cut till the next body. Next we'll go for up to vertex here. I'll say this as vertex point, this point. So it will level up the cut till the vertex point. I'll say it OK. Now you can see this cut is made till this vertex point. Next, again I will say edit feature. For editing any feature, you have to just select the option and say edit feature. If you want to edit sketch, then go for this edit sketch option as we have seen previously here. We'll go for edit feature now. We'll select up to surface. For up to surface, again you have to show one face here. So I'll select this face and the cut will be made coplanar with this face. So I'll say it OK. And now you can see this cut is matching to this face. We have not put any dimension here, any numerical value. It has been leveled up till this surface. This was up to surface. Now to understand the difference between up to surface and up to next, both are the end conditions. I have made one hexagon here and extruded it at some height. The position of hexagon taken here is 80 from this vertical edge and 80 from the horizontal edge. Now I'll say this face as sketch and draw one circle here. I'll give it one diameter. I'll say it as 50 mm diameter. Next, for center alignment, I will give it 80 mm length as the center of this extrude was also at 80 mm from the horizontal distance. Then we'll put one vertical height here. I'll say it 40 mm. And now we will go for extrude boss. We'll reverse the direction here. Now I want to extrude it till this surface. So I'll say it up to surface. And select the surface here. We have seen it earlier also in this example here. But suppose if I select up to next, then it will grasp all the three faces of the hexagon. Whatever comes in between, the extrusion will grasp the shape. I'll say it OK. This was up to next command. Now in part modeling, we cannot be dependent only on these three planes, that is front, top and right. As the geometry of part becomes complicated, we may require more planes to be added to make the part from correct orientation. So I need one plane from the face, from this face as at 200 mm distance parallel to the face. For that, I'll take one plane here. So to apply more planes, I'll go in this feature tabs, select the reference plane option, and now you can see at left side there are total 3 reference plane options given here. It means that you can call new planes either by 3 references or minimum 1 reference is required here. So I'll add this first reference as this face. As I need parallel plane to this face only, that's why I'm taking this face. Now select the distance you require. I'll put here the distance of 200 mm. Now you can see this face is the reference, first reference, and the distance we are taking here as 200 mm offset distance. And now one plane is appearing here. I'll say it okay. Suppose I want to flip the plane at other side, opposite side, so I can do it by flip offset. So it is coming at 200 only, but at the other side. I want it at front side again, so I'll make again this option, flip offset, and say it okay. You can see one more plane is added in model tree. It is showing here. Now you can use this plane as we have used this front, top and right plane. Similar way we can make it sketch and draw sketches here. We'll exit this sketch here. This was the method to apply the planes if you want a parallel plane from any particular flat face. Now I'll hide this plane. So to hide the plane, you can select the plane and say hide. Now I require one more plane here between these two faces here in middle. So I'll go for reference plane, select the plane option and go for the first reference as this face, and I'll add the second reference here as this face. You can see one plane is coming in mid of these two faces. You don't need to require to put up the values here. The plane will directly come as you select the first reference and second reference. I have selected the first reference as this face and second as this face. Just two faces are to be selected, then the third plane will come at between of these two faces. I'll say it okay. After saying okay, I'll make it sketch and draw one rib here. For that, I'll make one triangle here. I'll select this line. And now for this two line, I can directly use the convert entities option here. So in convert entities, you just need to select the edges here so as to convert them on the current sketch or plane. So I'll select one edge here, this one, and this second edge, this one, and say it okay. Now you can see that edges are converted into sketches. So I have one triangle here. As a close sketch, I'll go for features and extrude boss. In extrude boss, I'll select the mid plane option. Suppose if I select blind, then the thickness will come at one side only. I want symmetric side thickness, so I'll take it mid plane option here and say the thickness as 12 mm. I'll say it okay. Now the rib is between these two faces. Now I will hide these planes after working. So to hide the plane, just select the plane and say it hide. You can also do it by selecting in model tree area, select the required plane and say them hide. The planes which are hidden, the icon will show in white color, and the plane which are being shown, the icon will be shown in blue color. So in this way you can judge which plane is hidden in model tree. Now one more condition we will see here is boss extrude, and in boss extrude there is one option given there, merge result. So for that merge result, I have made two sketches here, sketch 4 and sketch 5 on this body. I'll hide this sketch 5 option for now and extrude this sketch 4. Here one extrusion is been made and you can see the result showing here is merge on. It means that both the boss extrudes are merged with each other, combined with each other so as to make one body. I'll say it okay. You can see the number of bodies showing here is 1 and both the boss extrude are combined with each other. There is no edge formation between these two boss extrudes, that is separating the body. Now I'll put on this sketch 5 here. I'll show this sketch 5 again. And now again I'll go for extrude boss. Select this sketch. But this time I'll make one change here. That is, I'll put off this merge option here. So now both the boss extrudes are not merged with each other. This means that this body is separate and this feature is separate. I will say it okay. Now you can also see one edge formation between these two bodies here, showing that this is a separate body and these two combined are one body here. That's why it is showing the number of bodies here as 2. So when you put off the merge option, any feature that is boss extruded will be a separate body. So this was merge result option for you. So for now, for the part modeling exercise, I will refer this model here. You can see this bottom plate. We will start with the bottom plate first. Now the orientation of this rectangle is given from top side. So we'll start it from top plane. I'll select top plane here. Select the sketch and put up the values here. I'll say it as a rectangle, center rectangle. This value as 75 and the other value is given as 56 mm here. So I'll put up the value as 56 here. Now the extrusion is given 18. After that we'll make these holes here of diameter 12. So we'll go with features, extrude boss and say this extrusion as 18 mm with blind end condition. I'll put the blind condition here as blind and say it OK. Next, I'll make this cutout here. I'll draw one corner rectangle first. I'm going for this cutout now. So the sizes given here are 32 by 6. Select the smart dimension option. I'll put up the value as 32 and height as 6 mm. I also need to make this rectangle symmetric so as to constrain this movement. For that I'll make one center line and I'll say both the sides of rectangle symmetric to this line. The relation applied here is symmetricity. I'll say it OK. Now as the position of rectangle is constrained, it is fully defined, we'll go for the end condition as through all, so as to make this cut as through all through the body. So I'll go with features as extrude cut and say the end condition as through all. Say it OK. Now we'll go for these two cuts now. So the position here given as 28 and here the horizontal distance it is given as 15 mm. So I'll draw one circle here. Now this distance is given as 15 and the vertical distance is given as 28. Diameter here is given as 12. I'll mirror this sketch. Select the mirror entities. Entities to mirror, I will take this circle here and then mirror about this line. You can also go for feature mirror. For that I'll undo this sketch, the other circle. First I'll make extrude cut here. Features, extrude cut. End condition again I'll say through all and say it OK. Now you can mirror this cut extrude feature on the other side. So for that we will require one center plane here. So we can see the front plane, top plane and right plane. The right plane is coming in center so as to mirror this feature here. So we'll go for mirror command. Now there are two mirror commands. First we have seen in Sketcher. This was mirror entities. But in features, only mirror feature is given here. So I'll select the feature first. Then it will ask for plane. I'll go for right plane and then apply the feature I want to select. I'll say this as cut extrude 6. I want to mirror this feature. Select the feature and say OK. Now you can see this feature has been mirrored here at the opposite side. Now your base plate is complete. Now we will start with this cylindrical feature. For that the vertical height is given as 63 and horizontal as 100 mm. The 63 height is given here from the base of the part So I'll select the reference plane here. For the first reference, I'll select the base and put up the value here as 63. Say it OK. I need to reverse this plane orientation, so I'll say it as flip offset and say OK again. Now select the plane and activate the sketch. We'll make two circles here. Now the orientation of circle center is aligned with the center of the rectangle plate. We'll put up the values here. The outer rectangle is of diameter 36 and the inner rectangle is inner circle is of 22. We'll match the orientation from center. I'll say it as vertical and then put up the value here. This value was given as 100 mm and now the sketch is completely defined here. We'll go for features and boss extrude. It will by default consider the inner circle also and then it will extrude boss. We'll say the end condition as blind and put up the value here. You can see this boss extrude is made by 25 mm here. So I'll go for 25 mm value and say it OK. I'll hide this plane. We will go for this rib feature now. We will make this rib feature in two parts. First one will be this projection and then second is inclined portion. For that we will calculate the distance here. So the distance here from the side of the rectangle was given as 100 mm and we have to make this rectangular profile now. For that starting rectangular profile we'll minus this 36 from 100 and take one plane here. So we'll start with SolidWorks. Go on reference plane option, select the face, we'll put up 64 value and reverse the direction of plane and say it OK. Now activate the plane and draw one corner rectangle. We'll make this rectangle constraint. Put the value here as 12. Now I'll make this rectangle symmetric from center line. I'll draw one line, select the sides of the rectangle and apply relation as symmetric with center line. Now this rectangle is made fully constrained. We'll go for extrude boss command. Apply the end condition as up to next here. We'll say first blind, reverse the direction and then say up to next. So it will accumulate the curve shape here. Now we'll say it OK. Again for the mid portion, I'll hide this plane and select the mid plane here. Activate the plane. Now we will draw some lines here. First we will take this line and now to enclose this profile we can also go for line command as we are drawing this line. But I'll show you one more option here, that is convert entities. We will select this edges and say them as convert entities, both the edges. These edges will be converted into sketches now. Then we'll select one more line here till this entity. Next again you need to close this profile. For that again we'll go for convert entities, select the edges and convert them to sketches. So now the closed profile has been completed here. We'll go for features and extrude boss. We'll apply the end condition as mid plane so as to divide the value 12 mm symmetric on both sides and say it OK. Now here the part has been completed. We'll arrange it in isometric view. For that we'll go in view orientation option here and say it as isometric. And now for appearance, we will right click the part, select the appearance option. Here you can give appearance according to faces, features, body and part. So we will select part option here. At left side, multiple colors will appear. So whatever appearance you require, you can apply here. I'll apply this appearance here and say it OK. And now the part has been completed. So this was the session on part modeling, extrude boss and extrude cut. We will continue other features in next lecture. Till then, thank you. Hello everyone. So in this session we are going to learn about reference planes and convert entities. So to start with reference plane, first we need to understand the need of planes. You can see front plane, top plane and right plane are given already here. These are default planes. But as the geometry complexity increases, there is a need of planes here. So you may require some extra planes so as to compensate with the complex geometry. For that we are going to go in features option and you can see here reference property option. But to take a different plane or to apply some extra planes, first we have to exit the working plane. So I will exit the working plane here. And now we'll go for reference geometry and plane option. So in plane option you can see there are total 3 options given here for reference. Reference is nothing but if you want to take a plane from a face at certain distance, then that face is nothing but reference. So the maximum number of planes we can take here are 3, but at least one reference is compulsory required so as to take the new plane. So in first reference I am going to take here front plane, as I have drawn this sketch on front plane here. Now you can see one plane is appearing from reference of front plane parallel at a distance of 600 mm. You can provide offset distance here. If you want to flip the side of the plane, then go for flip offset. If you want to increase in total number of planes, you can increase the numbers and the planes will appear at regular intervals of the taken distance. I select only one plane here and say it OK. Now as usually you can select the plane and say sketch. After activating this sketch, you can go for convert entities here. So in convert entities, you have to select the entities required to convert. So I'll say sketch to this plane. It is compulsory first to activate the plane and then go for convert entities option. So I'll activate this plane here and say sketch. After that we'll go for convert entities. Now select the entities required to convert here. I'll select both the entities here. Now you have an option here, select chain. Suppose if you want to individually select the 2 sides of rectangle only, then you can go for directly the sides. But if you want to completely select the rectangle, then you can select the select chain option here and then select the rectangle. All the chain of the rectangle will be selected as a sketch 1 here and say OK then. All the 3 entities we selected were converted to sketch here. So this was convert entities here. Suppose I want to convert the circle also. I have not converted that circle first. Again I will go for convert entities and select the circle here and say OK. Whatever sketch I am going to convert, it will appear on activated plane here. So this was convert entities. Now we'll draw one sketch on front plane again. I will draw one sketch here. I have taken front plane first now. I will say exit sketch and go for another plane from reference geometry. Now select the first reference. I will say it again front plane. And I will take 300 mm distance here so as to put the another plane here. Now by this method you were applying distance here so as to take a new plane. Now we'll see one more method, that is by adding 2 references and taking the plane in between. For that again I'll go for reference geometry and plane option. I'll show here, right click and show the front plane first. And the second reference I'll show here as plane 1. Now you can see by selecting first as a front plane and second reference as plane 1, one mid plane is coming here. It will automatically divide the distances in 2 halves so as to place this plane. So it will by default come in mid. For that you have to go for 2 references, that is first reference as first plane and second reference as a second plane. If 3D part is here, then you can go for two faces, first face and second face. By default, you will get one plane in middle here, that is mid plane option. So I'll say it okay. In this way, you can add this by the second way also the planes. Again, I'll go on reference plane. Now I want plane in between plane 1 and plane 2. So in first reference, I'll add plane 1 and in second reference, I'll add plane 2. Again, you can see third plane is coming here in between plane 1 and plane 2. I'll say it okay. So this was the second method by reference of which you can take planes in between of the parts or faces. First one was by taking or applying distance, second was by applying two references. Now if you want to convert this circle again, I'll select any plane here and say it sketch first, activating the sketch and then going for convert entities. Select the sketch to be converted and say it okay. You can see here this circle is converted on plane number 3. So it is very helpful option, but one drawback is there. I can't change the value of converted entity here. If you want to change the size or edit the size, then you have to get fully dependent on the first sketch. So if I want to change the diameter here, I'll exit this sketch and first I'll make change in the basic sketch through which I have converted the other sketch. So I'll go on this sketch, say it again, edit sketch. And after editing this sketch, I'll change the value here by 300 mm. And say exit sketch. You can see the converted sketch also changed by a diameter of 300 mm. This is because this sketch was converted by the first sketch and it was fully dependent on the first sketch. That's why any change to be made in second converted sketch, then you have to change the basic sketch by which you have converted the second sketch. So this was convert entities and reference plane. Now I'll draw one 3D part and then we will continue with the 3D part so as to check the convert entities and reference plane option there also. Now I have made one 3D part here. So we'll start with reference plane and convert entities on 3D parts now. For that, select the reference plane option and add the first reference as this face. Put the offset distance here to add the plane. I'll say it 300 mm. Say it OK. Now this plane is added at offset distance of 300 by the reference of this face. After selecting the plane, say it sketch. And now I'll go for convert entities option. For that, first we'll hide the plane here. Select the plane in model tree area at left side and say it hide. Now convert entities. For converting entities, I'll select the edges. I'll select first and second edge here and say it OK. So both the edges are converted as sketch on the plane number 12, the added plane. So you can see these edges are converted to sketches. Again, I'll delete this sketch. And activate this plane again. Say convert entities. This time I'll select complete face here. The selected face will show in blue color. Say it OK. Now you can see whole face edges are converted into sketch here. This whole face was converted into sketch here. Now we will take this cylindrical feature to be converted on the plane. For that, make the plane normal. Again select convert entities and go for the outer edges. I'll select all the three boundary edges here and say it OK. So now this cylindrical feature will be converted here into a line command by selecting the outer edges. This was convert entities. I'll exit the plane here. Now I want a plane in between the cylindrical two faces, opposite sides. So I'll go for reference plane again, say it plane option. And in first reference, I'll select this end. And in second reference, I'll select the other end of the cylinder. Now you can see the plane is coming in middle of the cylinder here. You don't need to give any value or numerical instance. You just need to select two faces here and say it OK. The plane will automatically come in middle of the feature. Same way you can do here also. Select the reference geometry, plane. In first reference, select the first face, and on other second, say it OK. This plane will appear in middle of these two faces. I'll hide these two planes now. Now we'll go for another option here. You can also apply plane to the corner section here. You just need to go for reference geometry, plane, and in first reference I'll add this edge, and in second reference I'll add the opposite edge, this one, and now you can see one plane is passing between these two edges. So our first reference was edge 1 and second was this edge 2, opposite side edge, and now the plane is coming in between two edges. I'll say it OK. This was another method to add the plane. We'll see some more methods. I'll hide this plane here. Now I want a plane tangent to this surface. For that, I'll select reference geometry and plane. I'll select first reference as this flat top face and second as this circular face. Now you can see one plane is appearing perpendicular to the selected flat face and tangent to the circular face. You can say them parallel. It will change its orientation. You can also go for angle option here. Select the angle and provide as the required angle here. I'll say it 45 degrees. If you want to flip the side, you can flip the side also. For changing the quadrants, say it OK. I'll hide this plane again. Another way is to take plane is by taking three references. For that, I'll again go to reference geometry and plane option. In first, second and third reference, I'll add three vertex points here. I'll select this first vertex point, second linear to the first one, and third at opposite side of the second one. Now you can see I've selected the three edges or three vertex points, first, second and third. I'll say it OK. Now again you can see one plane has been added here by reference of three vertex points. First point, second point and this third point. Another way, I'll hide this plane again and go for reference geometry, plane. Here I'll select the edge as first reference and the face as second reference. You can see one plane is added perpendicular to the face as the orientation here was shown perpendicular. I'll say it at angle here. For angle, you just need to apply the angle value here. At whatever degree you want this plane to be inclined with the face, you can add the angle and say it OK. This was another way to add the planes. So in this way you can add multiple types of planes, and planes are really very necessary here. As the shape or sketch becomes intricate and complicated, we may require multiple planes. That's why it is very needed to know which options are available for the planes here. So in this session, we have gone through reference geometry and convert entities. For further features and commands, we'll continue in another session. So for today, we'll stop here. Do like, share and subscribe. Thank you. Now the next command we are going to see here is revolve boss and revolve cut. So for that, I'll make one sketch here. Suppose I want objects which are having straight axis but circular cross section, then we can prefer revolve boss and revolve cut command. So for that I have made this sketch here. I'll put the radius here. I'll say it 50 as radius 1 and 30 as radius 2. So there are two different cross sections which are going to revolve against this axis. The sketch should be enclosed one. Now we have to put the linear length here. So I'll put here 80 mm, and for this I'll put 120 mm. So I've made two cross sections with two different radius, as well as I've provided length here for two cross sections. Now I'll say features and revolve boss. You can see here at upper right side, upper left side, I'll select the revolve boss command. Now you have to provide one axis here. So I'll provide this as an axis. You have to keep in mind that the sketch should be complete enclosed one and there should not be any intersecting line or something here. I'll just provide this as axis, and now you have to provide the angle required to revolve around the axis. So I want it to revolve as 180 degrees. You can see here the object is being revolved at 180 degrees here. Suppose I want to flip the side of revolving, so I can do it by this icon, reverse direction. Now if I want to increase the angle, I can increase the angle also here. Suppose I want 180 degrees at one direction, but on another direction that is opposite to this sketch now, and this at this side, so I can go for direction 2 also here. I'll provide one angle here. I'll say this angle at other side as 30 degrees. So now it is coming 30 degrees at other side, and on first side it is coming as 180 degrees, and it is revolving against this axis. I'll say it okay. You can see the part has been completed here. Again we will undo the part and go for revolve command, features, revolve boss. You have to select the axis. I'll select the axis, and now I'll say 360 degrees complete, so I'll say it okay. You can see part with straight axis and circular cross section is been made here. So only for this purpose we can use revolve command. Suppose this axis is not straight, then we cannot apply revolve command there. Now we'll cross check the diameters here. We'll select the diameter. For that we'll select the edge. At lower right side you can see the diameter is showing here as 100 mm. As the radius here was taken as 50, the other radius was 30, so it will show 60 here as a diameter. So this was the basic concept, that you have to make radius of the cross section at one side and revolve it against the axis, that will be converted into diameters. Only thing is the axis should be straight here so as to make the revolve command. So the next command here is revolve cut. For that I'll select one plane to make profile. I'll select this plane in such a way that it should cross the largest cross sectional area of the profile, that is this diameter. I'll select one plane. I'll say front plane, activate the plane here, and then we'll start making one profile. The profile should be closed one, so I'll make one rectangle here. Then I'll provide the positional dimensions here. I'll say 3 mm. The width of the rectangle I'll take as 40 mm. The depth from the circular edge I'll take it as 8 mm here. Say escape. Now you can see the diameter of the cross section was 140 mm. As soon as we apply this revolve cut here, the dimension from upper side will be 8 mm. The depth of cut same will be for the lower side. It means it will revolve cut on both the sides, and total 16 mm will be deducted from the main diameter, from 8 mm from above side and 8 mm from the lower side. So we'll go for revolve cut here now. For that we may require one axis also here. So for axis you can draw the axis manually either, or you can go for hide and show items and show the temporary axis here. After highlighting the temporary axis, we'll go for revolve cut. Select the axis. This axis is only available for cross-sectional area that are circular in nature. So I'll select this axis first, and then you can see this revolve cut is taking place here. You have to provide one angle. I'll say 360 degrees here and say OK. Same as revolve boss. Now the revolve cut is made. The depth of cut was 8 mm from above. That was rotated. Now the total material removed will be 16 mm from the diameter. So here the diameter was 140 mm. And the diameter coming for the cut now is 124 mm. Now we will make some more profiles here by revolve cut. For that I'll select the plane, front plane, sketch, You can also go for top plane here, as it is also passing through the largest cross-sectional area here. Select the plane and say sketch. But we cannot select right plane here, as it is perpendicular to the axis of the main body. So any plane which is perpendicular to the axis of the body, it cannot be selected for revolve cut. So we can't go for revolve cut for right plane. I'll select front plane only and say sketch again. Now we will make 2 to 3 profiles here. I'll make one circle with diameter of 50 mm. Another profile, I'll make a tapered cut. For that I'll make this triangle here. Provide dimensions. We'll minimize the size so as to take it as 20. Then position the sketches here. I select center and left side of the edge. Make it 60 mm. Also define this sketch by 40 and 30. I'll say 20 only. Now you have 2 more profiles. Here the depth of cut will be, the diameter is 20, so the depth of cut will be the radius, that is 10 mm. And here the depth of cut will be taper by the highest depth is 20 mm. Again we need axis. We can go for one line, and we can put on the temporary axis also here. I'll make line this time and then select the revolve cut feature. You can see all the profiles are revolving against this axis. It is shown in yellow color here. Then say it OK. If you want to take partial cut, you can provide different angles here. I'll say it 180 and again say it OK. You can see only 180 degrees means half profile cut is been made here. Suppose if you want to make all 360 degrees cut, then change the angle by editing the feature. I'll provide angle as 360 degrees and say it OK again. Now you can see one circular cutout with cross section as circular and another is tapered cut. So all this body is made by only 3 features: revolve, cut revolve 3 and cut revolve 5. You can see here in model tree area. So this will optimize the commands, and in only 3 features I have made this part now. Now we will make one bolt here. For that I'll select front plane and I'll go for sketch, making a rectangle, corner rectangle. I'm drawing the shaft first. So I'll take this length as 80 mm. I need diameter of 20, so I'll take this radius as 10 mm. Features and revolve pause. Select the axis of revolution and say it OK. Now the head I want is hexagonal shape, as I am making the bolt here. I'll select the face and say sketch. I'll go for hexagon here. Provide one diameter. I'll say 25. We'll increase the value here. Then you need to provide one relation so as to stop the rotating movement. So I'll make it horizontal. Now you have to extrude boss here. I'll say features, extrude boss. And say it blind, as we need to extrude on one side only. I'll say the value here as 20 mm. Say it OK. Now we want to apply one fillet here, and we cannot apply the standard fillet here. So we need to go for revolve cut to apply the fillet. You can also apply the chamfer if it is given here. So for starting the sketch, I'll select one plane. The plane should be in such a condition that it should cross the maximum distance of the cross section. Here the maximum distance will be the corners of the hexagon, any 2 corners. So I'll select one plane which is passing between 2 corners. So you can see front plane is passing here between 2 corners. Top plane It is coming at bottom side and perpendicular to the axis. So we cannot go for top plane here. Then you can see also right plane is coming here. But right plane is not passing the maximum distance. It is just passing the sides of the hexagon. The maximum distance will be vertex point, this vertex point to this vertex point, opposite edges. Only one plane is passing, so I'll go for front plane and say it sketch. Now I'll make 3-point arc here. Just avoid the center point and then start the arc. First point, second and third point. To enclose the sketch, provide 2 lines here. And now you have to make this arc tangent to both the sides. I'll select this tangency. On the other side also I'll make it tangent. And now provide one radius. I'll say it 3 mm here. I'll increase the value as 4. And now we will take one temporary axis. You can either go for line command with center line, or you can select the temporary axis from this side. This option, hide and show items. Now you have both axis and profile. We'll start with revolve cut command. For axis, I'll select this temporary axis. And now you can see this profile has been revolve cut against the axis by 360 degrees. I'll say it OK. You can see a fillet has been made here at the above side of the bolt by using revolve cut. I'll put off the temporary axis now. Next feature we are going to see here is shell command. For that I have made one part here. It is a simple extrude boss by taking a rectangle here. So I have to make this part hollow now. So we'll go for shell feature here. In features tab you can see the shell command. Select the feature. Provide one constant thickness here. So I'll make this thickness as 5 mm. And then say it OK. From outer side it has been observed that there is no change here. But when we take section view here, I'll change the side of the section view. Now you can see this part is been made hollow from inside. Means the material was removed from inner side and the constant thickness from all the sides and from the bottom was considered as 3 mm. So the object is been made hollowed by the shell command. We will see some more features in shell command. Say it edit feature. Now you can provide faces to remove. So I'll consider this face as to remove the face. I'll say it OK. Now you can see this part is been made hollow and the upper face was removed. Constant thickness was taken as 5 mm. All from the 4 sides as well as from the bottom. We will make the visual style change and say it as hidden lines visible. Here you can see the constant thickness is being shown by the dotted line, hidden line here. That is from sides and from bottom. Next, again go for shell command. Now the material previously was removed from the inner side. If you want to add the material as thickness 5 mm from the outer side, then you can select this command shell outward. So it will add the thickness from outer side and remove the internal material. I'll say it OK. You can see in preview also here. So as to take a demo, this is adding 5 mm thickness from outer sides and removing the internal material. I'll say it OK. Now the thickness has been added from outer side as 5 mm from all sides and the upper face was been removed. We'll select the command and add one more face to remove. I'll say this face now. This face also. So now there are total 3 faces to be removed. I'll say it OK. Now you can see the part here. All the 3 faces were removed and the constant thickness was 5 mm. Again next, you can also add multiple thicknesses here instead of this constant thickness. I'll add one different thickness on this face. For that I have to select the multiple thickness settings and select on the face. After selecting the face only, then you have to provide the thickness here. I'll say this thickness as 12 mm. So the other thickness was 5 mm, but at this face we have provided a different value by 12 mm. Again I'll select this face now and provide the different value for the face. I'll say it as 20 mm here. And we have taken shell outward, that's why it is adding material from outer side. If we put off this option, again the material will be removed from the inner side and the thickness will become constant on the other sides of these two sides, and these two faces will have different thickness, that is of 10 and 20 mm. Say it okay. You can see here multiple thicknesses are added here. This was shell command for you. Now we will make one revolve part here with cross section as circular. For that we will start this part with line command and we'll make one close profile. Next we'll provide one length. I'll say it as 160 mm. This length as 40. So as to make the diameter 80, this one as 60. The diameter will be 120 and the last one will be 80. So the diameter here will be 160 after revolving around this axis. We also provide one length here. This another length as 90 mm. We'll go in feature and say revolve command. Select the axis to revolve and say it OK. Now if I want to make this part hollow, I'll go with shell feature and provide one constant thickness here as 5 mm and say this as removing face and say it OK. So now you can see this part has been made hollow here. You can take section view here. For section view, select this tab in view sketch heads up toolbar. Now you can see here this part has been made hollow. Say it OK. The constant thickness here coming is as 5 mm. Suppose I want to change the thickness here and provide one different thickness. So we will go for multiple thickness option. I'll put off the section view. Edit feature for the shell command. And in multiple thickness, I'll select this face and provide one value as 20 mm. So from the other sides, the thickness will be constant, that is 5 mm. But at this face, the thickness will be 20 mm as we are taking multi-thickness settings option here. Say it OK. For visualization, I'll make these lines as hidden visible lines. You can see all the constant size thickness 5 mm here, but at this size, this thickness is 20 mm. So here the thickness is changed by 20 and the other thicknesses are 5 mm. Again make it solid. So this was shell and revolve was revolve cut command. We'll end the session here. Thank you. Hello everyone. So today we will see loft pause and loft cut feature. The basic principle of loft command is when you have two or more cross sections for a single body, you can make it by loft pause or loft cut. So we'll start with multiple profiles here. I'll make first profile on front plane, say it sketch. I'll go for center rectangle here. Provide the required dimensions to define the sketch. I'll say it 150 here. Now I've made this sketch on front plane. I'll say it exit sketch. And now I'll take one more parallel plane to the front plane. For that I'll go for reference geometry and plane option. Here you have to select the first reference. I'll say it front plane here. Then provide the required distance between two faces. I'll say it 400 mm and OK. Now you have plane 1 model tree. We will apply sketch and activate the plane. Next profile I am going to take here is circular profile. Provide one dimension here, I'll say it 160 and hide this plane. Now you have two different profiles at two ends. We'll select features and lofted boss command. So in profiles I'll select both the sketches, first and second. Now in profiles I've shown these two sketches. There are 2 points showing the alignment of the body. Now suppose I move this point, the part will get twisted here because this alignment is been disturbed. So I'll put again this point on its initial position so as to maintain the alignment. I'll say it okay. The loft is complete here. Similar way we can go for lofted cut. Again for that we'll make two profiles here. I'll select this face. Sketch. We'll make one ellipse here. Define the sketch by providing dimensions and relations. Again we have to provide relations here. I'll make this vertical. Now this sketch is completely constrained. Again say sketch on the other face, other side. We'll make one circle only here. Provide one dimension so as to define the sketch. Exit and say lofted cut now. So for loft cut, we'll go in features and say lofted cut. Similar process of lofted boss. We have to select the profiles first. After selection of profile, you can see the alignment of point. It is coming straight here. So it will take a straight cut. I'll say it okay. Now we'll go for section view here. I'll change the side. I'll flip the side here. You can see at one end it is coming as elliptical shape and on the other side it is coming as circular shape. And the alignment of cut is still straight. So this was lofted cut. Now again we will see loft command by using guide curves. For that we will delete the previous loft command here. And now we need one sketch which is intersecting both the sketches from the center. There are two planes here, top plane and right plane. Both the planes are intersecting the sketches. The orientation of right plane here is coming as vertical, so I'll select this plane. Activate this sketch. Now for making guide curve, either you can use lines, you can also use arcs. We will go for splines here. I'll start this spline from the circle and end at the rectangle. You can adjust the splines here. Next, we need to pierce the sketches. So I'll pierce this spline's endpoint on the rectangle. The relation we are using here is pierce. We cannot use coincide relations as both the sketches are on the different planes. Again select the point and circle and apply pierce relation here. We can adjust the profile again. I'll change a little bit curvatures here. And now we will go for lofted boss. Select both the profiles. After selection you have to apply guide curve here. So I'll click in this box and say this spline as a guide curve. Now you can see the profile is been made in the shape of this guide curve. Whole body has been twisted according to this guide curve. I'll say it okay. There was only one guide curve. Now I'll again undo the part, activate this sketch here, and now we'll do one thing. We'll mirror this sketch. I'll say it mirror entities. Select the entities to mirror, mirror about this line and say it okay. Now we are having two guide curves. Again we will go for features and lofted boss command. First we will select the profiles. This time when you select the guide curve, one notification will appear here asking whether this profile is open or closed loop. So I'll select the closed loop and say okay. I'll select the other guide curve also. Again say open loop and say it okay. Open and closed loop means if this sketch is starting from one point and again closing at the same point, then it is called as closed loop. But in this condition, this spline was starting from circle and ending at rectangle. So this was open loop. That's why we have selected open loop here. Say it okay. Now this part is made following the guide curves here. Suppose if you want to make it shell or hollow, then again we will go for features and shell command here. Apply one thickness. I'll say it as 5 mm. Select the removing face here and say it okay. Complete part will be made hollow and the common thickness will be 5 mm here. You can see here in section view. Say it okay. Constant thickness here maintained is 5 mm. from the bottom and all the sides. I'll put off the section view here. So this was lofted command using guide curves. Now one more thing you have to consider here while making guide curves. I'll say this sketch, edit sketch. We have made guide curves by connecting the two profiles here. You cannot make the guide curve connecting the center points of the profile. You have to follow this step. If you select the guide curve connecting the centers of the profiles, then it will be invalid for the geometry. Same way we'll go for lofted cut using guide curves here. For that, I'll delete this shell command. We will make two profiles first. I'll make one center rectangle again. Start the center rectangle from the origin. Provide the values here. 130 by 100. Now we'll go for the other side. Exit this sketch and select the other side. We'll make one slot here. We will use center point slot here. Again exit this sketch. And now for guide curve, we will select the plane which is intersecting both the sketches from the center. Again here we will select right plane as it is intersecting both the sketches here. Side sketch and apply one guide curve. This time we will take 3-point arc. First, second and third point. We'll provide one radius. I'll say it as 500 mm. So I will select this slot and the end point here. Apply the pierce relation. Same on the other side. Select the point and rectangle and apply the pierce relation here. We'll change the profile radius here. I'll say it as 1000 mm. And now we will go for lofted cut. For that we'll exit the sketch. Go in features and apply lofted cut here. Select both the profiles, first and second, and apply this arc as a guide curve here. Now you can see the material will cut according to the shape of guide curve. I'll say it OK. And now here lofted cut has been applied according to the guide curve. We'll take section view here. You can see the cut is made following the guide curve shape. Now we will make one elbow profile using lofted feature here. So select the sketch and we will draw two lines adjacent to each other. We will provide equal relation here. Say the dimension as 200 and also provide one fillet. Say it OK. The radius I have taken here for fillet is 80 mm. Now I want one plane normal to this line. So I'll exit this sketch. Go for features and reference geometry, plane option. I will select first reference here as line and the second reference as point here. I'll say it OK. We'll activate this plane now and we'll make one circle here with diameter of 120. Exit this sketch. On the other side also we will repeat the same thing. We'll make one plane here perpendicular to this line. Select the line and point as first and second reference here and say it OK. Activate the plane and make the other circle here. I'll make this circle as diameter of 90 only this time. So at one end, the circle size is larger as compared to the other circle size. Both sizes of the circles are not equal here. Now we will go for lofted boss feature. Select the profiles. In guide curves option, I'll select this profile and say it OK. Here the note is coming that guide curve number 1 is not valid. It does not intersect the section 1. As we have discussed earlier, we cannot apply guide curve from the center points of the profile. That's why it's not taking this as a profile or a guide curve here. For that, the alternate option here given is centerline parameters. We'll select the centerline parameters and select this profile as a guide curve in centerline parameters option. Now you can see this profile is selected as a guide curve using centerline parameters option. I'll say it OK. I'll hide this plane. You can see one elbow type part has been made here. Now so as to make the part hollow, I'll say the shell command again. Provide one thickness. I'll say it as 3 mm. Select the removing face first and second. Say it OK. Now in section view you can see I have made one elbow part which is hollow in cross section. So in this way also you can use the loft feature. Now we will see loft command using multi sections. For that I'll select top plane and start with sketch. We will make multiple entities here at different planes. For that I'll start with this circle of diameter 30. Exit sketch. Now we'll go for reference geometry and plane option. In first reference, I'll select the top plane as I've drawn this sketch on top plane only. That's why I'm taking top plane here. Now the distance I'm going to take here is 20 mm offset distance, and I'll have multiple planes here. We'll take 6 planes here. Now when you put the number here, the distances between each plane will be constant as 20. I'll say it OK. Select the other plane, and one by one we'll make different diameters on each plane. This time I'll take it as 52. Next, the other diameter as 32. Exit. The next diameter as 25. Exit. Sketch. One more diameter here. I'll take it as 56 here. So now we have selected multiple diameters here. I don't need the 5 and 6 number plane, so I directly select and delete them. For that we need to exit the sketch first and then select for deleting. Now we will hide all the planes here. Select the plane from model tree and then say hide. You can see we are having multiple circular profiles here. Now when you connect two profiles by lofted boss, it will connect by the edge, by the straight edge. But when you connect the multiple profiles by using lofted boss, it will automatically take the tangency with each profile and connect them. So we'll go for lofted boss here. Select the profiles first, second. You can see here it is coming straight by the nature. After selecting the third one, you can see the curve formation here. Then select the fourth and the last one. Now each profile has been selected by curve tangent to each other. Suppose if you want this first lofted boss to be connected with a little bit straightness and then curvature, then you can go for the option here in start constraint as normal to profile. You can see a little straightness will be added here and then the curve will be taken place. You can also add the normal to profile at the end of the loft. For that, I'll select the end profile as normal to profile. But we'll go with default setting here at the end. At the start, we are taking normal to profile. I'll say it OK. And now you can see the part using multi-section has been completed here. Suppose if you want to change the dimensions of profiles and circles, then you can directly double click on the part and apply the required changes. I'll change it to 32 here. We'll make this profile as 55. Suppose I want to change the other one also. I'll make it as 36. I'll change the other diameter, this one also. The neck diameter, I'll say it as 30 mm. And now you just need to update the part here. Here the update command is available. So just click on the part so as to rebuild the required feature we have changed. Again we'll change the diameter here. I'll make it 25 only. But we will change the upper diameter. I'll say it as 52. And then again click on update command so as to rebuild the part. Suppose if you want to change the distance of the planes, then we'll go for plane 1, select the plane, then provide the distance required. I'll say it as 25 mm here. Again update the part. This was loft command using multi sections here. Now I have made one base plate here with 4 tap holes of size M5. We will mirror this plate on the other side. For that we will select the feature and go for mirror option. For that I'll select right plane here. And now as this part is not connected to any base, so we will say it as bodies to mirror. I'll select it as a body. And now we will put off this merge solid options as this part is not merged with any other object. And then say it OK. Now we have 2 base plates here. I've also made one sketch on the first base plate of elliptical shape. I'll show it here. After that I have taken a mid plane here on right plane. I have made this sketch 5. We'll show this sketch again. Now on the other hand also I'll make the same sketch here. We'll follow this first sketch dimensions only here. The major axis was 25 and minor axis as 8 mm. Exit sketch. Select the face and say sketch. Start with ellipse command. The minor axis was 8 mm. The major was 25 mm. We'll make these alignments proper now. Now we have to align the center of ellipse with the origin. Select both points and add the relation as horizontal here. We'll also provide this half distance 17.5 as the total plate distance was 35. Also align the 3 points here. Make them vertical as well as these 3 points as horizontal. Now the sketch is completely constrained here. Say exit sketch. And now we will apply lofted boss command here. And then we will add these profiles. First, second, and this third profile. Now we have to align these points at the center of the ellipse so as to make the alignment proper and say it OK. We'll hide these sketches. The other sketch also. Now here you can see one loft is made between these 3 profiles. Now suppose if you want to change the curve, then you can add guide curves also here. Here we have made 2 boss extrusions. You can see here in model tree. The first one is in rectangular shape with fillets of 30 mm and extruded till 50 mm. Then we have taken plane here at the distance of 150 and then the other extrude boss with circle 50 mm extrusion. Now we'll make lofted boss. I'm showing these examples just to show that we can directly loft faces also here. Select first face and the other face and then say it OK. Hide the plane here. We will increase the diameter here. Just double click and change the value. Now we can make this part hollow also by applying shell command. So we'll go for shell command here. Provide one thickness. I'll say it as 3 mm. And then add the removing face. I'll add this top and bottom face. And then say it OK. So this was lofted boss and lofted cut command. We'll continue with other features in next lecture. Till then, thank you. Hello everyone. So today we'll start with part molding modification commands. So with modification, we will start with mirror command first. We have seen mirror command in earlier features also, but now we will see in detail. So for that, I'll make one part here. I'll start with top plane, center rectangle, provide some values here so as to constrain the sketch. Then we will say it as extrude boss here. So after adding extrude boss of 60, we'll make 2 features more here. So we'll go with circle again. Put up the value here as 50 diameter. And then position the sketch. So for positioning, I have taken this value as 30 mm. Then the other value, horizontal value as 40. Now I'll say extrude boss and OK. And in the same feature boss extrude, again I will say sketch and make one cut here as 30 and features extrude cut. I'll take this cut value as 30 mm here and say it OK. Now we are having 2 features here, boss extrude and cut extrude. So we need to mirror these 2 features on the other side. That is, these features were on left side. I want to mirror them on right side. So as in 2D sketch mirror, we needed one line here. In 3D, we will need one plane in between so as to mirror the feature. So we have to take a plane at midsection of these features. First, we will see whether there is a default plane set or not. So we can see a front plane, top plane and right plane. So this right plane is coming in between the features. Suppose if I want to mirror this feature on the opposite side, then we can refer to this right plane here as it is coming in the mid side of the body. So we'll go with feature commands, and in feature we are going to say mirror. There is mirror command in sketcher also, but it is mirror entities, and now we are going for features mirror. There is no entity written here. That's why it is used for features only. So I'll select this mirror command, and now I have to show the mid plane against which I want to mirror this feature. For that, select the required plane. I'll say it right plane, and then select the required features. You don't need to select any secondary plane. You just need to select the features here. So I'll add these features as boss extrude 2, and suppose I say OK. The cut extrude is not been mirrored here. So if you want to add this cut extrude also for mirroring, then you have to go in edit feature, and in features you have to add cut extrude 1 also and say it OK. Now in mirror edit feature, you can see both features are being mirrored here. Then we will say OK, and the result is all the features at the left side are on right side now. We have made one sketch here on this face, and now we will make this extrude boss. Say it value as 30 mm, and this time while extrusion we have to off this merge result option. So after putting off merge result, both these bodies are separated. Means the upper body is separate and the earlier body is separated now. Total there are two bodies, first and the second body. Say it OK. You can see here it is showing solid bodies as two. This first body and the second body. So if you put off the merge result option, it will convert these two features into two separate bodies. We will say mirror command. Now suppose I am selecting this right plane as a mirror plane and features to mirror as this feature. As it was not merged, it will show an error here, showing that a note is coming only merging features may be patterned. So instead of selecting this boss extrude in features, I'll add this boss extrude in bodies to mirror, as it is a separate body now. So select this bodies to mirror and add this body here and say OK. So when the feature is merged, it will be selected in features to mirror. And if the feature is not merged, it will be selected as a bodies to mirror. Both the options are given in mirror command, features to mirror and bodies to mirror. So this was mirror command. Now we will see linear pattern and circular pattern. So for linear pattern I have made this part and one extrusion on this part. So we will go for linear pattern here. Select the linear pattern. In direction 1, I will refer this edge as direction 1 and this edge as direction 2. Make sure that these arrows are showing the correct direction. You can flip these arrows so as to correct the directions. Then in features, we will show this feature command. Now we have to pattern this feature. For that, I'll refer distance 1, D1. This was distance 1. So I'll refer this distance as 27. And this will be the center to center distance, and items here I will refer as 4, and in second direction I will refer this distance as 28, and the number of instances here we will take it as 6, and then you can say it OK. If you want to edit the feature again, select the feature and say edit feature. There is one more option given here, pattern seed only. Pattern seed only means it will only pattern the base part, the first part we have made. So I'll say pattern seed only. It will only take one column and one row. Suppose if I off this option, it will pattern again the same number of columns and number of rows as we have taken. The number of columns were 6 and number of rows were 4. Suppose if you want to skip any entity in between, so you can go for instances to skip. Select the instances. In this box you have to select the instances. I'll select the last two of the first row and then say it OK. The pattern will be made, but that instances were skipped. If you want to add them again, just say it edit feature and clear the selection in instances column, and then again say it OK. Here the pattern has been completed. Now again we will say edit feature and make this pattern as pattern seed only. After making it pattern seed only, you can vary each instance distance individually. So for that I have to say instances to vary. And now in instances to vary, suppose I want to vary this instance. Now in instances to vary, you can differ each center to center distance here. For that I'll select this point and say modify instance. So in modify instance, it is showing that The spacing between these 2 points was 27 here, and the horizontal spacing was 0. As both the points were in vertical alignment, that's why it is showing here 0. Suppose if I want to vary this distance 27, I'll take it as now 29, and also vary the horizontal distance here. It was 0, so I'll make it 5 mm. Now you can see the center to center distance between these two instances is being changed, as well as there is horizontal distance between these 2 points now. Earlier these 2 points were in vertical alignments, that's why the horizontal distance was showing 0, but I have changed this horizontal distance to 5 mm. So you can vary the instances here, the value of distances also. So in this way you can vary the center to center distance between each instance in x as well as y direction, in horizontal as well as vertical direction. I'll say it okay. Now this instance is looking little bit offset from the other instances. So this was linear pattern command. Now we will see circular pattern command. For circular pattern command, in this rectangular block I have made one circular cut here. We will take one more feature here so as to pattern the feature. For that I will make one circle, provide one diameter here as 10 mm, add one relation as vertical, and center to center distance as 25. Now we will say it extrude cut, features and extrude cut, will make it 10 mm cut. After making the cut, now we have to pattern this cut around this circular cutout. So for that, go in linear pattern, and in second number option you can see here circular pattern. Select the circular pattern. So in direction of circular pattern, we have to show the circular edge. In linear patterns, we have shown linear edges, and now in circular pattern, we are showing circular edge as a reference. After that, select the features. In features tab, you have to show the feature you want to pattern. So I'll select this cut extrude 2, and now put the number of instances you require here. You can put the instances in this column also, or you can go here and put up the values even here also. So I'll put the value here as 8. The number of instances coming here are 8, around 360 degrees. If I want to change the angle, I'll make it 180 degrees. So this is the total angle and equal spacing. It means the total number of entities will come in the angle shown here. That is 180 degrees. If you want to flip the side, you can flip the side here. Again, I'll say 360 degrees here. Now if you want to skip the instances as in linear pattern, you can go for instances to skip, and in this box you can select the instances you want to skip. So I'll skip this instance and then say it okay. So you can see all the patterns are being made except this instance. If you want to add this instance again, you just need to go in circular pattern, edit feature, and in instances to skip you have to clear the selections. This instance will be added automatically. Say it okay, and now the circular pattern is complete. Suppose if you don't have this circular cutout for the reference of edge, then there is another way of making the circular pattern. Now I want to make this cutout pattern. For that, I'll go in reference geometry and select axis option here. So for axis option, you need to select two planes which are intersecting each other at perpendicular orientation. For that, I'll select front plane and right plane. These two planes are intersecting each other at the center of the part. So automatically one axis will be made here that we can refer as the circular pattern reference. So for that, we'll start with reference and axis option. So in axis option, you have to select two planes option here. I select these two planes as front plane and right plane. Both the planes are intersecting each other at perpendicular orientation, and one axis is being formed here in yellow color. I'll say it okay. Now you have one axis. So we'll go for circular pattern again. Select the circular pattern, and in direction you have to refer this axis, and in features we will say this cutout so as to pattern this cutout. Put up the number of entities required and equal spacing as 360 degrees. You can change the number here. Total number of entities 4, and say it okay again. If you want to hide this axis, you can go in show and hide items here and hide the axis here. So this was circular pattern without reference of circular edge. Instead of edge, we have used axis option by using reference axis. So this was another way of making circular pattern here. So the next command we are going to see here is fillet command. For that I have made one part here. I have also made some features here. So we'll go for fillet command. There are total 4 types of fillet being given here. First one is constant size, second is variable, third is face fillet, and fourth is full round fillet. So we will start with constant size fillet. For that we have to select one edge and say symmetric fillet here. So for reference we have taken edge and now we have to provide the value. So I'll take it as 15 mm. So the fillet coming around the edge is 15 radius. I'll say it okay. You can see here one fillet is been made by radius 15 on the edge. Now this radius size is constant on both the sides. Suppose if I want to vary the sizes on both the sides, then we can go for again fillet option, edit feature, and in constant size fillet you can say asymmetric. Asymmetric means you can vary the distances on both the sides, horizontal and vertical. So for horizontal I'll take it as 20 mm. So this side is showing as horizontal and this is vertical, and for vertical side I'll take it as 10 mm. So in horizontal direction it is 20 and in vertical direction it is showing as 10 mm fillet. As we have selected asymmetric, both the distances can be varied. If you want to flip the direction, you can flip the directions also here and then say it okay. So this was non-symmetric fillet on both the sides by varying the distances. Now in this second number of fillet is variable size fillet. Select the variable size fillet and select the required edge. Now you can see after selecting the edge, two values will appear, V1 and V2. So you can change the values here. I'll say it's symmetric only this time. And in symmetric, V1 was 20, so I'll make it 10. And V2 I'm taking it as 20. So on the linear edge, you can vary the sizes here. It has been connected tangentially, so one side is showing 20 mm radius and one side is showing 10 mm radius. You can say okay. We don't use this type of fillets very much. So this was variable size fillet. The next type will be face fillet. So for face fillet, in these two different boxes, you have to select two different faces which are adjacent to each other and having one common edge in between. So I'll select the condition, the first face and second face which are adjacent to each other, but we have to select both in different boxes. I have selected this in one box only. So if these two faces are selected in the same box, fillet will not appear here. I'll clear the selections and go for selection again, and in first box I'll select the first face and in second box I'll select the second face. The common edge between two faces will appear as a fillet. So I'll put up the value error for the fillet. I'll take it as 10 mm and say it okay. So this was face fillet. You have to select two adjacent faces in two different boxes so as to make this fillet. You directly don't need to select the edge. You will select the faces here. Now we will see the last type of fillet, that is full round fillet. So for selections, I'll select the fillet command. Select the option full round fillet here. Now it is showing three face sets here. First face set 1, second middle face or center face, third face set 2. So for the selections, I'll select this side face as face set 1 per selection, and then in mid face selection, I'll select this mid face here or center face here. Then in third selection of box, I'll select the side face, the other side face, and now you can see one fillet is being appeared here. The size of fillet we don't have to put any numerical value here. The width of this rectangular shape will automatically become the diameter of this fillet. So I'll select and say it okay. So now the rectangular cross section is converted into the round fillet here. Again we will provide the round fillet here also. For that select the fillet command, go with full round option. In face set 1 I'll select the side face. In center face selection I'll select the center face. And in side face 2 selection I'll select the other side face. Now a fillet has been appeared, I'll say it okay. So this was full round fillet option given here. Now suppose I'm selecting this fillet command and instead of edges I'm selecting here the face. As soon as you select the face, all the corner edges, connected edges will be converted into fillets. For that I'll change the value here. I'll say it as 5 mm. So you don't need to apply individual fillet selections. You just need to select the face and all the edges of the face will be converted into fillets. I'll say it okay here. Now after fillet command, we will start with chamfer command. So for making chamfers, I have made one extrusion here. We'll go for chamfer. In fillet feature only, at downside the chamfer option is given. Select the chamfer option here. Now there are total 3 types of chamfer given in feature command. For that we will select angle distance first, then second is double distance, and third one is vertex. So we'll go for angle distance this time. Select the feature and click on the edge required on the chamfer. Now you have to put up the values here. Angle distance means first you have to put the distance value and then the angle value. So I'll put up the distance value here as 12 mm and angle as 30 degrees. Now at whatever direction this arrow is showing, distance will be applied in this direction, in arrow direction. And on the other side, on the opposite side of the arrow direction, angle will be applied. So here the arrow direction is showing on vertical side. So the distance is applied on vertical side and angle is being applied on horizontal side. Suppose if you want to flip the directions, you can flip the directions here directly. Now the distance has been applied on horizontal and angle is been applied on vertical side. Say it okay. The chamfer has been applied now. You can edit the feature here and see it is showing that the distance was applied on horizontal. So this was distance from this edge to the point, and the angle 30 degrees was applied on the vertical edge. This yellow line is presenting the angle from the horizontal. This is the angle and this one is the distance. So this was chamfer command. Say it okay. Now in second method, again we will go for chamfer command below the fillet tab only. Now the second method is given here as double distance method. That is, we have to put two distances here. Select the distance method, and now if option is coming here as symmetric, then you will only apply one distance that will be applied on both the sides equally. So I have selected here symmetric and I am applying the distance as 12 mm. Select the edge. Now the chamfer is coming of 12 by 12. Horizontal and vertical as 12 by 12. I'll say it okay. Now this chamfer is been applied by double distance method. There is no angle been given here, only distances we have applied, that was symmetric distance of 12 mm. Now I will say edit feature here, and suppose I don't want symmetric distance on both the sides, that is horizontal and vertical, then I'll go for asymmetric option here, and now you can apply different values so as to differ the distances here, D1 and D2. So for D1 I'll say 20 mm and D2 I'll add it here as 12 mm. D1 as 20 and D2 as 12. So on horizontal phase it is taking 12 mm distance and on vertical phase it is taking 20 mm distance. So the distances are differed here, D1 and D2, by taking asymmetric or non-symmetric option here. I'll say it okay. The last method of chamfer is by applying chamfer on vertex point. Now here the vertex points means the conjunction of three edges, that is this point. Suppose I go for vertex option and select this point. So there are total 3 edges. So it will show D1, D2 and D3, 3 different distances. So I can put up the values here. I can differ the values. I'll say D1 as 20, D2 as 25 and D3 as 20 again. So here you can see D1, that is on vertical edge, D2 on horizontal edge, this front horizontal edge, and D3 on this side horizontal edge. So there are total 3 distances of different values on 3 edges. So this was vertex option. I'll say it okay. And this chamfer is been completed now. You need to select 3 distances, D1, D2 and D3. So these were the options in chamfer command. We will continue with further features in next lecture. Till now, thank you. So the next command we are going to see here is sweep boss and sweep cut. For that I have made one sketch here. We'll go in features and sweep boss command. Select the feature. Now there are two options given here. First one is sketch profile and another one is circular profile. Suppose if you are going to draw any cross section that is not in circular shape, then you can go for sketch profile. And if you are going to draw any part which is having a cross section of circular profile, then you can directly go for circular profile option here. So I want to make this part in a cross section which is circular. So that's why I'm going to select here circular profile. Now here it will ask you path. So I'll select this path. And then you have to provide one diameter here as a cross section. So for diameter, I am going to give here the value as 100 mm diameter. So you can see This diameter is being swept along this part. I'll say it okay. And now the swept boss has been completed by circular cross section. You can change and manage the diameter after double clicking the part. Here it will show the diameter. If you want to change the diameter, just double click on the part and put up the changed value here. I'll say it 70 now and then say it update. This cross section is changed from 100 diameter to 70 mm diameter. Now for swept cut, again we will go for swept cut feature in features tab. Select the swept cut command. Again I want to cut the cross section in circular shape, so I'll go for circular profile. Here you have to show the path. So I'll show the earlier path only which we have used for swept boss command here. That path I will get in model tree. So I'll go in model tree and expand this swept command by clicking on drop down menu here. Select the sketch as a path and then provide the diameter here. I'll say this diameter as 20 mm or I'll say it as 50 mm diameter. So you can see one profile has been cut from the part that is of diameter 50, and the path we have used here was the earlier path only that we have used for swept boss command. Just you have to go in model tree, expand the swept boss command by drop down menu and select the sketch for the path. Say it okay. And now you can see here swept cut is been made along the path from the first end till the last end. We will change the transparency here. We will go in display style and select the command as hidden lines visible here. You can see the internal cut is shown in hidden lines here. It was started from the starting phase and finished at the end phase. So this was swept boss and swept cut in a simple way. We have chosen circular option there on both swept boss and swept cut. We have not selected yet the sketch profile option. Next we will see the sketch profile option here. I have deleted the earlier swept boss and swept cut command. We will select the swept boss feature again, but before selecting we need to make one perpendicular sketch here. For that we will require one reference plane. I'll select the plane option, and in first reference we will select this line and second reference we will select the point. So one plane will be appearing there as perpendicular to this profile. I'll say it okay. Now we'll activate this plane and make one cross section here as rectangular. So I'll select center rectangle here. You can go for any shape required. I am selecting one rectangle. Say this value as 60 mm and this other length as 100 mm. We will say it 120. After defining the sketch, we will exit the sketch, hide the plane and again go for swept boss command. So in swept boss command, earlier we have used circular profile and now we are going to use sketch profile, as we have made one sketch here that is not circular in cross section. So for selecting the profile, click on this box and then select the profile, and then the second selection will be the path. And now you can see this profile is being swept along this path. I'll say it okay. Next we will go for swept cut using sketch profile. For that I am not going to take any plane, as we are having this flat face now. We will select this face as a plane and then activate the sketch on this face. We will make one profile. I'll take this time a slot option. I'll take center point slot. We will define this slot by giving center to center distance first and then applying one radius at any end. Also define the position of this slot here. So I'll take it to 50 mm. And now I will apply one relation also so as to constrain the sketch. Now as this slot is completely defined, we will go for swept cut using sketch profile. For that we will select the feature swept cut here. We need to exit the sketch if it is not showing the swept cut option here. We will exit the sketch and then go for swept cut option. And now in swept cut we are having sketch profile and path option given here. I'll select this profile as a slot. And for the path, again we will do the same thing. We will expand this model tree and use the path of the swept boss command which was made earlier. For that we have to open this drop down menu. Select the path here. I have selected the earlier path only for swept cut again, which was used for swept boss command. Say it okay. And now the swept cut feature has been completed here. You can see this cut was made from starting to the end portion. We will change the display style here and say it hidden lines visible. Make this part normal, and by hidden lines you can see the swept cut feature again. So we will take one more example here. For that I have made one part and one path has been made. tangent to the cylinder. So we will go for swept boss command. Select the swept boss option here, and in swept boss I will select sketch profile option. For profile I will show this face, and for path I will go with this path. You can see material is been added according to the shape of the path. I will say it okay, and this swept boss has been completed here. This cross section has been swept according to the path here. Similar way for swept cut. On this part, on the front face I have drawn one spline here. I'll exit the sketch, and perpendicular to this point means on this face I'll say it sketch again. So on this face I'll draw one cross section perpendicular to this point and make it normal. Then go for center rectangle. I'll provide the values here 18 by 20. Now as this profile is not connected to this spline, I have to give relation here. For that I'll select the center point of the rectangle and the spline's end point. You can also make it coincide here. And now you are having path as well as profile. So we will exit the sketch and go for swept cut. In selection of swept cut, here you have to select the sketch, and other you have to select this spline here and then say it okay. You can see one rectangular cross section been cut in the part. So this was swept cut, for which we have needed one path and one profile, and along the path the cross section was cut in a rectangular shape. This was another example to make these kinds of cuts. So now by using swept command we will make one spring here. So to start with spring, I will go for top plane, sketch the plane and draw one circle here. I will make this circle diameter as 35. Then we have to go in features and then select curves. Here it will give the option helix and spiral. So for making springs you have to select the option from features, that is curves and helix and spiral. Select helix and spiral. Here three conditions will be given. First one will be pitch and revolution, second will be height and revolution, and third will be height and pitch. Spiral, it will not create an helix, it will create a different shape. So we will see only these three conditions first, that is pitch revolution, height revolution and height pitch for making any helix. So I'll go for pitch and revolution here. So in pitch and revolution, as the name suggests, you have to give the pitch value and number of revolutions you required. So I'll give the pitch value here as 10 and the number of revolutions I'll require is 20. So one curve has been made by using pitch and revolution, in which pitch is of 10 mm. Pitch means the center to center distance of a leaf. From one leaf to the other leaf, the center to center distance will be the pitch value, that is 10 mm, and number of revolutions means how much times it revolved to make this height. So that is 20. The number of revolutions was 20. So again we can change the pitch here. I'll say this pitch as 5 mm only. And now you can see this curve is been made by pitch 5 and number of revolutions here 20. I'll say it okay. So in blue color you can see one helix has been made as a curve. Now we will go for swept boss command and select the circular profile command. As the cross section of spring is always circular in section, that's why we are going to select circular profile option. It will directly give the diameter here. You just need to select the path. But before giving path, I'll set the diameter first. As we were having pitch of 5 mm, I'll set this diameter as 3.5 and then select the path. Now one cross-sectional diameter of 3.5 has been applied on the path and the spring has been made here. I'll say it okay. Now I will hide this helix and spiral shown in blue color. So in model tree I'll select the helix and spiral and then hide the command. And here you can see this spring has been completed with pitch of 5 mm. Pitch was the distance from one leaf to second leaf, the center to center distance. Now we will see the second condition in helix and spiral. For that I'll delete this swept command and again we will go for helix and edit feature. Now after editing the feature, the second condition here given is height and revolution. So in this we have to maintain two values here, that is height and number of revolutions. So I'll go with height as 80 mm and number of revolutions as 15. Here you don't need to give any pitch value. The pitch will automatically will be defined as we define height and revolution. I'll say it okay. I'll show this sketch. I'll show this helix and spiral here. Again go for sweep command. Select circular profile and select the path. We'll keep the diameter here as 3 mm and then say it okay. So in second condition, that was height and revolution, there was no need to maintain the pitch. Just we have to give two values, that is height and revolution, which will automatically get maintained. These three conditions are given. It is because when you get the input, you may get it as pitch and revolution, you may get height and revolution, or you may get height and pitch value. From these three conditions, you may get any one condition so as to make this spring. So I have taken height and revolution, pitch and revolution, and now we will go for height and pitch. Here we do not need any revolution value, we just need height and pitch value here. So I select height and pitch. Here the height is given as 80 and pitch is given as 4 mm. There are two more parameters given here, that is start angle and whether you have to make spring clockwise or counterclockwise. So here the angle, we can see start angle, it is given as 225 degrees. That's why it's starting from this point. Suppose I say this angle as 0 degree. At this position it is taking 0 degrees. I'll put the angle here 90 degrees. Here it is moving to 90 degrees. I say 180. So from 0 to 180. I'll say 270 degrees. It will come on this position. And again 0. It will start from the initial position. So this was start angle. If you want to change the position from clockwise to counterclockwise, then you can select the counterclockwise option here. You can see here the change is being occurred. I said clockwise again counterclockwise. Now suppose if I want to make this spring taper or if I want to give angle to this spring. Now it is coming straight. So I'll provide one taper helix angle. I'll select the option from left side as taper helix. Suppose I say 3 degrees only and in inner side. So if I opt this option taper outward, it will by default come at inner side at 3 degrees inclination. Again I want to make it outer side, then I'll put on this option here taper outward. I'll say 5 degrees, and if I want it invert, then again I'll put off this option. The angle will come inner sides and the spring will be completed. I'll say it okay. Again I'll hide this helix here. Now this is ideal spring, but if you want to rest it on some part, then it must have any resting area. Then it must have a resting area here. So for that, I'll take one plane here, sketch the plane. I'll draw one corner rectangle here. Features, extrude cut. I'll make this cut on through all both sides and say it okay. So now you are having a cross section which is having larger area so as to rest on any part. Same I'll do it for bottom side also, or we can do both cuts in similar sketch. I'll make one rectangle in bottom side also here. Then again features, and then just you need to do is exit this sketch. It will automatically get updated here. Now you can see it is coming flat at bottom side and top side so as to provide proper resting on any part. So this was spring command by using swept boss. If I want to increase the pitch here, again I will go for helix, edit feature, and you can increase the pitch value. I'll say it as 6 mm here and then okay. Now this pitch value is increased. You can see the gap between each leaf is been increased here. So this was spring command by using swept boss and swept cut. Now after completing the helix command, we will see how to make threads on the bolts for any part. So for that I'll make one bolt here. Say control new part. I'll select the front plane here and start with this sketch. I'll draw one corner rectangle, features and revolve boss. Select the axis of revolution. I'll say it 360 degrees here and say it okay. Suppose if I want to change the feature diameter, I'll double click on the part and I'll change the radius here. I'll say it 10 mm. So as to make this diameter 20, but the change is not applied, so I'll say it rebuild here. Now the change has been applied for the diameter. Next we will select the face and say sketch again, and after saying sketch I'll say this face and convert entities. So whenever you select the face and convert the entities, all the edges connected to face will be converted into sketch. So I am getting one circle sketch here, one circular sketch. I'll use this sketch for making helix here so as to make the pitch of the thread. Now go to features, select the curves and helix and spiral. I'll reverse the direction. For reversing you have the option here, reverse direction. And now the helix has been appeared here. You just need to put the kind of condition you require. So you can go for pitch revolution, or height and pitch. I'll consider height and pitch here. So I'll take the height as 60 mm and the pitch I'll consider here is 4 mm. I am taking the start angle as 0. Then again I'll select the right plane as it was passing from the helix starting point. That's why I'm selecting right plane here. Whichever plane that passes through the starting point of the helix, that should be made sketch so as to make the profile for the cross section. I'll draw one triangular profile here. I'll make one line, center line. This line is made just to make these two sides symmetric with the center line. So I'll select both the sides with the line. All the three lines should be selected and then make them symmetric here. We'll also provide the depth of cut. So I'll take this depth as 3 mm and this value as 2.5. Now I'll select this point and this helix. After selection of point and helix, I'll go for relation here. I select the relation here as pierce. I have not taken coincide relation. So suppose there are two sketches that are needed to be connected but are in different planes, then we need to select for pierce relation. After going for pierce relation, now the sketch is positioned well on the helix. I'll exit this sketch here and again we will continue with swept cut command. After selecting swept cut, now you need to select sketch profile option. We can't select circular profile as the cross section is not circular here. That's why we are going for sketch profile. Now in sketch profile, first it is asking for profile. So I'll select the triangle here. Then it will ask for path. So I'll show this helix as a path. So now path and profile both are being shown. I'll say it okay. And now you can see the threads are made. If I want to edit this depth of the cut, so I'll go for cut swap. Select this sketch and edit this sketch. We can adjust the depth here by changing this value. I'll say 2.5 only. And this size as 2.2 only. Then exit this sketch and again you will get this threads completed. So in this way you can make threads. I have made a triangular cut thread. You can go for trapezoidal shape. You can also make square cut threads or round threads. Whatever thread profile you want, you can make it on this cross section and that cross sectional shape will be appeared as a thread profile here. I'll make this head also here. I'll make one hexagon. I'll say one diameter. I'll say it as 30. Provide one relation so as to lock the positions. Then go for extrude. I'll say it 15 mm and then say OK. So for making the fillet around the head, I'll select one plane which is crossing the largest cross-sectional distance. So it is not right plane. I'll select front plane here as it is passing from this vertex point to the opposite side vertex point. And this point to point distance is the largest distance according to the cross-section. I'll select front plane and say sketch. Make one profile here by 3-point arc. For making the radius, close this profile by 2 lines, provide one radius. I'll say this as 5 radius and then make tangency of line and arc. We'll change the value. I'll say 3 mm only now. And now we will on the temporary axis so as to make the revolve cut. We are not using fillet command here. We are making this upper head fillet by using revolve cut. Again in features, say features and revolve cut. I'll show this axis, temporary axis, and then the profile will be rotated and cut along the axis. I'll say it OK. Again for hiding this axis, I'll go in hide and show items and off the temporary axis here. So here this bolt is completed with a thread profile by using swept command as well as the bolt head is filleted by using revolve cut command. So this was swept cut. And this way you can make threads by using swept cut command. You just need one cross-sectional profile and one path along the shaft so as to make the threads. So for further features we will continue in next session. For today I'll say thank you and please do like, share and subscribe. Hello everyone. So today we'll start with rip command. For that I'll select one mid plane here. After selecting the plane, I'll activate this plane and draw one single line here. Next I'll go for smart dimension so as to define the position of line. I'll say it's 60 mm and now we have made this line in the mid section of this part. We'll go for features and rib command. Here you can see 3 options are given for the thickness of the rib to be oriented. So if I click on this option, it will go on left side. You can see here. If I select the both side option, the thickness will be divided on both the sides. 5 mm on this side and 5 mm on the other side. If I select the right hand side option, the complete thickness will go on right side. So these options are given for thickness orientation. I'll select midpoint option here on both the sides and then say OK. You can see one rib has been made. We just require one single line to make the rib. We don't require a complete sketch or a close sketch. Now in this rib, we can change the shape of this rib from triangular to polygonal shape. For that we need to edit the sketch of this rib. I'll select the sketch and say edit sketch. Now here we will delete the relation and dimension both and move this point little bit upward and again add one line here. This point will coincide the edge, will increase the height and decrease the distance. You can also provide one angle here. I'll say it 120 degrees and then exit the sketch. This rib will be automatically get updated as we have edited the sketch here. And now it is converted to polygonal rib. You just need to edit the sketch and add one line here. Now we will delete the rib command here. And again we will try to make one more rib. But in this time I'll change the shape of the rib. Instead of taking line, I'll go for curve shape. So I'll select this line, delete the option here and then start with 3-point arc. First point, second and here third point. We'll provide one radius here as 200 and one more dimension. I'll take this dimension as 50 mm here. Then exit this sketch. Features, rib, select the curve and provide the direction here. Now we are having material at lower side, so we'll select the direction at lower side only. I'll say it OK. And now this rib is made on both the directions, that is from mid plane, half distance on other side and half distance on the first side. You can also edit the feature again, change the orientation of thickness. I'll take it on right side or left side. If I want to divide this value equally, then I'll go for both sides and then again say it OK. In feature, to flip this arrow, you can either click on the arrow or you can go for flip material option here. By this option also you can flip the arrow side and then say it OK. Now we will see one more condition. For that I'll draw one cylindrical boss extrude here. So to make cylindrical boss extrude, I'll select this face and say sketch. Draw one circle. Now we will define this circle with one diameter, that is 59. Also provide the reference for the position and relation as horizontal. Now we will go for boss extrude feature. For that I'll select features, extrude boss and I'll say it mid plane here. I'll say it OK. I've extruded the cylinder by 80 mm. And now we require to make one rib here. At first case, this background was flat. And now when we make a rib by the reference of this part, this background is in shape of curve. So the conditions will change a little bit. For that I'll select front plane, sketch. I'll make one line here. I'll select the cylindrical edge, highlighting in orange color and then select on the flat edge. We'll define these rib dimensions. I'll take this height as 65 mm. And this distance, I'll take it 68 mm and then say it OK. Now we have provided one sketch for the rib and here instead of flat background, here it is having a cylindrical shape. So we'll provide features and rib command here. First we'll observe the direction, it is coming at lower side, then it's OK. Then we'll provide a thickness value here. I'll take this value as 14 mm. And now you can see here, this black line is intersecting the part, but the other two yellow lines on each side are not intersecting the part. But they will intersect this part at upper side as there is a material at upper side height also. So I'll say it OK. And now one rib is made. This black line, the center line was intersecting on this part at the center here. And these two yellow lines are intersecting at a little bit above height. That is, these are the points of intersection of the yellow lines. That's why it is taking a curve shape, as these two lines intersected this part at a little bit higher height. It is because there was a material left above the rib. This time we will change the rib position. For that I'll make this sketch a little different way. I'll select the plane, say it sketch. And instead of taking this rib from the lower side, I'll start the rib from the circular edge till this point. Earlier we made rib that was a little bit lower starting point. This time I have made it from the circular edge I'll say it exit sketch and then go for rip feature here. Select the rip command and select the sketch. Make sure this arrow is coming at lower side so as to add the material at lower side for the rip and then say it OK. You can see after saying OK, it is showing the resulting rib did not intersect the existing model. Please try changing the extrusion direction to fix the problem. So it is showing that this rib is not intersecting the model. It is because when you see the line closely, now when you see closely, this black line is connected to the circular edge, but the other two lines are not connected to the circular edge, these yellow lines. Earlier also they were not connected, but in this case there is no material left above, so it will not intersect the body. These two lines will not intersect the body as there is no material above. So for that I'll cancel this rip command here and we will make some modifications in this sketch only. Select this sketch, edit sketch and then again go in line command and we will add one smaller line again here in horizontal direction. This line whatever length it may be, it doesn't matter. Again exit sketch and go for rip feature here and select this sketch. This time these two lines are connected to the circular cylinder here in horizontal direction as we have drawn this sketch here. I'll say it OK and now this rib is made. It will form a little bit wedge shape here. We cannot make a perfect rib in SolidWorks, neither in Solid Edge nor in CATIA. So in this way you can make rib. For this condition, if it is circular edge and you are starting the sketch from the circular edge, then you have to make one horizontal line also here so as to complete the rib feature. The sketch should look like this. There should be one line here with this line. And suppose if this sketch is not starting from the edge, it is starting from little bit lower side, then there is no need of this line. The rib will come automatically there. Exit this sketch. This was the rib feature by two conditions. Second, we have seen on the circular cylindrical part with starting from the circular edge. Now for understanding the rib, I have made one part here. We will add one rib here, but you can see both the parts are in cylindrical shapes. Here the face is flat, but on this face there is curved shape. So it will be difficult directly to add the rib. I'll make one base for that first. I'll say this face sketch, add center line and then offset the center line and then offset this center line. It's 5 mm on both the sides. So this will be the thickness for the required rib here. I'll say 7 mm. Say OK. I'm making a base here for the rib. I'll say convert entities. Again, this edge also will be converted and extend the required entities so as to touch the circles. We'll trim the extra sketches here. And you can see here one sketch is been made so as to build the base. I'll say features, extrude boss and select the command up to surface and select the surface here. Say it OK. Now one base has been made. After that, I'll go for plane option. So as to make this sketch in middle, I'll go for reference plane option. And in references, I'll select both the faces. And here you have one mid plane. Say it OK. Select the plane and say it sketch. And now we'll make one sketch, one single line here. It is by default constraint. And now we will go for rib feature. Select the features. Select the command rib. Select the sketch. You can see material is been added on the lower side. And when we say OK, this rib will be extended to the other face. It is because we have not made one line here so as to restrict the height of the rib. I'll delete this rib and modify this sketch again. Say edit sketch. We will add one more line here. Here the distance doesn't matter. Exit this sketch and again go for rib command. Select the rib command here and then say it OK. Now this rib has been made between these two cylinders. Suppose I want to match the thickness of this rib on both the sides. I'll edit this dimension by double clicking and then say 15 mm and update the model. And now you can see one rib has been made between two cylinders here. I made it in two parts. First the base and then the rib. And that too with this horizontal line as it was extending further to the surface. I'll hide this plane here. So this was one more example for the rib command. So the next command we are going to see here is draft command. For that I'll say extrude boss select the sketch. We will take blind on one side. Now the extrusion is taking here is 120 mm straight in linear direction. But if I want to draft this part, draft means making this part incline or extruding this part with an angle. So I'll select this draft feature and add one angular value as 5 degrees. So this part is getting extruded by 5 degrees inclination at linear direction upwards. Suppose if I want to draft at outward direction, so I'll say draft outward here. You can see this option. So it is getting drafted at outward direction. If I off this direction, then it will get drafted at inner sides. And the angle between these two faces is 5 degrees, that is 2.5 degrees at one side and 2.5 degrees at other side. But in this draft, all the faces of the extrude are getting drafted. Suppose if I want to draft only one or two faces, then it is not possible to draft with extrude boss here. As we take extrude boss and draft, it will draft all the sides. So I will cancel the draft here and then say it OK. So now we have not made draft in this boss extrude. I'll select the draft command from features only and I'll say it manual draft. There are three types of draft. We will see neutral plane draft. So in neutral plane, you have to select one neutral plane first. I'll select this face as a neutral plane here and then we will give the draft angle. I'll provide it as 15 degrees and here you need to show faces to draft. Which face you need to draft, so I'll select this face. And you can see the direction of arrow, it is showing upwards, means it is going to draft on outer side. Here the common edge between neutral face and faces to draft is called as hinge edge, or you can say this edge is fixed and the draft will take from the bottom side, not from the upper side, as this edge is fixed or hinged. So we have mentioned here angle of 15 degrees and this direction is showing upward and this one is the hinged edge. So I'll say it OK. So this face was drafted from the bottom side. We can say edit feature and select another face here. Now both the faces are selected and these two edges will act as hinge edges. So the draft will take from the bottom sides. I'll say it OK. So both the faces are being drafted from the bottom sides and the upper sides were hinged. I'll select the draft command again and reverse the direction. After reversing the direction by clicking on this arrow option to reverse or directly clicking on this arrow, it will draft from the lower side at inner sides now. You can see here, it is drafted at inner sides from both the sides. So this was draft using neutral plane option. Now the next command we are going to see here is wrap command. For that I have made one cylindrical body. We will select front plane here and by using front plane we will take one reference plane. Outside the body you can take any distance and say it OK. I'll activate this plane here. Now to type any text on this plane, select the text command and in text here you can type any text you require. So I will type one text here. I set 4 dimensions infotech. You can see here the text will always be generated from the origin side. Suppose if you want to edit the text, first we will position the text here and then select the text to edit. Say it bold, italic. Suppose if you want to increase the size of the text, then we will put off this option, use document font option here. I'll just say it off and go to font option here. In font you can increase the size of the text by using points command. Here we will increase the value. I'll say 25. You can see here the text size has been increased. Again if I want to edit the size, go to font option again. We'll say it as 21 and say OK. You can also change the type of the text here. For that again go to font option, select the type you require. You can see here font types are given and also change the size again. Say it OK and place the text at the proper position you want. If you want to increase the gap between each text, you can go for this option here by increasing the width. You can also increase the width factor of each text by using this command. I will increase the value of width factor here. You can see width of each text is been increased and then say it OK. If you want to edit the text again, double click on the text. You will decrease the width factor here and also decrease the distance between each letter and position the text again. Say it OK. After exiting the sketch, we'll select the text and then go for wrap command. Here we will show the text we want to wrap on the face. So I'll select this text and then go for faces to be wrapped. I'll select this face. You can see there are 3 options given. First one is embossing. I'll select the emboss option, for which you can provide thickness, and embossing will print the text on the face at the outer side. So in embossing, the text will be printed on the body at the outer side thickness of 1.5 mm. I'll say it okay. You can see here this text has been embossed here on the body, cylindrical body. I'll hide this plane. If we want to deboss the text or remove the material here, we can use edit feature again and go for deboss option by the depth of 1.5 mm and say it okay. This time it will remove the material by 1.5 mm thickness here and deboss this text here. So engraving is done on this body by using wrap command. Now if I just want to scribe this text on the body without adding or subtracting the material, then select the wrap command again and say edit feature and say scribe. Okay. So in scribe, neither the material will be added nor it will be removed. It will just print the text here. You can provide appearance for that. Select on any letter of the text, right click and appearance, and we will select the feature here, wrap, and then you can provide the color to this feature. I'll say it okay. You can see here this text has been printed on this body. So we were having three options. First one was embossing by adding the material and giving the thickness. Second one was debossing. It will remove the material thickness by 1.5 mm depth. And third one was scribe. It will just print the text. Neither remove the material nor add the material. Say it okay. So this was wrap command. By using this command, you can give names to the parts, engrave the names, emboss, deboss or scribe the names here on any part. So this was our session 12 in which we have seen rip command, wrap command and draft command. Still some commands are remaining there, so we'll continue in further lectures and then start with assembly lectures. So for now, I'll say thank you. Please do like, share and subscribe the channel 4 Dimensions Infotech. So the next thing we are going to see here is how to apply the material for the part. For that, in model tree, their option is given here, material. You just need to select and right click the material option, edit material. And here you will get the folders of the material such as steel, iron, aluminum alloys, copper alloys, titanium alloys, other metals, silicons, rubbers, woods. So whichever material you require, you just need to open the folder, select the required subtype of material. Suppose in woods I will select mahogany. You will see the properties of that material here. The properties will be Poisson's ratio, shear modulus, mass density, tensile strength, etc. You just need to apply and close. And now the material is been applied to the part. After applying material to the part, if you want to evaluate the mass properties of that material, you just need to go to evaluate, select the mass properties option, and in mass properties you can see the mass of the material is showing here as 2839 grams. If you want to show this mass in kgs, you just need to go on options here, select the custom settings, and in grams, instead of grams I'll say kilograms. Say it okay. And now the mass is showing in kilograms, that is 2.84 kilograms. Suppose if I change the material again here, instead of mahogany, I'll right click and say edit material. And in edit material, I'll go for steel or iron. So in iron folder, there is ductile iron, grey cast iron, malleable cast iron. So I'll go for grey cast iron here. Apply the material, close. And now you can see the appearance, it is showing in black color. It is because of grey cast iron. We will see the evaluate and mass properties again, whether the mass is changed or not. So you can see here, instead of 2 point something kilos, it is now showing as 34 kilos, as the material was updated to iron instead of wood. So this is mass properties option. It will also show you center of mass, density, volume, surface area and moment of inertia options. Suppose if you want to override the mass properties, you can go in override options here. And in override mass, you can override the properties, but it is not the proper way to change the mass. If you want to change the mass, you should change the model shape or sizes. So this was mass properties. I'll close this option. Again, I'll go to material option, right click and say edit material. Now in edit material, there is one more option given here, custom materials. You just need to right click the custom materials, go to new library or new category. In new category, I'll type mild steel. In mild steel, I'll right click and say new material. Again mild steel, and now for mild steel it will show the properties option. Here you can update the properties as required. You can also update the appearance here. Suppose I want a high glossy appearance, I'll go for this high glossy appearance. Say it yellow high gloss appearance. It will show the appearance here in this box. Apply the appearance there, close, and now you can see the material applied here is mild steel. So for customizing the material, you just need to go to edit material, customize mild steel, and you have to fill up the properties. Here the properties option is very important. Suppose if you want to change the mass density, I'll change the mass density here 4900. If you want to change the Poisson's ratio, I'll say it 0.2 instead of 0.28 and say apply. In such a way, you can change all the other properties also. I'll say it apply and close. Now the material appearance is also changed. So this was material option. Now we will start with some modification commands. For that we are going to use view heads up toolbar. So in view heads up toolbar, the first command is zoom to fit. Suppose if you called a part for an assembly and suppose that part is not visible here, then you can just click on zoom to fit and that part will appear in the center of the screen. So if you want to gather all the parts at the center of the screen, you just need to click on zoom to fit and all the required parts will be at center of the screen in front of you. Now the next one is zoom to area. Suppose I want to zoom this area, so I can use this command here, zoom to area. For that I'll make one window in which I want to zoom the area. You can zoom the particular area or any intricate shapes or gaps which are not visible by keeping it in a normal view. So you just need to make a closure here. It will zoom to that closure and you will be able to see the features here. So this is zoom to area. Again here. Next one is previous view. Suppose if you have arranged this part in a certain position so as to show the feature, and if that parts get disturbed by that position, then you can again arrange that position by going to previous view option here. You just need to select or click the previous view option. It will show all the previous view you have taken or positioned the object. You can see here, I am just clicking on this option continuously and it is showing me the previous views I have taken here. So this is previous view option here. Next command is section view. For section view, you have to click on the icon and you can see here the section view is being appeared. Section views are shown to show the internal features of the part. So for that, you have to select the reference plane here. Now it is taking by default as front plane as a reference. I'll select this one. This is top plane. So it will refer the section from top side. You can see here, you just need to drag this arrow and all the internal cut features will be shown here. Again, I will change the plane. I'll take this right side and suppose I want to see the two holes here, two internal holes. Then you just need to drag the arrow. And suppose if you want to show the angular cutouts, then you can drag this arc also. Even this horizontal arc. Again, suppose if I want to orient it again by top plane or right plane or front plane, you just need to select the plane. You can also select the faces as a plane here. So I'll select this face and then start dragging the object so as to show the internal features. Say it OK. Here you can see the internal features. Two cutouts were made of radius 12.5. You can see the radius below here. If you want the normal view again, you just need to put off this option, section view again. And now it is back to the normal view again. One more time, section view. Here are the internal features. Suppose if you want to change this color for the section view, the background color coming here as a green color, you can edit the color and change the required color. If you don't want to select plane, you can go for faces also as we discussed earlier. Now here the section colors are showing in red color. Say it OK. And this was section view for you. So after section view, we are going to see orientations of the object. For that, we are having one command here known as view orientation in view heads up toolbar only. So I'll select this view orientation option and there are certain icons given here. Each icon has its own meaning. Suppose I select this icon here. It will show a window pop-up that is showing the top view. So I'll click on this icon. It will show me the top view here. Again I'll go to this icon and say left side view. It will show the left side. Next I'll go for this front view. It will show me the front view. Next right hand side. Next bottom view. Suppose I want to see back view. I'll select this view again. It will also show me the isometric view. The shortcut key for pressing the isometric view you can see there. That is Ctrl 7. Suppose if you press Ctrl 7, it will by default be shown in isometric view by the use of keyboard. Suppose I'll click this icon here directly. It will show me the isometric view. The importance of isometric view is these two sides are adjacent and are at the angle of 120 degrees from each other, and the angle from the ground will be 30 degrees each. So the importance of isometric view is you can see all the three faces, front, top and side, and the features that are covering that faces. So it is very easy to understand or read the object by showing all the three sides by arranging them in isometric view. There are multiple options there. Same as isometric, there is diametric view. The angle will be little changed. Again, there is trimetric view. They are same as isometric view only, but the angles are being changed little bit. Next, here it is showing one cube. Suppose I go for front, I'll select this face. For top, I'll select this cubical face. For isometric view, I'll select this hexagonal face. Suppose I want to see it from northwest side, I'll select this isometric view. Same, you are having multiple isometric views also here. You just need to select these hexagonal faces. Same goes with these faces also. Whenever I will select this face, the window popping up here will show that particular view. Now it is showing back view there. So this option here, view orientation, is used to showing the particular views. You can also divide these views in top view. Suppose I want to show top and front view. I'll select this top view. It will show top as well as front view. Again I'll go to view orientation. So now it is showing front and right view. Again view orientation and four views. Here it will show you front, left side view, trimetric view and top view. So in this way you can observe the object by all the views here. So it is very important option here given as view orientation. I'll select this single view option again and we are back to normal view. Now in display style, you can see certain types of display styles are given here. First one is shaded with edges. So by default, as you are seeing this part, it is in display with edges only. I'll select the second option, that is shaded, in which all the edges will disappear here. The part will be shown without edges. Again, I'll change the display style. The third option given here is hidden lines removed. It will only display the edges here. It will not show the internal features. Only the outer external features as an edges will be shown here. Next one is hidden lines visible. Now in this view type, you can see all the internal features shown in hidden lines and all the external features are shown by the dark edges here. Next type is wireframe, displays all the edges of the model. So all the internal and external edges will be shown as a dark edges here. So you can see the internal features also. Suppose instead of section, you can use this alternate view option here. So if you want to see the internal features, instead of taking section, you can also go for this option here. That is either hidden lines visible or wireframe option. So this was display style option here. I'll again make it normal with shaded with edges. Now the next feature given here is hide and show items. I'll click on this drop down menu here. Suppose if you want to show the planes you have taken, so I'll select this plane. It will show all the planes we have taken here, extra planes other than the default planes. So I have taken here plane 1 and plane 2 earlier. It is showing me now as we have on this option here, that is view planes. Next option given here is view default planes. So if I want to show the default planes also, that is front, top and right, I'll click on this option. Suppose if I want to hide all the planes again, all the default planes, I'll click on this option and hide the planes. Again we have to hide these other planes also, extra planes, so I'll again go to view tabs and hide the other planes. Other than that, you can show the display axis here. You can control the view of axis. If you are having any circular internal features or external features been cut out or been boss extruded, any circular features, then you can go for view temporary axis option here. It will view all the temporary axis for all the circular features. Either it may be circular cuts or it may be circular boss or revolve boss or revolve cut options. It will show access to all the circular features here. Now suppose if I want to hide all the access here, I'll go to visibility option, put off this view temporary access. The access will be hidden again. We cannot see the access anymore here. Next, in hide and show items, you can show the sketch relations and sketch dimensions. For that, I'll select this feature and say edit sketch. Now after saying edit sketch, here you can see the sketch of that particular feature. You just need to go in visibility option. Again show the relations. If you want to show the sketch relations, just put on this option. Here you can see in green colors all the relations are being displayed. Again, if you want to hide these options or relations, you just need to put off this option view sketch relations. Suppose if you want to hide the dimensions of this sketch, again go to hide and show items and put off this option view dimensions off. Here all the dimension will disappear. To bring back the dimensions, go to that option again and say view sketch dimensions. So in this way you can use this hide and show items here. You can also control the visibility of origin here by hide and show items. You just need to show or hide the view origins option. So if I view the origin, it will show me in blue color here. Again, if I want to hide the origin, I'll just click on this option. It will hide the origins again. So this was hide and show options here. So now I've made more two bodies here other than the first body. So the total bodies they are showing are solid bodies as 3. I'll go for appearance option now. For that, I'll right click the part and select appearance option. In appearance option, you can apply appearance in 4 ways. That is by applying appearance to face, features, bodies or complete part. So I'll start with face option. So in face option, you can select any face and that particular appearance of color will be applied there. You have to select the face color here and click on the face. You can see the colors are being applied on the face. We'll select more faces here. Same color will be applied for all the faces. I'll cancel this feature. Again right click on the part, go for appearance. This time we will select features. So suppose now I want to apply color for this particular feature, that is cut extrude 3. So I'll right click on that feature, go for appearance and select the feature option here, that is cut extrude 3. So the color will be applied only for that particular feature, that cutout. I'll select the color and say OK. Now suppose I want to give appearance to the internal features, that is cut extrude 1 and cut extrude 2. We will see one by one. I'll select cut extrude 1, right click and say appearance, and for appearance I select the feature. I'll apply one color here and say it OK. For cut extrude 2 also, that is internal cut, internal circular cut, right click and say appearance, go for the feature and apply another color here, say it OK. Now we'll display the colors by taking section views. You just have to say OK. And now you can see all the cut extrude features in internal portions are being applied by some appearance. So this were cut extrude 1 and cut extrude 2. So in this way you can apply colors to features also. First we have seen faces and now we have seen features. Next option given there is you can also apply color to separate bodies. So we are having 3 bodies here. This base as first body, this is the second body and this is the third body. So for that right click on the body and go for appearance, select the body option and apply the required color here. Say it OK. Now this time I have applied the appearance according to bodies. Suppose instead of taking appearance for faces, bodies, now I want color for complete part. So I'll remove all the appearance first. Just right click on the part or any feature. Go for appearance option and say remove all the part appearance. You can remove the appearance individually also by clicking on this icon, or you can just say remove all part appearance. All the part appearance internal and external will be removed now. See the section views. All the cut extrude feature appearance also has been removed now. Say it OK. Off the section view, right click on the part and go for part appearance. So in part appearance, whole body or part will be appeared in same color option. I'll select this one color here and say it OK. This time this appearance has been applied to complete part. So in this way, these 4 types, that is face, feature, body and part, you can apply the color appearances here. Hello everyone. So today we'll start with assembly module. So to start with assembly, I'll go for files, new, and now here assembly, say OK. So here is the starting interface of the assembly. You can see here, this is the starting interface of the assembly. Here you have unit selection, same as part modeling. First we will select the required unit of assembly. Next, here it is given the model tree area. Here is the UCS, user coordinate system, which is used to show the required working planes. So you can see here the common things are that here also we are having one origin, front, top, right plane. Next thing here is you have to call the components by using this tab, insert components. So to start with assembly, I'll go in insert components, select the insert components option, and from there you can browse the files here. The icon is given here, or by default this page will pop up so as to browse the part as required. Suppose I want to say browse here, it will again direct to this page, and from here you can browse the required part you want to assemble. So we'll start with browsing parts. In desktop, I have saved my parts in this Rathore Sagar name folder. First I'll call this whole plate here. I select the part, say it open. Now the first part has been inserted here. I just need to click on the screen. This part is placed as a fixed part. You can see here, this icon will represent the part. This F icon will represent that part is fully fixed. You cannot drag and move the part here. But if you hold the cursor and then drag, it will move. But actually it is in fixed condition only. So if you drop the cursor and then drag, it will not move from its position as it is a fixed part. So to make this part float, I'll right click on the part and say float command. So after saying float, this part will start moving and floating here. There is a purpose behind doing this. It is because we have to make the assembly origin being coincided with the first part origin. Press the control key and now you can see both the origins in blue color here. Both the origins are apart from each other. So I need to match both the origins by using mates option. So in assembly we are going to see multiple categories and types of mates by which we are going to assemble the required parts. So before understanding the assembly, we are going to see what are mates. So you can see the icon here. One pin icon is given named as mate. So I'll select this mate category here. So in mates, there are certain types of categories given. First one is standard, second is advanced, and third is mechanical. We are going to go through all these three categories. But what are mates? Mates are nothing but the relations or commands which are going to be used for making one part lie on another part and make a combined assembly. So mates are nothing but relations that we are going to apply between two parts or multiple parts so as to make a combined assembly. So to start with mate, today we are going to start with standard mates. So in standard mates, there are total 8 categories given here. First one is coincide, second parallel, third perpendicular, then tangent, concentric, lock, second last with numerical value, that is distance mate, and the last one is angle mate. The last two mates will have the numerical values here so as to apply the required mate. Now before starting with the mates, you can see here the front, top and right plane of assembly are showing separately from the part, and if you select the parts front plane, top plane and right plane, they are apart from the assembly's planes. So to work properly with center planes, we will combine all the planes. For that, we need to combine the origin of first part and assembly. So for combining the origins, we will go for mates option here. And now we will select assembly origin and the first part origin. Now this part is moved towards the assembly origin and coincide mate has been applied here. You can see at this upper side, all the applied mates will be shown here. This part was moved towards the assembly origin. It is because firstly we have made this part float in condition. Suppose earlier if we have kept this part fixed only, then this mate would have shown error here as this part would have not been moving here. So it is compulsory for the part to make in float condition and then only go for mates option here. Now the coincide mate has been applied here. I'll say it okay. And now we can see front, top and right plane of assembly are combined with front, top and right plane of first part. You just need to combine the origins of assembly and first part so as to combine all the planes. It will make us easy to assemble the parts with center references That's why we have done this process, and it is done only for the first part. The further parts will not require this process. After mating the origins of first part and assembly, now we will call the second part here. For that I'll say insert components, and I'll call the shaft plate here. Now I need to assemble this shaft with the hole. For that we'll go for concentric mate. As both the surfaces of the shaft and hole are circular in nature, for that we'll go for concentricity. Concentricity means matching the centers or axes of circular parts, that may be hole or a shaft. For that I'll select mates option here. Select the outer circular surface of the shaft and circular face of the hole. You can see by default system is taking a concentricity mate. If you want to flip the orientation of the part, you can click on this option, flip mate alignment. This option is also available here. If you want to click here, you can flip the alignment by clicking on these arrows, or else you can flip the alignment by clicking on this option also. I'll say it anti-align and align. So this option is used to flip the parts here after making concentricity or any mate. I'll say it OK. So the second mate I have applied here is concentricity. Now you can see I cannot move this part in Z and X directions as the mate concentricity has been applied here. Only Y directional movement is been on and the rotational movement of the part is on. So to constrain all these rotational and axial movements, I'll go for another mates. I'll say parallel this face and this particular face. Again say it OK. And now the parallel mate is been added between these two faces. That's why both are in same alignment. So instead of going for parallel mate, you can also go for coincide mate. Suppose this part is position incline here. Again I'll go for mates option. Select both the faces. System will by default take coincide mate. There is very slight difference between coincide and parallel mate here. Say it OK. And now both these faces are being coincided. In mate history I can see 3 mates are being applied. First one was origin with origin. Second was concentricity between the hole and shaft. And third mate was coincide. Now only one movement is on here. That is Y directional movement. So to lock this Y directional movement, I will have two options. I'll select the mate option here. Suppose if I select flat faces here, it will by default go for coincide mate. Means these two faces will be coincided here. Next, suppose if I delete this coincide mate between two faces, again this movement is on, then I'll go for distance mate here. Select the mate option. Select both the required faces. You have to be careful while selection of faces and edges. Here the edge is been selected, so I'll clear the selection. Again go for selection of faces. System by default is taking here as coincide mate. I'll say I don't want coincide, I'll go for distance mate. So for applying distance mate, you just need to click on the symbol of distance here and apply the required distance between two faces. So I'll go for distance of 50 mm between two faces here and then say it OK. Now all the motion are constrained between two parts, and here the assembly is showing as fully defined. So for constraining all the three motion X, Y and Z as well as the rotational movement, you need to require at least 3 mates here. First one was concentric, second was coincide and third was distance mate. Now you can see here we have given coincide mate. So this coincide mate was given to lock the rotation of the part. Now to lock the rotation, there is one more alternative way. We will delete this coincide mate. The rotational movement is again on here. The part is rotating. So instead of giving coincide mate between two faces to lock the rotation, we can also do one thing here. That is, we can edit the concentric feature. Say edit feature, and in concentricity, while applying the mate, you are having one option here to lock the rotation. So I'll on this option and then say it OK. Now lock rotation is on. This part will not rotate here. The concentricity was given here and that concentricity was locked now. That's why this part is not moving. So instead of giving coincide mate between two faces, we can also do here is lock the concentricity of that part. That part will not rotate again. Again I will go for unlock rotation. You can lock and unlock rotation but just by right clicking on the mate and saying it unlock the rotation. Again this part is rotatable now. You can see the symbol difference here. Both the circles are showing a plain circles. Suppose if I lock the rotation by right click and say lock rotation, the inner circle will show as a dark circle. Again unlock rotation. Now the circle is not showing dark here because the rotation is unlocked. But suppose if you want to again lock the rotation, just right click and say lock rotation. But the drawback of concentricity made being locked, that the position of this plate is not defined. It may be inclined or parallel, perpendicular. In any position it may get locked. That's why it is better to unlock the rotation again. And previously as we have provided coincide made, again we will go for coincide made only. Select both the face again and then say coincide. Again these two faces are coincided with each other and the part is positioned in a linear way correctly here. Say it okay. Now if you want to copy any part, you just need to hold the control key continuously and drag the part. This part will be copied here. You just need to hold the control key and then drag the part. So you can see multiple copies of that part are being applied here. I just want one copy, so I'll delete this part. Now if you want to see the difference between coincide and parallel here, these both mates were close to each other. So if I want to see the difference between coincide and parallel mate, then I'll make this part little bit inclined. For that I'll go for rotate component here and I'll disturb this part and make the position here as inclined. Say okay. First we'll coincide both the top faces. And now to see the difference between parallel and coincide mate, I'll select the mate option. Select both the faces here, both the side faces. Now the mate been applied here is coincide mate. So in coincide mate, both the faces will be parallel and will be both attached to each other. I'll say it okay. Now you can see here both the faces are parallel and are connected to each other. I'll undo this mate or delete this mate again. That is the last coincide mate between two side faces. I'll delete this mate again. And again I'll make this part a little bit incline here by rotate command from this move component option. Now we will do parallel. First we have given coincide. Now I'll go for parallel. You just need to see the difference between coincide and parallel. Select the mate. And instead of saying coincide, I'll firstly select parallel mate and then select both the faces. You can see both these faces are being parallel, but they are not attached to each other. So in coincide mates, these faces will get attached to each other, and in parallel mate, two faces will become only parallel. They will not get attached to each other. So this was the main difference between coincide and parallel mate. I'll say it okay. Now instead of parallel, I want to apply perpendicular mate here. For that also, I'll delete the parallel mate and then go for perpendicular mate. Select the mate option. Select the perpendicular option. You can apply perpendicular mate either between edges of two parts or faces of two parts. So I'll select the flat faces here, this side face and this side face. Now you can see both the faces are perpendicular to each other. That is, they both are at 90 degrees to each other. Say it okay. Now again we will revise the distance mate here. Now suppose I want distance between these two faces, this face and this face. Select the mate option. Select the distance mate here. You have to keep note that distance mate, parallel mate, perpendicular mate or coincide mate. All these four mates will be applied between flat faces only. Maybe faces, maybe planes, maybe edges, but they should be linear and flat. I'll select both the faces again. And for distance value, I'll put up the distance mate here as 60 mm. So these two faces are 60 mm apart from each other now. Say it okay. So we have revised the distance mate again here. Next, I'll take copy of this bottom plate part to apply the angle mate. For that, I'll go for mate options. Select the required edges to coincide. I'll coincide the side faces also. And now you can see the part movement here. It is rotating in all 360 degrees here. So if I want to make an angle mate between these two faces as 45 degrees angle, I'll select the angle mate here. Select both the required faces. and provide the required angle. I'll say it 45 degrees here. I'll flip the dimension and flip the orientation of the part. So you can place this angle mate in all four quadrants just by flipping the dimension or by flipping the mate alignment. You can see here. Now it is in fourth quadrant. Again it is in first quadrant. For second and third, I'll flip this part alignment. For third quadrant position, I'll make this orientation flipped here. Now it is in third quadrant. Again say flip dimension. It is in second quadrant. So now it is taking 45 degrees here as an angle mate. Say it OK. Now the next mate we are going to see here is tangent mate. For that I'll call one part. So I'll call one cylindrical shaft here. Now I want this shaft to be placed on this flat face. The cross section of this shaft is circular in nature and this face is flat in nature. So if I want to place this shaft on the flat face, I need to apply that tangency mate. For that, select the mate option, select the circular face and flat face. You can reverse the selections. First you can select the flat face and then circular face. Either ways you can do this mate. Now say it OK. Before saying it OK, you can see here, if I want to flip the direction of tangency, there is one option given here, that is flip mate alignment. So I'll select here flip mate alignment, and this shaft now is coming here in between at lower side of the surface, but it is still tangent to the surface. If I say OK and drag this part away, suppose it is not selectable here. If you are not able to select here, you can do one thing is select the part from model tree and then drag the part here. Now you can see this part. It is away from this face, but it is still tangent to the face. So if I drag it here again, you can see the tangency of that circular face with the upper flat face. Again, if I want to flip the direction of the tangency, I'll go in mate, select the tangent mate, say edit feature and flip the tangency here. Say it OK. So now this part is tangent with the plate and kept on the above surface of the plate. And now suppose I want to place this shaft with this orientation at center of the plate. So it should have equal distance from both the sides, from left side and right side, and it should be placed in center. For that we can do here is select the mate option and we will select the assembly plane here, this right plane. As we have matched the assembly's origin with first part origin, the planes are coming in center. That's why I have selected the right plane here. And then go for the parts plane, similar plane of part. That is this top plane. We can select this top plane also or this right plane also. So I'll select the top plane with the assembly's right plane. And now both the planes are coincide with each other, you can see here. And as they are coincide, I'll select the edit mate feature again to show the reference plane. As both the planes are coincide with each other, this part is locked with the center plane of the assembly and it will not move either on right side or left side. It will by default come on the center orientation. So if you are having circular parts, you can match the center planes of the parts with the assembly planes so as to orient in center. Now again, the second way of orientation in center is, suppose I want this part again to be oriented in center with reference to this distance. Now I want this part to be placed in exact center. So I'll calculate the distance first. So to calculate the distance between two faces, you can do evaluate, go for measure command and select the two reference faces. I'll select this face and the other face. You can see one scale mark is coming here instead of arrow. That is for selection of the faces. I have selected both the faces and it is showing here the 100 mm distance. You can see here the distance, it is showing 100 mm between these two faces. I'll exit this. Again evaluate and measure the distance of the shaft now. We will select both the faces here. And now the distance of the shaft, it is showing as 50 mm. So I'll do some calculations here. I know that the distance of this plate here, it is 100 mm and this is 50. So I'll minus this 50 from this 100 mm. So the result is again 50 mm. And suppose if I want this part to be kept in center, from both the side equal distances, then I need to select these distances as 25 mm from one side and 25 mm from other side. So the second option here to orient it is by giving distance mate. I'll go for assembly again, select the mate, and I'll apply the distance mate between these two faces. That was 25. Say it OK again. And now this part is completely placed between the center of the plate, horizontally also and vertically also. So for vertical orientation, we have used plane option, and for horizontal orientation in center, we have used distance command. Now suppose I want to edit this part. If you are already in assembly and still you want to edit the part, you came to know that part is not of the required distances or sizes, then you can edit the part in between assembly also. For that, select the part. One chart will pop up here. You just need to select open part option here, the first option, or the second option, open part in position. Both options are useful. I'll go for open part option here. And now we are redirected to part molding, in which this shaft is open again. So it is a part molding interface here. I'll edit this shaft. You can see the model tree of shaft been made here. So I want this length to be increased. Instead of 50, I'll say it's 70 mm. And then update the part. You have to rebuild. You have to click on the rebuild option here. Now the shaft length is updated here. You compulsory have to say save here. Control save. Next, close the part. It will automatically get updated here. Now you can see the length of the shaft is 70 mm. First we have used 25 mm distance to place this shaft. Now we will again recalculate the distances. So this was 100 mm. The updated value is 70. So 100 minus 70 is 30 mm. Divide by 2, that is 15 mm distance. So I need to change the distance made here. I'll go in made history again on left side of model tree. Say distance made, edit feature. And instead of 25 mm, I'll say it 15 mm this time. Again, it will get oriented in center of the plate. Say OK. So in this way, you can edit the part in between assembly also. You just need to click on the part and say open part, re-edit the part, save the part, and again redirect it to assembly. The next and last mate we will see here is lock mate. Now for lock mate, I'll drag copies of this part here. Now both the parts are individually moving here. I'll go to mates option, select the lock mate and select both the parts. Say it OK. Now you can see lock the two components together mate is been applied here. Say it OK. Again OK. And if I drag the first part, the second part will move with the first part because of lock mate applied here. This was lock mate. It is used when you are having two parts that are to be moved relatively with each other. That time you can apply this lock mate. So this way the standard mates given. We have seen and gone through each mate here. We'll stop here. So in last session we have seen assembly basics, and now we will start with some examples of assemblies. For that I am going to assemble here butterfly wall assembly. So we'll start with the parts, calling with the first part. For that I'll say insert components, browse, and in browse I'll go for the folder in which I have saved the files for butterfly wall assembly. So in assemblies here I have this folder. I'll go for butterfly wall assembly here, and we'll start with the main body first. So we'll call first part as a main body. Select the part and say open part. And now this is the first part of assembly. So we'll first right click the part and then say it float in condition. After making the part float, we'll go for the first mate, that is assembly's origin with first part origin, so as to combine all the center planes. For that I'll select assembly's origin and the first part's origin here. Now both the origins are being coincided here by applying coincide mate. It is done because all the planes of assemblies and first part will combine together. Next part we will call here is shaft. So for that insert components and browse. For that I'll call this shaft as a second part here. Now you can see the cross section of the shaft is circular. We have to insert in this slot here, circular slot. For that I'll again go for concentric mate. Whenever shaft and hole are given there, to assemble we have to go with concentricity. For that I'll select the mate command, Select the circular face and again go for the second circular face here. Say them concentric. I'll not lock the rotation this time. I want to keep it moving here. I'll say it okay first. Again okay. We can see here the shaft is rotating here as we have not locked the concentricity. Next I want this circular face of the shaft to be coincided with internal circular face of this body. For that again we will go for mates option. Select this face and the internal circular face of the main body and say OK. You can see here the movement of the shaft. And we'll go for the next part now, that is insert components again. Say browse and say retainer plate. Next select mate. We will say coincide of these faces. Again say OK. And we have to match the holes now. For that we will say concentric mate here. Now still these upper bolting holes are not matched. For that we'll go for concentricity again. So we are giving here 2 times concentricity so as to match all the holes, the center hole and the side holes. Again we will go for concentricity. Select both the circular faces for bolting and now this part is fixed. We'll call the next part here. That will be the screw. Say it OK, open. And now we'll apply the screws here. We'll apply only one screw and then make pattern of that screw. For that select the bait option here. The circular shaft and circular hole. Means by default it will take concentricity here as both the parts are circular. We have to flip the orientation of the screw. For that I'll select the mates for the screw, that was concentric mate, and then select the edit feature for that concentric mate and we will orient the part by mate alignment. Now the orientation is flipped. Say it OK. As we have flipped the orientation, I'll continue with mates, making it coincide with the circular face. Say it OK. Now to lock the circular movement of the screw, we have two options here. That is, first one is making this flat face of screw parallel with the upper face. By default it will take parallel mate here. As this flat face of screw is parallel with the upper face of this body, the movement of rotation is locked here. Say it OK. Now we can see it is not moving or rotating here. Next option we will see, that is locking the concentricity. For that I'll undo this made here and now right click on the part, and suppose if you want to see the specific mates of this particular part only, then just select the part, right click the part, and here you have the options view mates. Now this option will show only the particular mates of that single part only. Here if you see the mates, here it will show all the applied mate for all parts. But if I go for this option, right clicking and then viewing the mates, it will show only the mates of that particular part. So in concentricity, I'll right click and say lock rotation. So this is the second option to lock the rotation. It will randomly lock the rotation of the screw. It will not take any references of the faces here. Now this was the second option to lock this rotation. First one was making this face parallel to the upper face. Second was to lock the concentricity. Now I'll make the pattern of the screws here. For that we have linear component pattern option given. In that linear component pattern we'll go for second option, that is circular component pattern. As these holes are given in a circular PCD, pitch circle diameter, for that we'll go for circular component pattern. Select the option. In direction it is same as circular pattern in part molding only. So we'll select the circular edge here. So the linear and circular patterns are same as part molding circular patterns and linear patterns. You just need to select the direction box here. First you have to click in this box. Then for direction I'll select the circular edge as it is a circular pattern. If it is a linear pattern then I'll go for linear edges. Next, components to pattern. I'll show the screw here and then apply the number of entities you require to pattern. I'll say it 3. Say it OK here. Make this option equal spacing only. Now these screws are being patterned here. But you have to make sure before pattern that the first part which are you going to pattern, it is compulsory constraint. Then only make a pattern of that part. If you don't lock this part by constraints, if there is any movement remaining in the part, it will be carry forwarded in patterns also. That's why you have to make sure that part is fully constrained and then only you have to pattern the parts. So now this pattern is completed. We'll go for the next part. Select the insert components option. Say browse and now we will call the arm here. I'll make this arm concentric with the shaft here. Say it OK. Now make the back face of this arm coincide with this face. First we need to select the mate option and then go for the selections. Now this is coincided with the back face there. You can see the rotation of this arm. Next part we are going to insert here is the nut. And now I'll make concentricity here with same shaft. I'll flip the orientation of the nut. Say it OK. Again OK. Then we'll select the mate option and go for coincide mate for the nut with the arm. Say it OK. Now to lock this rotation, I'll make this mate, that is the upper face of this nut parallel with the upper face of the main body. You just need to select two faces. System will by default take the parallel mate here. Say it OK. Now this nut is also fixed here. We'll call for the next part, the last part, that is this plate, elliptical plate. So for this elliptical plate, we'll make concentric mates first. We have to assemble this plate on this shaft here. So now these two holes will match the shaft two holes here. For that, select the mate option and then select the concentricity between first hole of plate and first hole of shaft. Say it OK. This plate is underlying. We'll pick up the plate here. First say it OK and then drag this at upper side. Next we'll match the other hole. For that, select the mate option. Select both the holes to be concentric. Say it OK. We'll rotate this shaft little bit. Again say it OK. Bring this plate at upper side and then go for the mate of this bottom face of the plate and upper face of the shaft. Again say it OK. Now you can see here this plate is been merged and been flushed by this part. Means this plate and part are being flushed here. This plate is intersecting this part. So we need to change the dimension either of the main body or of the plate here. We'll see the plate's dimension first. We'll double click on the part. And as it is a elliptical plate, there are two radius been given here. So the bigger diameter of the elliptical plate will be 205 mm. And now we will see the hole size of this main body. So the diameter for that is coming as 194. Now the biggest diameter here is 205 and here the diameter is showing 194. That's why this part is being flushed in this body. So to avoid this, we have to make change in this body here. For that, I'll select the body and say open part. It will be redirected in part modeling here. You can see the model tree for the particular part. Now we'll change the diameter of this boss extrude, the internal diameter. Double click on the part and here instead of giving 194 size, I'll go for 205.5. I'll keep 0.5 mm clearance. Again rebuild the part so as to update the part. Now the size has been updated here. We'll make Ctrl S and save the part and then close the part. It will be updated in the assembly also. Now you can see the edges are being shown. It means the intersection of this part has been avoided here. Now I'll make one more mate here. For that I'll go for lock mate. We have seen lock mate in assembly features. We'll select the lock mate. I'll select the upper face of this plate, elliptical plate, and this face of the shaft. Say it OK. And now as we rotate the handle here, the elliptical plate inside the main body is also rotated there. This assembly would look better if you apply appearance for each part or any material for each part. So before assembling, it is better to apply the appearances for different parts and then assemble the parts. So here the assembly has been completed now. So this was butterfly wall assembly, the first example of assembly for standard mates. So the second assembly we are going to see here is press tool assembly. This is the finished assembly that we have assembled. Now we'll see the complete process of assembling these parts and make this press tool assembly completed. For that we'll start with file, new and say assembly here. We'll browse for the parts, select the browse feature. First we will call the bottom plate here, say open. So this is the first part. You can see F sign here. It means this part is fixed. So to float this part, I'll right click on the part and say float feature. Now this plate is movable. This sign is also changed here. Now it is showing minus sign here. It means this part is in floating condition. So we will repeat the same thing here. That is coinciding assembly's origin with first part origin so as to match the planes. We'll start with mate option. Select the assembly's origin and first part origin as the first mate. You can see a coincide mate is been applied. say it OK. Now all the planes of assembly and parts are matched together. Then we'll go for second part, say insert components, browse, guide pillar. The first mate we are going to apply here is concentric mate, as both the shaft and hole are circular in cross section. So select mate, say concentric, the outer surface of the shaft and surface of the hole, say it OK. Next we are going to coincide bottom face of guide pillar with bottom face of plate. For that select the mate, go for bottom faces here. The mate been applied here is coincide. Say it OK. Now as we are having one guide pillar been assembled here, we need to see whether it is fully constrained or not. For that I'll move this guide pillar, I'll zoom and then move. So it is showing that rotational movement is still on here. So to constrain this rotational movement, I'll select mate option. We can do one thing here, that select the guide pillars planes. Suppose I select here right plane and then select the side face of the plate. You can see this plane is rotated and is parallel now with side face of the plate. So in this way you can lock the rotation of the guide pillar. Now it is not rotating here. You can see if I suppress this mate, this motion is again on here and the part is showing minus sign here. That is, this part is not fully constrained. So again I'll unsuppress this mate. The guide pillar minus sign is removed and it is showing that part is fully constrained now, as parallel mate is been applied there between the plane of the guide pillar and face of the plate. Both plane and face of the guide pillar and plate are parallel to each other. That's why the part is not rotating now and it is showing fully defined here. So after defining the part, we'll go for the next option, that is pattern the parts. If you want to individually assemble the part, it will take much time there. For that, I'll go for linear component pattern. For directions, I'll refer these edges. So the linear pattern of assembly and linear pattern of part molding is same only. You just need to select the edges as directions. So I want to pattern this guide pillar in vertical direction and in horizontal direction. For that, I've selected this edge and the direction 2 will be the other edge. You have to select the edge only. Now select the components to pattern. Define the number of entities you require. With this hashtag sign, you can define the number of entities and the distance between each entity. The spacing option here. So for direction 1, I'll go for 90 mm distance here. And for direction 2, I'll select 190 mm distance. And now you can see the guide pillars are properly patterned here. Say it OK. Now we will call the next part, that is guide bush. So I'll browse that part here. Say guide bush here. So again we'll go for concentricity between guide pillar and guide bush. Select the mate. Select the inner circular face and outer circular face here. You can see concentric mate has been applied. Say it OK. Now I have to apply the distance mate between this upper face of the guide pillar and upper face of guide bush. So for that I'll select mate option. Go for distance mate. Select both the faces and apply the required distance. I'll say 20 mm here. If you want to flip the direction of the distance, you can click the flip option here. So this distance will be flipped upwards or downwards. Say it OK. Now we will see whether the part is constrained or not by moving the part. So it is not moving vertically, means the distance mate has been applied here, but still the rotation is on here. So to lock this rotation, we can again do that, selecting the mid plane of the guide bush and making parallel with the side face of the plate as we did for guide pillar. Or else we can do, select the guide pillar, say view mates, and here in concentricity, say right click and say lock rotation. So now the rotation has been locked here. You can see this minus sign is also removed. If I again go on the part, view mates, and unlock the rotation, this part will show under constraint here. You can see the sign. That's why we have made concentricity locked here. Right click and say lock rotation. Close the object. After the guide bush being assembled, again we'll go for pattern option. Select the linear component pattern. In direction, we will refer edges. Direction 1 and direction 2. Cross check the directions of the arrows. And then select the component to pattern. Just provide the number of entities with hashtag sign here, as well as distance or spacing between each entity. Say it OK here. Now the last part for the assembly, that is top plate. I'll select the insert components option again. Say browse component, top plate here. Select the mate option. I'll select this face and the circular face here. You can flip the part here and then say it okay. Next, I'll make this hole concentric with the guide bush face here. You have to select faces only. It may by default show axis also there, but if you select the axis option, it will take coincide mate. But we will go for concentricity, and for that we have to select circular faces only. Next option here you can see this plate is still moving. Now I want to make coincide this top face of the guide bush with top face of the plate. For that, select the mate option, select the required faces. Both the faces are coincide with each other. Say it okay. And now this assembly is also completed here. We'll arrange it in isometric view. You have to press shortcut Control 7 here. So this press tool assembly is completed here. We will see one more option here. I'll delete this part here. Say delete. We will also delete the guide bushes here except the original one. Select all the bushes and say delete directly. Say yes to all. And now instead of pattern you can do one more option here, that is copy with mates. So for copy with mates, I'll select the option. It will ask you to select the component. I'll select the guide bush and then click on this next arrow, and we have applied two mates here, that was concentric and the concentricity was locked, and then distance mate by 20 mm. So we'll select the concentricity and distance command. So we will select the references for concentricity and distance command on the other guide pillars also. For concentricity reference, I'll select this face, and for distance reference, I'll select the upper face. As a hint, it will show the color options here also, so as to refer on these faces. So it is showing purple color on this top face. I'll select this top face only again. Now this part has been copied with mates on the other pillar. I'll say OK and repeat on the next guide pillar, that is selection of the faces. SolidWorks will highlight the required faces on the other part so as to copy with mates. So in purple color it is highlighting here that we have to select this face, and the other face will be the top face. You can see here the color showing. So I'll select this top face again. Say OK. Again repeat the same procedure. For concentric selections here, I'll select this face, and for distance selection, I'll select the top face. So all the guide bushes are copied with mates here. Say it OK, and then you have to say cancel to close the command. Again these guide bushes are being patterned here. So this was the option showing copy with mates command. It is also very important option here. But it is better to copy the parts individually instead of copying 2 or 3 parts together. So I'll suggest don't copy 2 or 3 parts together. Go with individual parts to make copy with mates option work properly. So this was press tool assembly and other options. We'll stop here and continue with the advanced mates in the next lecture. For now, I'll say thank you. Please like, share and subscribe the channel. Hello everyone. So today we'll start with assembly day 9, that is advanced mates. For that we are going to browse parts here. From the folder I'll select the required part, that is frame. So now we are going to do one window assembly in which we are going to see at least 3 mates, that is width mate, limit angle mate and symmetric mate. So to start with mates, I'll call the second part, but before that we need to complete our process, that is combining assembly origin with the first part origin. So I'll make this part right click and say float. After floating the part, you can see the part is moving now. We'll call the mates here and select the required mate, that is coincide. For that I'll select the first assembly's origin and then the first part's origin. Now both the origins are coincided with each other. I'll say it OK. We have seen already there the advantage of coinciding the center points or origins is that the planes of assembly and first part will be matched here. You can see the assembly planes and first part planes are been together here. So the assembly will work from the center plane reference only now. Next we are going to call the other component. Say browse. And now we are going to take the door here. After calling the door, first we'll go for concentric mate. So I'll select the required selections here. That is hole and shaft. And now both the hole and shaft are being concentric here. But the window is still moving in linear direction. Now we can see the length of the window. The height of the window here is given as 546 mm. And the inner height of the frame is given as 550 mm. The difference is of 4 mm. So if I want to place this window at center, I have to keep clearance of 2 mm from upper side and 2 mm from lower side. So for that we are having three options here. First option is to lock the midplane of door with the midplane of the frame. So I'll go for that mate. I'll select the top plane of assembly and similar plane, that is top plane of door. Now you can see the door is aligned in the center as the mid center planes are matched here by coincide mate. So this was the first option given. I'll delete this option and go for another option. I'll delete this mate. Again the another option is by applying distance mate. So for distance mate, select the mate. Go for distance and say 2 mm distance. First face and second face. Now the clearance here is 2 mm from upper side. Same is going to be for lower side, that is 2 mm only. So again the door is placed at a center. So this was another option, the second option, that is distance mate. But we are here to see advanced mates. So I'll delete this mate also. And now in advanced mate, the first option we are going to see here is width mate. The work of width mate is to align the part at the center of the given references. So it will make this door at equal distances from upper and lower side. So I'll go for width mate here. Select the required references. First we'll select the references of frames, that is upper and lower face, and then we'll select these references of door, that is the lower and upper face. You can select the first selection as door also and then frame also. You can go for the reverse selections also. First you can select the door faces and then the frame faces. Now you can see the constraint mate is width mate and the door will automatically come at the center of these two upper and lower faces of the frame. Say it OK. Means you have to go for 4 selections, that is upper and lower face of the door and upper and lower face of the frame, inner sides. Now width mate has been applied here. Again we are going to repeat the same mate, that is coincide and width mate, for the next door also. So we'll start with mates. Go for the selections again, that is concentricity between this shaft and hole, and then applying width mate here. In advanced mates, go for the selection of width mate. In width selection, we'll select the doors faces first, upper and lower side, and then the frames faces. And this door is settled at the center now. Say it OK. So again the width mate is applied here. Now you can see both the doors are rotating at 360 degrees here. So I need to restrict this door at particular angles by giving it maximum and minimum angles now. So in advanced mates, we are going to apply limit angle mate here by applying two limits, that is maximum limit of angle and minimum limit of angle, so that the part will reciprocate in between that two angles only. Similar kind of mate we have seen in standard mates angle mate also. We don't need to provide limit angles, that is maximum and minimum. Only one angle was needed so as to constrain the part. But in advanced mates, we need two angles, that is maximum angle and minimum angle. So we'll go for mates and select the advanced mates. If you select the standard mates, you can see the angle here. Only one angle was needed. But now this time we are going for advanced mates. So here if you select the angle mate, there are three values given here. That is, first one is initial value that lies beside the icon of the angle mate. Second is the maximum value and third is the minimum value. So here we require only maximum and minimum values that are important. This initial angle value doesn't matter if you keep it 0 degrees, 45 degrees or 90 degrees, any angle you can keep. It is just the start initial position of the part. But maximum and minimum values, these two values are important here. So for the selection of angle mate, I need to select this front face of the door and front face of the frame. So maximum angle I'll keep it here as 120. I'll say 108 degrees. And minimum angle I'll say it's 0 degrees. Selection of two faces I have given here, that is frames front plane and doors front plane. Say it OK. Now you can see here, now this door will not exceed behind the frame, neither it will exceed the angle of 108 degrees in front side. It is because limit angle mate is been applied here. So it will take 0 position here and maximum 108 degrees position here. So this is limit angle mate. This is minimum limit, that was 0. That's why these two faces as we have selected for angle mate are coplanar with each other, and the minimum and maximum angle are given as 108 and 0. This was limit angle mate. We'll not going to apply this limit angle mate on this frame or this door. It is because we are going to apply a symmetric mate, and due to application of symmetric mate, so we don't need to apply limit angle mate on the second door here. We'll go for mates. So now we are going to see a symmetric mate. So for symmetric mate, you may require a center plane. So we are having a center plane here as right plane, and we need to select two faces of the opposite parts which are going to be symmetric with the center plane. So in advanced mates, select the symmetric mate. It is asking for symmetric plane. As we have discussed, we are going to take right plane here. It is coming in between the assembly, that's why I'm taking right plane. So in symmetricity, you need to consider that whatever two parts which are going to be symmetric, the plane should be lie in between that two parts. That's why I'm selecting the right plane here as a symmetric plane, and we have to give the selection of two faces of the parts which are going to be symmetric. So I'll select the two faces of the parts here. I'll select the inner face of this first door and the inner face of the second door also. The selection should be similar. If you are selecting inner faces, then select the inner faces of both the doors. If you are selecting outer faces, then select the outer faces of both the doors. It doesn't work if you go for inner face selection of first door and outer face selection of second door. So here the symmetric mate has been applied, say it OK. And now if you drag this door, the first door will follow the limit angle mate that we have given here. You can see in mate history at left side bottom side, the limit angle mate was given to the first door only. So it will follow the limit angle mate. But the second door we have not given any limit angle mate. It is following the first door just because the symmetric mate was been applied. So the first door's movement will be copied for the second door also due to symmetricity mate. Again, I'll repeat the selections here. So for symmetric mate, you need to select one center plane between the two parts to be made symmetric and the two faces of the parts that are to be made symmetric. Say it OK. This way symmetric mate is also been applied here. So this was limit angle and symmetric mate. Now the next mate we are going to see here is linear coupler mate. For that I'll call the parts here. This is the first part here, that is track rail. In the second part I'll browse here as this rectangular rail. Mate selection, I'll go for mates here again. First we'll coincide the origins of first part with the assembly origin. For that go for mate selection and then select the assembly's origin first, and the first part was this track. So I'll select the origin of the first part also again. But as I say OK, the mate is not been applied here. It is showing error. This is because I have not made this part float in condition. So it is compulsory for us before applying mate that the part should be float here. Then only we are going to apply coincide mate. So I'll right click and say this part as float and then go for mates. Select the assembly's origin and the first part origin, that is track part. Say it OK, and now the planes are matched here. Now I'll go for second part. I'll place this block on this track here. For that I need coincide mate first. I'll select the coincide mate, select the bottom face and the second bottom face. Say it OK, again OK. Now this part is moving, so I need to apply width mate there. I'll select for mate option and then go for width mate. In advanced mate, select width. First selection I'll select the side of the block and the other side of the block, and then in tab selections I'll select the two faces of the track, two internal faces, so as to make this part at the center, so as to place this part at the center of the cutout. Say it OK. Now you can see the distance of the block was 50 mm and the track in between distance was 54. So by applying the width mate, 2 mm clearance has been also applied here. That's why we used width mate here, so that the part is placed at the center of the cutout. Next option, I'm going to apply a limit distance mate, that is the new mate we are going to see here. So for limit distance mate also, you have to apply two limits, that is maximum and minimum. We will go for limit distance mate here. Select the limit distance mate tab here. You can see maximum and minimum distance. So in advanced mates distance mate, we have to apply two distances, that will be maximum and minimum. Initial distance is here. It is given beside the symbol of distance mate. So I'll take the initial distance as 0. The values that matter here are maximum and minimum value. So the maximum value I'm going to take here is 110 mm and the minimum value here as 0 mm. So for reference selection, I'll select the back face of the track and back face of the block. We are going to apply limit distance made between these two faces. I've selected both the faces, applied the maximum and minimum distance, and then say OK. Here you can see the part is moving at 110 mm, but it is moving in a reverse direction. So to solve this issue, I'll again go in Made, edit the limit distance made feature, and then flip the dimension here. You can see this option, flip the dimension. It will reverse the distance dimension here. So now it is going to move in right side direction, maximum 110 and minimum 0. So this was limit distance made. Sometimes there is confusion as we are having standard mates. There is also a distance made, but this distance made is different from limit distance made of advanced mates. Here you need to apply only one distance, and in advanced mates you are going to apply maximum and minimum two distances here. So that's why limit distance mate is different from standard mates distance mate. Say it OK. We have applied maximum and minimum distance to this part. Now I need one copy of this part, so I'll press Ctrl, hold the Ctrl key and then drag the part so as to make the copy. Go for mate option again. Select the bottom face of the bar and the face of the track. Say OK. Advanced mates. Again repeat the width mate here to align the part in center. So now width mate is also been applied, but we are not going to apply limit distance mate to the second block here. We are going to see one new option, that is positioning the part without applying the mate. For that I'll go for mates option. Now we require this part to be placed in such a way that these two in between distances of the faces, first face and second face, the distance should be 10 mm. If I randomly place this part here, it is not going to take 10 mm distance. For that, one option is given there in mates. Go for that option, select the mate option. We'll select the required faces and then go for the distance mate. Apply the required distance. I'll say it 8 mm here. But directly before saying it OK, we are going to tick on this option, that is used for positioning only. What this option will do is, it will not apply distance mate directly. It will just position this part at 10 mm distance from the first face. Say it OK. Now you can see in made history, distance mate is not been applied here, but the part is been positioned at 10 mm. We can check the distances. Just control press and hold the control press key, then select the both faces. You can see the normal distance showing here as 8 mm without applying the distance mate. Now we'll go for linear coupler mate. Select the mates option. In advanced mates, go for linear coupler mate. We have to give similar side selection of the faces here. That means if I am going to select left side of this first block, I select the similar face of the second block also. That is left face. So if you are selecting left face of first block, you have to select left face of second block also. You have to watch the ratio also. It is showing here as 1:1. So the speed coordination between these two parts will be 1:1. That means if this part moves at 10 mm, this will also move at 10 mm only. Say it OK. Only two selections were required. That was this face and the other part similar face. Left face and the other left face. If you are selecting right face for the selection, then for second part also you need to select the right face only. Now here we have applied linear coupler mate. The mechanism of linear coupler mate is such that if I move this first part, the second part will also move because of coupling, that is linear coupler mate. And now suppose if I edit this mate and here I'll change the ratio by 1:2. So the speed will also be varied by 1:2 ratio. It means if this first block will move 10 mm, the other block will move 20 mm here. You can see here the speed ratio is changed. The second block is moving 2 times faster than the first block here. It is because of change in ratio. So that is the importance of linear coupler mate, that you can couple and move the part in required ratios. That is 1:1, it may be 1:2, maybe 1:3, and then say it OK. So now the speed ratio between first and second part is 1:2 and linear coupler mate has been applied here. The next made we are going to see here is path made. The concept is very simple. There will be two parts. First part is having path and second part will have the vertex point, and the part will move according to the path been drawn. So for that I'm going to browse the parts first. In desktop I'll go for day 9. Here we are having one plate. We'll call this plate here. As it is the first part of assembly, say right click, float, then made. Assemblies origin with the first part origin so as to match the center planes. Then we are going to call the second part, that will be the slot strip here. Now we are going to make one made, that is concentricity. We need to select only the circular faces so as to make this part concentric. Say it OK. Now I'll see the movement of this part. Again I'll apply one mate here, that is coincide mate between the bottom face of this part and upper face of the plate. Say it OK. You can see this part is concentric and coincide with the plate now. We are going to see one more mate here, that is slot mate, which lies under the category of mechanical mates. So for that I am going to call the next part sliding pin, say open, and now go for mates. In mates I'll go for mechanical category and apply the slot mate here. For slot selection, select the circular face of the pin and circular face of the slotted link here. You can see the slot mate has been applied. We'll also go for coincide mate here between the bottom face of the upper head of the pin and the upper face of the link. Say it OK. Now as we have applied slot mate, this part will only travel between the slots here. It will not leave the slot here. The selections for the slot mate were circular face of the link and the circular face of the pin. After applying slot mate, I'll place this pin here. Now you can see one path. So this pin will follow this path by applying path mate. Now this path was made on this face. So this path is coplanar to this face here. I just need to apply one vertex point in this pin so as to follow the path. But the question is where to apply the vertex point here. Suppose if I apply this vertex point on the upper head, this pin is not going to move downwards so as to catch this path. So we cannot apply the vertex point at the upper side. Neither we can apply this point at the lower body. So the requirement here is to count the distance between the upper face of the pin and this face, as this path was coplanar to this face. Before applying path mate, we need to place one vertex point here. The vertex point should be at level of this path. So this path was made on this face and the normal distance is coming here as 13 mm. So I'll open this part, say open part, and after opening only I'll place this vertex point here. Go for the selection of mid plane, say it sketch, and after saying sketch, place the point here, say smart dimension, and from the upper face we have counted distance was 13 mm. So I'll place this point at 13 mm distance only. It is because it should grab the point of the path there. We'll constrain this point here by applying the vertical relation. Then close the part by saving this change here. Close the part. Now you can see this vertex point has also been applied, same at the level of this path, that is from upper face 13 mm distance. So the basic requirement is that this path and the vertex point should be coplanar, should be at the similar plane. That's why I have applied the 13 mm distance. Now I will go for path mate here. Select the mate option. In advanced mates, go for path selections. In component vertex selection, I will select the vertex point, and in path selection, I will select this line here. But as we have selected the line, it is not completely selected. So for that, we'll go for selection manager. We'll select this sketch here and set it as open loop and then OK. I've set this as open loop. This is because it is not a closed sketch. It is starting from this point and ending at the other point. That's why I've selected open loop here. Say it OK. And now as the path mate has been applied, the pin will follow the path mate here. Same time it will not exceed the limit of the slot mate and it will remain in the link there. You can see here the movement of path mate and slot mate being together applied. We cannot apply slot mate in this condition. It is because slot mate require only one combined sketch, but this path was made by combining more than one sketches, that is this line, then arc, then the other line. So in this scenario, it is not possible to apply slot mate there. That's why we have applied path mate here. So this was the last mate of advanced mate, path mate. We'll stop the lecture here. Thank you. Hello everyone. So today we'll start with session number 17. In previous sessions from 1 to 16, we have seen sketcher, part modeling and features, as well as assembly and types such as standard mates and advanced mates. So today we are going to start with mechanical mates, and in mechanical mates we are going to see gear mate and screw mate. So to start with the parts, we don't need to make parts of gear. So these parts can be called directly from the design library provided by the SolidWorks itself. So at the left side you can see this toolbar known as task pen. So to open the design library, we'll select on the second option here. It is highlighting there as design library. We'll click on the option there, and here we have to go and select toolbox option. In toolbox, you need to click on this add in now option. So it will open the library. Library is according to the standards of various countries. So to start with, I'll go for ISO. Either we can go for ISO or we can go for ANSI matrix, ANSI inches, and different type of standards according to country are given here. So I'll go for ISO right now, and in ISO I'll select the bolt and screws option, and in bolt and screw folder you can see subfolders are also given there showing different types of bolts here. So I'll go for simple hexa bolts, structural bolts. Select the folder, and inside the folder you can see two types of bolts are given with the grade option. I will call any one type of the bolt. So you just need to select the bolt and drag the bolt in the screen here. So now I am in a part modeling mode. We can't call the parts of design library in part modeling. So we'll change the interface here. I'll say file, new, and assembly. So in assembly, we can directly use library parts also here. So instead of browsing the parts, I'll go for design library option. From this option, you can go at the back steps. You can see again the standards are showing here. I'll select ISO. In ISO, I'll select bolt and screws, and in bolt and screws, I'll select hexa bolt structural. There are two bolts given here. I'll drag one of the bolt. So now this bolt is been shown here. At left side, you can see the configuration manager, in which you can manage the sizes of the bolt as well as finish, length, thread display, how to display the thread, how to control the length of the thread, and its designation, part name, and everything is given here. So in configure part, you can edit the part as required according to the sizes. First, I'll change the display mode here. And again, I'll go for that part. Now for the size, it is given here M16, M20. So the bolts here are starting with M16 size. I'll go for M16 only. Next, whether this backside of the head required washer face or chamfer face. There are two options been given. In this bolt, it is showing only one option. At the lower side, I'll go for the thread length and shaft length. So in shaft length, I'll select 70 mm here. The thread length, it is showing here as 38. If I say 75, it will take complete threads on the shaft, as the shaft length also was given 75. So even after applying the thread length and length of the shaft, the threads are not being shown here. It is because the thread display we have selected here is simplified. So I'll select that option and go for cosmetic threads. Now you can see an illusion type threads are being shown, actual threads are not being shown there. So this is cosmetic type thread display. If I go for schematic, then it will show the actual threads there. You don't need to manually make any thread here. In design library parts, bolts and nuts will show by default threads. You just need to select the type of thread display here. If I select simplified, threads will not be displayed. If I go for cosmetic, not an actual thread but an illusion of the threads will be displayed here. And if I go for schematic, the actual threads will be displayed here. So I'll change the thread length here. We are having only two options given here, 38 and 75. I'll select 38 only now. You can later change the thread length also. So before saying OK, again we'll go through the configuration here. You can see the size given here is M16. Finish given here is washer face. Length of the bolt, that is shaft length, it is shown as 75. Thread length, it is shown as 38 mm here. And type of thread I have taken here, schematic. Say it OK. So as soon as you say OK, it will show that part one more time, asking whether you have to repeat this part or not. If you don't want to repeat this part, just go and say close option here. Now one bolt has been displayed here. Suppose if I needed to change the length here or type of washer face or else the thread length or anything, if I want to edit this configuration again, I'll right click on the bolt and say edit toolbox component. Select the option there. So you can see here at the left side, again the configuration items are showing here. If you want to make changes, you can make the changes here, or else we will say OK and come out of the option. So after calling bolt, I'll call the nut here. Same option design library. I'll go at backside, one step backside. Again you are having options here. Nuts. So in nut folder, there are different type of nuts being showing here. Hexa nuts, hexa nut with fine pitch, prevailing torque nuts, and simple hexa structural nuts. I'll call this hexa nut. Now the size for the bolt was taken M16. I'll go for the same size with the nut option also here. I'll select the M16 size. You can see the finish here, it is showing as washer face. If I don't want washer face, I'll say double chamfer. So at both the cross sectional ends, it will have simple chamfer faces. Again, if I change the type here of the finish, you can see washer face. At one side it will show washer and at the other side it will show chamfer. So whatever requirement you have, you can change the option here. I'll go for double chamfer only here. So our bolt was M16 size and nut is also M16 size. Say it OK. I don't want any copy of this part, so I'll say directly close. But you can see the thread display is not been shown here. It is because it was kept simplified only. So I will change the thread display here. Right click on the part, say edit toolbox components. Again in thread display, I'll go for schematic threads. Say it OK. And now we'll go for the concentric mate here between bolt and nut. For that I'll go for mate options. Select the circular face of the bolt and the other circular face of the nut. You can see concentricity has been applied here. Say it OK. So after concentricity, we'll go for limit distance mate here. By double clicking the part, you can see the threaded length, it was given 38 mm. So I want this nut to travel from the backside face till the end of the threads. The distance was 38 mm. So we have seen in advanced mates, we can apply the limit distance mate. Maximum limit will be 38 and minimum will be 0. So the required faces to apply the distance mate here will be back face of the bolt and front face of the nut. So to apply distance mate, we'll go for mates option. Select the advanced mates. In advanced mates, I'll go for limit distance mate. So maximum limit will be 38. That was the threaded length here. And minimum will be 0. Select the required faces to apply the mate. Front face of the nut and the back face of the bolt. Say it OK again. Now as we drag this distance, it is not going at the forward position. We will check whether the mate has been applied or not. So here you can see limit distance mate has been applied, but it is not moving forward in 38 mm. Rather than it is moving at back side. So for changing this dimension of the feed, I'll again edit this feature, that is limit distance mate, edit feature, and say flip dimension here. Say it OK again. After flipping this dimension, this nut is following the distance here. So this was the 0 position. So this is 0 position in which the starting face of the nut and end face of the bolt are coplanar, and it will end at 38 mm. That was the thread length here. So limit distance mate has been applied here. Next we are going to go for screw mate. Select the mate option. Select mechanical mates, and in mechanical mates I'll select the screw mate. So two conditions are being given here. Suppose if I raise this option revolutions per mm, instead of taking value 1, I'll go for 4. So now the rotating speed of the nut will be decreased as it will take 4 revolutions to cross 1 mm. But if I go for second option, that is distance per revolution, and if I increase this value, I'll say 3 mm. So now in one revolution it will travel 3 mm distance. So both the options are sounding same, but they are different. In revolutions per mm, if you increase the value, the nut speed of rotating will be slow. And suppose if I increase the distance per revolution, the rotating speed or crossing this path will be faster. But before selecting this value, we'll go for the references in between which the screw mate is needed to be applied. For that we have to select the upper circular face of the bolt and any circular edge of the nut maybe this outer edge, or you can also go for the inner edge here, this edge. Either of these edges can be okay for applying screw mate here. So for nut, I'll select this outer edge, and for bolt selection, I've selected this circular face. So these are the selections to apply screw mate here. After selecting the references, we'll go for this distance option. Again, we'll go for distance per revolution as we want to increase the revolution speed. So instead of taking 1 mm distance per revolution, I'll go for 3 mm distance per revolution here. Say it OK. Again OK. And now if I directly drag this nut here, you can see it will not travel the distance here directly. Instead, we have to go for rotation option. So if I rotate this nut by holding any vertex point at the corners, you can see this nut is feeding forward as I am rotating the mouse outside the screen here by holding the vertex point. So in this way, you can apply this screw mate. First, we have applied concentric mate. You can see the mate history here. First, we have applied concentric mate. Then we have gone for limit distance mate to apply the limit distance. So as the nut will travel only the threaded distance here. Then we'll go for screw mate and select the bolt circular face and nut circular edge. So this was screw mate for you. Next mate we are going to see here is gear mate. So after screw mate, the next mate we are going to see here is gear mate. So to call the parts for gear mates or to call the gears, we are having design library here in which we can directly configure the gear and call the required gears here. So we'll go for design library option, select toolbox option here, say add in now, and here you can see the standards given here according to country. So I'll go for ISO. In ISO, I'll go for the folder power transmission, and in power transmission you will get this option gears. So there are different types of gears been given here: helical gear, internal spur gear, rack and pinion spur, straight meter gear. So I'll go for spur gear here. You can see as soon as you drag the part inside, the configuration option will automatically get on here. So now we have to select the module size here. So different types of modules are given for different sizes of gear. I'm going for module 3. This value does not have any unit. It actually represents the teeth size, overall teeth size. Here the number of teeth are showing as 13. I'll say number of teeth I want here is 20. So now the number of teeth showing here is 20. Pressure angle it is showing here 20. The face width is showing 15. Face width it is showing here 15. So this is the face width. Hub style. Now hub style means if you want to provide a hub for the shaft alignment, suppose I go for the second type B, you can see the hub been provided here. So the purpose of this hub is to align the shaft while rotation of the gear. So if I want to change the hub diameter, you can change the diameter here. I'll say it 45 only. Suppose I want this hub on both the sides divided equally. So I'll go for type C hub. So whatever will be the overall length will be divided equally on both sides. The overall length of the hub is showing here as 50 mm. Now this is important term here, nominal shaft diameter. This diameter will decide how much diameter shaft will be inserted here in between the gear. So I want to change this value and say 15 here. So now the nominal shaft diameter is given here as 15. Suppose again if I want to remove this hub that we have taken for shaft alignment, we can go here and say type style A. It will automatically remove the hub here. And suppose if you want keyway for 100% power transmission and for proper locking of gear and shaft, then you can provide the keyway also here. If you want square key at one side, so now the keyway has been provided here. If I want to provide two square keys, then I'll go for the option square key 2. So now two keys can be provided here. Two slots are been given within the nominal shaft diameter. I'll say it OK. I'll cancel the square keys here and then we will say OK here. Now it is asking us if you want to take one more gear same size or if you want to configure the another gear. So I'll cancel this gear. I just want one piece here. Now we have provided one spur gear here. I want one more gear with larger diameter and more number of teeth. So again we'll go for design library and call the same spur gear again. But this time in configuration we'll change the sizes. So instead of taking number of teeth 20, I'll go for number of teeth here as 40. So it will double the size of the gear. But the module we should keep the same module. It is very important that the module for both the gears should be same only. Suppose I have taken the module for this gear as 3. So I should take the module for this gear also as 3 only. So I'll change this value and say it 3 here. So now the modules of the gears are similar. Then only these gears will engage with each other. Or else this module is changed, the gear teeth will not engage with each other and they may intersect each other. Say it okay again. If I want to cross check the modules, I'll right click on the gear, say edit toolbox components. I'll set the module here 3. Okay. Again for this, right click the part and say edit toolbox component. And now it is showing the module 3 only here. Say it okay again. Now after taking both the gears here, I'll right click this part as this part, the first spur gear, it is showing fixed here. You can see the F sign here. So I'll right click this part and say float. I will keep both the gears in floating condition only here. Now I want one plane that is parallel to both the gears front faces here. So we can see here front, top and right. So right plane is coming parallel to the front face of the gears. So I'll select the right plane and say sketch. We are providing two circles here so as to mount the gears by applying mat on that circles so that they can be stable on that circles there and then we can relatively rotate them each other. So for that I need to show the tooth cut of spur gear 1. I'll expand this model tree here. Here you can see tooth cut option. Just drop down the menu here and say tooth cut sketch show. Now you can see pitch circles are being shown here. We are going to require these pitch circles only. For second gear also I'll do the same process. Expand the model tree, expand the tooth cut option and show the tooth cut here. Again these pitch circles are also being shown here for the second gear. Now I'll make this view normal and select the outer pitch circle and say convert entities. So for the first gear I have made this circle. I'll go for the second gear also. But you can see here as we have converted the entities, it is showing a fully defined sketch. So if I follow the same process for the second gear also, this circle will be converted but it will be fully defined. But I don't want that circle to be fully defined. So for that I am going to manually draw that circle here. I want the orientation of both the gears to be horizontal. That's why I have taken this center point beside this center point only. Now we have to put the diameter. Before that we'll check the diameter of the pitch circle given for the upper gear here. So after clicking this outer pitch circle diameter, the value here it is showing as 120 mm. Same value I will provide for the second circle here, that is 120 mm. And now I want the horizontal orientation, so I'll keep the relation here as horizontal between the two centers of the circles. Next, I'll keep the circles tangent so that the teeth will be properly engaged between two gears. Now we will exit the sketch here. You have to make notice that we have drawn this sketch in assembly zone itself. Next step is to match the gears on the circles. For that we will apply mates here. The mates will be coincide and concentric for each gear with the circle's reference. So we'll start with mates. Select the first circle and the smaller gears front face. Now circle and front face of the gear are coincide with each other. Say it okay. Again the second mate we require is concentric. So we'll select the concentric mate. Go for the selections. I'll select the gear circular face of nominal shaft diameter. And this circle we have drawn. So both the centers of the circular face and the circle will be concentric with each other. Say it okay again. Similar process for the second gear also. First will coincide the face and the circle. Say mate. Select the face and circle. Both of them are coincided. Next we are going to go for concentric mate. Select the selections here, say concentric and OK. Now as we have made this circles tangent, the teeth we can match here. So now we have matched the teeth here. You can hold the vertex point and drag the teeth as required. We have to properly arrange the gears here. We have to make sure that the gears may not flush each other or intersect each other. After placing the gears, we'll go for the mate option, gear mate here. Select the mate. Now the gear mate comes under the mechanical category. I select the mechanical mates. Go for the gear mate. Now for the reference selections, we'll select the internal circular faces here to apply the gear mate. As soon as you select the internal faces for applying the gear mate as a reference, the ratio option will be highlighted here. So in ratio option, you have to take the ratio as equal to number of teeth. So number of teeth for the first gear were 20. So I'll select the ratio here as 20. And number of teeth for the second gear was 40. So I'll select the teeth ratio here as 40. So this ratio will depend on number of teeth we have taken for the first gear and for the second gear. First value will stand for the first gear number of teeth and second value will stand for the second gear number of teeth. Say it OK. And suppose if you don't take the similar values, this gear may collide each other and will not rotate relatively here. So that's why it is compulsory to take this ratio according to the number of teeth given for the first and second gear. I'll say it OK here. And now when you move or rotate the gears relatively by holding the vertex point, you can see, so even if the gear sizes are different here, the second one is bigger and the first one is smaller, even then the relative motion will be applied here between two gears. We'll hide the sketches first. And you can see the relative motion here. I am rotating the first gear and the second gear will automatically be rotated by the help of gear mate. This relative motion is because of gear mate only. If I reverse the gear, the second gear will also move in reverse direction. So this was gear mate for you. So this was session 17 in which we have seen mechanical mates that were screw mate and gear mate. Please do like, share and subscribe. And for more videos related to SolidWorks, we have provided complete playlist in our playlist option. So you can go for sketcher, part modeling, assemblies. Each and every module is covered in playlist. So please go through the playlist and you will get all the options related to SolidWorks there. Till then, thank you. So hello everyone. Today we are going to take mechanical mates. In mechanical mates, we are going to cover rack and pinion mate, hinge mate and cam mate. So to start with rack and pinion mate, I am going to refer design library here. In design library, we are going to take toolbox option. And from toolbox, we are directly going to call the required parts for rack and pinion. That will be rack gear and pinion gear, that is per gear. So to start with, I'll say add in now. Standard, I am going to select here ISO, power transmission, gears. So in gears, first I'll call rack gear here. Rack means a straight profile gear in which we have to mention the module. Module is overall size of teeth. It doesn't have any unit here. So the module I am going to take here is 3. Next parameter we are going to see here is face width. It is showing 15 mm here. So this is the face width here, the width of the object. Next important parameter here is length of the rack, that is 300 mm. Suppose if I want to change the length of the rack, then we'll select this part, say right click, edit toolbox components, and in rack we'll provide the length here as 550 mm. We have to remember that we have taken module value here as 3. Say it OK. Next part we are going to call here is spur gear, which is going to run with reference to rack and pinion arrangement on this rack gear. So we'll call the part here from design library. Say spur gear here again. In previous videos, we have seen gear mate and we have seen what are the parameters for this spur gear there. So you can refer that video also, the previous video in playlist. So for spur gear also we will continue with the same module, that is module 3. Number of teeth here it is showing as 40. I'll change this number of teeth and say 25. So the number of teeth here is showing 25. Hub style, that is type A only. I'll keep this hub style type A. If you want to change the hub style, then you can go for type B. Hub means one extrusion will appear here. So hubs are used to maintain the alignment of the shaft when the gears are rotating at high speeds. If you want to change the diameter of hub, you can change the diameters also here. You can control the style of hub. If you want both sides, then you can go for the both side option here. Suppose I want to change the length of the hub. I'll say it 80 mm. So this hub length is 80 mm now. Nominal shaft diameter here it is showing as 15 mm. You can see here nominal shaft diameter is 15 mm. I will remove the hub here. I have taken that hub only to show you what is hub and how to customize the hub. We don't require hub here. I'll say it okay. So we have configured the gear also here, per gear. Now the first mate we are going to apply here is, coincide mate between front face of the gear and the front face of the rack gear. Will flip the direction. Both the faces are being coincided here, but they are at opposite directions. So if you want to coincide them in same direction, then we'll flip the dimension of the alignment. Say it okay. Now you can see both front faces of the gears are coplanar now. So after making coincide and coplanar the front faces of the gears, we'll arrange this gear, take this gear at upward side, keep the rack normal here, let that gears be engaged here. Next, we need to show the pitch circles here. So we'll go in spur gear option in model tree. So we'll select this spur gear part in model tree, and you can see the tooth cut option here. And in tooth cut, you have to show the sketch here. By expanding this arrow, you will get this tooth cut sketch. You just need to show it. Then the pitch circles for that gear will be shown here. So we will require to show this pitch circles here. It will also highlight the center of the pitch circles here. So after showing the pitch circles, we'll go in mate option. We don't need to select any mate directly. We have to just give the selections between which we want to apply the mates. The selections will be center point of the pitch circles we have shown here in sketch. So I'll select the center, and the second selection will be edge of the rack. Suppose if this gear directly comes down here, it may not apply the rack and pinion mate here. That time you just need to do one thing, that is to close the software completely and again restart the SolidWorks and then apply for the same steps. So I am going to do that only. So we have restarted the SolidWorks and completed the back steps here. Again we are going to start with the mate, and what we were going to do here is select the center point and the rack's bottom edge here, and whatever distance it is showing here, we just need to select the icon of distance and apply whatever the distance is coming between this point and line here. If this gear again comes down, we have to repeat the same process, that is to close the software and restart the software again and then repeat the mate. I'll say it okay here. So here we have applied the distance mate. We have not counted any distance, we just clicked on this point and edge. Whatever distance came, we just applied by saying it okay. And now we are going to go for mechanical mates. And in mechanical mates, we are going to go for rack and pinion. Select the rack here as this linear edge of the rack gear, and pinion here as the pitch circle, outer pitch circle of the spur gear. We have given the selections of the references required for the rack and pinion mate. I'll say it okay. And now if we drag this part here, you can see this gear is following the teeth of the rack and traveling in between the rack here. Suppose if I want these two parts to be moving in relative motion with each other, then I'll provide one more part here. I'll provide one shaft. You can see here the diameter is showing here at the bottom. So what we'll do is we'll make one part or shaft here with diameter 15 mm. So I have already made this part here. We have browsed the part and we are going to assemble this part in nominal shaft diameter. For that we are going to select mate. We will say concentric mate between shaft and circular hole here. Say it okay. To align the shaft between the gear at the centers, we'll go for advanced mates and select width mate here. In width selection, I'll select both the faces, both the side faces, in the gears both the side faces. This part or shaft is been centered aligned here. Say it okay. And now as we have called this rack gear as the first part. This part was fixed. You can see here. You can see here rack gear. The F sign is showing here, highlighting that this rack was fixed. So I will float this rack first, and I will fix this shaft only here. It is compulsory to make one of the part fixed. Then only we'll get the relative motion between the spur gear and rack. So I'll fix this shaft. And now if I drag this rack here, you can see gear is also been dragged. But the motion of the rack gear, it is becoming inclined. So to solve that, we'll go for parallel mate. So for the selections, I'll apply the mate. And while applying the mate, we'll open this pin part and take the top plane of the pin parallel with the bottom face of the rack gear. Now you can see parallel mate has been applied. Say it OK. Again OK. Now this rack gear is also stable. You can drag and see rack and pinion arrangement and motion has been applied here. I'll hide these sketches here. So in rack and pinion arrangement, one part will rotate and the other part relatively will reciprocate with the first part. So that is rack and pinion arrangement. The example you can have here is the steering wheel of the four-wheeler. You can also refer the rack and pinion example as we have seen the glue sticks here. As you rotate the glue stick from the bottom, that tube will come outside in linear motion. So that circular motion at the bottom will be converted to linear motion. So in this example, we can call that relative motion as rack and pinion mechanism. Steering wheel of four-wheeler is also one of the example. As you rotate the steering wheel, the axial wheel of the steering wheel will reciprocate there. So that is also one of the examples of rack and pinion only. So the next mate we are going to see here is cam mate. For that I'll browse the parts. I've made some parts for cam mates. So first I'll browse the cam base here. I've made the circular base. For different machines this cam base may differ in shape and size. I have made it circular one. As it is the first part of assembly, I'll right click this part, say float, and then we will apply the coincide mate between the first part origin of the assembly and the assembly's origin. This will make all the planes at the center alignment. You can see all the three planes of assembly and first part are now been aligned here. Then we will go for the next part. I'll insert the next part here. We will consider it as cam piston rod. Say it open. And now we will make these parts concentric. Say OK. We will keep this motion in continuity. Next part we are going to call here is cam body. Say open. Will coincide the front flat face of the cam body with the flat face of the cam piston rod. Both the faces are coincided, but the alignment is opposite. So I'll flip the mate alignment here. Say it OK. And now both these faces are coplanar with each other. You can see here, both the faces are coplanar now. Next part we are going to call here is cam shaft. Before that we will revise once again what mates we have taken here. So the first mate was coincide mate. By coincide assembly's origin with the first part origin. Second mate was this concentric mate. You can see parts are highlighting the required surfaces selected for the mate. Then the third mate we have taken here as coincide mate between these two faces. Next part we are going to call here is cam shaft. Select the cam shaft, say open. Again mate. Make this cam shaft concentric with the cam bodies hole here. Say it OK. Next we will apply the width mate for the center alignment of the shaft. Select the mate option. Go for advanced mates width. Select the required faces of shaft. Same for the body here. And this shaft is center aligned now. Say it OK. Now you can see this shaft is moving horizontally. So I want to make this shaft align with the cam piston rod. so that it should not move horizontally here. For that, I'll make coincide the center plane of the assembly with the center plane of the shaft. We will go for mates. We will select the front plane of the assembly first, and same orientation plane for the shaft. That will be right plane here. So both these planes are coincide now, you can see here. So if I coincide this shaft plane with the assembly's plane, so this shaft will stop moving side by side here. Say it OK. And now if I drag the shaft at the sides, you can see it will not move as the center planes of both the assembly and shaft part are being coincided there. Next, we are not having any standard height for the cab shaft to be placed. So I will randomly place the shaft here. Say right click on the shaft and I will fix the shaft here. As the shaft is fixed now, it will not move vertically also now. It will not move vertically also now. You can see the cam movement around the shaft. All the parts are moving in condition except the cam base and cam shaft. Now we will again see the history of the mates we have given here. First mate was assembly's origin with first part origin. Second was concentric mate. Third was this coincide mate. You can see the faces highlighted there. Fourth was the concentric mate between cam shaft and cam body. Fifth was the width mate. And now the next mate we are going to take here is cam mate, which comes under mechanical mates category. Select the mate option, go for mechanical mates and select the cam mate here. In cam mate, first we have to select the cam path here. I'll select this as a cam path, the side faces of the cam body. And then we'll go for cam follower. For that we will select this round portion of cam piston rod. Say it OK here. And now as I rotate this part, so as we rotate here, you can see this cam piston rod is tangent with the cam path. So it will follow the cam path here. As we rotate the cam body, you can see the reciprocating motion there. So here the cam mate has been applied. So this was cam mate for you. So the next mate we are going to see here is hinge mate. So to start with hinge mate, I'll browse the parts here. I've already made some parts for hinge mates. I'll select hinge 1. Now this is the part hinge 1, which is having 3 knobs here. I'll call the second part also. The mating part having 2 knobs here. Now both of them are lying at the similar sides. We'll rotate the second part. Here you are having rotate component option, by which you can rotate the part orientation without applying mates. So I'll select the rotate component option here and I'll rotate this part orientation. Say it OK. And now we will go for hinge mate. For that we'll select the mate option and directly go for mechanical mates and hinge mate. So hinge mate is nothing but combination of 2 mates, that is coincide mate and concentric mate. Both these mate can be applied at one platform here, that is called as hinge mate. It comes under mechanical category only. So for concentric selections, I'll select the circular faces here. And for coincide selections, I'll select the alternate faces which are going to be engaged as these hinges will be put together. So I'll select this face here. And the other face, I'll select this face of the first knob. Say it OK. And now you can see hinge mate has been applied and both this part are engaged together with hinge mate. But we can also see this part is rotating here completely 360 degrees. So we'll apply the limit angle mate there. From advanced mates, I select the mate option, go for advanced mates, select the limit angle mate. So the maximum angle I'm going to select here is 180 degrees and minimum angle will take it as 0 degrees. So the selection of reference faces I'm going to give here is internal faces. You can flip the part orientation as well as you can flip the part dimensions also. You can see here, say it OK. And now as you rotate this part, it will go for the maximum angle here as 180 and minimum 0. Now it will not completely rotate there as limit angle mate has been applied. So this was hinge mate here. So these were all the mechanical mates. In next lecture, we are going to continue with some more commands related to assembly. Till now, we have completed all the mates. So to learn all the mates, please go through the SolidWorks playlist given there. Till then, thank you. So now we are going to start day 19, in which we are going to complete all the assembly commands. So we will start with exploded view first. Select the command from the upper ribbon here. There are two types of steps given here. First one is regular step and second is radial step. So if you want to explode the part according to the axis direction, then we will go for regular step. And suppose if you want to explode the parts at one time in multiple directions, then we'll go for radial step. So I'm going to select first regular step. The first part I'm going to explode here is the last part which I have mounted in the assembly. So I'll start with this nut. Select the nut and drag to the axis direction in which it was mounted. After exploding and dragging each part, we have to say done here. You can see at left side, and then only go for the other part. Select the next part. Again drag the part in the required axis direction. Say done. Then the other part, which I am going to take this nuts out here. So select all the nuts together only. And then drag the part according to the axis. Again say done. Next part here is the retainer plate. I'll select the plate and drag the option there. Say done. Now this elliptical plate is mounted on the shaft and it is little bit inclined. So I'll select this part and you can see the center point here, it is showing in white color. I'll right click on the center and say exploding align with the component origin. So we have to select this option, align with the component origin, and then we'll drag this part here so as to explode the part according to the direction mounted on the assembly. Say it done here. Then the next part, I'll take this shaft, drag it according to direction, say done, and then go for the last part. As there was no space for dragging the shaft, I'll drag this part only here, say done. Again select the shaft and take it little bit forward so as to place it in proper space, say done. And now this assembly has been exploded here. I'll say it okay. Next thing we are going to provide here is routing lines, which will resemble the assembly, how each part is been assembled with the alignment of the other. For that we have to select the faces which are going to be aligned there. You can see the opposite directions are being shown by the arrows here. We'll click on the arrow and put it in the same direction. Then this handle is going to be assembled with this retainer plate at the center. So I'll select this center face. Then this plate is going to be assembled with the shaft. So I'll select this shaft face here, circular face. And then the shaft is going to assemble in this part, circular part face. So now the line diagram for routing is completed here for one set. I said okay. Next, these nuts, put the arrows in same direction. The other nut, change the directions properly. Then the last nut. Again the items to connect. This retainer plate is going to be aligned with this holes here. So I'll connect that holes also with the routing line. Select the required face. Put the arrows in same direction. Say OK. Then the second hole. Direction of arrow. You just need to say OK for the one time only. Then this space will be empty again. And you can again give the selections there. So now these routing lines are also been provided there. Say it OK. And now you can see all the parts routing lines are being shown. We'll finish this by saying it OK again. And now this part has been exploded. We'll say it exit sketch. Okay, this one part was remaining showing the routing lines. So I'll give the routing lines for this part also. Select the bottom arrow of exploded view option again. Go for explode line sketch. Then again put the routing lines here. So this plate is going to be mounted on the shaft. That's why I've selected this circular faces. Again the other two faces. You don't need to select all the selections together. At a time show only two faces there. Say OK and again go for the other two faces. That will be the proper way. Just check the arrow direction in between. Now it is showing proper way. Say it OK. And now all the routing lines are being provided there in assembly, showing the alignments. Say it exit sketch. And now when you click on the title of the assembly, so we'll go on this title, say right click. Again we will click on collapse here. So this assembly will be reassembled or unexploded again. If you want to see the exploded stretch, go for assembly option, say right click and say explode. It will repeat or show the exploded view which we have made earlier. Again say collapse. Again right click and say explode. So in this way this exploded view has been saved in the assembly. So anytime you can go and collapse and explode the assembly view. If you want to see the animation of the explode cycle, you can right click on the title again. Go for animate explode. Now it will show one by one how this part or assembly has been exploded there. If you want to see it in a loop mode, here there is an option animation controller. You just need to select playback mode and then again say play. If you want to slow down the speed of the animation, say slow play. And you can see how these parts were assembled here. So in this way you can save animation as well as save the exploded steps there. If you want to record this animation for a purpose to send or share, then you can say save animation here. We will show the path in which we have to save the file. I'll say desktop. If you want to change the assembly or animation name, I'll say butterfly wall. Then say save again. Say it OK. Now this screen will buffer a little bit, saving the animation. At least you have to wait for one cycle to be completed there. I'll say stop again. And now we'll minimize the screen there. And here the butterfly wall animation is been saved. I'll right click and say it open with media player. And now you can see the animation being played here. The display will not show any reference of SolidWorks here, neither model tree nor that ribbon. Only this animation will be saved here. So in this way you can save the animation and share the video you require. So this was exploded view here. Right click, explode. Again right click on title and say collapse. So the next assembly feature we are going to see here is mirror command. So that option of mirror you will get in this linear component pattern. Here it is given linear component pattern, circular pattern as well as mirror components. We have not seen linear component pattern and circular component pattern. If you want to pattern the components, you just use the same method as we have used in part modeling. So we'll start with mirror commands here, mirror components. In components to mirror, I have to select this part. I have made this part specially for mirror command only. You can see here, these pillars colors are matching with the UCS colors XYZ. First, we have to select the components to mirror and then select the reference plane. So I'll select this as a reference plane, this face. Then we have to click on this option, that is next. As soon as you go for the next, these options will appear there, showing the way how these parts are going to be mirrored here, according to the boundaries of the box or according to the center of the mass. So this mirror command is little bit different as compared to features mirror command, in the sense that it is having orientation options here. So you can see the first orientation. I'll select the center of bounding box so as to understand the command. It is showing all the axes at the similar sides. Say it OK. You can see X, Y, Z are at similar sides and this mirror part has been created here. Again say edit feature, select the second orientation and OK. Now these cuts position are being changed here and these green pillars are showing at the similar sides. It means that this object is mirrored but oriented along the Y direction, that is along the Y axis. Again say edit feature We'll see the next orientation. This time it is x-axis, as this both the shafts of red color are at the same sides. So again this part is mirrored but along the x rotation. You can see this cut is coming at the other side, at the upper side, as it was rotated along the x-axis. Again next option, the last orientation, that will be along z-axis, around the z-axis. You can see here both the axes are showing at the similar direction, and this cut, it is rotated in this way around the z direction, and that's why this slot is coming at the upper side. So in this mirror command you can orient the object along the axis you require, which is not possible in regular mirror command as we used in part modeling. That's why it is little bit different, but the patterns, linear component pattern and circular component pattern, are similar to part modeling. That's why I am not repeating that commands again here. So this was mirror command with different orientations. Next thing we are going to see here is configuration of parts. So to configure the part means, suppose if you have made configuration for this part, I can make it in different sizes and update the part according to the configuration. So to start with the configurations, I'll open this part, and now after double clicking you can see the dimensions of the part here. The center to center distance here it is giving as 300 mm, and this diameter it is showing here as 112.5, the outer diameter. So we will update some of the values here and configure this part in two different sizes. So for configuration, you can see in left side the model tree is given, and above the model tree here the third option is given as configuration manager. We have to select this option here. The part name is being displayed here, that is arm, and the current configuration here it is going on is default configuration. So to create another configuration, I'll right click on this option, say add configuration. We have to provide one name here. I'll say config 2 here, configuration 2. Now there are two configurations. First one is default and another one is configuration 2. So in the second configuration, I'll double click on these parts so as to edit the values and change the sizes. Suppose I want this distance to be shortened here. Double click on the distance and this box will appear. If this box is not appearing, again cancel the dimensioning option, double click the part again, and again click on the dimension. Suppose it is showing a single box here, this is not of a use. Select the part again, double click, and this box, we need this box only. You can see one drop down menu here. Select that option, go for this configuration. Instead of saying all configuration, I'll select this option, that is with a single box. And here I'll change the value. I'll say it as 180. Say update. And now this handle size has been updated here. Suppose now if I double click on this default configuration, it will show a different sized arm. Again go for the next configuration by double clicking. This is showing the same part with different configuration. So in this way you can update the configurations. I'll go to home by clicking on this option and I'll save this part. Say Ctrl S, and now this part is having two configurations here in configuration manager, default configuration and configuration 2. Now we will see how to update this part in assembly also. So I'll save this part and shift to assembly. Now in assembly, I'll right click on the part and say configure component. In configure component, you can see the configuration option. Select this drop down menu and instead of default, I'll say configuration 2. Apply and OK. Now here the handle is showing in a little bit smaller size. That was our configuration number 2 for the handle. Again, if you want to update this configuration, right click on the part, go for configure component and again say default, say it OK and apply. So in this way we have configured this part. We'll repeat this configure option for this nut also again. So I'll say open to this part and here we will change the size of the nut. Say configuration manager, right click on the title, say add configuration and go for one name here. I'll say nut 2, say OK, and now double click on this part. If you want to change the size, double click on the value, and in this value say this configuration option only. It is compulsory to update this option here, then change the value. So I'll change this value again. I'll say it 50 only this time. Update this part. Now there is default configuration first and the second configuration. I'll go to home and save this part. Again go to assembly, and for configuring this nut now, click on the nut, right click and say configure component. Here we have nut 2, apply and OK. So now this nut size has been updated here. Again, if you want the similar size of nut as it was earlier, right click on the nut, go for configure component again and select default nut. Say apply and OK. So in this way you can configure the part and display it in assembly also. We can also make configuration of assemblies here. So for the configuration of assemblies, we'll go for configuration manager in assembly itself. Right click on title, say add configuration. I'll say assembly with second handle. I have given the title here, say it OK. And now there is default assembly and assembly with second handle. So in this configuration, I'll update this handle size. We already have the configuration of this handle. I'll right click on this part, say configure component, and now you can see assembly configurations here. So in assembly with second handle, instead of default, I'll select configure to, apply and OK. Now you can see assembly with second handle and default assembly. There is a difference of handle size. As I click on default assembly, the handle size is changed here. Again go for the second configuration. This handle size is again changed here. So now we are having assembly configurations also with different handle sizes. So this was part and assembly configuration. It is very useful tool if you are having similar parts but of different sizes. You can just configure the part, accordingly configure the assemblies. So this was the session for today. That was session number 19. So in next sessions, we'll start with sheet metal work. Till then, thank you. So hello everyone. We are going to start with sheet metal today. For that, we are going to see some theory before starting the sheet metal in SolidWorks. So I have some theory here. We'll go through this theory so as to understand what commands we are going to see and what reference points we are going to need it there for executing the commands. So to start with sheet metal, here is some introduction about sheet metal. What is sheet metal? Sheet metal is one of the shapes and forms in metal that can be bought in. Sheet metal is any metal that is in the form of sheets and has thickness range of 0.15 to 6 millimeters. So what does it means? That sheet metal thickness ranges from 0.15 mm to 6 millimeters. We can go above 6 millimeters also for the sheet metal thickness, but then it may be considered in weldments, or else the metal property should be ductile enough so as to provide bend in sheet metals. Then we can go above 6 millimeters for the thickness range. Sheet metal manufacturing is the process of creating sheet metal parts by cutting, bending and forming. So these are the basic operations which are used to form the sheet metal parts, that is cutting, bending and forming. Sheet metal is a thin, flat form of metal. It is shaped by rolling methods such as hot rolling and cold rolling. So there are different methods to provide sheet metal parts. One of the two major methods are hot rolling and cold rolling by using different kinds of cold rolling or hot rolling equipments. Now you can see one image is showing here hot rolling process. In the kinds of parts we are going to manufacture in sheet metal. This kind of parts can be manufactured by using sheet metal. So you can see CPU cabinet here, one box, grid boxes, drawers, brackets and multiple parts that can be made in sheet metal. So there are different types of sheet metal operations which are used, such as shearing, punching, perforating, notching, sheet metal cutting, blanking and fine blanking, piercing, slotting, bending. So most of the sheet metal work is dependent on this operation, that is bending. So we will see what is bending. So what is sheet metal bending? Sheet metal bending refers to the process of shaping the metal sheets. Manufacturers bend the sheets to make them easier to use in various products. So basically we are going to bend the sheets at different angles and obtain the different kinds of shapes and sizes of the product. Lastly, the final product will be made. So bending is must to understand. Now here difference of hot rolling and cold rolling process is given. So before learning sheet metal in SolidWorks, you need to understand what is hot rolling and cold rolling process also. So just go through the difference between the hot rolling and cold rolling operations. It is available anywhere on the net. Then here it is shown bending terminology. One piece of sheet metal piece is bended here. You can see. So this straight portion it is shown as flange length, and this straight portion which was earlier then bended was shown as setback. Here this neutral axis portion in between which is bended, it is known as bending allowance. This width of the sheet metal piece is known as bending length. Here the inner side of the angle it is known as bending angle, and the inner side of radius is known as bending radius. Outer side is not known as bending radius. We have to refer bending radius as inner side radius. So always keep in mind that we are going to refer inner side radius as a bending radius. Here it is given a thickness. This is the neutral axis which changes its position after bending. So this is the basic terminology of sheet after bending. So there are some terms which we are going to require, such as K factor, bending allowance, development length. Sometimes K factor, bending allowance, development length formulas and problems are also asked. So you should be prepared for understanding what is K factor, what is bending allowance, and what is development length. So here we will see K factor. The K factor in a sheet metal working is the ratio of neutral axis to the material thickness. Now what it means that K factor you can see here, small t by capital T. So this small t is nothing but neutral axis offset. You can see here, this is the neutral axis, and the distance from the inner side of the sheet metal piece to the neutral axis is known as neutral axis offset. So this is referred as small t, and the total thickness, that is sheet thickness, is referred as capital T. So the ratio of small t by capital T is nothing but K factor. Further you can read here, when metal is bent, the top section is going to undergo compression. You can see here, this top section is going to go under compression here, and the bottom section will be stretched. So this bottom section is stretched here. The line where the transition from compression to stretching occurs is called as neutral axis. So the line where the effect of compression and expansion does not occur or does not have any effect, that is known as neutral axis. So this location of neutral axis will not be same as in middle. It is going to differ depending on physical properties of metal or material and the thickness of the material. So in short we can say the K factor is the ratio of neutral axis, that is small t, and the material thickness, that is capital T. So the K factor is given here, and one chart is showing here different kinds of K factor referred according to the material and properties. So here you can see if the radius is equal to thickness, then aluminum will have the K factor as 0.33. If it is steel, then it is going to have K factor as 0.38. If it is hard steel, then it is going to have K factor as 0.4. And suppose if radius is going to be 3 times the thickness, then aluminum will have the K factor as 0.4. Mild steel or medium steel will have 0.43. Hard steel, the K factor is going to be 0.45. If the radius is going to be above 3 times the thickness, then the aluminum, mild steel and stainless steel, all three materials will have the K factor as 0.5. So all the things are dependent on material properties for K factor as well as the metal thickness. So why the K factor is very important here? It is because we are going to find development length, and in development length calculation bending allowance is required there. So to find out bending allowance, you can see here K factor is must. So this is the formula to find out bending allowance, that is bending allowance BA equals to capital A pi by 180 in bracket R plus KT. So all the initials, the meanings are given here. BA stands for bending allowance, A is for bending angle, R is inside radius, K factor, then material thickness. So K factor plays very important role to find out bending allowance as well as development length of the part. Bending allowance formula is given. You should understand this formula and then go for calculating the development length. The development length formula is given here. LT stands for flattened length equals to A, that is straight flange length, plus B, that is straight flange length of the other side, plus bending allowance. So this part was having two straight flange lengths as well as one bending allowance. So we just have to add all these things, A plus B plus this bending allowance, and you will get the development length. So this was the theory we required to understand before starting the sheet metal work. Now we will go for SolidWorks and go for sheet metal commands. So to start with sheet metal, the first command we are going to see here is base flange. For base flange, you can either make open sketch or you can go for the close profile also. Both are applicable here. So we'll start with base flange command. You can see here. Select the command, required plane, and go for the sketch. I'll make one zigzag cross section here, one joke plate. Provide the dimensions required. I'll say it 50 mm. This one has 25 mm and the other one has 35 mm. Now after putting the values, we don't need to require put up the fillets here as it will take bending radius. So directly we will exit the sketch, say sheet metal and base flange. So in base flange, first option is direction 1. We have to provide the extrude distance here. I'll take it as 50 mm. Provide the reference from mid plane. If you want to reverse the direction of the thickness, you can see the thickness is coming at the outside of the sketch. You can reverse the direction. Then go for the thickness option. I'll put up the value here as 1.5 mm. And I'll keep the same value for bending radius also here, that is 1.5 mm only. K factor as 0.5. So the values we have taken here are extrusion for 50 mm, thickness of 1.5 mm, bending radius of 1.5 mm. Bending radius should always be equal to thickness or more than thickness. It should not be below the thickness, or else the part may be weakened from the bending area there. So that's why bending radius is always taken as equal to thickness or more than thickness. I'll say it okay here. Now this part is completed using base flange. Parameters we have provided were K factor, bending radius, thickness and direction of thickness. Now we will start with new file here. Select the sketch. We are going to make one panel in sheet metal. For that I'll make one base flange using midpoint line here. I am taking midpoint line as because I want all the reference plane to come at center. That's why we are starting the part with center line only or midpoint line only. Say horizontal. I'll take this distance as 300 mm as I want the panel box width to be 300 mm. As I want this panel box width to be 300 mm. Next, sheet metal base flange. Put up the extrusion value here. I'll say it 150 mm. I'll take it from mid plane and then say OK. Thickness here I have taken 1.5 and bending radius also as 1.5. K factor as 0.5 only at this time. Say it OK. If I want to reverse the direction of thickness, again I'll go for base flange. Say edit feature and reverse the thickness. Now you can see the reverse thickness. I'll say it OK again. The next command we are going to see here is edge flange. Select the required edge flange command. And as the name suggests, it will start from the edge side. I'll select one of the edge and put up the height here. Click on the screen and then go for the flange length. So I'll put up the length here as 80 mm. Then we have to show whether this 80 mm is coming from bottom side including thickness or we have to exclude the thickness. Both the options are given here. Outer virtual sharp means including the thickness and inner virtual sharp means excluding the thickness. So I can go for either options here. I'll go for the base option only. Next, I'll go for flange position. So there are multiple options given here for the flange position. If I go for the first option, that is material inside, all things will come inside the edge reference. If I say thickness excluded or material outside, then thickness will come outside of the sketch or selected edge. If I go for the total material bend outside, select the bend outside option, all the bending will come outside the edge reference. So these are the three options given here. First one is material inside, second is material outside excluding thickness, and third one is given as bend outside. Complete bend will come outside the edge. I'll keep material inside. Usually it is referred as material inside only. Then this trim side bends, we'll see it later. Then the other command here, it is given as offset. If I want offset, I'll go for offset. The flange position will take offset distance from the edge. We can provide here the distance required, I'll say 5 mm. So instead of coming from the edge, now the flange is coming by taking offset distance of 5 mm from the edge and then going for the height required. So it is one of the flange position only. First we have seen all these three positions, then we have seen this offset option. Suppose if I put off the option, again it will refer from the edge only. Next, if I want to change the angle, above options are given here as angle. So I'll take this angle as 135. Now it is taking bending from 135 degrees. If I want this length 80 mm to be tangent from this radius, I'll go for the third option here for the flange length, that is tangent bend. Now this 80 mm is coming from the tangency, imaginary tangency line and this particular edge. So in between distance it is coming as 80 mm. I'll again put up the value for the angle as 90 degrees. Next, if I want to edit the radius of the bending, then I can put off this option and go for the editing option for the bend radius. You can also edit the edge flange profile from here. Select the edge flange profile. And then you just need to drag from the bottom sides and provide the distance, whatever you require from the sides. I'll put up this distance at 50 mm here from this side and 50 mm from the other side also. Now this flange is coming at center of the edge. Just finish the option, it will be updated there. Now we can see here gap is coming. It is called as auto relief. This gap is compulsory is to be given. It is because when you bend the flange from the middle portion of the edge, multiple stresses will be developed here and the area of this metal will have shrinkage here. So to avoid the shrinkage from this area as well as to relieve the stresses from this bending here, we have to provide this gap, that is called as auto relief. So this auto relief you can see here on both sides. For that we have to give the values here. So go in edit flange and at the last you can see custom relief type. So here in custom relief type, I have taken the option here as rectangular shape relief type. So that's why it is showing a rectangular shape here. If I want to change the type, I'll say round. So it will take a round portion here. Again, I'll go for rectangle. And this width and depth is totally dependent on the ratio given here, that is 0.5. So what the ratio value here it means is, suppose if I am having a thickness that is 1.5 mm. So if ratio is taken 0.5, then it will take the gap or depth in value as half of the thickness. That's why it is taken 0.5 ratio. It means half the thickness, that is 0.75. You can click and see here, this value is coming 0.75. Also the width, it is coming here as 0.75. And this one is horizontal one is width and the vertical one is depth. Suppose I want multiple flanges together, I'll again go for the flanges option. Select the required flange and you can click on the other edges also to make the edge flanges. All the four side edge flanges are completed here with flange length of 80 mm and angle as 90 degrees. Here you can see the gap as 0.5 mm. It is shown here 0.5. Now if you want to change the gap, you can go for the gap option and say 1 mm. Then this gap is updated for each corner, that is 1 mm. Say it OK. Now you can see 4 edge flanges are given here. Suppose if I go and delete one of the flange, now you can see only 3 edges are showing here. One edge I have deleted here. It is because I want to take this edge of different height here. That's why I have deleted the edge. I'll say it OK and again say edge flange for the second time. You can see I'll go for this edge and put up this height as 130 mm. Say it OK. And now I'll go for the flange positions. You can see blind 130 mm position is taken from the bottom face, including the thickness to the end of the height, and the flange position here it is taken as outside the bend. I'll say it material inside and then OK. So after saying material inside, if you go for this condition at this time, after changing the height, these bends will overlap each other. So to avoid this overlapping, I'll again go for edit flange and here I will say trim side bends and then OK. Now this overlapping side bend is been trimmed here. For that only that trim side bends option is given so as to avoid the overlapping of the bends. Now you can see these 3 flanges are of different height and the other second option we have taken here is of another height. So this was edge flange option given. Now in edge flange, again I'll go for editing this flange, and we can also edit in the way that if I want to delete this relation, say OK, and if I want to add one more sketch here, I'll take corner rectangle here, select the corner rectangle and trim the side bends and then finish. So this way also you can edit the flanges here. You can see I've given one more gap and added one more profile here. Now we will continue with other commands in next lecture. Till then, thank you. So the next command we are going to see here is sketch bend. To start with sketch bend, I have made one base flange here. I'll select this face and say sketch. We have to make one line here from where we have to bend this part. So I'll put up this line at distance of 70 mm. I want to bend this part from the left side and 70 mm distance at 90 degrees. That's why I've made this line here. Now we'll go for sketch bend sheet metal operation. Select the command. In bend parameters, we have to show the fixed face here. So I'll show this fixed face here. Whatever face you select for the fixed face, one dot will appear on that face indicating that this face is fixed here. Now give the required angle. I'll say it 90 degrees only. You have to change the direction, suppose, then click on this reverse direction. The direction will be changed. First we have here bend from center line option. So there are certain options given for the bend position. I'll select the first option here as bend from center line. You can see this bend is coming with reference to center line at the middle portion. But if I go for material inside, this complete bend will come under this line, inside the line. If I go for the another option, that is material outside, only thickness will come outside the line here. You can see here, this thickness is coming outside the line. And if I want complete bend outside, then we'll go for bend outside option. So these are the three options given. First, material inside, second, material outside, and third one is bend outside. Suppose you want this bend at the center, you will go for neutral axis. If you want to change the radius, you can off this default radius option and go for the change in radius. But I will consider it as default radius only, that is 1.5. Say it OK. So now sketch bend is completed here. You can also bend this in this way. Take one random line. It does not need to start from the edge or end at the edge. You can directly make a random line and then go for the sheet metal operation and say sketch bend. In sketch bend again, bending parameters, I'll say this face as fixed face. The opposite face will be bended or sketch bend. You can reverse the directions here. I'll say it OK again. So this was the sketch bend command. If you want to see this part again in a flatten length, then you can go for this flatten option given here. I'll select the flatten. It will roll back the bends and show us the flatten view. Only bending lines will be visible here, that is this line and the other line. If you want to exit this flatten command, you can exit it directly. Again say flatten, it will roll back. But there is one more thing to be considered, that we cannot make cutouts or any operation in flatten view. This flatten view is just needed to observe how the part is shown as flatten. Other than this, we cannot go for any commands here. So this was flatten. I'll exit the flatten again and it will restore the positions. Now if I want to unbend these folds, then I'll go for unfold option here. Select the unfold option. It will ask for a fixed face. I'll say this fixed face here. Then it will ask for the bends to be unfold. So I'll select this bend. The selected bend will be highlighted in sky blue color borderline. Say it OK. Now I've unfolded only one bend here. You can see the difference in flatten and unfold. That is, the bending area will also be shown in unfold, whereas in flatten only bending lines are being shown. So again, if I want to fold this part, we will go for the second option, that is fold. The fixed face will automatically get selected here, as we have selected for unfold option, same face. We just need to show the bends to be folded. So I'll show this bend again. I want to fold it again and restore the position. I'll say it OK. It will go for the same position again. So this is unfold command. This time we'll again go for unfold and fold. Select the unfold. fixed face. I'll select both the bends now, first and second. Say it OK again. Both the bends are unfolded. To refold them again, fold command. Fixed face will be selected by default. Bends to unfold will be this first bend and the other bend. Say it OK again. So this was unfold and fold command here. Now what is the need of unfold here? Suppose if I want to make a cutout here on this bend shape, then I'll go for unfold. Say fixed face, select the bend and say OK. Now you can directly sketch on this face and go for cutouts, such as if I want a slot here, I'll go for center point slot. Take this reference and make one slot here. Put up the values. I'll say it 45. Bending radius as 5 mm. Press Ctrl and select both the points here. Say horizontal. Make them symmetric. And now you can directly go for sheet metal extrude cut option. Extrude cut option is given here also in sheet metal tab. You can go for extrude cut from this side, or else you can go for features extrude cut also. Both are the same things only. I'll say extrude cut. Only one thing, one more option is added here is link to thickness option. So it will cut only the thickness portion here. And now again I will fold it. Say OK. So now one cutout is been provided at the bend here using unfold and fold option. Again I'll say flatten. So this bending area will not appear here. Only lines will appear showing the bending lines. So this was flatten, fold, unfold and sketch bend. Next we will see here is jog command. For that I'll delete this sketch bend option here. And now for jog command also same thing. Jog is similar to sketch bend only. The process of making jog and sketch are similar. Only the difference is it will take two bends here instead of one single bend. It will form a zigzag bend here. For that I'll make one sketch. Select the line and put up the value here. I'll say it 55 mm. Exit sketch and jog. Select the fixed face. Select the fixed face here. We have to put the jog offset value here, that is 20 mm. Now it is taking as 20 mm. I want to change these values to 10 mm. Now the jog height it is showing here as 10 mm. So there are multiple options for taking the height. That is, first one is outside offset. It means this 10 mm is taking from the upper face of the plate to the upper face of the jog surface. Second one is the upper face of the plate to the lower face of the jog face. And the third one is, that is this face and the bottom face. So in these three different ways you can provide the height. Next is jog position. We have seen in sketch bend also this option. Now it is taking from axis bend. If I want to take it material inside, I'll go for material inside. All the bend will come inside the line. Second one is thickness outside. Now this thickness will come outside the line. And third one is bend radius. Say it OK. Now this jog has been completed here. So this was jog option given. We can see the flatten view. I needed to show one more thing here in jog command. For that I have made one sketch. I'll go for jog command. Select the fixed space. And you can see jog is coming here. Offset distance is taken as 10 mm. But practically when you see, there are two bends coming here. So the material should be deducted from the upper side and this flange position should come at the back side here, as the material is being taken by these two bends. But still it is coming coplanar to this face only. So to adjust that, one option is given here, that is fixed projected length. So if I put off this option, the material being deducted here in bends will be shown as it is. But if I don't put up the option here, then it will take the same length for the jog as it was in bottom. So this was very important point here. So you need to control this option as to show it in a natural position or in a fixed position. Say it OK. And here the jog is completed again. Next command we are going to see here is Lofted Bend. It is similar to Lofted Boss command. For that I'll take one new file. Earlier we have seen Lofted Boss in features tab here. Again we'll go for Lofted Bend in sheet metal. But there will be some restrictions. In Lofted feature, there were no restrictions for the sketches to be taken for the loft. Means you can take 1, 2 or 3 parallel sketches and then go for the loft command and loft the material. But in sheet metal, there is a restriction only of 2 sketches can be lofted at a time. Plus the sketches should not be in a closed loop. It should be in an open loop. As well as we have to avoid the sharp corners in the sketches. So we'll go for lofted bend here. I'll start with the top plane, select the sketch, say center rectangle here. Put up the values for the required rectangle. I'll say 200 mm and this side as 150 mm. Select the fillet command and avoid the sharp corners here. It is compulsory to avoid the sharp corners for the lofted bend command. In lofted boss, it is not needed there. Say it OK. We have to make it open loop, but now it is showing as a closed loop. For that, I'll make one line, one center line, and then offset this line at both the ends. Say offset, I'll take a very minor value here, say as 0.2 mm, bi-directional offset on both the sides. Say it OK. Now I've taken this offset and line just to trim the object. So I'll make this as a reference line, both the lines. And then go for trim option. So we have trimmed the option and now the sketch here, it is an open loop. It is not a complete closed loop here. Again exit the sketch, reference geometry and plane option. In first reference I'll select the top plane as I need to make the sketch parallel to the first one. I'll take one plane here, say OK and then go for the sketch command. Select the sketch. I'll make one circle. I'll say it 130. Convert entities. And say OK. I'm converting these lines again here. Show it in construction mode. We have converted this line just because we want to trim the circle also here as we want an open profile. No needs of fillet as it is a circular shape here. Say exit sketch and all my condition for making a lofted bend are completed here. That is making an open profile, avoiding sharp corners and only use of 2 sketches. More than 2 cannot be lofted here. So I'll go for sheet metal and lofted bend feature. In lofted bend, there are 2 ways for making this part by manufacturing method. First one is by bending or by forming. So we'll see each one. First I'll use bend command here. The open point may be of left side or right side. Similar, the other opening point. If I have selected above the left side, I'll go for this option also, left side only. And the lofted bend is been created here. Now there are certain parameters to show the lofted bend command here. First one is chord tolerance. So you can see this symbol here. Chord tolerance means when you observe at the bottom, it is not a complete circular shape. Sheet metal is bended here in the form of chords. So the maximum distance from the sketch to the chord, it will come at the mid portion here. You can see here from one end to another end, one curve shape is coming and the maximum distance between the chord and the curve shape, that is called as chord tolerance. So you can go for the chord tolerance. I'll put up the value here as 1 mm. So now this chord tolerance, maximum distance between chord and the curve is increased, that is 1 mm. But the sharpness of the loft is been decreased here. So if you want more sharp value, decrease the chord length here. I'll say 0.3 mm only now. As I will decrease the values, I will get more smooth lofted bend here. Second option given here is number of bends. So instead of chord tolerance, I can go for number of bends at each corner. Now it is showing number of bends at each corner as 2. That's why only 2 facets are being created here. At first corner this 2, then this second, then this third and this fourth. But if I create this loft in this way, the smoothness will not be there at the bottom side. So to increase this smoothness again, I'll increase this value here. Facet value I'll increase and say I want 20 bends at each corner. Now you can see the end side, the smoothness has been increased here, and then proper lofted bend with smooth edges will appear here. Next, segment length. Now this segment length option refers to the length of this portion from one end to another end of each bend. So I'll decrease this segment length to smoothen the part. So in segment length, we have to decrease this value. In chord tolerance also, we have to decrease this value. In number of bends, at each corner, we will increase the value so as to make this part smooth. Last one is segment angle. So you have to put angle between each bend here. So it is taking 30 degrees. The limitation for angle is above 5 degrees and below 90 degrees. So I'll put up the value here as 10 degrees. It will again smoothen the round portion here at the bottom, and the lofted bend will be created there. I'll say 6 degrees only here, and then say OK. The method we were using, manufacturing method, was bend, and these 4 options. At the bottom side you can see bending radius and sheet metal thickness parameter is given. If you want to change them, you can change them here. After completing, say it OK. It may take some time to resolve this, and now you can see one lofted bend has been created. So at the corners in each bend, the angle between two bends is 6 degrees taken here, and then made this part. So this lofted bend command will be used for making hoppers in sheet metal type. The other way, we'll see the other way now. I'll delete this lofted bend. Again go for lofted bend command. But manufacturing method, this time I'll select form 1. Select the profile similar way as that of bend. I'll select the left point of the above sketch, same as the left point of the below sketch. Don't go for alternate point selection. It will not make a loft. Instead, it will show an error there. So similar side points are being selected and lofted bend using form command is been made. It is very simple to make by this method. Say it OK. And now this lofted bend is completed here. I'll make it flatten. You can see here in a flatten view also. Now I'll show the practical images of lofted bend where we can use in sheet metal. You can see this part. This is also made by lofted bend only and then flatten. Again we'll return to software. Exit the flatten view. So this was the lofted bend feature here. Next feature we are going to see here is vent option. Sheet metal vent. For that I'll make one part. Suppose I need to make one control panel box there. So I'll go for the sketch, front plane, say midpoint line, put up the values required. I'll say 300 mm. Go for sheet metal base flange, put up the thickness as 1.5 and extrude it by 150 mm here or 200 mm, and then say it as mid plane. Reverse the direction of thickness. Bending radius it is taken here as 1.5 and thickness also 1.5. Then we'll go for edge flanges here. Select the edge flange. Select all the corner edges. You can either select upper edge or lower edge. Both are applicable there. It will provide same height only. Put up the height here as 90 mm. Say it OK. I'll again go for edge flanges. Select the flange and I will move it in the inside direction here. First, second, third, and the last one. As we take the direction inside, it will by default take the miter joint here. But if we change the direction by flipping the direction option, it will not take miter joints there. That time we are going to use miter flange option if you want outside flanges with miter joints. But this time I am going to go for inside flanges with miter joints, which is possible to take by inch flanges. I'll say it OK. Now again some flanges, I'll add edge flanges again with vertical heights first, second, third, and the last one. Say it OK. Now one control panel box has been made here. I want to provide one vent option here. Now the purpose of providing the vent, so as the air will ventilate inside the box and all the internal parts inside the control panel will be at a certain level of temperature only. It will not exceed the temperature there. That's why we provide vent here. So I'll select the face and say sketch. I'll select one circle here, put up the value. I'll say it as 68 mm. Define the sketch by positioning the sketch. Put up the required values 50. Now I'll say it offset by 10 mm or by 7 mm. Instead of bi-direction, I'll go for only one direction. Say it OK. Now for vent, I have made these circles. Next, I'll go for lines here. I'll make one line and make this line pattern, circular sketch pattern. Parameters, I'll select the center point, and entities to pattern, I'll select this line and say 6 entities I want here. Say it OK. Now sketch for the vent command is completed here. I'll exit this sketch and select the vent command from sheet metal tab. In boundary we have to show the outer circle only. It will automatically cut the part here. You can see here. And now we'll go for the other options, that is ribs. So in ribs we have to select only that entities which are connected to the outer boundary here. So the entities which are connected to the outer boundary are the lines here. I select these lines as ribs, then provide one thickness value for the ribs. I'll take it as 2 mm. Then we'll select spars here. So you can select spars for the last option also here, or you can select that last option as a fill-in boundary so as to pack this portion here. It will be complete filled up here. So for both the options you can use the last sketch here, that is for spars or for fill-in boundary. One more option was given upper side, that was this radius option below the boundary option only. So I will provide this radius as 0.5 mm here, and all the corners will have the sharp edges removed and radius been provided here as 0.5 mm. So there will not be any sharp edges or corners here. I'll say it OK. And now this vent is been created. I'll hide this sketch here. You can see one vent is been created in sheet metal. So this was vent command for you. We will continue sheet metal in further lectures also. Previously we have seen 2 lectures for the sheet metal. You can go for the playlist option and study the earlier commands there. Please do like, share and subscribe the channel for more content. Thank you. So hello everyone. Today we are going to see form tool command in sheet metal. This is the session 3 for sheet metal. Earlier we have seen all the basic commands such as base flange, edge flange, sketch bend, unfold, fold, flatten, extrude, cut and more. So today we are going to see forming tool operation. You can see here in the above tab. Forming operation, if you just keep the cursor on that, it will show the definition, that is uses the parts that act as a die to bend, stretch or otherwise form a sheet metal. Means we are going to make a simple part in part modeling, and then it will act as a die to bend the part, stretch the part or else to form the part in different shapes. So for that only forming tool is used. So we'll start with forming tool. We will manually make a tool here. I am saying it manually because there is a design library content also in which you can have a forming tool. But I have not added that add-ins while installation. That's why it is not showing me here forming tool option. But in design library also it is available. That's why I referred the word as we are going to make manually the forming tool. So to make the forming tool, I will switch my window to part modeling. Say part. And now in part modeling, we are going to see how to make this form tool. Suppose I want to make form tool as lowers, lances. So what are lowers and lances? So you can see here, these are lowers. This is double lower and this is single lower. For best example to understand lower is when you travel in a train, you can see there is a window like this, and on these windows these projections are made. These are nothing but lowers. These are made for ventilation of the internal systems. So how to apply these lowers, how to make this lower, we are going to see in part modeling there. As well as you can see here, this shape is nothing but lances. These are opening. These are nothing but openings here in zigzag patterns. So you can make lowers and lances in forming tool. You can also make these bridges here. You can see These bridges are given here: peak type bridge, radius bridge, tabletop bridge, special shape bridge, single bridge. We are going to see single bridge today. So these kinds of shape you can make directly on a part by using forming tool. So we'll start with forming tool. How to make the forming tool here? I'll go in part, and here I'll start with making lowers here first. I'll select the sketch front plane. We'll make one center rectangle here. I'm using front plane here. Now it doesn't matter which size of rectangle you require. You just need to consider that the size of rectangle shape we are taking here should be always more than the forming tool size. Thickness you can take as much you want. I'll take it 10 mm only. Say features, extrude boss. And now while extruding the part, I'll extrude it from mid plane here. Now the role of this part is nothing but to add fillet at the outer direction. For that only I have made this base part. Later I am going to delete this part. I'll take front plane here, say sketch. Front plane was lying in between the part, that's why I've taken front plane. Now we will make sketch to form lowers here. Take two lines perpendicular to each other with equal length. I'll say it 15 mm. The other size also 15. I'll say relation between them as equal relation between two lines. Now add one curve also here. I'll take 3-point arc. And we will provide the radius here also as 15 only. Now I have a complete fully defined sketch at mid of the body, that is on front plane. Now I'll make extrude boss here. We will extrude it till 40 mm from mid plane. Say OK. Next, I'll select this face here. Say sketch. And I'll select the face and say convert entities. Now these complete edges are converted to sketches. You can see a close entity is formed here. I'll use it for the feature revolve boss. I'll consider this line as an axis for revolve, and I'll take this angle as 90 degree here. Say it OK. And I'll mirror this portion at the other side also. So I'll take mid plane here. Say mirror command, features to require, and OK. Now this particular feature revolve is been mirrored at the other side also now, and our part is completed. But we have to keep in mind that we have to provide fillets at the edges, as this part is going to be punched in a sheet metal part. That time, for the withdrawal of this part, these edges should be filleted here. If there is a sharp edge, the other part on which we are going to punch the forming tool may get damaged or may have cuts there. That's why we have to provide fillets here around the edges, and it is compulsory that we have to take fillet more than the thickness of the part on which we are going to apply the forming tool. Suppose I have taken this part, we have taken already the part here. So the thickness for this part was, I'll select this edge, it will show me the thickness here 1.5 mm. So I need to select the fillet size more than 1.5 mm for the forming tool. So I'll go for fillet option and select the edges. Fillet is coming around it, and the value for the fillet I'll take here as 3 mm. This 3 mm value has been taken for the fillet, and now you can see why I have made this surface, that this fillet should lie on the particular surface outside. If I would have not made this plate here, this fillet would have come at the internal side of the part. It would have not been concave shape, it would have been convex shape here. That's why I've taken this plate here, so as to make this fillet in a convex shape. Say it OK. Now we will remove this plate here. So I'll select this face, say sketch, and I'll convert that all face here. Now you can see one rectangular sketch has been formed. Say features and extrude cut. I'll completely cut this part, say blind and through all. Only through all is needed there. And now you can see one lower shape part has been made here. Now we will move it to sheet metal tab, and here you are having option forming tool. Select the forming tool after making the part. Now we have to add stopping face. So stopping face is the face which is going to be attached on the sheet metal surface. So I'll consider this as the stopping face, and faces to remove I'll consider the bottom face here. We need to ventilate the air from this part. That's why we need to remove this face compulsorily here. I'll say it okay. Now this color codes will also indicate which phase is of stopping phase and which is to be removed. So red color will represent the phases to be removed and sky blue color will represent the phase to be stopped at the face, stopping phase. Still this part is in a part modeling format only. We have to change it to forming tool. So the upcoming step here is very important. For that we will go for save as option, and during save as option you have to change the save as type. Instead of SolidWorks part I am going to select form tool here. The extension for form tool is given SLDFTP. We have to show the name, we have to save the name here. So I'll keep the name here as form 1 or form tool, and then show the part where we have to save this part. So I'll save it on desktop here. I'll go for desktop option, and on desktop only I'm going to save this part as a form tool name and type also as form tool. So this is very important that you should change the save type. Say save, and now this part is being saved as a form tool there. You can see on desktop the file will be shown in this format, a simple white page written as extension SLDFTP. Now next I'm going to go for the form tool option, and we are going to apply form tool on this part here. So to apply form tool, so here is the option at the right side. Select this file explorer option, and I'll go on desktop to browse. Here we have the name form tool and extension SLDFTP. The window will pop up and also show the appearance of that particular form tool. So I'll select the form tool and directly drag it on the part. Now you can see this form tool has been applied. We have given the stopping phase, so it has been applied on the outer side here, and this form tool orientation is coming at the inner side here. So if you want to flip the orientation, I'll flip the orientation. Now stopping phase will become this internal phase and the orientation will come at the outer side. So wherever the stopping phase is, orientation will come at the opposite side only. Suppose I want to orient it at particular angle, I'll make it horizontal by giving the angle as 90 degrees here. So instead of 90, I'll give it 270 degrees. Now you can see the form tool is been placed. Now I want to position the form tool by giving dimension. For that I'm going to go for position. It is same like as an hole wizard command. So in hole wizard also we go in position and then position the hole. Same way we have to do it here also. Select the references, say 80 mm, and the other outer reference I will take it here as 60 mm. Now I have positioned this part here. I'll say it okay, and now one form tool is been applied here. You can see here this form tool is been applied. Now I want to pattern this form tool horizontally and vertically. For that I am going to go in features tab, select the linear pattern command. In direction 1 I'll keep this direction as 1 and this direction as 2. So for the references I have shown the edges here. Features to pattern, I am going to go and show forming tool here. You just put up the distance and number of entities you require. Here also in y direction, sorry, next direction, and then say it okay. So now this form tool has been applied here. You can see this was the removing phase for air to ventilate, and this was the stopping phase which has been applied at the internal phase here. So this fillet was must, and the value for the fillet should always be greater than the thickness. Compulsory you have to take this value in this format only, that fillet size should always be greater than the thickness given. Now next, again we will go for one more type of forming tool here. I'll say file, new, and part. We'll go in part again. This time we are going to make bridge here. We have seen all the bridges here. So single bridge form type I'm going to make here. This type of bridge. So we'll start here by making a part only. I'll select the top plane, say sketch, center rectangle. The base plate I'm going to make here is only for the fillet, so as to apply the concave shape there, 200 mm. This base plate size should always be greater than the forming tool size. Whatever size you take, doesn't matter. Say it OK. Again, select the sketch and go for center rectangle here. Features and extrude boss. Features and extrude boss. I'll make this extrude boss straight. Say OK. I'll decrease this height here. I'll say 25 only here. Update the value. And now we will delete the corners. I'll draw one close profile here. For the inclination face, I'm going to give the angle here. I'll say it 60 degrees. Features, extrude, cut. Through all cut I need here. I'll mirror this cut on the other side also. The tool we are going to make here is the bridge used as a form tool. Next, we need to apply fillets. So I'll take the fillet here as 2 mm or 3 mm. I'll take a little bit larger size. I'll take it as 5 mm. So fillet should be applied on these above corners and the below corners. All the 4 sides. It doesn't need to apply on the sides here. Say it OK. And now we'll remove this bottom plate, as we have taken this fillet in a convex shape. Just we needed the support for this fillet. That's why we have made this plate. We'll select this face and say sketch, convert entities, features and extrude cut. Cut I'll take through all here. And now the shape of the forming tool is been completed. I'll go in sheet metal, say forming tool. I'll show this as a stopping face and faces to remove. You can see the image here. So at the side faces are been removed here. I'll refer the side faces only for removing. So faces to remove, I'll add these faces, first and second one. And stopping face, I will add this face here as a stopping face. Say it OK. Now this form tool is been made, but still is in a part modeling way only. So we need to convert it by saving. Say save as. I'll save it on desktop only again. I'll give it a name as form 2 or bridge only. You have to change the extension here. I'll save it as form tool, file format SLDFTP and form tool. So it is been saved at desktop. Name is given and type also given. And now we'll go for the part on which we have to apply the form tool. I'll restore this size. So now we will apply the bridge over here. I'll restore the screen. You can see on desktop this bridge part has been saved. I'll drag this part and apply on the face. Maximize the screen. Change the orientation by angle. Flip the required side. I want it to be applied externally. Then position the part here. Say smart dimension. And apply the required position. I'll say it 50 mm from the side. And say OK again. And now you can see this bridge shape is been applied by using form tool here. So this was form tool command. In this way you can apply form tools of different shapes and sizes by customizing the sizes and apply by using form tool option. You just need to keep 2 notes in mind. First, we have to take this fillet compulsory, and that fillet size should always be greater than the thickness. Second, you have to save it as a save as file as form tool only. Then only it will be applied as a form tool. If you save it as a save part, then it will not apply as a form tool there. So we'll continue with gusset command next. So the next part we are going to see here is sheet metal gusset. Gussets are nothing but ribs which are provided to support the 2 perpendicular faces in sheet metal. For that we are going to go for this command sheet metal gusset. Select the required faces for the position of the gusset. You can see here, I'll show you the images first. So you can see between these 2 flanges, one gusset is being provided for the support. You can see here also in this part, these are the sheet metal gussets. There are some more parts here. You can see on this parts also. On this bracket also gusset is being provided. So to start with gusset, select the command, select the two perpendicular faces and gusset will appear there. It will take the offset distance of 50 mm. So the references for the distance will be this end point. You can see this point has been highlighted here. So the distance has been carried out from this point to center of the gussets. For sizes, I will provide the indent depth. It means the overall depth or size. I'll take it as 15 mm. So this indent depth is nothing but the overall depth. It means that the vertical and horizontal distances will be common here. Suppose I am taking it 15 mm. I'll say 20 mm. You can see overall size has been increased here. Suppose if you want to provide individual dimensions, then you can go for profile dimensions option. And here you can provide the individual dimensions for D1, D2 and angle. So I'll take this dimension as 25 here. On the other side also 25. Next, the shape of the front face. If I want, I'll take it rounded gusset. If I want flat, I'll go for this option. That is flat gusset. If you are taking a flat gusset, then edge fillets are must here. And suppose if you are going for round gusset, this option will automatically will disappear. You can see. Next is indent width. This width option. Suppose I want this width of the gusset to be taken as 10 mm. So you can see the change here. Thickness I will keep it as it is. That is 1.5. Thickness should not be changed here. It should be taken as of the part thickness only. Then there is option for side face draft. You can see these two side faces are being drafted here by 2 degrees. If you want to change the value, I'll say 5 degrees here. So you can see here, now the angle between two faces is 5 degrees. Draft angle is being provided, it is because the operation to provide the gusset is similar of forming tool only. So at the time of punching the part and making this gusset, I'll say it okay and show you. So when you punch this part, to withdraw the die which we have punched to make this cavity, if the die does not have any fillets or tapered angle, it may damage the part here and may create cracks here or cut the part as it is a thin sheet metal part only. That's why drafted faces are being provided for the easy withdrawal of the tool or die. We'll go on sheet metal gusset, say edit feature, provide the inner corner fillets. We have provided the inner corner fillets here. You can see in full preview. This option will show the complete preview which is going to come on the part. So we are having inner side fillets. We just need to provide outer fillet here. I'll put on this option also. So there are outer fillets also now been provided. If you want to show this gusset in flat pattern, then put on these options. Override documents and show profile, show center. Then only the gusset profile will be visible in flat pattern, or else it will not show in flat pattern. Say it okay then. Now this gusset has been provided. If I want to flatten this, I'll show it in flatten view. So this was gusset option, same as form tool only. You just need to provide dimensions, parameters, draft angle and two faces for the references. So this was forming tool and gusset in this lecture. There are some more commands remaining for sheet metal. We'll continue in further lectures. If you want to learn the previous commands, just refer the SolidWorks playlist provided on the channel. Channel name is 4 Dimensions Infotech. Please do like, share and subscribe. Till then, thank you. So hello everyone. Today we are going to start with sheet metal miter flange. So to understand miter flange, first I have drawn two edge flanges here. This first set is for vertical flanges and the other second set is for horizontal flanges. So you can see the outcome of these two sets. The corners are not connected here. Means if you want a miter joint, these corners are needed to be connected at 45 degrees, but they are not connected at 45 degrees. Instead, they are showing a 90-degree angle here. So if you want a miter flange, you can see here the title is given, and with that title, the symbol of miter flange is also given. So we want corner treatment like this in miter flange, so that there is a 45 degrees angle between two flanges and there is a small gap between them. But here they are coming at 90 degrees. That's why miter flanges are needed here. One more use of miter flange. If you see the drawback of edge flange, you can make straight flanges only. But if you want to make a flange that is in curve shape, we cannot use edge flanges there. Instead of that, we can use miter flanges there. So that is also one of the use. So to start with miter flanges, first I'll delete this H flange 1 and H flange 2 here. So I'll delete both of them. Now the way to make miter flange is, suppose if I want miter flange on this particular edge, so I need to sketch the face which is perpendicular to this edge. So here you can see this blue edge. So I will sketch this face only as it is perpendicular to the edge. I select the face, say sketch, and while starting the miter flange you have to make a cross-sectional profile for that. So I'm making a profile here. Suppose I want two sets, so I'll go for two lines here, vertical and horizontal. Then put up the required values. I'll say it 100 mm and this one as 50 mm. This line was starting from the upper point, you can see here. Now as soon as I say exit sketch, it will be converted into miter flange, which is going to come on this edge first. So I'll exit this sketch. One more thing to note, that when you start this sketch, you don't need to start it from the bottom point. You must compulsorily start with the upper point here. Then only the miter flange will be created. So I'll exit this sketch here and say miter flange, select the required sketch, and now you can see on this particular edge, side edge, this flange is coming here. So I'll change the default radius if I want to change, or else you can keep the default radius here. Go for the flange position. Now the flange position is showing material inside, and suppose if I want to change the flange position as it was in edge flange you have seen earlier in lectures, so you can change the position also here. Suppose I want material outside, I'll take this material outside. Suppose I want this total radius outside, I'll take this radius outside. So in this way you can change the flange positions here. There is a gap distance being shown here, but it will be shown only when we select this second edge. So I'll select this as a second edge, and now you can see this upper corner, there is a gap which is given here, that is 0.25, I'll say 0.5 mm gap, and the joint here is coming as miter joint, that is the both flanges are connected by 45 degrees angle here. There is no gap such as in edge flange was there. So if you want this kind of corner treatment, we'll go for miter flanges. Also one more thing, suppose I want to edit this sketch and make it a curve shape there. So I'll say edit sketch. I'll change the distance value here, I'll say 30 mm. This value as 80 mm. Now I want a curve nature here, so I'll go for 3-point arc. First point, second point, and third point as required. I'll give it a value here. I'll say it 20 mm radius. One more relation here, horizontal. And now when we exit this sketch, it will get updated there. Say miter flange and select the command. So now you can see you can make curve shape flanges also there in miter flange, which cannot be made by edge flanges here. Again, select the all edges. You can see the corner treatment here. It is completely packed, having only one gap at each corner, that is of 0.5 mm, which we have given here at the left side in model tree. Suppose I clear the selection and only select one edge, and I want to drag this miter joint inside from the corner at a particular distance. Then we will go for start and offset. So I'll put up the distance here. I'll say 20 mm. So you can see D1 is from the sketch we have drawn, this distance, and D2 will be the opposite side distance. I want the distance of 20 mm from opposite side also. So now both the sides are been dragged inside here. Say it OK, and the miter flange has been created here. You can see the auto relief gap. It is in a rectangular shape. If you want to change it into abound, you can change it into abound here. Go to custom relief type in edit feature miter flange, and you can change the option here as abound. Say it OK there. Now it is abound. So earlier also we have explained what is this gap. This is nothing but auto relief gap, which is produced to relieve the stresses which are developed during bending in between the edges. It also avoids the shrinkage of metal here. That's why this gap is given, and the gap value depends on the thickness ratio. So this was miter flange here. I'll delete this and make it one more time. Suppose I want flange on this edge, so I'll go for the perpendicular face, that is this one, front one face. I'll select this face and say sketch, then go for line treatment there, put up the values. I'll say it 70 mm, say it 30 mm here, exit this sketch here, and you can see miter flange has been created. I'll select all the upper edges. You have to note that you have to select only the upper edges. Lower edge selection will not apply the miter flange there. So the corner treatment is coming as miter here. That's why it is called as miter joint. Say it OK. If I want to flatten, I'll go for flatten command here. You can see the corners. Again, exit the flatten. So this was miter joint here. Next command we are going to see here is hem flange. So to start with hem flange, I select the feature here. We don't need to make any sketch for the hem flange. You just need to select the required edges for making the hem. I have selected the left side edge here, and now you can see one hem has been created. There are total 4 types of hem given here. So first we will start with close hem. So this one is close hem. You just have to provide the flange length. So this distance given here is the flange length, that is 15 mm as shown. So this 15 mm will be counted from the quadrant of this circular edge. From this point, the extreme end point of the circular edge, this quadrant point till the straight edges here. You can see in symbol also it is shown. It is been counted from the outer quadrant of the circular edge till the flat face of the other end. So this is the 15 mm distance from this point to this point. Suppose I want to change the distance here. I'll say it 10 mm, and this flange is called as close hem. It is because there is no gap between here. You can see a little bit minor gap, but it is not counted as a gap here. So it will be considered as a close hem only. Next we are going to see here the type is open hem. So in open hem, we have to provide the diameter inside. You can see the diameter given here. So I'll say it 3 mm here, and the length is 10 mm. I'll say it 15. And now this complete hem, you can see the position is coming outside the edge. So if I want this position to be taken inside the edge so as to match the flange base parameter, I'll go for inside hem. I select this option, say inside hem, and suppose I want the bend outside, so I'll go for this option. Next type here it is given as teardrop hem. So this is teardrop hem. It is in shape of a drop, that's why it is called as teardrop hem. In this teardrop hem, there is a limitation of angle. In open hem, the parameters we have given were diameter inside or a gap distance and the flange length. But in teardrop, we are going to give one angle and one radius here. Instead of diameter, we are going to give radius and the angle here. So the angle limit is given here as 180 above and 270 below. So the angle should come above 180 and below 270. I'll take it as 210. This straight portion of the flange will always be bended towards this face. If I change the angle, then also this flange is connected to the face only. I'll change the angle, I'll say 250. Still, the flange is connected here on the face. If I say 190, even then this flange is connected to this face. So these foldings are nothing but hems. We will see the types also here. So these are the types of hem we are seeing there. We have seen flat hem, open hem, and now we were currently seeing the teardrop hem. Next we are going to go for this roll hem. So these 4 types are given in SolidWorks. This rope hem is not given, this type of rope hem is not given in SolidWorks. But if you refer Solid software, then you can get this type of hem also there. Again we'll come to software. So this was the teardrop hem. If you want to increase the curve shape, you have to increase the radius value. I'll say 2 mm or 3 mm here, and change the angle. I'll say 225 degrees, or else I'll say 250 degrees or 230 degrees, or I'll say 210 degrees. Hem inside, and now okay. This was teardrop hem. Now suppose I want to drag this hem inside. I'll again say edit hem feature and go for edit hem width. Drag these points here. Go for smart dimension and select the points. I'll say 30 mm, and on the other side also I'll keep the same distance, that will be 30 only. Say finish, and this teardrop hem has been created here with auto reliefs given, rectangular type. So this auto relief and dragging option is given in all options such as edge flange, miter flange, hem flange. Whatever command you take from these 3, this option is given to drag these flanges inside the part. The last type we are going to see here, that is hems roll bend. I'll select the roll bend, select the required edge, and you can see one rolled hem has been created here. You have to change the angle as well as the radius inside. I'll say 1 mm radius. We'll take 3 mm radius here. And now you can give the angle from 0 to 360 degrees. There is no limitation of angle as there was in teardrop. Suppose I want to edit the hem width. I'll go for hem width, and you need to select the points below points and then drag the hem. Place the required dimension to end the hem at the other side. Say finish, and this rolled hem has been created here. We can see here. This was hem feature for you. Next command we are going to see here is swept flange. It is similar to miter flange only, but in miter flange, corners were created with the gaps there. Ripping gap was given there. But in swept flange, the flanges will be created but without gap. So I'll delete both these hems there. And now I'll start with swept flange. For that I have to make profile on the cross section. Suppose I am going to make one edge flange. Say it OK. And now I select this flange face and directly go for one line here from the outer point. If I want to give an angle, I'll provide the angle also there. I have taken 25 degrees angle and flange length as required. Instead of giving the incline length, we can refer the length from the bottom side to the top end of the part. I'll say it 80 mm here. Exit this sketch and select this swept flange here. Profile, I'll select this line, and in edge profile, I'll select this edge, and now you can see this profile is been swept here along this flange till the end. Suppose if I want to give distance from the end, I don't want it complete on the edge, then I can go for this D2 distance here. Second distance I will provide it as 20 mm. So it will take a gap of 20 mm there. And suppose in start also if I want to give the gap, I will go for this D1 distance. In this way also you can create the flange same as miter. Say it OK. And now you can see one swept flange has been created here with auto relief gaps to relieve the stresses and avoid the shrinkage of the metal here. This was swept flange command. So these were the commands we were going to see today. For further commands or next commands, we continue in the next lecture. You can see the previous playlist for the other commands we have seen here. So till then, thank you. So hello everyone. Today we are going to start with the last session of the sheet metal. We have seen earlier sessions. Now we are going to see development length and corner treatments in sheet metal. So to start with corner treatments, first I will draw one component of sheet metal here. I will take front plane sketch, say midpoint line, and we'll put up the dimensions here. I will say 300 mm. Exit sketch, sheet metal base flange. We'll select the extrusion from mid plane here. Put up the value here as 150 mm. Say OK. Now we will go for edge flanges. First, I'll take complete setup of the flanges. Next, we are going to provide gap here. So here the gap is coming as 0.5 mm. I'll say it 1 mm gap. Say OK. Now you can see at each corner 1 mm gap is been provided between all flanges. So if I want to give a corner treatment for particular corners, I'll go for corners here. Select the closed corner option. Select the faces to extend. So I'll select the left side face. So it is getting extended here, and the other opposite face will be underlapped here. Because the corner type, there are three types given. The first type is butt type, in which both the corners will change together to maintain the required gap to be mentioned here. So I'll mention it as 0.2 mm gap. So both corners will be moved either in minus direction or in plus direction so as to maintain this gap. Suppose I want one side to be overlapped and second other side to be underlapped, then I'll go for end but one or overlap option. So in overlap, the selected face which we have selected it first will be overlapped and the opposite face will be underlapped. And the final gap you will maintain here will be 0.2 mm as mentioned here. Suppose I go for third corner treatment, then it will take underlap. The first selected face will be underlapped here and the opposite face will be overlapped against the first face, maintaining the gap of 0.2 mm. So these are the three treatments given here. First one is butt, second one is overlapped, the selected face will be overlapped, and third one is underlap. The selected face will be underlapped and the second face opposite will be overlapped. So if you want to control this underlapping and overlapping of the faces, you can control it by giving the value of overlap underlap ratio. Now it is taking as 1 mm, that's why it is completely underlap or overlapped here. You can see both the faces are coplanar here. Suppose if I say 0.5 mm overlapping ratio, then the overlapping face will cover only the 50% of the underlapping face. Suppose if I change the value to 1, again it will 100% overlap the face. Means this value is representing the percentage of overlapping and underlapping. I'll say it okay. Now we have given corner treatment at this particular corner only. So if you want to change all the corners, you have to change simultaneously each one. You cannot change at a time all the corners. Suppose I want one more corner treatment here. I'll again select the corners, say close corner, select the faces to extend. This time I will say underlap and the ratio I'll keep here as 0.5 only. So it will only 50% underlap the face, maintaining the gap of 0.2 mm. Again say it okay. Now we have given gap to these two corners here, the first one and the second one. When you flatten the part, these are not having any corner relief cutouts here. You can see here. That's why when the part is folded again, you can see the metal is being folded here. Means the part will have a shrinkage material here. At the other corner also you can see metal is being folded and shrinked here. So to avoid this shrinkage and to relieve the stresses being developed here, we'll go for the other option in corner treatment, that will be corner relief. So I'll select the corner relief option here and select all the corners. Suppose I want to say all corners, I'll say collect all corners here, and then we will provide the type of relief to be given. There are four types. First one is rectangular, second is circular, third is tear, and fourth is around. Constant width is not used much, that's why we are going to refer out of this four only. I'll select rectangular here. After selecting the rectangular type of relief, you have to select the distance or provide the distance here, slot length. So I'll provide the distance here as 3 mm and then say it okay. Now we were having corner treatments on these two sides, but after taking 4 mm size also, this cutout is not covering the full radius. That's why I'm going to change the value here. So instead of editing, I'll delete this option and again go to corner relief option to provide the corner relief gap. The reason for providing gap, this is asked in interview questions, is to relieve the stresses as well as to avoid the metal shrinkage here. So you have to keep in mind the reason we are going to give for the corner relief. Next, I select all the corners, say rectangular relief only, but this time I'll change the value, I'll say it 6 mm here and then say it okay. So this relief gap has been provided for all the corners. I'll flatten it and now you can see this corner relief gap has been provided. A cutout of rectangular shape or square shape has been provided with the size of slot length 6 mm by 6 mm. Suppose if you want to give circular relief, I'll delete this relief option, exit the flatten view first and then edit the part. So I'll delete this option here. Again we will go to corner relief option, but this time we will control only these two corners. For that we will select all the corners first, collect all the corners, and after selecting all the corners we will delete the first and fourth corner here. I'll say delete first one and the fourth one. Now only two corners are being selected here. So the corner which is in orange color, you can see two colors are also been appearing here. First one is orange and second one is in pink color. So any corner which is having orange color will be edited first. I'll say it's circular and say the radius of 4 mm here. And suppose if you want to edit the third corner also, corner number 3, first we have to select this in this box, 3 number corner, then only it will be highlighted in orange color. And then go for editing and say it separately as a circular profile. Put the value of 4 mm only So if you want to individually edit, you can individually edit. Say it OK. And now when you flatten the part, you can see these two corner treatments are being provided. But this time they are in circular form. First we have taken rectangular for all corners. This time we have taken only circular for two corners only. Say exit flatten view. So this was corner relief option. I delete this option. I will delete this option and go for the other treatments given in corner, such as break and corner view. Now we will see break corner and trim. Select break corner and trim. So break corner is applicable for the corner edges only. So I'll select this corner edge, and you can see we can provide either chamfer or fillet. So I'll provide here 5 mm fillet only. Say it OK. On the other side I am going to provide chamfer here. Select corners, break corner and select the corner edge. The edge to be selected is between these two faces, this one, and then go for chamfer option. Say it OK. So now one is fillet and the other one is chamfer. You can also go for the option by selecting the face directly. I'll select break corner, select the face directly, and both the ends of the corners will be chamfered or filleted. The other two sides, bottom sides, will not be filleted or chamfered. It is because they are having bending radius here. So we cannot provide fillet and chamfer to the ends here. Say it OK. You can see chamfers are being provided of 5 mm on both the corners. But this time we have selected face instead of corners. That was the only difference here. So this was corners, break corner and trim. The last one we are going to see here is welded corner. For that I'll delete all the corner treatments first. If you are having any corner treatment and then you go for weld, it will not take there. So that's why we have deleted here. And then go for welded corner. Select the corner to weld. I'll select only one face and you can see complete weld is been provided in this gap. If you want to add fillet, fillet is optional here. You can see one corner fillet has been coming here. So that is optional. If you want to off the fillet, you can off, or else if you want, you can add the fillet. You can change the values also here. I say 0.5 mm fillet. The purpose of this fillet is just to handle the parts properly with removal of sharp edges. Say it OK. And now here you can see when welded corner has been provided, this gap is completely filled with the welding here. We'll select the welded corner for the other side also. At one time only you can provide one weld corner. Say OK again and then go for the other corner. Again OK. So this was welded corner in sheet metal. So these were the 4 types of corner treatment that are needed to be given if required. But one more thing I want to show here. After selecting the welded corner, you can see in sheet metal tab, in ribbon many options are being freezed here. It is because the welded corner option is to be provided at the last of the part when the part has been completed. Or else you cannot use the other features here which are freezed. That's why welded corner should be taken at last only. Even if we go in corners, you can see the other corners such as break corner, corner relief are now been not shown here. It is because welded corner is the only last treatment. After that we cannot show any corner treatment there. So this was corner treatment. Now the next part we are going to see here is development length. So for development length, you can use multiple types of tools here to create a development of a parts such as elbow pipes of HVAC systems and more parts. So for example, I have downloaded one image. I'll show you. So if you want this kind of structures in HVAC product, you can see here. It is a kind of elbow pipe only but made of sheet metal. So in this product or in this part, all the sections you can see first, second and third, as well as this fourth portion are separate portions and then they are welded or riveted together to form the particular structure. So to make this kind of parts or this kind of parts, we have to make this part in part molding first in SolidWorks and then we have to convert them to sheet metal. So we are going to make one elbow in SolidWorks. First we are going to make a solid part, then we are going to convert it into sheet metal. For conversion of part modeling into sheet metal, 3 things are required. If you want, you can note down. First one is we have to provide thickness for the sheet metal part. Then we have to provide the ripping gap or a gap that it should be flattened. And the third thing we are going to provide here is bending radius. So thickness, ripping gap and bending radius. These three things are must so as to convert the part into sheet metal. So we'll start with making this elbow type part here. For that I am going to make a structure and then going to convert it into sheet metal part. After converting, we are going to divide this part or split this part into different sections, first, second, third and fourth. So in this way we are going to complete this part for bend development. So we'll start with this. Select this sketch first. I am going to make a circle of 500 mm diameter. Then we are going to make two lines here, horizontal and vertical. We need to make all this geometry in construction. So I'll make it in construction first. We are going to use swept boss here to make this part. So except the path, everything, all the sketch we are going to make in construction. Only path should be in a solid line. So I have made one diameter circle 500. Then I'm going to make sections. How much sections we want, you can see here. In part also there are sections. In this part you can see there are 4 sections given. For example, you can see here this complete section is been made in 11 sections. First, second, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th and 11th. So total 11 sections were required to make this kind of part. We will make a part with 5 sections. For that I am going to draw 5 lines here. First, second, third, fourth and fifth chord. Total 5 chords I have drawn here. Make sure that each chord is tangent to the construction circle given here. For that I am going to tangent this each line here with the circle. So now we are going to provide angles. Put it as 11.25 from the bottom side. And in between sections, all the 3 sections will have the same angle, that is 22.5 for this first, second and third section. The last angle I will put it here as 11.25 only. And now you can see one path has been completed and other things are made by construction lines here. Now we will go for features and swept boss. Select the circular profile and in path I will select this path. Provide this cross-sectional diameter as 225. Say it OK. Now this part has been completed here. As we have said, to convert any part molding part in sheet metal, we have to provide 3 things. First one is thickness, second one is ripping gap and the third one is bending radius. So to start with thickness, I am going to give shell command here in part molding so as to provide a constant thickness. I'll select the shell command and whatever thickness I want for the sheet metal I am going to provide it here. So I'll provide 1.5 mm thickness and I'll say to remove these spaces, top and bottom, say it OK. Now this part is hollow and you can see here 1.5 mm thickness has been constantly applied on the body. Next, the second thing was ripping gap or a cutout so as to make this part flatten. For that I am going to select the front plane only and say sketch, make one circle. So the diameter value of the circle doesn't matter here. Only the thing to be considered while making this circle is that it should cross this thickness and above. Features, say extrude cut. In direction I'll say mid plane. And whatever ripping gap I want to provide, I'll provide it here. I'll say it 1.2 mm. So if it is taking mid plane, then it will be taking 0.6 mm at one side and 0.6 mm at other side. Say it OK. Now this ripping gap is also been provided and the part has been ripped from first end to the last end. You can see here. And now we will save this part first. It is compulsory to save this part at this moment here. So I'll save this part, make save as option work here. I'll save it in this folder. You just need to remember the part where you are saving this part because the other bodies which are going to be divided further are going to be saved in the same folder here. I'll give it a name as bend development part. Saved here. Next I am going to take front plane or any plane which is parallel to the body. I'll select that plane and then provide a reference plane from that. You just need to make sure that reference plane is coming outside the body without intersecting or touching the body. The distance doesn't matter here. I'll say it sketch. As we have taken new plane and we have said sketch, we are going to convert these edges in a sketch using convert entities option. So in convert entities, I am going to select this first edge, then this second, third and fourth edge. Say it OK. Now all these sketches are being converted using the edges to convert. Now the purpose of converting these sketches is that I am going to consider this sketch as a tool to cut this part in different sections or different bodies. I'll hide this plane and now we'll go in direct editing tab here, and we are going to use one new command here which we have not seen earlier, that is split command. So the purpose or use of making this split command is to create multiple bodies from a single body. You can create the bodies in the existing part or in a separate parts. So I'll use this command here, and for splitting only we have saved this part, because while using this command or before using this command the part is compulsorily to be saved. Then only you can use this command. That's why I have saved it earlier only. I'll go with split command, and in trimming tool I am going to add this sketch. Here we have to say 4 things. First one is trimming tool, then second step is to say cut part. So as soon as you say cut part, all these parts are been divided into separate bodies. You can see here, as I drag this cursor, it is showing separate bodies here. Then third step is to assign names. I'll auto assign the names here. You can see all the title names are been assigned as body 1, body 2, body 3, body 4 and body 5. And the fourth step is to put on this option, that is propagate visual properties. So first one was to show the sketch, second was to say cut part, third was to propagate visual properties, and fourth was to assign the title names here. So after completing all the 4 steps, we are going to say OK. You just need to keep one more thing in mind, that you should not on this option here, consume cut bodies. If we put on this option here, all the bodies will be separated from the single body, but they will not be saved separately. So to save separate parts, you just need to keep the option as it is showing here. You don't need to put on this option here, just put it off only. You just need to tick on this option only, that is propagate visual properties. So first one was sketch, second cut part, third auto assign names, and fourth propagate visual properties. Say it OK. And after saying OK, you can see here this file will continuously blink for 5 times, saving each part separately. I'll say it OK. Say don't show again, and yes, it will blink 5 times here. It means the 5 bodies separately are being saved there. Now as we have discussed, any part to be converted in sheet metal required 3 things. First one was thickness, second was ripping gap, which we have provided here, as well as we have provided thickness, but the last thing remaining here was bending radius. So the third thing to convert the part into sheet metal is bending radius, inserting the bending radius, but we have not inserted the bending radius here. So we are going to open each body here separately and then provide the bending radius or insert the bending radius. We don't need to insert the bending radius on this part. We'll keep this part as it is and open the required parts here. So I'll say open. We need to remember where we have saved this earlier part. There only these bodies will be saved. So I'll select this body 1 or any body you require. I'll say body 4. Say open. Now you can see this body is separately cut and been saved there, and we have opened that body here. So after opening the body, go to sheet metal, but you can see here this flatten option is not showing. It is still freezed only. It is because we have not inserted the bed. We have not fulfilled the third condition, that is to insert the bends. So we are going to use insert bends, this option here, and in insert bends we have to show the fixed face or edge. So I am going to show this edge here, provide the bending radius. Just ignore all the options. Only 2 things are required. First one is to show the edge and second one is to provide the bending radius value. Say it OK. And now as you flatten here, you can see this flatten option has been on. I'll select this option and this bend development piece has been created. It will provide the length and width of the part or thickness of the part so as to make this particular shape. We are going to make each separate part and then we are going to rivet or weld this part so as to make that particular component which we are seeing here. So we have to open each part similar way. I have opened body 4. Now I'll open body 3 here. Say it open. Again we have to provide same thing, that is insert bends. Select the edge. Say OK and then flatten. So each piece has been developed here. So this was bend development. Next thing we are going to see here is convert to sheet metal. For that I am going to make one cubical part there. And then I am going to convert this part into sheet metal. For that, say top plane, sketch, center rectangle, say features and extrude boss. I have not taken dimensions here. Say OK. And then we have to go to sheet metal and there is an option given here. Convert to sheet metal, select the option. And suppose I want to make this as control panel and this was the base of the control panel. So in fixed space, you can see the first option. It is asking us for select a fixed entity. So I'll select this bottom face as a fixed face. You have to provide thickness and bending radius here. So I'll provide 1.2 mm thickness and similar goes with the bending radius, or you can increase the value here, but don't decrease the value below the thickness value. So after giving the thickness and bending radius, I am going to say bending edges. So we have given this as a base flange. And now we are going to assign this all edges around this base flange as a bending edges. So as soon as I select two bending edges, one ripping gap edge is by default been selected here by smart selection. You can see here. So now I'm going to click on this edge as a bending radius edge. These two edges will be converted into ripping gaps. You can see it is by default converted. We don't need to give selection for the vertical edges. You just need to select the bottom bending edges and provide the parameters here. Then go to at bottom sides. There is one more option given here, corner radius or corner defaults. So there are three corner treatments as we have seen in this lecture only earlier. First one is open butt, second is overlap, third is underlap. So I'll select this overlap option and you need to provide gap. I'll say it 1.5 mm. And overlap underlap ratio I'll say it 1 mm, K factor as 0.5 mm. So what we have shown here, all the parameters, we'll revise it again. We have shown the bottom face as a base flange, all the side edges of the base face as a bending edges. These ripping edges were by default selected, we don't need to select them. As we select two bending edges, this ripping edge in between the two bending edges will be automatically selected. And then we have provided the gap, corner treatment and K factor here. Say it OK. You can see this part has been converted from part molding to sheet metal. When we flatten this part, it will show me this kind of treatment here. And corner relief are also been taken here as in a rectangular shape, you can see, so as to relieve the stresses and shrinkage of the part. Again we can unflatten this. So this was convert to sheet metal option. We can do the same thing by another method also, in which we are going to cover this insert bend and rip command. So for that again we'll delete this parts here, and again it is a part molding part. The another and last way to convert this part into sheet metal, one more method, that is first we are going to shell this part to provide thickness. So I want this thickness of 1.5 mm. I'll say this face as removing face and say OK. So now this part is been made hollowed and the upper face is removed by constant thickness of 1.5 mm. Next, still you can see in sheet metal flatten is not available. It means that this part is not converted to sheet metal yet. Next we are going to go for the ripping command. Rip command, select the rip command. And in rip select the required edges to be ripped. Ripping means providing the gap between the edges. So I am going to open these edges as a gaps. Just need to provide the gap value. I'll say 0.7 mm. You can take any value here. If you want to change the direction for overlap underlap, you can select the change direction option. Now the edge 4 has been changed here. You can see this face has been underlapped and the opposite face is overlapped. In the direction again. Now it is taking butt joint here. Same again. Now this face is overlapping and this face is underlapping. You can see the arrow direction. So you can do this for each edge. I was doing for edge 4 only. I'll keep butt joint only here and gap with 0.7 mm. Say OK. Now these ripping edges are been also provided for the gap. Still this part is not showing flatten because third input is still remaining, that is insert bends. So I am going to select insert bends here. It will ask you for the fixed face or edge. So I'll select this as a fixed face. Provide the bending radius value. Say OK. Now it will give a notification showing that auto relief cuts were made for one or more bends. Said OK. It means these auto relief cuts were made to relieve the stresses and avoid the shrinkage here. Now we can flatten the part here. So this is another way of converting a part into sheet metal. So with this command we are going to end this lecture here. Next lecture we are going to see weldments. There are two types of weldments, that is structural weldments and plate weldments. Both types we are going to see there. So continue watching the lectures. Please subscribe the channel for 4 Dimensions Infotech, as well as you can follow the playlist for earlier lectures which included part modeling, assembly and types, as well as sheet metal here. So thank you for today. We'll stop here. So hello everyone. Today we are going to start with weldment structures. There are two types of structures in weldments. First are that are made of standard structures such as square tube, round tube, C-channel, I-section beams. I'll show you some examples here. You can see here, this is I-section beam. Then we have angle sections here, C-channels in this way also. Then square tubings, rectangular tubings and circular tubings. So whatever structural tubings are we are saying, that are all hollow in structure and are having common thickness here. So we will start with all these structures. We are having some examples of structure to show you. What are weldment structures? Now you can see in these images. Suppose if you want to make this kind of structures, you can see here complete supports, stand plates, stairs and all the structure around is made of weldments. So this kind of structures we can make using weldments. So this is another example in which square tubes, round tubes, bases of sheet metal and other multiple things are used, such as I-section beams and all, to make a particular structure. Another example completely made of weldment structure only. The workers are working on the structures. These are I-section beams here, which are used in heavy structures. One more example of I-section beam here is this one. You can see here, these two sections, these two pieces of I-sections are connected to the middle piece here, that is horizontal in orientation, and these are vertical in orientation. For the support, ribs are been added here that are called as gussets. We are going to see that also here, and then they are bolted on the structure. So this kind of structures we are going to make in weldments. So the reason we are pronouncing it as weldments, it is because we are going to weld one structure upon another. So we'll start with this sketch here. Either we can use 2D sketch or we can go for 3D sketches here. So I'll start with weldments. There itself you are having option of 3D sketch, or else you can go by the traditional method using planes and then making sketches. That method also can be used to make sketches, or else you can make sketches by using 3D sketch. You can make a hybrid sketch also using 2D as well as 3D sketch. It doesn't matter in which way you have made sketch. So we'll start with weldments by making a 3D sketch first. So we are going to make one table here. For that I am going to select 3D sketch, and after selecting 3D sketch you can see the origin has been highlighted here in isometric view. So to start with I am going to draw a rectangle which should be oriented at the top side here. So I'll select the rectangle. You have to keep in mind that we have not selected any plane here. We are directly selecting the command and starting with the center rectangle. But as I said, I want this orientation at the top, but it is coming at the front side. So to change the orientation in 3D sketch, we are having tab key on the keyboard. We just need to click on the tab key here. You can see the red color axis line will also change with the tab here. As I click on the tab, the direction of axis will change. So you can see the rectangle is coming at top side. After completing the rectangle and the orientation properly, we are going to give dimensions here. I'll say it as 1200 mm and this one as 600 mm. After putting up the dimension, it would have fully defined here, but still it is not defined. It is because we have drawn 3D sketch. We have not used plane here. To define the sketches, you have to define the orientation of the lines, and I need to add relation at which direction it is parallel to. So I'll add this direction as along X. You can see the UCS icon here. This line is coming parallel to X. That's why I'm going to add along X here. And this line is coming parallel to Y. So for that I'm going to add along Y. So it is coming along Z. So I'm going to add along Z here. And now you can see this sketch is completely defined. It means you have to add dimensions as well as you have to add the relations showing the axis at which direction the line is coming. And then only this sketch will be defined here. So after completing the rectangle, I am going to go for the support legs here for the table. For that I am going to draw vertical lines here along Y direction, you can see here. So I'll go for the line, select the line and drag the line in the vertical direction. It is seemed to be drawn in vertical line, but when you rotate the part you can see this line is not coming parallel to Y axis. Instead it is coming on the same plane as of these two lines. So what we need to do here is select the line and say it along Z. We need to select it along Y. I'll say it along Y. So it may over define here. I'll delete this relation along Z. Then it will automatically come to along Y. And now it is coming perpendicular to the sketch as a support leg here. We need to provide one dimension. So I'll say it as 620. The next line also I'm going to select the line. After drawing the line, we'll select the line again and say along Y. And then I'll put up the relation here as equal. After these two legs, I'm going to go for the third. So now you can do one more thing here to change the direction. Instead of adding the relation later, we can tap the directions. You can see the red color axis will change the directions there. And now it is coming in Y direction. I'll click here. So instead of giving relation, you can go for this option also. That tap the button and you can change the direction along X, Y and Z. We have done this earlier also for the rectangle. Again the next line, it is by default coming in Y direction only. You can see the tracing line also there, blue color. We'll put up the relation equal for these lines also, both the lines. We will add one more support in between here. So from this midpoint to this midpoint. Now my 3D sketch has been completed here. Still I want 4 more lines here. So I'll go for lines again. Select the line, the other line. And you can see it is coming parallel to Z direction. So if I need parallel to Z direction, I'll select the line and add the relation as along Z. Same way, we'll go for this line here. It is coming parallel to along X. Next line parallel to Z and another line, the last one, to complete this sketch. Now we need to provide the distances here for the lines. So I'll provide this distance as 160 mm. Similar, I'm going to add the distance here also. Same as 160. I'll say this line parallel to the other line. Suppose it is over defining this sketch, then we'll delete these lines and make them one more time. So I'll draw this line again here and then say it parallel to the other line, and then the last line we have to provide here to complete this sketch. And now this sketch has been completed. We'll draw one more support in between this also. So I'll take this line command from midpoint to midpoint here. Our table structure has been completed. We are going to add structures here. Why 3D sketch is referred mostly? It is because if you use 3D sketch, you can see you don't need to make multiple planes here to complete this sketch. But in 2D sketch, you need multiple planes so as to complete this kind of complicated sketch there. So to avoid planes and to work in a single sketch, it is better to go with 3D sketch. Or else you can refer 2D sketch also, as we have used in part molding earlier. So I'll exit this sketch here to add structures now. Then we are going to select this Weldment icon here. Click on this icon and after that only we are going to start giving the structural members. It is compulsory to click on this icon as it will generate a cut list there. So if you select this icon, the parts we are going to make here will not be merged together and they will come as a separate bodies here. So after selecting Weldments, I am going to go for the main command. After putting Weldments, I am going to go for the main command, that is structural member. Select the option. You have to provide the standard first. So I am going to go with ISO. There are multiple standards such as NC inch, NC metric, JIS, GB, DIN, but we are going to go with ISO. Then for the type of section, we are going to select the types here. We have seen angle iron, C channel, pipe, tube, square tube, I section beam. So I'm going to select here C channel. Then we are going to go for the sizes here. I'll select 80 by 8. These sizes we can customize, we will see it later. Now in these groups, we have to select in such a order that multiple entities should be selected in one group. So it will make editing easy. As many groups as you are going to make here, editing will be different for the different groups. The important thing here is you can make groups of C channel. The condition is all the sizes should be equal and shape should be same. If the size or cross-sectional shape of the structural member changes, then we are going to take another structural member instead of taking group. We cannot add group there. So it is compulsory for making groups that all the sections should have equal shape and size, then only we can go for the groups option here. First, I'm going to add this group here. I'm going to select the lines in chain first, then this line as second, and this third, and the last one. But if I break this order, suppose I'm going to delete this group and again go for the group. I'm going to select this first line and the second line. But when I select the third line, it will not accept as a third line. As I have broken the chain here for the selections, it will not accept. So I have to go for new group so as to apply the structures here. So it is better to select the profiles in chain order here. I'll select this first line, second, third, and the last one. After selecting the lines, there are three corner treatments given here. First one is miter joint. You can see here all the corners are connected by 45 degrees joint here. I'll say it OK. And to understand, I'll hide this sketch. So now you can see the corners. These are the miter joints connected at 45 degrees. Suppose I change the type here. I'll say it end but one. You can see each cross section is connected in such a way that one is overlapping and the other side is underlapping. So this one is underlapping here, this bar, and it is overlapping at the other side. Same goes with this bar. It is underlapping here and overlapping here. So this was end but one. Suppose I change the type here and go for the third option, that is end but two. It is similar to end but one. One side will be overlapped and the other will be underlapped. Only the thing is these sides are flipped here. So in end but one, this was underlapping, and in end but two, it is overlapping. Same with the other sides. But suppose I want these channels to be underlapping here from both the ends, from the upper end also and from lower end also. It is already underlapped from the upper side. Then we should go for individual corner treatment. I'll show you. Suppose I want this bar to be underlapped from both the ends, so I have to go for treatment on this point here. And for this bar, I'm going to go for treatment on this corner point. So I'll select the C channel, say edit feature, select the individual point. The difference is here, if you select the corner treatment, it will be applied for all four corners. But if you go for individual points, then it will apply only for the particular corner only. So I'll select that point, and instead of end but 2, I'll give its opposite side end but 1. Say it OK. And for this point also, end but 1, say it OK. Now after selecting OK, you can see here both these C channels are underlapping on both the ends here. Here also you can see, and these both horizontal channels are overlapping on both the ends. So this way you can individually change the corner treatment. Suppose I want to add this as a C channel only, then I'll go for new group and select this as a C channel. You have to keep in mind all the groups will have same shape and size. We cannot change the size for this particular group here. If you want to change the size, you have to go for new structural member. I'll select the orientation. I want to orient it at the top side. Now it is coming at the bottom side. So to go for top side, you can see the profile, 2D sketch profile here. And that profile is having multiple points. So if I click on this corner point, this whole profile will be shifted at upper sides on this point. So for that, one option is given here, that is locate profile. I'll select this locate profile. After selection, it will work for once only. So again, if I want to change the profile, again I have to click on locate profile. So after selecting locate profile, I'll go for this point, and you can see this C channel is being shifted at the upper side here. If I want this C channel to be shifted at both the ends at midpoint, then I'll go for this midpoint option. And now you can see C channel is coming. And now you can see C channel is coming from the mid orientation here. Same if I want this C channel to be coming at this corner here. So I'll again say locate profile and click on the corner point. So in this way, by using these multiple points, you can shift the profile as the way you want. Say it OK. Now we'll see the locate profile for this outer side also here. Select edit feature, and now for group 1 I want to locate the profiles here. Suppose I want this C channel to be coming in such a way that it should be oriented half at upper side, half at lower side. And again I'll say locate profile. For the point selection I am going to give this midpoint here. So this profile is coming half at upper side, half at lower side. Say it okay here. We will show the sketch so as to understand the references. You can see here the section is coming equally divided on both the sides. Now if I want this thickness to come outside, then again I'll edit the feature here. Go for locate profile, and you can see all the star points you can utilize here to locate the profile as the way you want. So I'll select this point here. Now the thickness is coming at outside. Suppose I want this point and the profile to be located upwards. So I'll say locate profile again and say this point. This profile will be located upper side from all the ends as a single group. This was locate profile option. You can utilize it here. If you want to add some star marks here, you can go to the sketch and add the marks or star points as you require. Suppose I want to locate one more point by customization. I'll say it okay. I'll expand this C channel model tree, and in sketch I'll say it edit sketch, and here you can see the C channel profile. I'll add one more point here with alignment to this end at the center. I'll define it properly by giving the vertical relation and horizontal relation with this horizontal point. Say exit sketch. Now we will say edit feature again. Go for locate profile, and you can see that we have added one more point here. This is the customized point. If I select this point will be shifted on the intersection of the sketch at this pink color section. So I'll select this point here. And now this complete profile is located for C channel. All the 4 channels have been located at the same point as it was taken completely in one group. This channel is not been located as it was in another group. If you want to edit that channel also, say group 2 and then add the required point. I'll say this point. Say it okay. So this was corner treatments and locate profile option. Now we'll do one thing. We are going to change the structure here. So I'll say edit feature again. And instead of C channel, I am going to go for rectangular tubings here. You can see after applying tubing also, even then these channels are not been updated yet. It is because till the time you don't apply this size, it will not be shown here or it will not be displayed here. So I'll say one size here, say 50, 30, 2.6. So this is length, width and thickness. So we have applied a group here, and the same profile will be applied for the other group also with same sizes. So I'll say it okay again, and now you can see this rectangular tubings. Even after applying the rectangular tubing, the corner treatments are same as they were for C channel. Now we'll go for edit feature again, and now the orientation for the rectangular tubing is coming in such a way that it is vertically oriented. Suppose if I want this rectangular tubing to be oriented horizontally, then we are going to change the angle here. For that, select the angle option. So in the same feature there is option for angle. I'll select the angle and say it 90 degrees. So this orientation is now horizontal for rectangular tubing. You can see here, but only group 1 is been edited here. To edit group 2, I'll select the group 2 option and then change the angle for group 2 also. I'll say it 90 degrees, same as earlier. And now all the orientations for rectangular tubing are coming in horizontal way. You can see here. If we again go for locate profile, there are certain points given by which we can locate the profile. So for this group 2 profile, I'll select this point. Complete tubing is coming at lower side, you can see. Again, I want to orient it from mid section, so I'll select locate profile and say midpoint here. This point will be shifted on the sketch here. So this was locate profile. We can also go for angle iron section. Select the required size, and now all the profiles are coming as an angle iron here. I'll locate the profile so as to bring it in proper alignment. I'll edit the group 1. One more option is also given, that is mirror profile. Select the mirror profile option, and you can see the angle profile has been oriented horizontally here. If I off this option, the initial position was this one, but if I on this option again, it will go for horizontal axis and the orientation will be changed. You need to observe here. I'll select mirror profile and it is flipping horizontally. Again off this option. and say on again. Next we are going to go for vertical axis. Now it is flipping vertically here, you can see. So this is mirror profile option. By this option also you can orient the profiles as you require. I'll change it for group 2 also. Select the group 2 and again go for mirror profile. Say locate and change the location. Again say OK. So now angle frame has been applied here. You can see the orientations. I'll put on the sketch again. This was structural member tab. We are going to continue with the table in next lecture and we are going to cover the other commands which are left here. If I continue in the same lecture, it would be a lengthy lecture. So this was session 25 for Weldments. The first session for Weldments. The further remaining command for the Weldments will be continued in upcoming lecture or session 26. So please follow the playlist so as to completely understand the Weldments here. Till then, thank you. So in previous lectures we have seen structural member command in Weldments. This is lecture number 2 for Weldments. We are continuing the earlier lecture. In first lecture we have seen till structural member. So now we'll move further and see the other remaining commands. For that I'll again change the cross sections here. First we have taken angle iron. Now I'm going to go for square tubing or rectangular tubing here. So I'll say edit feature. Select the rectangular tubing option and go for the size. I'll say it as 60 by 40 by 3.2. So this is length, width and thickness. I'll select it and then say OK. We will just check the corner treatments. They are coming in proper way. Both the horizontal structures are overlapping the vertical ones. Now we'll continue with the second group here. Then we will go for the table legs. So for the second group, I'm going to take the same size for this profile also. I'm going to select the group here, say edit feature. And in group 1, group 2, next I'll say group 3 here. Sizes I'll continue with the same sizes. Select these bars. And say OK again. Now in this group we need to change the alignments. So for that I am going to select it and say it edit feature again. And I want these vertical tubings to be coming inside the horizontal tubings. For that I am going to change the corners for this upper side at left side. Say end but 1. Here we will select the type which is opposite to end but 2. As end but 2 is pre-selected, I am going to go for end but 1. So this is opposite of end but 2 and then say it OK. Now this is updated. From both sides this vertical tubing is coming inside. Now I'll go for the right side tubing. Here you can see this side is overlapping of this pipe. So I'll select this side and go for end but 2 here. Say it OK. Now all the sides have been updated here. Say it OK again. And now we can see here square tubing at all sides has been updated here. Now I'll go for these pipes or legs. For that we are going to select structural members. As I am going to go for the new cross-sectional shape, that will be pipe. So I need to select structural member again. We can't continue in this group only as the shape and size has been changed here. So I'll select structural member again. Go for the pipe. I'll select the maximum size of the pipe here and add them as a supports here. So we can see here pipes are been added as a support. Again said OK. Now I need to orient this rectangular tubing. As it is vertically oriented, I want to orient it again in horizontal direction. So I want this face to be oriented at horizontal direction. So I'll go for edit feature in rectangular tubing. And for group 3, as it was taken in group 3 here, so I'm going to go for angle and update the angle by 90 degrees here. Say it OK again. If I would have kept that vertical orientation, this joint would have been weakened here. That's why to make a strong joint, we need to select such a face that it would accumulate the cross section of the pipe. That's why we have oriented to 90 degrees this rectangular tubing. We need one more support here. If you want to update, you can update the 3D sketch here. I'll add one more line here. We'll also update the height. I'll say 200 mm. Exit. There will be no change in structures there. And now I want to add one more group here of the same cross section. Now I want to add one more structure here. It should be in rectangular cross section only, but the size will be little bit smaller or customized here. So for that, I'm going to go for structural member. We can't add another group here. It is because we are going to change the size. So if I update the size in this similar section or similar type, then all the sections will be updated by the same size. But I don't want to change the sizes of this rectangular tubings here. I just want to update the size of the middle one, lower middle one. So for that, I need to select another structural member and then go for the size. I'll select rectangular tubing. I'll select the size as 50 by 30 by 2.6 and update it here. I want the orientation to be horizontal, so I'll make it 90 degrees angle. It is coming perfect now. Say it OK. You can see another structural member has been updated here. Now we will hide these sketches. Now if you see these rectangular tubings or pipes, these pipes are been intersected in these rectangular tubings here also and in mid portions also. You can see here on all the four sides these pipes are intersected to the rectangular tubings, as well as you can see this another added rectangular tubing. It is also intersecting the body here. You can see the blue shade being shown here as it is intersected inside the body. And one more thing to notice, that there is no edge formation in this corner. It is because when a part is flushed or intersected in the other part in SolidWorks, the edge formation doesn't appear there, indicating that these parts are flush to each other or intersected to each other. If I locate this profile of the rectangular tubing at upper sides, this pipe will automatically come below the rectangular tubing. We will go for that option here. First we will see it by updating the position or locating the profile, and then we will go for trim commands. So I'll select the rectangular tubing, edit feature, and now you can say locate profile. I'll locate this profile to upper sides, as this complete structure will come at upper sides and the pipe will remain at the lower side. So for that I'm going to select this point, and now you can see whole structure has been updated to upper sides here. I'll also update the group 2 here. For that also I'm going to go for the lower point here. So the structure will move upwards. Say locate profile and then click the required point. This structure is also updated here. Say OK. And now you can see these pipes are not intersecting the model here, as we have moved complete structure only upwards. Sketch and pipe sizes are same, but this structure has been moved upwards. But there is one more problem if we do this. If you don't want to change or update the height, then it is better to keep this pipe intersected as it is and then go for trim commands instead of locating the rectangular tubing upwards. So I'll Ctrl Z or undo this. You can see I've undone that command locate profile, and again it is intersecting the part here. So instead of locating, I'll go for trim command here. I'll hide the sketch first, and here there is trim and extend command. Select the command. I'll select the first option only here and trim. It is asking us for the bodies to be trimmed, so I'll select the bodies to be trimmed here. That will be the pipes, all the 4 pipes, and then we'll go for the trimming boundaries. Here we need to show the boundaries in 2 forms. We can show it either by faces as a boundary or bodies as a boundary. So I'll select the faces option first, just to show you how the face option works. Then I'll select this faces here. I'll select this bottom face as a boundary here, and for the other side also the same kind of bottom face. And now you can see on each pipe there are 2 stickers been highlighted. On the first pipe you can see here, first one, the upper side, it is dimmed in color and showing that this portion is to be discarded. or to be deleted here. And the other sticker on the same pipe, first and second, the other sticker is showing as to keep the parts. So I'll keep this part here. Similar is for the other pipes also. On this pipe also you can see internal pipe, discard and keep. Upper one is discard and lower one is keep. Third side also, upper one is discard and lower one is keep. At the fourth side also discard and keep. Say it okay. And now this upper pipes are been trimmed here. We have used boundaries as faces only. In similar option we would have done trimming for these pipes also. So I'll edit the feature here. And in trimming boundaries I'll select these faces also. The first one and the lower one. Again the first one, upper and lower one. And now I want to discard this intersecting portion here. So on this pipe I'll say click on this keep command and it will discard the pipe here. Again for here also, and then for this internal portion also I'll discard. I just need to click on this option and it will be converted from keep to discard. For this internal portion also I'll say discard. You can see this point here. And lastly for this portion also discard. Say it okay. And now you can see these pipes, they are been discarded here. Now the only portion which is not been trimmed here is the internal one. You can see the projection of this mid support is coming inside the tubings here. The horizontal tubing is intersecting the vertical tubing. So I need to discard this one also. So now we will see trim and extend by using the body as a boundary. Select the trim command. Select the bodies to be trimmed. I'll select this tubing here. And in trimming boundary, there are two options giving face and bodies. We have seen the face option. Now I'll go for bodies option. So here we need to show the bodies as a boundary. So I'll select these two bodies as a boundary here. And now it will show only this option keep. Discard option will be by default gone here. Say it okay. It will again ask you for the extension type. You can see. Now the extension type here, it is showing a simple extension. But if I say coped with cuts, this extra portion will be extended here, covering this curve. You can see the difference. As I click, you can see here. In coped cut, it will cover up the full radius also. But in straight cut or simple cut, it will not cover or cope up with the radius here. So these are the corner treatments. If you want to add, you can go for this also. I'll say it okay. I'll keep the simple one only and then say it okay. So this was trimming using boundary here. You can also use this command for extend. So for gap, we are going to edit the first rectangular tubing, group 1. So in group 1, I'll select this corner and add one gap here. Say it 10 mm gap. Again say it okay. Now you can see gap has been added here. But if I want to extend it further, these gaps are added just to fill up the welded material here. But if you want to extend it further and you don't want a gap, so you can go for the trim and extend command. In oblique, extend command is also being shown. So I'll select the extend and trim command only here. And in bodies to be trim or extended, I'll select this body. And here these options should be ticked on here. It should be on, that is allow extension. Here also it should be put on, that is allow extension. And then we have to show the boundary. So again we can show boundary by faces or bodies. I'll show it by bodies only. I'll select this boundary as this body only. Now this part is extended here. So this command can be used for trimming as well as for extend both. Only thing is you need to keep this option on while extension, that is allow extension. If you don't put this option on, it will not extend, it will only trim the borders, it will only trim the sections. So if you want to extend, just put on this option allow extension and it will be extended instead of trimming. It will work both the ways. Say OK. This was trim and extend command. You can see here. Now everything is properly trimmed. So after trimming, one more thing important here is that if you want to edit the cross section sizes, you can see here we have taken rectangular tubing as 60 by 40 by 3.2 and the other rectangular tubing as 50 by 30 by 2.6, and also the pipe size here given is 33.7. But if you want to edit these sizes or you don't want to take the standard sizes, your need is of different sizes, you can directly expand the structural member model tree. And in structural member model tree, you can see here the sketch of that particular tubing is given. So we can edit this sketch and apply as the required sizes we want. So if I want this size to be 65 mm and this size to be 45 and this radius or thickness to be different as 3.5 mm. So we can edit all the parameters here and then exit the sketch. So that tubings will automatically will be updated there. You just need to go to sketch and edit the required sketch which you want to, which you just need to go on the structural member, expand the model tree, edit the required sketch and put up the sizes as we want. Say it 40 mm if you want and this as 33. That will automatically get updated if I exit this sketch here. So in this way you can edit the cross sections also and apply the required sizes you want. Next command we are going to see here is end cap. Select the end cap. So these end caps are provided on the cross sections such as rectangular tubings, circular tubings at the ends, as because if we keep these ends open only, then it might cause corrosion here due to oxidization and the internal surfaces may get rusted here. So to avoid that, we are going to provide end caps. You just need to select the face, flat face, and the end cap will be provided here. Now it is covering half of the thickness you can see here. It is because the ratio of offset is given as 0.5. If I say it 0, it will cover the complete outer boundary of the face. And if I say it 1, it will cover the inner boundary of the face. And then you can also go for corner treatments, fillet or chamfer. I'll select chamfer either or fillet and then say it OK. Now the type of end cap I have taken here is, you can see outward. That's why this end cap has been projected outside the pipe here. If I want to change the thickness of the end cap, I'll select and say 8 mm here or 3 mm here. These end caps will be welded. So I'll put the thickness 5 mm. As the thickness is very low, it will be difficult for us to weld this cap here. Say it OK. And now one end cap is added externally. If I want this end cap to be coplanar with this face, both the faces should be coplanar, then again I'll select the end cap, say edit feature and go for the second option, that is inward. Sometimes we get that inward means it is going to go inside the tubings, but inward doesn't mean that it is going to be inside, but it will replace the length of the tubing here, and instead of going inside, this tubing length will be decreased here and this end cap face will be coplanar with the other tubing's face. So you can see here, this end cap is not gone inside the tube, but the tube length is decreased here. That's why it is called inward. The third type given here is internal. Now in this we can say that pipe length will remain same, but the end cap will go inside the body. So to compensate the gaps between here, I'll say this offset ratio as 0. And the end cap will completely pack the internal portion of the rectangular tubing. But you can see this part is but you can see this end cap is flushing the rectangular tubing here. So to avoid this, I'll measure the radius first and then I'll add that radius. I'll delete this end cap. Measure the internal radius of the pipe. It is given 3.2. I'll again go for end cap, select the required face. Go for corner treatment as 3.2 and the type of end cap I'll select internal. I'll give the ratio 0 here, so there is no offset distance between cap and structure. Say it OK. You can see this end cap is completely covering the internal portion. Now if you want this end cap to be placed little bit offset inner sides, Then you can edit the feature here. Go for the feature, and in distance D1, insert distance you can see here. This insert distance only given for the third option. For first and second option there is no need of insert distance as the cap is going to come outside the tubings. So insert distance option is only given for internal type. So I'll select this insert distance as 10 mm. So instead of coming at the face, it is coming internally as 10 mm offset distance from the face. Say OK. Now this end cap is fitted here. If I want to continue for all the 4 portions, I'll select this end cap option and just need to select the faces. The same conditions for the first one will be applied for the second also. Select other end caps or other openings also. You need to click on the face and then say OK. So here the end caps are being provided internally with the offset distance of 10 mm. We are going to add the supports here as a rectangular plates. So for that we are going to select this face, say sketch, and then select the sketch, say center rectangle, and add one bottom plate here. I'll say it 160 by 120, and then add the plate, say it features and extrude boss. So I'll say 20 mm here. OK. Now this end plate has been added here as a support. I'll update this dimension. I'll make it smaller. I'll say 120 by 80 mm only. Again say update. And now if you want to pattern this, you can pattern these plates. For that we need to know the center to center distance. So we can find out by evaluating command. I'll say this tab evaluate and go for this measure option. Select the tubings and I'll go for center to center distance. There are 3 options given. I'll say center distance. This showing as 600. The another center distance horizontal. I'll select both the pipes. It is showing here as 1200. So I'll pattern these plates here. Go for features. Select linear pattern. And in directions, I'll show these edges here. For this one, and this edge has 2 direction. Check the arrows of the direction and then go for the features or bodies to be patterned. I'll select bodies instead of feature. As we are working in Weldments, all the single parts are different bodies here. That's why I'm going to go for bodies option. Select the body, this rectangular plating here, and add the number of entities required. I'll say 2, and the distance here is 600. And the other one is 1200. Number of entities there also 2 only, and then I say it OK. Now this base has been added to the structure here. Now while working on this part, you can see a cut list has been generated. This is very important that there must be a cut list showing each part and its sizes here. So this cut list is very important and it will be only generated if you have selected this option, that is Weldments, before starting the part. So you can see here I have selected this Weldment option. That's why it is showing the cut list here. And then we have started all the things here. Now one more thing remaining here is gussets. We provide gussets in between 2 adjacent faces so as to provide the strength and also provide the support for these faces so that they would not get diverged after applying the forces, as well as they will be stable, as the gusset will provide strength between the adjacent parts. So to add gusset, I'll select this option. You just need to select the 2 faces, adjacent faces, and the gusset will automatically be updated. Only one gusset at one time you can add here. You can either go for triangular shape or you can go polygonal shape here. You just need to update the dimensions you require. I'll say 30 by 30 by D3 as 15, this distance as 15. Or you can also change the angle here. If I want to change the angle, I'll go for the angle. I'll say it 60 degrees or I'll say it 45 only now. And then say it OK. This gusset has been added here. So for the thickness orientation, there are options given here. You can see here about its own axis. You can make it at left side, right side, or at the middle. Or else according to the face, you can locate it at left side, right side or middle. I'll select both the options here as middle only, so as to orient this gusset at mid side. If I want it a little bit offset, and you can go for this offset option also, and then put up the value here. I'll say it's 6 mm. So now it is taking 6 mm from this edge to the inner face here, from this blue edge to this inner face. I'll off this option, and now one gusset has been provided. Similar way you can go for the similar way you can cover all the sides here by providing gussets, but you have to keep in mind only one gusset at a time can be provided here. But you have to keep in mind that only one gusset at a time can be provided here. So this was gusset command. Lastly, we are going to see this weld bead option. So in weld bead, you have to select the weld geometry or weld path option so as to provide the weld here. I'll select the weld path option here. In weld geometry, you need to select two faces and the common edge between these two faces will be welded. The number of weld bead command will be increased here. So to avoid that, I am going to go for weld path here. So in weld path, you directly select the edges you want to weld and the weld will be provided there. So I have selected all the edges here, you can see. And after selecting all the edges, you need to provide the radius of the weld. I'll go say 2 mm. Then define the required symbol or type of welding. I'll say it fillet weld here. You can see number of type of welds have been shown here. First one is butt, the other one is square butt, and so on. So I've selected fillet weld, given the size as 2 mm, say it OK. You can see here. And suppose if I want to show that welding also, then you have to go in this view heads up tab. Here you have hide and show items. Go and say view weldments. As you say view weldments, the welding will be shown here. You can see here. If you don't provide weld bead here, it is not compulsory. You can directly show it in drafting also. The other commands such as extrude cut, hole wizard, chamfer, reference plane, and extrude boss are similar to the features command. There is no difference here. That's why I'm not showing that commands here. It is similar to feature ones we have seen already in lectures. Follow the playlist so as to understand the other commands also. If I want to add a glass here, I'll select this face, say sketch, and I'll select the corner rectangle. Select the corner from one end to the another. Features and say it extrude boss. And we can mirror this. I'll say it boss extrude and then say mirror. Select the reference plane in between. And this part will be mirrored there. I need to select this as a body here, not as a part. And now if you want to add the appearance, you'll go for the appearance. I'll select this tubing here. Say this piece as metallic one. So I'll say steel. Select the steel type and select the structural member. Weldments select tubes. So now the steel has been added here. But if I want to add this appearance as a glass for this 2 extrudes, then we'll select the appearance option again and then go for the appearance as a glass. I want textured glass. I'll select green color here. Drop it on this mirror. For the other face also. And while dragging and putting up, say it as a body only, the appearance. Then it will be applied only for that particular body, not for the complete structure. And now you can see glass appearance has been added there. And it is transparent also. You can see the ribs also here. So this was weldment structure. There are more things for this cut list. We will see in weldment cut list table in final lecture of drafting. That time we again will come for this option. And in detail we will provide the properties also here for this cut list. Now it is showing the number as 29. You can see. Now this cut list is representing the total number of single entities used for making this structure. Either it may be this boss extrudes or the bodies, we can see these glasses here, or it may be standard structures or gussets or end caps. The total individual bodies which are utilized to make this structure are 29. So the cut list is showing the total number of single individual bodies that are being used to make this complete weldment. Previously we have completed part molding, sketcher, assemblies and types, sheet metal, and now we have completed with weldments. Next lecture we are going to see plate weldments, and then we are going to go for drafting them. And please follow and continue to watch the playlist so as to learn SolidWorks completely. Our channel is 4 Dimensions Infotech. You can contact us directly for joining the classes, and we also provide placements in core mechanical design. So thank you for today. So hello everyone. Today we are going to see weldments by using plates. It is also called as plate weldments. So to start with plate weldments, we have to understand what we are going to make. So we are going to make some welding structures made of different sizes of plates which are welded together. So in this lecture we are also going to see how to make welded structures by using manufacturing methods. This manufacturing method should be seen in your model tree also. So here the steps matter, at which point you are going to cut the part, at which point you are going to give the holes and everything. So we will start with the part. For that I have taken this PDF here. So this is a small structure given here made of total 4 parts, that is 4 plates. First the bottom plate, then the second vertical plate, third the rib left hand side, and fourth the right hand side. So these are the parts or plates we are going to make, in which there are 2 plates and 2 gussets or ribs here. So to start with I am going to make the base plate first. For that we have given the dimension, that is 63.5 width, 62 length, and thickness is 11 mm. So we'll start with the bottom plate first. So to start plate weldments, you have to select the weldments option or tab here. Then you have to go on weldments. First select this command for creating any weldments, whether it may be structure or plate weldments. It is compulsory to select this command first, then only the cut list will be generated there, showing the sizes of the plates or parts. So now after selecting the weldments, we are going to go for the planes and start making the plates. The making of plate is simple, that is by making it extrude boss and extrude cut only. But here what matters is that plates should not be merged with each other. They should be unmerged and should be shown as a different bodies. For that only this Weldment tab is given. When you click on this Weldment tab, each plate will be a separate body without merging with the other plate. So to start with, I am taking this top plane, say center rectangle here. To keep the planes in center, I am going to go for center rectangle 63.5 and this one as 62. So I am going to take this as 63.5 and this as 62. Say features and extrude boss. So the extrusion size here it is given as 11 mm. You can see here. So we'll select this tab and say it as 11 mm. Then we have to say it OK. Now the procedure according to manufacturing is to make all the parts first and then go for the larger cutouts for weight reduction, and then after that we are going to go for machining cuts, and lastly we are going to go for the holes that are standard holes being shown here. You can see these holes, and this way you have to complete. So the order will be first make all the plates as a structures welded on each other, and then we are going to go for these larger cutouts. This one you can see here, the big cutouts made for weight reductions, and then we are going to go for the machining cuts. You can see here one machining cut has been provided. So after this larger cutouts, then only we have to make this machining cuts, and lastly we are going to go for the holes. So this will be the procedure for making this part or a structure. So to start again, we have made this plate here. So now this face is coming in front position 63.5. Next we are going to go for this plate, the vertical plate. Height for the vertical plate from the bottom is given as 151, and the thickness here it is given as 12.7 plus 1.7 of the machining cut. We are not going to consider in this sketch the machining cut. We are going to separately cut this machining cut. So for now we are going to take this complete value for the thickness, adding this 12.7 plus 1.7. So 12.7 plus 1.7, 1.7. 12.7 plus 1.7, that is 14.4. So the complete thickness, that is 14.4. We are going to take this thickness for this plate. So I'll draw this part now. I'll say sketch to the back face of the plate. then going to go for the rectangle. Here the width of the plate will be same, that is 63.5, and height will be 151 from the bottom plate. So I'll put up the value here as 63.5 and the height from the bottom as 151. So if you calculate the height for the particular plate only, then you have to minus this 11 mm thickness from 151. That will be 140 mm height of this plate. We'll make extrude, reverse direction, and we have calculated the extrusion that was of 14.4 mm. So we have not minus the thickness of this machining cut. That's why it is coming 14.4. So I'll take it as 14.4 mm as a thickness and then say it OK. So the other plate is also been mounted here, and you can see in Boss Extrudes each plate is unmerged with the other one. It is because we have selected the weldment procedure. Next we are going to take these ribs. So you can see the height of rib is given as 40, this one as 10, and the bottom side distance, straight distance, is also given as 10. In the placement for the rib, we are going to see the other view here. So for placements, you can see the center of the rib is coming 4.5 mm from the right side, and the other one is coming center as 59 from the right side. So here the ordinate dimensions are given, you can see. So from this as a 0 reference, this will be 4.5 as a rib center and the other will be 59 mm. So I'll take a reference plane here at 4.5 from this face, right hand side, reverse the direction and say OK. And now on this plane I'm going to make this rib. So I'll draw one sketch. The distance is given here by 10 mm, horizontal and vertical straight distance, both 10 mm, and the height was given here was 40 mm for the rib. So I'll take this as 40 mm, and this bottom base size is given as 30 mm. So I'll take this one as 30. So now this sketch has been completely defined and we are going to make it extrude. And now the thickness of the rib here is given as 5 mm. You can see the thickness here. So I'll make it extrude by 5 mm from mid plane. So I'll take this as 5 mm rib and then say it OK. Again we are going to pattern this rib here. We can also make it mirror, but I'll go for pattern here. So for direction I am going to select this edge, and here bodies to be patterned, that will I'll show this rib. I have taken this as a body only, as all the parts are unmerged with each other in weldments. That's why I'm going to take here as a body. Select the required body, flip the direction, you can see the distance here. So I'll go for the distance as 54.5 in between distance. I don't want direction 2 to be taken here, and then we'll say it OK. Now both the ribs are also mounted. So all the parts are been welded here. The cut list is showing here as 4 parts. And now we'll go for the weight reduction cutouts. So after mounting the plates with each other, then only we are going to go for the cutouts here. So here the rectangular cutout is been given on this vertical plate. So we'll make this sketch here. I'll say it corner rectangle. This height as 55 mm. And this as 30 mm. Now I'll go for the center line and make this sketch symmetric here. Select both the lines, say symmetric from the center, and then we are going to see the position. So from bottom side as a 0 reference, the height of this cut is given as maximum 122. So I'll take this value from the bottom to define the height or position of this rectangle. I'll say it 122. Next we are going to go for this cutout, features and extrude cut. So I'll take this as blind and through all. Say it OK. We'll also make this cutout here. So this height is 26 and the width is 30 mm. And the position for the bottom start is 21. So we'll start with that figure. I'll say this one as sketch. Again go with the corner rectangle. I'll make this sides collinear with the edges so as to match the width of the cutout, and this height as 26. And the starting distance from bottom is 21 mm. We'll say it extrude cut again. will be through all cut. Say it okay. And now we are going to go for this fillets given here, that is radius 5 fillet. 8 sides means all 4 sides of this cutout and the other 4 sides of this cutout. The radius will be 5, so I am going to select here radius 5. Select feature command and then go for fillet. Say it 5 radius and then select the required edges here. Say it okay. Then we are going to go for this chamfer cutouts 5 by 45. So I'm going to go for this chamfer 5 by 45 on both sides. I am taking it on both the sides as here it was given as TYP means typical. That is to be understood as in such a way that if any chamfer value other than this is not given, then we can consider it as 5 by 45 as it is written typical here. You can see this word. So that's why I am taking both the chamfers as 5 by 45. Say it okay. Now we are going to observe this model tree here. So first we have made all the boss extrudes, then we have gone for the cutouts, and then we are taking this fillets and chamfer. So the order of manufacturing should be in such a way. While making this boss extrude 1 or 2, we would have made cut extrude 1 or 2 also there. But according to the manufacturing process, these cuts will not come with the boss extrudes here. That's why we have made these cuts later. And now lastly remaining are the holes, standard holes and machining cutouts. So before giving holes, machining cutouts must be given there. So to make machining cutouts here, I am going to prefer this dimension here. So the depth of the machining cut here is given as 1.7 mm from the back side of this plate. Now what are the machining cuts? They are supposed to be given when any other part is to be mounted on this face. So there should not be any waviness between two surfaces of two parts. That's why machining cut is been provided here and on which the other part is going to be mounted. So whenever two plates are going to be positioned with each other in weldments, the surface of that two plates should be machined first and then only the mating should be done there. That's why these machining cuts are being provided, and for that only it is written here as mask these surfaces. It means we have to provide machining cuts on these surfaces. So we are going to provide this machining cut of 1.7 mm as we have taken the width already here, but we have done one mistake there. We have not given this clearance there. So we'll update this part and then go for the machining cut. You can see here I have made these two faces flushed with each other. So to avoid this, I am going to go for the editing of the feature and I am going to take here the start end condition as offset and say 2 mm gap at the reverse side. So the sketch utilized for this extrusion will be the same, but it will take 2 mm offset to start the extrude process and we will get the desired position of this blade. Say it okay. Now you can see here there is a 2 mm difference gap as shown in figure, and then we are going to go for this machining cut of 1.7 mm. So here the depth of the machining cut is given. Make this part to be oriented as we want by selecting the view box. Then go for the corner rectangle and then we are going to provide the values here. So I'll take this one as 133 mm and the depth of cut as 1.7 mm. Machining cut depth, and then go for features and extrude cut. Say it okay. So this was the machining cut we required here for the other mating part which is going to be mounted on this face. Motive of machining cut just to avoid the burrs or irregular surfaces between two parts or plates. So lastly we are going to go for the hole commands. We are going to use standard holes here using hole wizard. So here 4 tap holes have been given with the distances as 0 reference. This one as 21.3 and the other 51.3 from the bottom. So this distance is given as 30 mm and the other one is also coming as 30 mm. So we'll go for this tap holes. The size of the tap hole here is given as M5 into 0.8. Now how to judge whether this hole is tap hole or some other hole? You can see here always for the tap holes the symbol is given here as 2 circles concentric with each other. One is dotted and the other one is solid. And other thing you have to recognize for the tap hole is always this pitch value will be given there. That is size will be given in metric, that is M5. That's why it is coming M here. And then into sign will be given showing the pitch value. So for the internal circle we can say M5 minus 0.8, that will be 4.2. That is the diameter of this internal circle. And for the external circle the diameter is of 5 mm. And with the similar size we are going to go for hole wizard. You don't need to say it sketch for the hole wizard. Just select the required face, make it normal, and then go for hole wizard tab. Select the required size. So for tab holes we are going to go here, that is in straight tab type, say custom sizing, and here we are going to select tab holes. Size here was given as M5 into 0.8. I'll select this size M5. Here 0.8 is not given, so don't get confused. You just need to put on this option, that is show custom sizing. And when you minus this 0.8 from M5, the internal circle value we were getting here was 4.2. So we just need to check whether it is coming here as 4.2, the internal diameter or not. So it is showing 4.2. So we don't need to make any change here. We'll just make it taper at the bottom and then go for the position. Select the required face on which you have to put up the holes. I'll select this face and place this hole here. Select smart dimension and I'm going to give this value as 21.3. Now the reference is taken as this one, this edge here. So I'll select this as 21.3 mm position. And this distance was given 16.75 from the left side. So this one has 16.75. So after positioning the holes, say it OK. And then we are going to go for linear pattern here. So now all the 4 tap holes are being provided. Next we are going to go for these holes. So these holes are nothing but dowel holes. So how to understand whether these holes are dowel holes? You can see here fitment with tolerance value is given here. So this fitment with tolerance value is only given for the dowel holes. So here the dowel hole is of diameter 5, fitment as N7. So I am going to go for hole wizard, and the position here it is given as 36.30. So I'll go for hole wizard again. In third type there are subtypes given. So you can see here dowel hole, standard I have taken ISO, and diameter here I have to take as 5 mm, and then go for the types of tolerance, that is fit with tolerance. So after selecting fit with tolerance, I need to give fitment for the hole. So I'm going to go with this symbol here. You can see the drop down menu showing the fits. So the fits was given here as N7. So I'm going to select the standard fit here as N7. We'll go at the bottom, say N7 fitment here. You can see the standard values by the N7 are by default coming here. Minus 0.04 and minus 0.016. Both the values are coming as we have selected the standard N7 here for the fitment of the hole. Then go for the position. Select the required face and position both the holes here. Said OK. And now the dowel holes are also been placed here. Next we are going to go for the holes on this plate. So for that we are going to refer this view here. So here you can see simple drill holes are given. If there are simple holes, there will not be any fitment or tolerance given here. Maybe tolerance will be given at some cases, but fitment will not be given here. So you can judge this as a simple hole, and these simple drill holes will also be shown every time with this diameter symbol here with 6.6 diameter and through end condition. So here 4 holes are been taken, first, second, third and fourth, with diameter of 6.6 and end condition as through. So we are going to make these through holes first, and then we are going to go for this last 2 holes. So here I'm going to take hole wizard, third type, say drill size holes with diameter as 6.6, end condition as through all. Say position and select the face required and give the required holes here. And now the holes are been positioned and been made there. So these were simple drill holes. Now we'll go for dowel holes. So for dowel holes the sizes are given here. We'll consider this PDF. The diameter of the dowel hole here is given as diameter 6. two holes are been given there, and N7 fitment is also given there, and condition for that holes are through holes. We'll go for this dowel holes here. Select hole wizard, select the required type of hole. So I'll go for dowel holes. In third type, the subtype is given dowel hole, say diameter as 6 and fitment with tolerance, that is N7. Position, say face selection, and place this dowel holes here. So from the bottom this is 57 and the upper hole is of 132. I'll take this dimension as 57 from the bottom and this one as 132. And the position from the left side is given 31.75. So I'll give this horizontal dimension to one only, 31.75, and the other will be made vertical relation. Now these whole positions are also defined, say it OK. And now this plate weldment structure has been completed here. So these were plate weldments. So we have made this structure by following all the manufacturing steps. That is, first boss extrudes, then go for the larger cutouts, then go for the machining cutouts, and lastly go for the standard holes. So in this way we should make these all parts. So we have completed the weldments here. Now in next lectures we are going to cover drafting, complete drafting in 4 to 5 lectures. And for previous things such as part modeling, sketcher, assemblies, sheet metal and weldments, you can refer to the playlist on the YouTube by the name of 4 Dimensions Infotech. So please like the channel, follow the channel for more videos. After completing the SolidWorks, we are going to go for Solid Edge lectures also here. Till then, thank you. So hello everyone, today we are going to start with drafting. So to start with, I have made this part with different kinds of features here. You can see we have taken different types of cutouts, holes, drafted faces, radius, fillets, chamfers, and now we are going to take this part for drafting and understand what types of views are available there for drafting. So to start with, I am going to select this file option and say make drawing from part. So now you can see different types of sheet formats are given here according to the sizes, that are A4, A3, A2, A1 and A0. As the number decreases here, the size of the sheet increases. So the smallest size of sheet is here is A4, then A3, then A2, A1 is larger than A2 and then A0. These are the formats of sheets which are available by default by the SolidWorks. So there is no need of selecting the standard sheet size there. Company will provide you the template, but in case if company is not providing the template and you need to make it from scratch, then you can select any size required here according to the standards and then go for the customization of the sheet. That option is also available there. So we are going to select A3 size here. Basically A4 and A3 sizes are mostly preferred for drawing, but in case some parts are complicated or assembly views are complicated to show with multiple features, then we can shift to A2 size also here. Depending on how much part is complicated and how many views we require to show the complete part, that will decide the size of the sheet here. But basically we are going to go for A4 if a simple part is there, or we can go for A3 for assembly or complicated parts. So I'll select A3 and say it OK. Now the sizes for A3 are coming as 297 and 420. If you want to display this table, you can display it by clicking on this option, display sheet format. If you don't want this sheet format here, if you don't want these borders and tables and all, you can off the option here, display sheet format. And suppose if you want a custom sheet size, then you can go for this custom sheet size option. Select and put up the values required for the sheet here, and the size of sheet will be appeared here. But I'm going to go for standard sheet size, and in that also I'm going to go for A3 size and then say it OK. Now here A3 size template sheet has been available. And now in task pane, there is a 4th number option given here, that is view palette. Select the view palette tab here, and you can see by this part only we have inserted By this part only we have entered the drafting zone here. So I'll call the front view first here. You just need to select and drag the front view there in shade. And then when you drag the view upwards, projected views are been appeared there, showing the top view and side view. If I drag it on left side, it will show the left side view. If I drag it on bottom side, it will show the bottom side view. The default method of projection which is used here is third angle method. So I'll also show the isometric view here. Say it OK. Now when you click on this view option, you can see here the display is showing as drawing view 1. As we have called this view first, that's why it is showing drawing view 1. Then we have projected this view. So for that it will show you drawing view 2. Then this is drawing view 3 and the other number of views. You can see here drawing view 4 is been projected there on cursor. So these are the different views which we have called here. If you want to drag this isometric view, you can drag it separately here. But when you drag the front view, the other views projected by the front view are also been dragged there. It is because the alignment is been attached by the front view, that is of top view and side view. The reason behind this alignment is this is the parent view and the other two views which we have called here are child views. That's why when I drag this part or front view, the other child views are also been edited or dragged there. Next we are going to go for the scale. You can see here it is showing the scale as 1:2. You can go for 1:1. This sheet view is not sufficient for projection of all the views here. So I will change it to 1:2 again. And these are the standard scale sizes which are available in SolidWorks. If you want to customize the scale size, you can customize. So here you can see the list of standard scales. I have applied 1:2 here. Now as this front view is the parent view, if I make any change in front view, that changes will be implemented in top and side view also as well as in isometric view. So I select this drawing view 1 and for orientation you can see the standard views given here. I have taken front view. If I want to change the parent view, I can say it right hand side view. I'll click on this option here. This will be changed to right hand side and according to right hand side all the views will be changed here. If I again want to change the parent view here and say it as front view, I'll select this front view option again and you just need to click on this yes option, allowing it to change the orientation. So in this way you can change the orientations of the first part here. Now there is a display style option given here. Same option is in view tabs also. So if you want to change the display style here, select the view and go for the display style. Suppose if I say hidden lines visible, all the internal features will be visible as a hidden line there in front view. But as I said, this is the parent view. The changes we are going to make here will be followed by the other views also. So you need to keep in mind while changing the display styles or any features that all the styles and features will be implemented for other views also here. And suppose if I go for change in drawing view 2 directly, and if I change this style and say hidden lines removed, then it will be implemented for that particular view only. It will not be applied for all views as this view is not a parent view. So if you want to customize the view separately, you can directly click on that particular view and change the required style you want there. You can see here, I have removed the hidden lines from this option. Again, I will click on this view and say to display it in a parent style only, that is showing the hidden lines. So I'll click on this option. You can see here, use parent style. So when I click on this option, again the hidden lines will be visible there. And for this also I'll say use parent style. As this is the parent view, the display style of this view will be applied there also. You can see these hidden features are shown. Say it OK. And if I want to change the display style of all the views at one time, then it is better to change the view style of parent view only. Directly click on the parent view and again say hidden lines removed. All the hidden lines will be removed from other views also. Say it OK. And now suppose if I want this isometric view to be shown in solid feature, I'll select this shading with option here. I will select this shading with edges option here. And you can see all the features and part is again visible there. If I want one more isometric view there, I'll go on this option, say projected view option, select the required front view and then drag the view. You can see the other side of the part shown in isometric view here. You can again place this isometric view here also, showing both the sides so as to understand the features which are placed on each face. We'll change the display style of this view also and say it shading with edges and say it OK again. Now these two are the isometric views and these are the standard views. Scale we have used here is 1:2 and it is standard sheet scale only here. We have not customized any scale here. So after standard scale we are going to go for custom scale. For that I'll select this isometric view here and here is the option given scale, and in scale now the current scale is applied as parent scale only. So the parent scale is nothing but the sheet scale we have applied here. So we'll change it and say custom, and in custom the difference is, suppose these are the standard scales 1:1, 1:2, 1:5. But if suppose I want 1:2 and if suppose I want this scale in between 1:2 or 1:5, for example 1:3, so that scale in standard is not available there. You can see 1:3 or 1:4 is not available. So that time you can customize this scale here, and instead of 1:2 and 1:5 go for 1:3. So you can see the size is been changed here as 1:3. Said OK. But keep one note in mind, according to drawing protocols, custom scales are not applicable for the three standard views here, front, top, side. And if any section views refer to these three standard views, on that section views also you cannot apply the custom scale. Other than that, for all views you can apply the custom scale here. We will see each view now one by one. So to start with, I am going to go for model view. We'll take the sheet number 2 here, add the sheet and say model. In model you can go for browse option to browse the parts. I'll select this part here. I'll select this part here. Front view, and now you can see this model view is converted to projected view. So model view is nothing but calling the first view, and then by default it is converted to projected view. You can drag the directions and take the views required. Suppose if I drag on left side, then left side view will be appeared there. If I drag on the bottom side view will be appeared. If I go for isometric view, in northeast it will take northeast isometric view, northwest isometric view, southeast and southwest isometric view. So whatever views we require here, you can go for projected view and get the required view. Say it OK after completing the views, and now you can see first one was the model view, second was the projected view been applied here. We will delete the unwanted views here, and now we'll go for auxiliary view here. So auxiliary view is required. Suppose if any incline feature is given which is not seen properly in standard views, then we can go for auxiliary view or incline view. So to put up the auxiliary view, you just need to select the option, select the hidden line here. You can see this incline hidden line, so as to show the incline face and the feature of rectangular cut there. I'll select this incline line here and the auxiliary view is generated. It will display this cutout as well as the feature of the rectangular cutout also there in perpendicular direction, so as to give the dimensions in proper way. So now I can put up the length here. This one is 30 suppose, and this one is 16 mm. So these lengths were not visible in these three standard views, but now in auxiliary view I can give the dimensions there. That's why auxiliary view is needed. This was auxiliary view here. Now as we have gone for the auxiliary view and placed it here, but still you can see when you move this view, this alignment is attached to the parent view. That was front view here. This dotted line or inclined line is showing the alignment here. So due to alignment, this view is restricted and we can't move or place the view in other positions here. And if I place it here, the sheet may look congested in area. So to avoid it, I need to break this alignment. You can see that dotted inclined line. So I need to break that alignment. So for breaking the alignment, I need to select the view, say right click and go on alignment option, say break alignment. Now this view is free to move anywhere and we can place it anywhere we require, so as to make proper view positioning, and the views will look proper here now. Again, if I want to align it as default, So I'll right click on this view again and say alignment. Either you can go by horizontal alignment. If I say horizontal and click on this view, it will align it horizontally. You can see the line. If I right click and again go for the alignment, break it, again say alignment and go for the vertical by origin and select this view as vertical by origin. Then this auxiliary view will be aligned vertically with the top view. Then this auxiliary will be aligned vertically with the top view here. You can see it. If I select and go for alignment again and say default alignment, it will get positioned as it was earlier when it was taken firstly. This is the alignment option. You can break or keep or again default align it. I'll break it and keep it here. So it is very important option here. But you just need to keep in mind that standard views alignment should not be broken here. Other than that, if you take any other kind of view type, then you can break the alignment and place it accordingly. So this was alignment option here. So the next type of view we are going to see here is detail view. Select the detail view here. So you can see here one fillet is given at this corner. But when we keep this view normal, it is not visible. We cannot see it clearly. So to visualize it properly and to show it in proper way, we are going to go for detail view. Detail view is nothing but it is going to show this particular feature, that is fillet, in a scaled form, which will be larger in size and will be more visible and properly seen. So we just need to make a border around it. So I'll select this point here and drag it. So one outline is being shown in the form of circle, showing that this particular area will be shown in detail view. So I'll click here and drag this view at side. So here you can see the detail view is being shown and the name assigned for that particular detail view is detail A. You can put on this option here, full outline. The circle will be completely shown here. You can see this border. And if I off this option, it will partially show that circle here. If you want to assign a ladder for this initial, you can go here and say to show the detail circle with leader. So one leader is added here. You can drag and place it where you want. And now this detail view has been highlighted here. I will keep it full outline only. The normal scale we were using here was 1:2. But in detail view, the scale has been increased. You can see here, increasing the scale of the drawing. So if you want to make it more larger or scale the object again by the size, you can go on custom sizing and again change the scale here. I'll say it 1:1. Instead of 1:1, I'll go for 2:1 here. I'll select 2:1 and the size has been increased here again. Say it OK. And now this detail view has been added by the scale factor of 2:1. We can do this for these features also. You can see here one cutout is being shown. This is the top side of the cutout showing the profile. And this is the depth of the cutout. So to show the profile of this cutout, I'll go for detail view again. Select detail view and make an outline around it. And drag it and place it where you want to place it. Just make sure that this initial is having leader here. So I'll select this and say with leader. Now if I drag this circle here, I'll keep it here. Now if I drag this circle here, this circle is also been increasing. So the outline of detail view and size of the detail view is also increasing here. But the value for that particular feature will be shown same on both the views. Either it is detail view or regular view. For example, if I want to say dimension for that particular radius which we have taken as a detail view here, if I go there and put up the value, here the radius is showing as radius 1. But as I put up the dimension in this detail view also, it will show the same value. The value will not be changed, but visually this particular feature is been increased in size so as to understand it. So this was detail view. It will also show the required scale which we have taken here for the detail. So this was detail view here. Now we will go for this relative view. So relative view is nothing but you can orient the part the way you want to show in front view or in top view. You just need to give two orientations and the part will be placed according to that. So we'll select the relative view. Before that, I'll add one sheet here. Then go for the view palette option. The 4th number option given in task pane. If the views doesn't appear here, you just need to click on this refresh option and the views will again be shown here. I'll take the isometric view, say OK. And now if I want to arrange all the views of front, top and side, to start with, I'll go for relative view. Select the view here, click on this option, and then as soon as you click on the view, you are directed to the part here. It will ask you two orientations, first orientation and second orientation. So whatever first orientation you are going to show, it will be front. You can also change the view type here, and the second orientation as required. I'll say this top view as front this time, and second this as top view, this face. Say it OK. And now you can see whatever first orientation I have given there, it will reflect here as a front view. Say it OK. This view is placed here. Means it is according to us if you want to customize front, top or side view and then place the object. At that time only you can use this relative view. The use of relative view is very much limited here, but you can go for this option also. So this was relative view here. So hello everyone, we are going to start with the remaining views. We were going through drafting and we have seen already model view, projected view, auxiliary view, detail view, and now we are going to go for standard view, section views and the other remaining views. So to start with, I'll select standard view here to call the part. Select the standard view, say browse, say open part. And now you can see all the three views, all the three standard views, front, top and right will directly appear here. So if we go with model view or projected view, views will appear one by one by dragging. But in standard view, all the views will directly appear here. The views means the standard views, front, top and side. Other than that, if you want to take the view, I'll go for projected view and again say projected one. Next we are going to see section view here. So to start with section view, I'll go with section option, and in section there are four options given here, that is vertical section, horizontal section, auxiliary section view and the last one align section view. This align section view is not much used, but we will go through this view also. So to start with, I have selected vertical view here. I click on this dowel hole and then say OK. There are more three options given, notch, single offset and arc offset. We will see regular section view first, say it OK, and then drag the part where you want to place this one. If you want to flip the direction of this section view, see, you can flip the direction also here. So now you can see these arrows are flipped and we are seeing from left to right side. And if I again flip the direction, then we will visualize it from right to left. You can see the difference here. Say it OK. So a line is appearing showing the cut section referred as CC, and the section view CC by scale 1:1 is been appeared here. Next option we are going to see here is same vertical option but referring to all the three subtypes there. So I'll delete this section view here first. I'll call it little bit closer here and then go for the section view again. Select the vertical section and then go for the positioning of this line. As we drag the cursor, the section line will move along it. I'll keep it on this dowel and now I'll go for single offset. One blue dot will appear there, you can see here. One blue dot will appear. And suppose I want to cover this counter bore hole. So before coming to its center alignment or before starting the hole itself, the alignment of this dot I'll keep it in such a way that this hole will not intersect the alignment. I'll put it earlier only, say at this point, and then we will drag this offset line to take single offset and place it on this center of the counter bore. You can see the alignment I have taken a little bit earlier so that it should not get aligned with the circle's alignment. Say it OK. And now we have covered both the holes here, that is the dowel hole, this rectangular cutout as well as the counter bore. So it is like a zigzag cut, you can see. If you want to flip the direction, you can flip the direction. In both the direction, all the features will be shown here which were selected here. That is this rectangular cutout, dowel hole as well as the counter bore hole. Say it OK. So this was section DD by using single offset, means a zigzag cut here. Next, again I'll delete this section view and then we will go for the notch type. For that I am going to refer this part here. Select the vertical section view only and place that section line on the countersunk center. Then go for the notch type instead of single offset. So I'll select the notch type in which we have to place 2 points. So I'll place this first point here and the second point here. And then we will provide the offset of the notch. Take it on the center flange. Say it OK. Again OK. Now this will show the section FF here. You can see it here. So as we have taken section line from the countersunks and center of the flanges, all the features are covered here. That is, it is showing the countersunk holes as well as the center of the flanges. So this was section view using notch command. Again, we'll go for the section. Now we'll see horizontal type. So in horizontal type section view, we'll select this one as horizontal and say it OK. Again, if you want to exclude the fasteners, I'll say exclude fastener and then OK. Now the section of this fastener is not shown here. Only the section of flanges is shown. You can see here. The fastener section is not shown. If I again delete view and go for the section, asking for the section of the fasteners also, then select the point here, say it OK and put off this option, that is exclude fasteners. Now the fastener centers or sections will also be shown here. You can see now hatching is being shown on these fasteners also, that is bolt and nut. Then say it OK. So now in this section view, fasteners are also being shown. Next we will see the align section view. For that I am going to go on sheet number 2 and then go for the align section view or auxiliary section view. Select the auxiliary section. The only difference is it will be shown with the inclined references. So I can control the section here, or I can select the points required through which the section line should be gone and then say it OK. This auxiliary section will be shown here. So now the cutout is coming inclined as the references of the points we have taken were inclined. So this was auxiliary section. Again we will go for the auxiliary section. Select the section, select the auxiliary section type and then I'll select this face here. I'll take this reference, the inclined face reference for the auxiliary section and I'll pass it through this point only. Say it OK. And now this auxiliary section has been appeared here. If I want to flip the section, I'll flip and it will show whatever the cutouts coming in that particular section. Say it OK again. And you can see here, this rectangular cutout is being shown on the auxiliary section. And now it is shown normal, so I can put up the values for the placement of this cutout also here. So if you want to take an auxiliary view which is not been properly shown in front, top and side, all the 3 standard views, then go for the auxiliary section. If you want to break the alignment, select and say alignment, go for break alignment and then you can place it wherever you want. Say it OK. This is align section view here. Next we are going to go for sheet number 1 again. And now I am going to delete the earlier section view we have taken, that was section F. Select the section view and say delete. Select the section view and go for half section view. So there are different orientations being given here, that is top side right, bottom side right, left side down and left side up. Similar will be these options that are top side left, bottom side left. Here it will show right side down and right side up. So you can select whichever reference you want to take. So I'll go for this option here. I'll take top side right here and then you just need to select the center here. After clicking on the center, it will ask you whether you want to exclude or include the fasteners. I'll refer to include it. So I'll say it OK directly. And now this view has been appeared showing this quarter section only. Say it OK again. You can see this hatching is being shown here at the upper side. Suppose if I want to rotate and see how this quarterly section view is being shown, so I'll go for this option here, 3D drawing view. Select the 3D drawing view here, select the view and then you can directly move the cursor and rotate the part to see the upper right section. So now you can refer this by putting up in this way. So this was the cut section which is shown here, the upper right cut section. You can rotate it and keep it as you want, or else I can place it to initial position by using this view orientation option. And now you can see, say it OK. So this view has been appeared here. Put off this option. Here is the section KK showing the half section view. We will see it one more time here. Again say section and go for the half section. I'll select this lower side here, bottom side left, and then select the center. Say OK. Go for rotate view, 3D rotate, and in 3D rotate you can rotate this and see the view here. So now the lower quarter half has been shown here. So these are half section view types. I'll go in view orientation and say bottom side. Say OK. Put off the 3D section view. It will orient it according to the section been taken, that is section LL, and this is section KK. You can also put the section view in a customized manner. For that I'll go to sheet number 2. Now if you want to customize the section line and then put up the section view, then go for the sketch option, select the required line you want to put up there. So for that I'll go on this sketch command, take the line command here. So I'll refer this hole here and then I'll cover this hole also. Then after putting up the line you want to cut as a section, go for drawing, and instead of directly selecting the section, first you need to select the sketch and then go for the section. Now this section is being shown covering both the holes here. Say it OK. So this was the section view in which you can customize the line and then go for the section view. The next one is align section, in which you can take 2 cutouts instead of 1. So first I'll select this cut from the first position and then I'll show this as a second position. So now my cut is going from this corner to the upper side and then again the second cut. Say it OK. And now you can see this cut is being shown, align section cut. So the length of this align section cut will come a little bit larger, as this cut is not a single cut but there are combination of 2 cuts, and that 2 cuts are been opened here. So this was the first one and the second one, and this was opened in this direction and then shown here parallel to this line. So this was align section cut. Next type of the view we are going to see here is remove section. Select the remove section command, and here you have to show 2 edges, the first edge and the opposite edge. So I'll select this first edge and this as the opposite edge, passing through the feature you want. Say OK. And now you can see here the section is being shown as a sliced section. So in sliced section, the portion which is not having material will not be shown with the boundaries here. That's why it is showing blank, and this hatching will represent the material which is been present there. So these were the counter suns which are being shown here without having any borders, as it is a slice section view. You can also customize this remove section. I'll delete this section, again go for the remove section, again select the required lines, 2 opposite lines, and instead of going for automatic I'll go for manual here. So in manual I can select the first point I require and then go for the second point. Say OK, and now it will show me the section cut in the form of slice only, but the orientation will be inclined here. Say it OK again, and now you can see I have selected these 2 points by manual selection, and here is the result showing slice cut. So this is remove section, alternate of section view. So the next type of view we are going to see here is broken out section. So to start with broken out section, select the command, and you just need to make a spline boundary around which you want to take this section of the part. So I will take this complete section under this boundary of a spline. As soon as you close this spline, here one message will appear asking for the depth option. How much depth you want to cut from this face so as to take this section of this part. So I'll put up the depth value here. I'll say it 58 mm. I'll say 20 mm here and then say preview. So now you can see here this yellow line or this portion plane, it will designate it is cutting the material till the depth of 20 mm. I kept the distance 20 mm here. It is because I just want to show this hole here. See, the whole distance from the side to center was 20 mm. That's why we have kept the depth as 20 mm. And here it is showing the section in that particular view only. But if we would have taken section view other than this broken out section, then this section would have been shown by adding one more view. Another time I want to take only this portion now. I want to see this portion only. So again I will go for broken out section. Make a close boundary with this spline. This spline will automatically come by the selection of that command. You just need to make a close profile there and then it will ask for profile depth. So I'll show the depth here as 58 mm this time or 60 mm this time and then preview it. So you can see here this was my spline boundary. So it will show only this much boundary there. You can see this yellow line preferring the section cut. It is also showing the internal feature of the cut which was taken here but was not visible from the upper side of the view. So that feature is also been covered here as well as this cutout is also been covered. So you can take these broken out sections in this same view you want to show other than taking another view. Say it OK. I'll delete this and show it one more time. This time I'll call the projected view here. Now this time I want to show the internal cut which was being placed here on this part but it is not visible in front view. So if I keep this part as a transparent then it will show that internal cutout. You can see the rectangular cutout here. So I'll put off the transparency again and then go for broken out section. So whatever area I want to show in that particular section of the view, I just need to make around this symbol of that particular feature. This spline should be a close profile. Then it will ask for depth. So I am knowing the depth of that cut from this face to this cutout was 58 mm. So I'll put up the depth here as 58 and then say OK. So here you can see this depth from this distance. I'll show it by annotation also. For that I'll make this transparent and then go for the dimension. Here the depth was 58 mm. That's why I've taken this depth as 58 mm so as to show the internal cutout. This was broken out section view. Next view we are going to see here is break view. So this break view is used to show the parts which are simple, not having much features but are bigger in length. So to understand this break view, I have one part. I'll call that part. Go in view palette, say browse, and I'll call this part here. So here this part I'll take front view first to show the cross section. So the cross section of that part you can see here is a U kind shape. But when I take this projection, the length of this part is given here as around 1000 to 1200 I think. So I'll measure this part first. So the length it is showing here as 1200 mm. It is a simple part only having a simple cross section. But the thing is the length of this part is not suitable to adjust in this sheet. So for that only if I change the scale also, suppose I say 1:2, then also it is not able to fit here. So to fit this part, I'll go for this break view, select the break view command, select the view required to break, and then it will ask you break line styles. You can see a straight, curve shape, zigzag. So I'll select the zigzag one. And it will ask you to position the first line. You have to position two lines here so as to break the part from two sides. So I'll put the position of the first line here and this position of the second line here, and it will also ask you the gap size. Now it is taking 10 mm. I'll say 5 mm only. Say it OK. Now you can see this cross section here showing the front view as well as the side view. The length is being shown, but this break view you can only take for the parts which does not have any mid features, which are in simple cross section such as shaft or a particular simple plate for weldments. At that time you can go for this break view. But if a part having multiple features in mid also, which are being hidden because of this section or break view, then it is not possible, then it is not valid to take that part for the break view. So this was break view here. I'll change the scale, I'll say it 1:1 only. After that also you can see the dimension, it will show 1200 only. The size will not change, it will remain same. But the adjustment of view is being changed according to the sheet size. So at whatever position I want to keep the zigzag lines, I can keep them and go for the break view. Next view we are going to cover here is crop view. For that, it will ask you for the sketch first. So instead of directly going for crop view, we'll make one sketch, one close entity. I'll say corner rectangle. So one more thing you have to keep in mind, that if you are going for crop view on any view, and that particular view is related to another view types, then we cannot go for crop view at that view. It is because if I have taken detail, section, auxiliary, align section, or any type of view from this particular cropping view, then it will reject the crop view option there. So I'll say crop view now. First select the sketch, same as for section we have done. Select the sketch first and then go for crop view. You cannot go directly for crop view and then select the sketch. The selection order should be such that first sketch should be selected and then go for crop view. And that particular view which was coming in rectangular drawing is been cropped here. Other than that, all the thing is removed here. And this crop view is not reversible, means we cannot undo this crop view. If you want to show that view again, you have to project that view by this projection option and then show it here again. But you cannot undo this option. Now I'll go for alternate view. So I'll select this alternate position view. Before that I'll call one assembly. Say browse by going view palette. And here we will go for this bench wise assembly. I'll say V block assembly here. Say open. And here are the views of the V block assembly. So I'll call the front view first. Say scale as 1:1. I'll say it 1:1. Then go for the projected view and take the other views required. And now this isometric view, you can see this U-shaped part which is positioned at a particular distance from here. Now if I want to move this part little bit backwards, then I'll go for alternate position view. And here it will ask you for the configuration. Select the view and say OK. It will direct you to assembly. And now move component option will appear here, asking you to move this position of the particular part you require. So I'll move this position and place it here at back side and then say it OK again. And now you can see this part is been shown little bit backward with the hidden lines here, showing the alternative view position here. Now I'll move this part, the similar part in this view also here, little bit back side. So I'll go for alternate position, select the required view, say OK for the new configuration, and now take it little bit back side, say it OK again, and now you can see the alternate position of this particular same part being shown here in hidden lines. So you can show the change position here of any particular part in assemblies. For that only alternate position view option is been used. It is mostly used in fixtures so as to show open position and closed position of the particular fixtures. So this was alternate position view here. So these were the important views which we require in drafting of SolidWorks, that was model, projected, auxiliary and so on. So in another lecture we are going to start with dimensioning. Previous lectures we have seen the types of views and other formats of SolidWorks such as part modeling, assembly, sheet metal, assembly types, weldments, and now we are started with drafting. So if you want to check all those videos, you just follow the lectures shown in playlist of SolidWorks, and also subscribe the channel 4 Dimensions Infotech for the upcoming videos. Till then, thank you. So hello everyone, today we are going to start with dimensioning of SolidWorks drafting. So to start with dimensioning, I'm going to select the smart dimension option. We have already taken one part here, shown the reference views, and now we are going for smart dimensions. So to start with smart dimension, select the smart dimension option here. It will come in this annotation tab. After selecting the tab, go for smart dimension and select the required edges you want to apply the dimensions. So I'm selecting this bottom face here. There should be a format of giving dimensions, such as if I want to give dimension, I'll go for the orientation such as bottom and left side. So all my dimensions should come at the bottom or left side. If vertical, then it should come on left side, and if horizontal, then it should come at bottom side. So this type of dimensioning is preferred in many industries. But when we are giving this dimension here, you can see the color of the dimension is coming very faint here. And if I go for the printout of this sheet, then this dimension also will be printed as faint color only. So to avoid that, first I'll go for layers and I'll make one layer for this dimension showing it in a black color. So to make layers, there is a tab given here, that is layers tab. Suppose if it is not present here, then you can click in this blank space, right click and go for toolbars. Here you will get this option layer. So after selecting layer, you can see that toolbar will appear here. Sometimes it may appear at the lower left side or it comes at upper right side here. So I'll start with layer. I'll go for this layers tab. And now I'm going to make one new layer. Select new command and then add here name of the layer. Say OK. Before saying OK, you just need to select the color as well as the line thickness and line type. So I'll keep the line type and thickness as default only, as well as color also as default as black only, and then say OK. You can see one layer has been made known as dimensions. So if I select these dimensions again and change the layer from tables to dimensions, then these dimensions will appear in black color and will be much brighter to observe. Now again, we'll go for smart dimension. Select the required side for giving dimensions. Now while giving dimensions, you have to keep in note that the spacing from the baseline we are giving for the dimension should be constant for every dimension. At least it should look visibly constant. Suppose I am giving dimension here in this way, then you can see this spacing and this spacing. It is not constant. So I have to keep this dimension placing here. So now you can see visually it is looking constant, this distance and the other distance. So this spacing matters here. So whatever spacing I have taken here, I am going to continue in this dimension also. So this spacing should be constant in each and every dimension. Next, if I keep this dimension here, you have to keep one more thing in mind, that each dimension having lower value should lie under the bigger value dimension. Now when you put the dimensions here, suppose this value is having 100 mm, this is 60 mm, so it is coming under this 100 mm as this value is smaller. So in this case also, as we have taken this 40 dimension, the value is smaller than 60. So while placing this dimension should not exceed the upper value. It should be placed under the bigger value only, that is 60 mm. It should not exceed 60 or 100 mm here and should be kept here. So this will be the wrong way of placing the dimension. You should position it according to the values only. Lower value should come under the upper value. Now you can see, due to text size, these arrows are coming at outer sides here. Here it were inside only, but this time they are coming outside. So if you want to flip the arrow, select the arrow and click on this dot, the arrow will be flipped here. Now when you want to position this dimension, you can position it in this way. It will be better if you position it at center from the arrows. Say it OK. Now suppose if I want to change the dimension size here, so you can change it by default settings by going in settings option, or you can individually apply the sizes here. If you want to change the particular size of dimension, only one dimension size you have to change, then select that particular dimension and go for this other option at left side. You will get values, leaders and other options. So I'll select this other, and here we'll put off this default option, that is use document font. So I'll tick off this option and go for customization of font. Select the font and then in points option I'll go for this change in value. If I want to decrease the size of the dimension, then I'll go for the lower value. So I'll select here as 8 and then say OK. So you can see the text size has been customized here, but that was only for that particular dimension. If I want to apply this text size for all the dimensions given here, then I'll go for this format painter and select the size here text size and then click on the other text size which I want to change. So it will copy the text size of the first selection followed by the others. Say it okay. So what this format painter is doing is it will work as match properties option given in AutoCAD. So whatever change I want to make, I'm going to go here, say other, say put off this document font option, go for font, select the points option and decrease the value here, say it as 10, then say it okay. Now the text size has been changed. I'll go for format painter again. I want to apply this text size to other dimensions also. So first I will select the dimension which has been changed and then go for the selection which I want to change. Just click on the selection, say it okay. And now this similar size which was earlierly applied for this dimension will be applied for the other dimensions also. So in this way I can change dimensions individually here. And now suppose if I again go for the new value here and put up the value, so it will follow the same size which has been customized by going in others and then putting up the value. Either we can go by this method, or else if you want to change the dimension size from the default settings only, then you can also go for the settings option, select the options command and go for this document properties tab, select the dimensions and then go for this font size. Changing the font size from here, it will change the default font size only. So I'll keep the default font size here as 9 and then say OK. And I'll click on this option also here. That is scale with dimension height. So it will affect the arrow size here. If I put on this option, then the dimension text size will be copied for the arrow size also. Means whenever if I change the font size, the arrow size will automatically get changed here. We don't need to customize the arrow sizes from here. But if you want to customize the arrow size, you can go for these options also by giving the values. So this value stands for total height of the arrow. This value will stand for complete width of the arrow. And this value will stand for the width of the head here. So in this way also you can customize the values of the arrow. Or else you just need to click on this option and it will automatically get scaled by the change in dimension text size. So it is better to keep on this option here and then say it OK. So in this way also you can change the default sizes of the text. Just select the text and put on the values here. And suppose if I want to change the precision also, then again I will go for the same options, go for settings, options, document properties, dimensions, and here you will get the precision option, primary precision. This primary precision stands for the value which are giving as a dimension. So I will change the precision here and say it as 0.1 only and then go for OK option. And now you can see the precision of zeros after dimension, it is coming as 0.0 only. Means whatever dimension I am going to take, the precision will be shown in one digit only. That is 0.0. If I again change the precision here, say document properties dimensions and go for the precision 0.000, that is 1, 2, 3. So here 3 digits are coming after the point and then say it OK. You can see the change. After each value, the precision will go in 3 digits value. So this was precision option for dimensioning. The way of dimensioning we have used here is smart dimension option only, which was earlier also used in Sketcher. It is similar to Sketcher only, but minor differences are there. This time you have to keep in mind what the text size has been taken, what are the precisions here we have taken, and how to place the text. So these are the changes which were not been implemented in Sketcher. So what we have seen till now here is how to place the dimension at equal spacing from the baseline, place the dimension at mid from the both arrows, also place the dimension at constant distance from each other. The orientation should be such that if you are going to orient this dimension for horizontal at lower side, then each horizontal dimension should come at lower side of the object. And if you are going for the upper side, then each dimension of horizontal should come at upper side. Same goes with the vertical. If you are orienting the vertical dimension, then either you can go for left side or right side. Then the other thing which we have seen, that is the lower value should be placed within the upper value or higher value. It should not exceed the upper value. Yeah, this 200 should come outer side and this 90 value should come at inner sides here. So the next thing we are going to see here is how to put up the center marks and center lines. So for that I am going to go in this annotation tab, and it is very much required before giving the dimensions only that we should put up the center marks and center lines. So I'll put up the center marks here for the holes. So I'll select the center mark option here and then select the hole required so as to put up the center mark. You can see here, I'll select this one also So there is a center mark being appeared here. If I want to change the center mark size, then I'll put off this default option off and then go for the mark size. I'll say 2 instead of 2.5 and say enter. So this size will be customized here. Say it OK. This way counters sunk holes. So for that also I'm going to go for center mark. Select the center mark option and provide the center mark here. Say it OK again. But if suppose I am going to give one dimension for this center mark from center to this end side, it is showing the value here as 13 mm. Now I know this value stands for this hole as 13 from the bottom side. And this hole is alignment with the first hole. But this is understood by me only as I have created this part. But suppose if this drawing goes for manufacturing, at that time the operator will not understand the distance for this hole is similar to the other hole also. So to understand that these two holes are in alignment and this 13 mm distance stand for both the holes from the bottom side, instead of giving the center mark in this way, I'll delete the center mark here. I'll also delete the dimension here and then again go for center mark. And instead of taking this first option, single center mark, I'll go for this option, that is linear center mark. It is very important option here. Select the linear center mark and then select the two holes. So one mark will appear here with a linear line showing that both the holes are at the same distance from the bottom side. So if I put up the value again here, this 13 mm value. So this 13 mm value will represent the position of both the holes from the bottom side. As this line is being appearing here in between center marks, showing both the holes are at horizontal alignment with each other. So that's why this kind of center mark, that is linear center mark, is very important here. Again, these two holes are in alignment with each other. So I'll put up the center mark first, say linear center mark, and then select both the holes. Both the holes will show a linear center line also here, representing the alignment of them. And then put up the value from the bottom side. So it is coming 12 mm, representing that both the holes stand at 12 mm from the bottom side. So this is linear center mark here. Next thing that is given here is center line. So select the center line option. And here I'll go for the center line. Now these two extrusions are circular in shape. Now I want one axis to be shown as a common axis for both the circular shapes or extrusions. So I'll select the center line option and click on the surface here. You can see. So again one center line has been added showing the axis for the second extrusion at the bottom side. Say it OK. Here also select the center line option. Select the extrusions and center line will appear here. These were the circular shapes. But if I go for the linear shapes, there also we can provide the center lines. So I want one center line to be shown between the two sides of the rectangular cutout. So I'll select both the sides and one center line is being shown. Say it OK. This was center line option. So after putting up the center marks and center line, then only we are going to go for the dimensioning. Center marks and center line should be given earlier only before providing the dimensions. Next thing, if I put up this dimension for this diameter, so this dimension is coming in this way. The text is aligned with the leader here. You can see here, the text has been aligned with the leader. So if I want to change the alignment, I want to put up the text in horizontal position. So I'll select the dimension and then select the leaders option here at left side. Now go for this option, that is custom text position. You can see at the bottom left side, custom text position. Select the custom text position option and here it is showing the alignment of the text with the dimension line. Suppose I want horizontal alignment, then I'll select this option here, that is broken leader horizontal text. So you can see this text has been placed horizontally. And if I go for the third option, the text will be placed after the leader with alignment of the leader. And here the text is placed above the leader with alignment of the leader. So both these options will show the text alignment with the leader only. Only the position of the text will be changed. But if I want horizontal position, then I will go for this mid option. And now the text has been positioned horizontally. You can also see the leader type. Here one line has been highlighted showing the diameter according to which this dimension has been given. So if I don't want this extended line here, so I'll select the dimension again, go for the leaders option, and here you are having multiple types of leaders been given here to display. So if I want to show the radius, I'll select the first option as radius. You can see at the left side. If I want diameter, then I'll go for the diameter. Either you can show radius or you can go for diameters also. According to protocol, if circle is of 360 degrees completely, then it should be shown by diameter only. But you can go for radius as well as diameter. Both options are given here. If I want to show diameter with linear lines, then I'll select this linear option. So both side arrows will be shown. Suppose I don't want this leader or line to be extended, then just click on this option, that is one arrow open leader. So I'll select this option here. So this line, extended line, will disappear. If I again want that line, I'll select this option. If I want these arrows to be flipped inside or outside, I can go here at the top side. You can see the arrowhead position being oriented by clicking on these options. And suppose if I want this arc extension line or opposite side of the arrow, then I'll put on this option. You can see in both ways we can show. So these are the options given for leader here. Now if you want to put some prefix or suffix for the dimensions given here, you can go for that option also. I'll select this 200 dimension. So as soon as you click on the dimension, now as soon as you click on this dimension, one box will appear in white color showing 4 arrows, and it will expand if I put this arrow position there. And now after expansion, you can see here the dimension properties dialog box will appear, and here you can add suffix and prefix also. So if I want some text above the text, then I'll go for this text on top option and type the text which I want there. So now this text is coming above the dimension. If I want the same text to be taken at prefix side, then it will come before the dimension. You can see here this text is coming before the dimension. I will delete this top text. If I want this text to be coming after the dimension text, so again I'll copy and delete this one here and go for the suffix option and say paste. So now this text is appearing after the value given here. And if I want this text to be taken at the bottom side, I'll paste it on bottom side. Now this text is coming below the dimension value. So if I want to put the brackets here, I'll go for this add parenthesis option. So it will add brackets there. If I want to put off again, I'll again click on the same option. If I want this text to be center aligned, I'll go for this option, that is center dimension. If I want to add some tolerances or values for the unit precision, I can do that also from here. We will see it later. So this was the things to be remembered before putting up the dimensions. In next lecture, we are going to continue with the different dimension types being given here. In this lecture, we have seen what are the formalities to be done before giving the dimensions. In next lecture, we are going to give the dimensions also here using all these options. Till then, thank you, and we will continue the drafting in next lecture. Hello everyone. So today this is the next lecture for drafting, in which we are going to see the dimensioning processes. Different types of dimensioning here. You can see smart dimension, horizontal, vertical, baseline, and similar. So to start with, first I will provide the center marks here. Select the regular center mark option. Select the center marks here. Say OK. Now for these holes, both are in alignments. So I'll go for linear center mark there. Select the center mark option. Select the linear center mark and select both the holes here. They will be provided with the linear center mark, showing that both are having equal spacing from the bottom side. Say it OK. I'll again go for the linear center mark and select both of these holes now. Say it OK again. Now for this circularity, we are going to provide a different kind of center mark, that is center mark with ordinates or circular center mark. Select the circular center mark option, select the feature here, and then you just need to click on the other circles which are on a particular PCD. So I'll select these circles here. So you can see one circular mark has been created, also showing the angular lines here. Say it OK. Next, for the cylindrical features, I'll go with the center line option. You just need to select the circular faces and the center line will be provided. Again, we'll go for this also. Then say it OK. But if the feature is coming in a rectangular way, then go for the center line option and select the sides of the rectangular shape. The center line will appear there. So after providing the center marks here, we'll go for the option, that is providing the dimensions. So I'll select the smart dimension option. In previous lectures, we have seen how to change the dimensions, how to change the precisions, how to place the dimensions, and how to change the layers of the dimensions so as the appearance will change. So now we are going to see the different types of dimension. For that, I'm going to select the first option, that is smart dimension option, and then go for this face here. So I'll provide this face dimension here as 200. Next, I'm going to go for this vertical dimension. All the horizontal dimensions will come at the bottom side and all the vertical dimensions will come at the left side. Before that, I'm going to change the layer again and go for the precision change and dimension text size change. For that, I'm going to go here in layers option tab, say new layer, provide one layer, name as dimension, say it OK, and select the dimension and update it into layer of dimensioning. You can see the color and brightness of the dimension has been changed. It is coming black now. Next, I'm going to go for the precision change as well as the text size change. For that, I'm going to go in default settings, options, and here document properties and dimensions. So in dimensions, I'm going to change font size first. So it is coming 13. I'll take it as 11 only. Say it OK. Next, I'll change the primary precision. I'll keep it 0.1 only here. I'll also click on this option, that is scale with dimension height. So the arrow size will be changed according to the dimension size being changed. Said OK. The type of arrowhead you can see here. If you want to change the default type of arrowhead, you can change here. I'll keep this one here. Said OK. Now you can see this arrowhead type is being changed, as well as the text size is also being changed, and the precision coming here is in 0.0 only, that is 0.1 digit only. Next, we are going to go for other dimensions. So a smart dimension is similar to the smart dimension option of Sketcher. You just need to arrange the dimensions. So I'll arrange it because I want this dimension to be shown here. I want to flip the arrow. I'll flip the arrow here. Say it OK. Now I need to keep thing in mind that the spacing from the baseline should be equal or constant on all dimensions. So I'll place them properly first. This was smart dimension option. If I go for this horizontal dimension, now it will take only horizontal dimensions here, or the dimensions for the horizontally positioned entities or features. Next option is given here as vertical dimensioning. So I'll select this option first, second, flip the arrow side, and this one as third one. Next option here is given is baseline dimensioning. So for baseline dimensioning, it is referred mostly in fixture design. It will take a common base and refer all the dimension from that particular common base. So it is very useful in fixture design as we have to show all the dimensions from one datum. At that time you can use this baseline dimensioning. So I'll select baseline dimensions option here. Select the first feature, second, and the third feature here. I'll select this point, and the fourth feature I'll select this edge. So you can see all the three dimensions are coming from the common base. This base or starting point is common in the dimensions, and the end of the dimensions is been deferred, taking dimension from a particular datum or a base and then showing the dimensions. Again, we'll show it here also. So here also I'll go for baseline dimensioning. Select the base first, then this axis, then this end side, then the second axis, and then the last face. All of the dimensions are having one common base or datum, and then followed by the ends differing at each end. Said OK. This was baseline dimensioning. I'll delete these options here, and now we'll go for the continuous line dimensioning or chain dimensioning. First, I'll put the center line mark here for the cylindrical faces and say it OK. And now we will select the next type, that is chain dimensioning. So for chain dimensioning, I'm going to select this face first, then the second face, then this point as the third point. It is not highlighting the point here as this feature is not intersected at this edge. That's why this point is not being shown. So I'll go for this option here, and then this axis, and then the last face. I'll select the chain dimension again. I'll select this as a base, the second one, third, and the last one. So all these dimensions are coming from one feature end to other feature end, point to point. They are not taking any common base or datum here. So this is chain dimensioning. You can dimension a series of features together. You can see these arrows are also been aligned properly here. So this setting is by default in chain dimensioning, that the dimensions will come aligned only. Suppose I drag one dimension, then the other dimensions will also be dragged here. You can see here. Next we are going to go for symmetric linear diameter. So in symmetric linear diameter, I'll use this feature. You can see two circular projections or extrudes been made here. So I want to show the diameters of this extrude. I'll select the axis first and select any one side of the cylindrical shape. It will show the diameter or highlight the diameter there. If I select the second side, it will highlight the other diameter also there. But according to selections, if you notice, we are taking the selection from axis to side. We can say it is a radius type selection, but the diameter has been displayed here. That's why it is very important option here, that you can display the diameters here without consuming much space. This feature of dimensioning is used only for the parts which are concentric and are in multiple layers. At that time you can go for this symmetric linear dimension. Next option is given here as ordinate dimensioning. So I'll delete these dimensions first and then I'll go for the ordinate dimensioning. Ordinate dimensioning is mostly used when you need to show some features that are in pattern form or at side by side in multiple numbers, which are very useful and are optimized while showing. So I'll start with ordinate dimensioning here. I'll select this ordinate dimension option. I'll take this side as 0 ordinate, then select this circular feature, the other one, and so on. I'll continue this clicking to show the all the standard hole features. You can also select the other features here. Suppose I want to end this dimension at the last end. So this ordinate dimensioning is being shown, showing each and every feature in a single dimension line. From 0 reference, all the dimensions are being shown. So this is 0 reference. The first hole is standing at 20 mm. The next hole is standing from 0 reference is at 38.6. The other one is 77, and so on. So this is also taking a datum dimension here. Means a datum has been referred as a 0 ordinate, and then we are going for dimensioning from that particular datum to all the required features. I'll select the vertical ordinate now. I'll go for this option again, select the ordinate dimensioning. I'll take this one as 0, and for vertical ordinates now, I'll select this one, the second one, third, fourth, this circular feature also, and then I'll go for this last option here. And now all the ordinates are coming from this 0, 0 references, vertical as well as horizontal. You can adjust this line by dragging it for the position. You can see here. You can also adjust the text position here by dragging them so that they are not messed up with each other. If I want to hide this arrow, then select any one dimension, and in leaders you can put off this ordinate chain option, and this will hide the arrows there for the complete dimensioning chain. Here also, if I want to go for this one also, I'll select any one dimension, go to leaders and put off this ordinate chain option. The arrows will disappear there. If I want the arrows back again, so I'll select the leader option and say ordinate chain on, and the arrows are visible now. I'll little bit decrease the size of the dimension text, go to default settings, say document properties, dimensions and font. Here I'll say it size as 7 only, said OK. And now this text size has been decreased to 7. Next type of ordinate dimensioning, I'll go for this horizontal and vertical. They are similar to this one only. And now suppose if any feature is been remaining there, which is not been added in this chain, so I can add that feature later also. But you don't need to select another ordinate option here. You just need to select the chain in which you want to add that particular feature dimension. I'll select this one, any one dimension, and then right click and say add to ordinate. And now suppose I have forgotten to add this dimension of the base, so I'll select this base here. So you can see this dimension is also been added here. I'll select this one also. So this dimension is also been added. So if any feature or dimensions remain there, you can adjust them and place them later also. And now suppose in horizontal chain also, if I have forgotten to put this feature here in this chain ordinates, so again I'll select any one value, right click and say add to ordinate and select that particular feature. So it will add the dimension from 0 reference for that feature also. Say it OK. So this was the ordinate dimensioning here. Next two types are similar, that is horizontal and vertical ordinates. They are nothing but ordinate dimensioning only, so I'm not going to show them. Here the difference is only the orientations are shown separately, vertical ordinates and horizontal ordinates. Next I'm going to go for this angular running dimension. I'll select the angular running dimension here. Take this as a 0 reference and then I'll click on this circle. It will show the angle. The other circle, it will show the angle in chain for that continued circle. Then the other circle, and you can see dimensioning has been created in a chain form but in a circular way, showing the angles. Say it OK and then place it wherever you want. So this was ordinate dimensioning in angular form. Place it wherever you want here. Say it OK. This were angular ordinate dimensioning. The last type of dimension to be shown here is chamfer dimension. We are not going to use this path length dimension. I'm directly going for this chamfer dimension here. So in chamfer dimension, you need to select the incline line first and then select the reference line for the horizontal ordinate. And now you can see this chamfer value is being shown here, showing it as 5 into 25. This is the distance and this one is the angle for the chamfer. Again, we will show one more chamfer dimension here also. So select the chamfer dimension. First select the incline edge and then go for the straight edge. And now this chamfer dimension is also been highlighted here. If I want to place this leaders in horizontal position showing the chamfer value, I'll select that particular leader, go for leaders option at left side and go for the custom text position. Here I'll place this leader in the second type, horizontal underline text. Say OK. And I want to copy this leader type here also. So I'll go for format painter, select the required leader type to be copied and select the required dimension on which I want to copy it. And this dimension will also be shown in horizontal text format. Say OK again. So these were the options here for dimensioning. Now we are going to see the hole callout option. So this hole callout option is only used for standard holes which are being applied by hole wizard. Mostly used for fasteners type holes. I'll select this hole callout here and then select this hole type. So it will directly give in detail which type of hole is been applied here in hole wizard. So it is showing here counter bore hole is been applied. The sign is been shown here. There are two diameters, that is diameter 5.5, that is internal diameter. I'll change the display option here to show the counter bore option. Say OK. Now you can see this counter bore. So both the diameter as well as both the depth are given. First one is given as through hole and second here it is showing as 3.5. So the type of hole, the size of hole, the end condition of hole, all are been highlighted in one dimension only by using hole callout. So it is very important option here. I'll select this hole callout option again and go for this counter sunk holes and I will display them here. So you can see there were two counter sunk holes. So it is also showing the total number of counter sunk holes as well as the sizes of the counter sunk holes. It will show the similar kind of holes in numbers also. How much number of similar holes are being shown there. Next I'll go for this hole, select the hole callout and put up the dimension. So now it is showing here as dowel hole. You can see the fitment is also being shown and the tolerances with the fitment are being shown, but they are been highlighted here as 00 only. It is because the tolerance precision we have not added there. Select the dimension to add the tolerance precision and here you can see the tolerance precision option. First one, this first option is standing for unit precision, that is for dimension, and the second one is for tolerance precision. So I'll increase this tolerance precision as here the note is coming as same as nominal or document dimension size. So I'll change it and I'll say I want a different precision for that particular tolerance value. I'll say 0.123 here. Now you can see this tolerance precision is being changed, but the dimensional precision or dimension precision is same. That was of 0.1 only. We will see all these options in detail in next lecture, in which we are going to see all the tolerance options. For further videos, you can follow the playlist, and also for the previous video, you can go for the channel 4 Dimensions Infotech, subscribe the channel, and you can learn SolidWorks from starting to the end. Now currently I am uploading the drafting videos. Still 2 to 3 videos more to come for completing the drafting here. Till then, thank you. So hello everyone. Today we are going to start with dimensioning only. We were seeing drafting, and in drafting we have already seen 4 lectures. Now this is the 5th lecture based on dimensioning and tolerances. So to start with, we are going to see the model items option here. Model items refer to automatic dimensioning here. So I'll select the model items option. So I'll select the view to provide automatic dimensioning here. I'll select this front view and say whether you want to import the dimensions on entire model or whether you want to import dimensions on the selected feature. So for both options you can go here, either for entire model or for the selected feature. So I'll select the entire model here and then I'll say import items to all views. It means that the dimensions we have given here for making this sketch and features, that will be imported in this part in drafting also. So I'll select these import items to all views and then say it OK. Now you can see automatic dimensioning is been provided here, but the dimensions are coming random, means they are not properly arranged. We need to arrange them one by one. So this is the drawback of model items or automatic dimensioning, that dimensioning will occur there, but for the features that are been dimensioned in sketcher only, not for the instances which are applied in features, such as holes. You can see the type of hole it is given here, but the depth of hole is not given. So if I give the dimensions by using model items, the depth of the cuts will not be included here and only overall dimensions will be shown. So it is not much useful command, as if it will take time for arrangement of the dimensions again and again, and it may provide the dimensions which may not be needed at that time or which may not in a priority to be given. Say it OK here. Therefore, model items option for dimensioning or auto dimensioning is not much used. Next way of dimensioning, again there is one more option for auto dimension. I'll put on this sheet number 3. I have taken 2 parts here, 2 different parts. First I'll select this part and then go for the smart dimension option. I'll click on the smart dimension directly and you can see auto dimension option is also given here. So I'll select this auto dimension option and then click on the required origin. Here we need to show the origin. So I'll say this point as an origin. Select this point. Here you need to clear the selections which were made earlier and then go for the selection of origin. So I'll select this as a origin. Next I need to give horizontal and vertical references here. So for horizontal I'll select this edge and for vertical one I'll select this one. I'll say it OK. So here also you can see by default dimensioning is been provided, but same drawback is here also with auto dimension, that unwanted dimensions are also given here which may not be needed much, and some required dimensions which may be important here are not been given or present here. That's why this dimension auto dimension option will also not cover all the dimensions. So it is better to refer and give the dimensions manual only, as we have seen in previous lectures. So this were the option by which we can apply the smart dimension automatically, but they are not much used. You can see this 146 dimension is been repeated here. Similar way, some more dimensions are been repeated here. So it will not give the highest precision for dimensioning. That's why these options for auto dimensions are not used frequently here. I'll cancel them both. Here also you can go for smart dimension, select auto dimension, then go for the origin. I'll select this as the origin and then say apply. Here also dimensions have been provided here, but not all the dimensions will be covered. This was auto dimensioning option. Now next we are going to see tolerances and how to apply tolerances on dimensions. For that we are going to refer here sheet 1, and here I have already given dimensions. We just need to apply the tolerances where required. So before applying the tolerances, I need to clear that values of the tolerances will depend on the conditions in which the part has been mounted. For what purpose this part has been mounted, what is the requirement of that particular part, whether this part is in motion or it is a rigid part. So that all conditions will decide what kind of tolerances are to be implemented here. So here we are going to see only the commands, how to implement the tolerances here by using the commands. So to start with, suppose I want to apply the tolerance for this dimension, that is dimension 25, which is controlling the position of this hole. So for that I'll select that particular dimension. So now here we are going to apply tolerances for this particular dimension which is controlling the position of this hole. So to start with, I'll select the dimension first and then go for this tolerance option. So in tolerance option, tolerance types which are given here. So first there is none, means no tolerance will be applied. Then the other type is given here as basic. So if I select the basic option here, so this rectangular frame around the dimension will only indicate that the dimension does not require to be given tolerances here, as this tolerances required for the dimensions are given somewhere else. So there is no need to apply tolerances for that particular dimension. I'll select this dimension again and go for the next option, that is bilateral tolerance. So the bilateral tolerances means we are going to apply the tolerances on both sides, that is positive and negative. So when you select the value, you can see bilateral has been applied and the values it is asking here. So if I want to apply tolerance for this 25 value, so I'll say 0.2 on positive side and 0.3 on negative side. So you can see here these tolerances are being applied bilaterally, means on both sides positive and negative. Suppose if I want to show these tolerances as unilateral, I'll select the dimension and I'll change the value first. I'll say it's 0 at negative side. So now you can see here the value is coming in positive side only and the other value is 0, 0. Means the tolerance is not going on the other side, in negative side. So you can say this tolerance as a unilateral tolerance. You can also go for the negative tolerance here. I'll say minus 0.2 and in positive side I'll go for 0 tolerance. Means the tolerance is at one side only, that is negative side. That's why it is called as unilateral tolerance. Again I'll select the tolerance option. Again I'll apply one more dimension here to place this point. By applying the tolerance on this dimensional value, I'll select that value here and here I'll go for this bilateral tolerance again. Now I'll put up the value here as 0.02 in positive side and 0.01 in negative side. But still you can see the bilateral tolerances are not visible even after applying. This is because the precision for the tolerance is shown as same for the document. It means that whatever precision is applied for the document dimension, that is default dimension, will be applied for the tolerance also. But if I want to change the precision of this particular tolerance, I'll select the value and here you can see the option for the tolerance precision is also given here. So I'll select here and instead of taking same as nominal, I'll go for dimension as 0.123. I'll go for precision as 0.3 or 3 digits after 0. So here you can see, now it is showing the tolerance in a proper way which I have given here. I'll go for the precision as 0.2 only. So now it is showing the proper value for the tolerances here with correct precision. Now suppose if I want to change the height of the text for the precision only, I don't want to change the height of this text for the dimension. So I'll select this others option, and here you can see the option is given tolerance font size. So I'll put off this option, put off the other option also, and here I'll go for the font scale. So I'll scale it as 0.5. So this scale is relative to the document font, that is dimensional font. So if I take this scale as 0.5, the tolerance text size will be half of the dimensional text size. I'll say it okay here. You can see the tolerance text size has been decreased and is half of the dimension size. So in this way you can change the text height of the tolerance also here. So the next type we are going to see here is limit tolerances. So to apply the limit tolerance, I'll select this value, and here I'll select the option as limit. So in limit tolerance, if I select the limit option, it will again ask me for the tolerance here. So I'll select and give the value. I'll say it's 0.2, and here I'll say it's 0.3. And after applying the tolerance values, I'm going to change the precision of the tolerance. I'll take it as 0.12. So now the tolerances in the limit option will be directly shown with the value. The tolerance values are not shown separately in limits option. They are added in the actual value only, and directly the values will be shown. So this is the limit tolerance or limit type of the tolerance. Next we are going to go for fits. So to display fits for the particular dowel holes, here you can see I have provided one dowel hole. So while making this hole in part modeling, at that time only I have provided the tolerance and fits there. So I will just select the hole callout option and then click on this hole, and the dowel hole will be shown with the fits here. But you can see as the precision of the tolerance value is 0.0 only, that's why the tolerance has been not shown here. That's why I'm going to select and change the tolerance precision here. I'll take it 0.123, and now you can see the fits fit tolerance has been shown. So this is the fit code, that is F7, and there is predefined tolerance which is applied for this F7. Now again, if you want to see how this hole is been applied with this fit, I'll open this part here, and now I'll apply that fit for this dowel hole also. So here the dowel hole has been created. I'll open this part. It will show that diameter 4 dowel hole has been created here, but fits were not applied for this dowel hole. So I'll apply the fits to show you how to apply the dimensional fit here. I'll click on this option, say edit feature. Here you can see at the bottom, tolerance option has been given. So the type of tolerance it is showing here none. I'll change it and say fit. And now it will ask you whether you want to apply fit for the hole or shaft. I'll select the hole option as the hole has been applied here, and all the fits for the hole will be shown in capital letters. If you consider the fit for the shaft, and for shaft all the alphabetical letters will come in small. So in this way you can recognize whether the fit is for hole or for shaft while reading the drawing. So I'll go for the hole option, and here I'll apply the fit as N7 now. So I need to select the option N7, say it OK. I'll save this part first and open the drafting sheet here. And now when we go for this hole callout option, select this hole callout, and here you can see as I have selected only fit option, fit is been shown. If I would have selected the option fit with tolerance, then the tolerances also would have been shown here. Now suppose if you have forgotten to give the hole the tolerance or the type of fit required, you can also provide that particular fit or tolerance in drafting sheet also. So here again I'll go for smart dimension, put up the value here. Instead of hole callout, I'm going to take dimension option and then go for this tolerance type and select fit with tolerance. This time I'm selecting fit with tolerance. Earlier I have selected only fit option. And after selecting fit with tolerance, I'll apply the required fit. I'll say it again F7. And here the fit with tolerance has been applied. I'll say it OK. But still after applying the tolerance precision is 0.0 only. That's why the actual value is not been displayed. So I'll select the dimension again, and here I will change the tolerance precision and say 0.123. And now you can see this value for the fits has been provided here. If I want to place this F7 at the lower side, I'll select this option. You can see the position of the fit is being changed, If I again go for the first option, it will show at upper side. So these options are just given for the fit position, whether you want to place it at bottom or at upper side. You can see the change here. I'll say it OK again. I'll make this leader horizontal, say custom text and say horizontal and say it OK. So now you can see this dowel hole has been provided fit tolerance. Only the difference of taking hole call out and smart dimension option and then applying fit. Here the depth is being shown and here the depth is not being shown. So if I want to show the depth also here, I'll select that particular dimension and go for the symbol here. In this casing, I'll add the symbol in dimension text and then I can put up the value here, or I can say through all here. So I'll say through all, and now the depth is also being shown. So you can customize the given dimension also. Suppose I want to add text for this particular dimension, I'll select that dimension and in dimension text you can add the required text here. Say it OK. One more option is given to add the text which we have seen earlier, that is this box, and here you can add the tolerances also. Suppose I want to add bilateral tolerance for that particular dimension, I'll select the bilateral option and here you can add the bilateral tolerance. I'll say upper side 0.02 and lower side 0.01. So in positive side it is coming 0.02 and negative side 0.01. But it is not being shown as the tolerance precision. We need to change it here. I'll select and change the tolerance precision. I'll say 0.123 and now you can see this tolerance has been added here. So by clicking on dimension and expanding this box, here also you can apply the dimensional tolerances. Suppose I want symmetric tolerance, I'll select this symmetric option. Now the symmetric tolerance means in positive and negative sides, both sides, only one value will be applied. That may be any value, I'll say 0.02. And then if you want to add the precision also here, so here the option for the tolerance precision also has been given. I'll select and say 0.123 and that particular precision has been added. You can see a symmetric tolerance has been applied in both positive and negative side. Symmetric means nothing but same value in positive and negative side. It is kind of bilateral tolerance only. So either you can go for manual option to apply the tolerances, either you can directly apply the tolerance, or else you can select the dimension, expand this box and here you can go for the tolerance option with change in precisions also. So in this way you can apply the tolerances here. We have seen all the different types of tolerances: bilateral, unilateral, symmetric, limit, as well as fits and tolerance. We will continue for the remaining commands such as tables in next lecture of drafting. Do like, share and subscribe the channel and follow for more lectures. Thank you. Hello once again. So today we'll start with tables and we are going to see different types of tables that are used in SolidWorks drafting. So there are multiple types of table being given here. You can see in annotation tab, you can click on this arrow, or this option of table may appear here also. Just select the arrow, drop down arrow, and you can see different types of tables are being given. So to start with, we are going to start with general table. So I'll select this option as general table. And here you need to specify number of rows and columns you want there. So these general tables are basically used when you want to make this bill of material manually only without linking the properties of the part. So if you want to make a BOM, bill of material, by inserting the values and properties without linking the part, then you can go for this regular table or general table. So we'll specify the number of columns here. I'll say columns number 5 and to rows I want here is 4. I'll say it OK, and now this table will appear here. You can see. So if you want to drag and place this table, you can click on this icon here and you can place this as you want. There is one more option given, that is attached to anchor point. At left side you can see here. So if I select this anchor point option, different orientations will come according to table. But if we'll take the common anchor point, that is this corner point. So you can place it as you want, say it OK. And now one general table has been placed here. So the need of general table is when you want to make a bill of material that is not linked with the part properties. So I can put up the values here, or else if I want to make a table which is showing the accessories of a particular assembly, at that time also I can use this regular table or general table. So you just need to double click on this cell and you can add the required text you want. Suppose I say SR number, then I'll tap this, double click on this cell here, I'll say name, next cell I will name it as date, and so on. So in this way you can add the text required in these cells and complete the required table. You just need to add the properties in the cell manually only. That's why it is called as general table. Next type of table we are going to see here is revision table. So for adding revision table, first you need to add a shape or symbol here featuring that particular revision we required to make. So I'll select one of the shape here. So I'll select here a rectangular shape or a square shape and then say it OK. We would have selected the circular shape also, but the problem is when you take a balloon option or auto balloon, at that time also the numberings will come in the outer circle shape as circular only. So to differentiate it from other symbols, we are going to take here as a rectangular or square shape. Said OK. And now you can see here one revision table has been added. It will come by default at the upper right side. And here it will ask you an option. You can see here, it will ask you to click and add the revision there. So I'll click on this option. And here you can see you can add the revision. First we have to symbolize it at which part or feature you want to make that particular revision. So I'll put up this revision on this circular face here and give the initial as A. Now we need to provide the description of that particular revision. So I'll double click here and add the description here. So in description I am going to write what revision is needed to be added there. So I'll double click and type here on this cell. So the revision is I want to add hardening process on that particular feature. So that feature is to be hardened there. So I'll double click here and type there hardening to be done. So we have put up the description also there. It will also highlight the date here and you can put up the approval of any authorized person you want to put here. You can add his name or initials here. Same way I want to add one more revision. Suppose I want surface finish to be flattened here. So I'll click on this option and add the particular revision for that zone. I'll select this surface here. So here I want the description for that particular revision. I'll say I need surface finish there. So I've added the second revision also here. Now this sheet size is A3 and it is a bigger size. So you need to locate that particular revision. For that one option is given, that is zone option. You can see it is showing C6 for that first revision. So you can locate that revision here by seeing that zone, that is C6. So here you can see this first revision, it is coming in C section by horizontally and vertically it is coming under column 6. So here horizontally the cell column is showing C and vertically it is showing 6. That's why the zone is given here as C6. So that you can locate that particular revision and see the description here. So this was revision table. So the next table we are going to see here is weld table. So for weld table, I have taken one weldments part here, you can see, and we are going to weld two gussets here on these two opposite corners, first one and the second one. So to put up the weld, we are going to use the command weld bit from weldments tab. So here weld bit is given. I'll select the weld bit tab. Then you need to select the type of weld selection. There are two ways for giving the weld bit. First one is to apply weld bit by using two faces, that is two adjacent faces. I'll say this face and this face. So the between edge will be welded as we select both the adjacent faces here. So you can go by this method also, or else one more method is given, that is weld path. I'll select weld path option here and you need to click on the edges you want to weld. So I'll select these edges here. So in both ways you can weld. First way is to select two adjacent faces and the common edge between the two faces will be welded. And the second one is directly by selecting the weld path option and then selection of edges required. So after putting the selection, you need to select the size of the weld. It will be in a radius size, so I'll say 5 mm radius. Next I'm going to define the symbol. So I'll select this define weld symbol option here. And here you can see the size has been given. I'll select the weld type and here I'll select fillet weld. Next is if you want to provide the finish for that particular weld, you can also say counter. You can go for these options here. First one is none, second is flat, third is convex shape or concave shape. So I'll select the flat one option here. Then select the weld option. Then go for the weld length. So whatever length you are going to weld there, you have to put up that length. I'll say 30 mm here. After putting up all these value and type of counter you required for the finish, say it OK. I select the weld bit option, go for weld path and select the required weld edges. So I'll select both the edges here, put up the value, define the required symbol for the weld and select the counter as flat. Whatever you want to select, you can go for that. I'm selecting flat and here I'll put up the symbol as fillet weld. Say it OK. Same we are going to go for this option also. This time I'll use the first method. We are going to put up the weld here also on the opposite gusset. So for that select the weld width and here we will select the first option this time. So you need to select two adjacent faces here and the common edge will be welded. Put up the value, select the symbol required here. I'll select fillet weld only Next, put up the counter or finish and put up the length you want to weld. I'll say 35 this time. Say it okay. Now this length is nothing but this edge length. So I've taken that length as 35. One more option is given here, that is from length to length. Means if you want to provide only the particular length of that weld, so you can use this option. So I'll say to start it from 0 and I want this length to be completed till 15 mm only. So the weld will start from 0 till 15 mm. Next, the option is given here is intermittent welding. If I select that intermittent weld, you can see here, you can provide the weld by providing a gap also in between the welds. You just need to put up the weld length, that is 1.25, this length, and the other one is gap. So I'll select this gap as 0.5 only. I'll select this gap as 1.5. So here intermittent weld has been provided here, you can see. Same on the other side, so I'll select again this weld bit option. Select the two adjacent faces. Define the symbol, fillet, and then put up the length. It was 25, actually we have taken 35 earlier, and put up the length. Also you need to put up the finish if you want. I'll say it flat, say it okay. Then after putting up the symbol and values, we'll click on this OK option. So here I have provided weld for the both gussets. Now if you want to show that weld bit, you can go in this show hide items and put on this option here, weld bit option, view weld bits. So here the weld will be shown, you can see here. Here it was intermittent welding, here it was continuous weld. On the other end also, here this gusset was welded by the fillet of 5 mm. Now by this part I will go for drafting. Select the file option, say make drawing from part. Select this A3 size, or you can browse if you are having any template ready made here. I'll select this template and say OK here. Now we'll call the front view first, and then it will present the top view. Here it will show the isometric view also. Select the tables option here, and here you can see different types of table given. So I'll select this weld table. There one more option regarding weld is given, that is Weldment cut list table. This is totally different table we have not seen yet. We are going to see it further. Now we are seeing that is weld table. So don't make confusion between these two words. This is weld table, which will highlight only the welds which we have put for the gussets. So I'll select this weld table here. You need to select the view and then say it OK. So here you can see one table has been appeared. I'll change the layer for that particular table. I'll select that table and say predefine. So for this particular weldment structure, we have provided 4 welds. So you can see the quantity here. First, then second, then third and fourth are both combined in single. That's why both the welds are being shown in single row here. So you can see in this table we have item number, weld size, type of symbol representing the type of weld, also the weld length we have provided. So the total weld length is also been provided here. So in this way you can provide the weld table. The another way to show this welding here is select that particular view. I will delete this unwanted views here. Now one more method is given to show up the welds here. For showing the welds automatically, we are going to go for this model items here. This option is also used to show the dimensions which we can provide automatically. So you need to select the source. So I'll select entire model here. Then instead of showing dimensions, I'll put off this option and go for this weld option. I'll select this weld symbols. I'll also say to show the caterpillar symbol here. And then I'll select this weld symbol or end treatment symbol. All these 3 symbols are needed to be selected and then say OK. So what we have done here, that is in source we have selected entire model, put off the auto dimensions option and then select these 3 symbols to show the particular welds. Say it OK. And now you can see all these welds have been provided. Say it OK again. And now you can relate the symbols with the table data. If you want to provide weld material, you can also provide the weld material here. So this was weld table. So the next type of table we are going to see here is bend table. For that, first I'll say flatten to this part, and after saying flatten, we are going to go for drafting. And in drafting, we are also going to see punch table, in which we are going to show this forming tools been applied here, the location of that particular forming tool and the orientation. So to start with, I'll take this file to drafting, make drawing from part, select the required paper size or template size, say it OK. And next I'm going to call here this flatten view, and we also take this side view of the flatten view, say it OK. After calling this flatten view, you just need to say scale as 1:1, as usually flatten views are being taken in 1:1 scale only, because they are going to go for laser cutting drawing also. That's why we are taking this scale here as 1:1. And for laser cutting drawing, I need to convert this drafting file to AutoCAD file so as to give it for laser cutting. Any part that is being transferred in AutoCAD should be transferred by a drawing, and it should be in scale as 1:1. We also need Weldments file there for the laser cutting at that time also. From drafting to AutoCAD conversion, the scale should be 1:1. After taking the flatten view, I'll select the tables option here. And in table, I'll select this bend table, select the required view. Now I'll change the layer of the table, select the table, and you have to change the layer here. I'll say as per standard. So now it is looking bright in color, that is in black color properly. So after that, applying the table, you can see the orientation or direction is being shown, as well as angle and inner radius are being shown. So for the direction, it is showing as downside. I'll select the view and say this view as flip view. So as soon as I say the view to flip side, now it is showing all the directions at upwards. Means all the bends are being made at the upper side with the angle of 90 degree and inner radius of 1.2. All the tags are being given A, B, C, D, and that tags are being applied to the bending lines here. The center lines or faint lines are nothing but the bending lines on which the initials are being applied. You can also show the thickness here for the flatten view. This was the bend table being given here. Same is the punch table, and punch table is only used when there are forming tools been applied. So I'll select this punch table, select the origin, take this as the origin reference, and select the face on which the forming tool is been applied. I'll select this face and then say it OK. So this punch table is been applied. I'll select as per standard, say it OK. And now you can see both the tables are been applied. This table is showing the bending and angles as well as radius, and this table will show the forming tool locations as well as the angle of orientation. It will also show the quantity here, but some of these tags are being shown in faint color. For that, I'll select all the view and change the layer to as per standard. Now everything will be shown in bright and black colors so as to recognize each and every punch. This was bend table and punch table being shown. So now we have seen in tables, general table, revision table, weld table, bend table, punch table. Now we are going to see hole table. For that, I'm going to call one part which is having multiple holes. So I'll take this part here. I'll take this part for drafting. Select the properties here, browse, say 4DI template and open. Apply changes. So now we are going to call the views for hole table. I'll select this view tab, select the front view, and with reference to front view, I'm going to take this top view also here. Click here and you have to put the scale here as 1:1. After keeping the scale as 1:1, we are going to call the table, select the table as whole table, and you need to put the origin reference. So I'll take this point as an origin. It will locate the holes, that's why we are going to put the origin reference here. And you need to show the faces on which the holes are being contained or to be shown in table. So I'll select this face and say it OK. Say it OK again. And now you can see one table is been appeared showing the holes here. So this was whole table. This was whole table. It will show all the standard cutouts been taken here with the location as well as the size. So now more two tables are been remaining here. That is bill of material and Weldment cut list table. To understand bill of material and Weldment cut list table, we are going to continue in next lecture. Till then, thank you. Hello everyone. So today we are going to see the remaining tables. That is bill of material, BOM, and the next table we are going to see here is Weldment cut list table. Both the tables are very important here. It is compulsory in many assemblies to give the reference of that two tables. That is bill of material and Weldment cut list. So to start with, I am going to take the bill of material first. For that, I have called this assembly here. So in assembly, first you need to assign the material and properties required so as to reflect them in bill of material. So to start with, I am going to individually open the part and then apply the material required and then go for the properties, filling up the properties each one by one, and then we are going to call bill of material. So first we need to fill up the properties here. So to start with, I am going to select this main body here. Select the main body, say open part. Now here you can see at model tree, material is not been specified. So I'll right click on this option and say plain carbon steel. So now the material is been specified here. I'll go and say file properties now. So to fill up the other properties, here you can see the symbol. Beside the setting symbol, you have file properties option. So you need to select the file properties option, and we are selecting this file properties option in part modeling, not in assembly. So you need to keep in mind this option is there also in assembly, but we are going to select in part modeling. So to start with, select the file properties. So I'll click on this file properties option And now in custom there are different tabs you can see here, but I am going to select custom, and in custom I am going to add the properties. So you just need to click on the second column here, then click on this drop down menu, and you can see the different properties been given by SolidWorks. These are default properties given by SolidWorks. So whatever property you want, you can select it. And after selecting the property in second column, we will jump directly to fourth column. Again, we'll do the same thing. We'll open this drop down menu and select the same kind of expression for that property. So I'll select this material here. You can see the applied material has been updated here. Next, we are going to go for weight, and as SolidWorks calculate mass only, so here the equivalent expression it is going to show mass. So I'll select on this mass, and you can see the mass is being shown here. Next property I am going to take here is total cost. Now total cost is not known by the system, so I'll manually enter it. I'll say it 1000, or it will show or reflect it in evaluated value. You can see here. Next property we are going to take here is part number. So most of the time in companies, the parts are being shown or saved in numbers only. So I'm going to take a description or part number option. So instead of part number, I'll select description here. And in description, instead of name, I'm going to put the number. Any constant series we can apply here. Say it OK. And now after applying all the four properties and then save the part. Again, we will move to assembly here. Now after updating the part, we'll go for the next part and going to continue with the same process. That is open the part, apply the required material. Again go for the file properties option and select the properties which we want. So I'll select total cost again. I'll apply the same properties which were applied for the previous part, but the number or the order we can change here. So I'm taking total cost first here. I'll put up the cost. Then we are going to go for material. Again select the equivalent property, that is material. Next we are going to go for weight. The equivalent property is mass. Next we are going to go for description, and we are going to provide one description. In actual process, in description we are going to provide the name of that part, and the part should be saved by the number, this number that is generated by company according to the parts. But instead we have done the reverse thing. In description we are showing the number, and actually while saving we have saved the name here. Say it OK. Again we'll save this part, say save part, and then next again move to assembly. We'll go for the next part here, say open, and one by one we are going to continue with the same process, that is applying the material and then going for the file properties option. Here selecting the required properties. Again select total cost. I'll put up the cost. Next we are going to go for weight. Equivalent property here is mass, and the last one is description. So I'll provide the description number here, and after putting up the same properties for this part also, I'll say it OK. We are not changing the properties here. For all parts we are going to keep same properties. Say save here and then move to assembly. Next we are going to take the shaft, open the part, but this time we are going to change or edit the list of the properties. I'll select the material option, say malleable cast iron. So after putting up the material here, the appearance has been changed, and now we are going to go for file properties and put up the properties here. So again we are going to repeat the same process, adding the material, then going for weight. Here I'll select mass. Next I am going to go for total cost. Next I am going to go for total cost, material cost. I'll say 300. And lastly description. But suppose if I want to add some customized properties in this list that are not been present in this list, then you can go for this edit list option, and in this option you can add the property you require. Now suppose I want to add one property, that is hardening process, whether each part is been given hardening process or not, or what kind of hardening process has been applied for that particular part. So I'll add here next property, that is hardening process. So after typing the name of the property, you just need to select on this add option, and that property has been added to this list. Same way you can edit the list. If you want to change the order of the properties, I'll put this hardening process at upper sides. So I'll say it move up. So you can change the order of that particular property here. I want this part number to be taken at lower side. So I'll say it move down. And suppose if I want to delete any property, then I'll select that particular property and say delete. So in this way you can add or edit the list also here. Say it OK. Again say it OK here. Now this property for that particular shaft is also been filled. I'll say it save here, and after saving all the properties, we are going to go for assembly again. So in same way, we are going to add these properties for this disc and bolt and nut also. So I am adding these properties first and again going to resume the video. Now after putting all the properties for the assembly, we are going to go for bill of material. We will shift this assembly to drafting here. So I'll select this file option. Say make drawing from assembly. Select the required paper size. I'll select this 4DI template here. Say it OK again. And now we are going to call the isometric view for that particular assembly here. So I'm going to call this view here. After placing the view, you can increase or decrease the size. I'll say it 1:2 as the scale, or you can also customize the scale. So I'll customize it. I'll say it 1:3 and then say it OK. Next, we are going to change the appearance for that particular view. I'm going to give the appearance here as shaded with edges. Next, we are going to apply balloons here. So these balloons can be applied in both ways. You can apply it manually one by one, or you can say auto balloon, by which all the parts will be designated by balloons according to the numbers we have saved them. So I'll select this balloon option here, and the order of numbering will be followed in a way we have saved or made that parts. So first I'll add this balloon here. We need to change the layer first. Say delete this balloon here, and again we are going to go for balloon. Select the part, and when you keep this arrow point on this face, it will appear as a dot here. If I want to change the style of that arrow, I'll right click on this dot and change it to arrow style as closed arrow. If I want to increase the size of that particular balloon, I'll change the size. I'll say 3 characters. If I want to change the size of the text also, then I will put off this use document font option and go for text. And here you can change the size of the text in the balloon. So I'll take it 20 here, say it OK. I'll say 2 characters only, again say it OK. Now after putting first balloon, we'll go for the second one. I'll give this shaft as second. I'll just select the parts and the balloons will appear there. It is better to keep or place the balloons at the faces only. So here all the balloons are been applied. I'll say it OK. And now as you can see, the default sizes are coming in a smaller way and the arrow type is also not coming as we have changed here. So you can go for this format painter option, and to apply the change for all the balloons, I'll go for this format painter. Select the balloons which we have made changes and then select the required balloons to be changed. You can see the size as well as the arrow type is also changing here. Say it OK. And now if you want to place these balloons in a single order or a single chain, then you can go for magnetic line option. Select the magnetic line option here. You just need to click one line here and then select the required balloons. You just need to drag the line. Automatically the line will grasp the balloons. Place it here. Say it OK. For this balloons, I am going to put one more magnetic line here. Just click and drag. It will grasp all the balloons. Say it OK. And now you can say this part has been designated with all the balloons here for individual parts. Suppose if I call this view again here, I'll update this view option as the views are not been shown. Again call the same view here. We will see the auto balloon option. So here the auto balloon option is very easy. You just need to select the auto balloon option and click on the required view to be balloon and say OK. Now here the balloons are coming automatically, but you just need to change the arrow type and size as well as the placement of the arrows. If you auto balloon the assembly, the arrows will be stuck on these edges. It will not be placed on the spaces here. You can see all the arrows are been stuck on the edges. So it may become difficult to judge for which part is this balloon been appeared here. So it is better to go for manual option only. I'll delete this view. Say yes. And now we are going to call the required table, that is bill of material. Select the bill of material option. Select the required view. It will ask you top level option, parts option or indented option. Suppose if you are having sub assemblies and then the individual parts, it is better you should go for top level only. But if you are having only parts with a single assembly, then we are going to select parts only option. And suppose you are having sub assemblies in number of quantity and then parts, then you can also go for this indented option. In indented option, first the title will be for the first assembly and then the parts for that particular assembly. Then the second sub assembly, then parts of that second sub assembly. Then the third assembly title and parts for that third assembly. So in this way, indented will display the table. So if the assembly contains multiple assemblies, it is better to go for top level or indented. But if the assembly is simple without having any sub assemblies and only parts, then it is better to go with parts only option. So I'll select this parts only option here and then say it OK. And you can see here, it will by default show this property, that is item number, part number, description and quantity. In quantity, it will show the number of parts which are being made similar in one column or row only. showing the total number. But still some properties are been remaining. So I'll add that properties. For that, I'll make this size of the table little bit optimized and then go for the other properties. So to call the other properties, when you drag on this table, you can see the blue color strip here and one black arrow has been appearing showing the direction at downward side. You just need to right click on this blue strip here and you can say insert column to right and left for the property. At which position you want, you can go for that. I'll say it on right side. As soon as you click on this direction, this property box will appear here. You just need to drop down this menu, property name, and fill up the properties which we have saved in parts. So I'll go for material first. So now it is showing material of all the parts. I will click on outside and exit the columns there. After placing the property, you just need to click outside and exit and again go for the same process. Say right click on this blue strip, say insert column to right left. Again put up the required property. I'll say total cost this time. So it is showing total cost of all the parts. Repeat the same process. Say insert column to right left and put up the required property. I'll say wait this time. And now you can see all the properties have been filled up. So if you want to place this table now, you can place this table at any position. I'll place it on this template table here. And now this bill of material has been applied here. You can see I'll change the position of these balloons here. So in this way you can apply bill of material. It is showing all the properties with total number and correct values which are been updated in properties. It is very useful table, compulsory being used, also called as BOM, BOM. Next we are going to see Weldment cut list table. For that I've called one structure. We'll open that structure here. So I've made one structure. We just need to place this in drafting. So I'm going to select this structure here and go for drafting option. First change the display style and then select file option, make drawing from part. I'll select the paper size, say OK. After selecting the paper size, if the required template has been appeared, it's OK. Or else you can change the template also here. I'll say sheet properties, browse for the sheet required or template required. I'll select this 4DI template and you can see this path here. All the templates are being saved in this path. If any company provides you ready-made template, then you need to save it on this path only. You can directly browse that templates then, say it open. Again say apply changes and now you can see this template has been applied. We'll call that table here. I'll call the isometric view of that table. If you want to change the display style, I'll select the view and change the display style here. I'll also change the scale. I'll say it 1:5 and then we are going to call the table. Select the table option and say Weldment cut list table. You just need to select on the view and the table will appear here. Say it OK. And you can see this cut list table has been updated here. I'll change the layer. It is showing very faint. So I'll select the table and I'll change this layer as per standards. Again I'll update this layer and now you can see for each particular section or part or body this table has been appeared showing the size of the tubings, cross-sectional size as well as the total length required. So when this table is to be manufactured, manufacturer will refer this table and then according to the sizes or length being shown, the structures will be taken. All the length of the structures will be cut according to this table only here. So it is very important to show this Weldment cut list table highlighting each and every individual body. So to refer these numbers, we are going to add balloons also again. So I'll say auto balloon option this time and say OK. Now these balloons are being added referring the structures with these numbers. So I'll place these arrows on the faces instead of edges. But as you see, when I place this arrow on the face, it is converted in arrow style as dot here. I'll say it OK. I'll click on this one dot and change the arrow style again and then use format painter to apply the changes for all the types. So in this way, you can update the balloons. Instead of dot, you can place it on the face and show arrows. Now you can refer these numbers for the table. But you can see here, the last row is not showing the description and length. So to put up or update the values for this description and length, we are going to open this Weldment structure and then update there. It is not showing because it is not a standard structure. Now 8 number it is showing here as this end caps. You can see here, these end caps are been applied and these end caps are not counted as a standard structure. That's why it is not been shown here as a description and length. So to put up or update that values, I'll open this part or structure here. Now you can see this cut list option it is showing here. Cut list means nothing but it is show all the individual or single bodies which are utilized to make this full structure. There are 25 items being utilized to make this structure. I'll drop down this arrow and in this arrow you can see all the standard structures being shown and here is the last part which is not shown by the properties. So I'll right click and say edit properties here Now in properties, I need to fill two properties, that is description and length. Here is the length option given. Said OK. But first we'll calculate the length of the cap. I'll select both the faces by pressing the control key continuously, and here the distance will be shown. So the normal distance, it is coming 30. So it is 30 by 30, and the thickness here is given 3 mm. So now I'm having the sizes of all the end caps here. You just need to go on this properties option in cut list, and whichever part which is not being shown by the cut list, you just need to click on that part, say properties, and fill up the description and length. So in description, I'm going to add the name as end caps. And here I'm going to add the length size or any cross-sectional size of that particular part. So now this end cap is of 30. I'll say caps lock on and then press X as a multiple sign. Caps lock off by 30 by 3. So this is length, width and thickness. Now this length and description values are also been updated. I'll say it OK. And now it is showing all the item names for the cut list. You can expand this and see the total quantities are also being shown with the lengths here. Same this table for the cut list is being shown in drafting. So cut list you can see here also in model tree, as well as you can display it in drafting also. It is very important table. So I'll save this part and move to drafting again. And here you can see this property is also been updated again. So in this way you can add the Weldment cut list table here. So these were all the tables which we needed to see in drafting. Among all this, these four tables are very important. That is general table, whole table, most important is bill of material and Weldment cut list. Other tables are also used, but rarely only. So we'll stop here and we'll continue we'll stop here today and we'll continue with adding the geometrical tolerance, datum feature, surface finish symbol, weld symbol, datum target, and other things remaining in next lecture. Till then, continue watching the 4 Dimensions Infotech channel. Continue with the playlist. You will get all the list of the lectures which are been conducted for SolidWorks, even for placements in Pune at any location, or else you can directly message us in comments. So please do like, share and subscribe. Till then, thank you. So hello everyone. Today we are going to see the remaining commands of drafting. To start with, I am going to start with the surface finish. So to start with surface finish, first we need to select the surface or feature on which we have to apply the surface finish. So I am going to select this edge, and then we are going to go for surface finish option. Here in this option you can see there are 3 basic symbols given. First one, it is showing basic, second is machining required, and third one is machining prohibited. So to understand this, I have one image. We are going to refer that image here. Now you can see in basic, surface may be produced by any method. Means here you can either use machining method, that is using of machines in which we are going to use grinding machine, milling machines, super finishing machines, super grinding machines, etc. Or else we can use the method in which the material removal will not occur. That category contains finishing processes like casting, forging, hot finishing, cold finishing, die casting, powder metallurgy, or injection molding. So either ways you can go. You can use surface finish method by removal of material, or else you can use the material removal method in which machining is prohibited or not needed. Either ways you can go if this symbol is being shown. But suppose if the symbol is shown with the line or a bar, then it is compulsory to use the method in which material is going to be removed. Such as you can see here, it is written that material removal by machining is required. The machining methods may be grinding, milling, honing, buffing, super finish grinding, etc. But in which compulsory material is going to be removed. The other method it is showing here with circle symbol, it means that material removal is prohibited. The circle in the V indicates that the surface must be produced by processes such as casting, forging, hot finishing, cold finishing, die casting, powder metallurgy or injection molding without subsequent removal of material. Means in this case material is not going to be removed, still the surface finish is going to be obtained. So these are the 3 basic symbols, that is this A symbol, the B symbol and the D symbol. Now we are going to again move to SolidWorks, and that symbols are being shown here. All the 3 symbols are being shown here. So now we will understand the layout of that symbol. First I will select the method, that is machining is required, and then you can see these 2 boxes at upper left side. These 2 boxes are representing the maximum roughness and minimum roughness required. The lower left side box is used for machining allowance. The box coming at the upper side of the line is shown for the production method or treatment, and here we are going to show the lay direction. In this box we are going to show sampling length, that how much length is to be surface finished. So to start with the surface layout, I am going to apply the maximum roughness and minimum roughness. The maximum roughness I am going to add here is that is 70 microns. The minimum roughness I am going to add here is 0.03, that is 30 microns. And the allowance here I have kept here is 100 microns. So I'll show it 0.1. Here the box above the line will show the treatment. So I am going to add the production method here. I'll say it milling process. Here I am going to show the length. Here I am going to show the length of the machining cut. I'll say it 40. As this radius of the cylinder is 20, that's why I'm taking here the length as 40, sampling length. And next I'm going to show the lay direction. It is also called as the pattern which the tool is going to make according to the surface finish operation on the surface of the part. It may be multi-directional, means the material removal will be multi-directional, or else it can be parallel, or else it can be perpendicular. So according to the production treatment, this lay direction will be decided here. I'll select multi-directional, and now you can see this complete layout is been shown on the surface which we have taken for machining. I'll say it okay. Now if you want to change the text size, you can go here, put off this use document font option, go in font. I'll say it 10, say it okay. Now this text is coming a little bit smaller here. If you want to orient this, you just need to select it, or you can orient it by the direction also. So for orientation of the symbol, angle option is also given and directions are also been shown. So in both ways we can change the orientation here. So this was surface finish option here. The next command we are going to see here is weld symbol. So to start with, I have one image. We are going to refer that image. Now these are the basic types of weld. Other than this, there are multiple types of weld which come under these 5 categories. So we will just see these 5 categories first. First one is butt weld. When two plates or two parts are being placed aside and they are joined together, that time we need to give butt joint. If two plates are kept lapped over each other, at that time the corners between the two plates can be welded by using this lap joint. The next joint is corner joint. In this case also you can see one horizontal plate is kept and one vertical plate is kept, and some clearance has been provided here to provide the weld required. So in corners you can provide the corner joint here. Next, here the orientation is just flipped here and the structure is kept in T section. That is one horizontal plate and one vertical plate, same like corner joint but flipped. This time this T joint has been provided by providing two welds on the corners on both sides. The other one is edge joint. When two plates are kept vertically with each other and they are needed to be joined from the upper or lower side at any one side, that time edge joints are placed. These plates are kept parallel to each other. These were the 5 types which are basic for the joints in weldments. Now we are going to see now we are going to see how this layout is being placed on the joints. So for that we are having this image here. Now you can see in this T joint, one is vertical plate, one is horizontal plate, and in between these two plates, one weld is being shown. Now the size of the weld is being shown. The horizontal it is 3 by 8 and vertical it is 1 by 4. This arrow is placed at the weld side, and when the arrow is placed at the weld side, the values and symbols are to be shown at the lower side of this line, this horizontal line. That's why the sizes are being shown at the lower side here, the horizontal line. And you can see the symbol is also been added, that is fillet weld. Now this weld is on the other side and the leg lengths are equal. Now this weld is on the other side. You can see here where the arrow is been placed, the weld is coming on the opposite side, not on that side. That's why when you show this symbol here, that time you need to place these values and all at the upper side of the horizontal line. Now it is saying that the weld is on the other side and the leg lengths are equal to 3 by 8 with the length is 7. So now the weld size is being shown, that is 3 by 8 on the both sides, as well as the weld length is also being shown, that is 7 mm. You can see here. The third scenario it is the weld is on the arrow side, equal leg length is 3 by 8 and intermittent weld length is 3 and pitch is 5. Now you can see here this arrow is placed at the weld side only, but the welding here is intermittent welding. That's why it is saying that the weld length is 3 mm. You can see here this weld length is 3 mm. And this pitch means center to center distance of one weld to another is 5 mm. And the cross sectional size of this weld is 3 by 8 by 3 by 8 horizontally and vertically. Next, the weld is on both the sides of the leg and the lengths are equal. So now here you can place this symbol at any side as both sides are been welded, and you can see here the size of the weld is been given, that is 3 by 8 by 3 by 8. So at the left side of the weld symbol, the value of the size is been placed. Now here these plates are kept lapping at over each other, and here it is shown the arrow The arrow is on the welded side. That's why this weld is coming on the arrow side only. And the size of the weld is 3 by 8. So these are the techniques by which we can place the layout here. This is the layout. And now we are going to shift on SolidWorks. Now I want to weld this plate, yellow plate on this green plate at this side. So I'll select the common edge first and then go for the weld symbol. First select the side or the placement where you have to put the weld and then go for the symbol. Next, I'm going to put on the arrow side. That's why I'm going to put the values at the lower side of this horizontal line. I'll select this and say fillet weld. Put up the size of the weld here. If you want to keep the weld at certain length only, then you have to put the value here. Or else, if the weld is continuous, you don't need to put the weld length there. Then one symbol is also given here, that is peripheral. If I put this symbol on, you can see one circle is being shown around the arrow. Now when this circle is being shown, it proves that weld is to be provided on all the sides of the part, means all around symbol. And now this symbol, that is field or side symbol, one flag has been appearing. It symbolizes that the weld is not to be provided at the manufacturing side, but is to be provided at the assembly side, means where the machine is to be mounted or assembly is to be done. Next, you can see one counter symbol is also given. This counter symbol represents the finish of the weld. After providing the weld, you need to finish that weld as the surface is very rough. So you can make flat weld. You can also go for convex or concave shape. So I'll provide you a flat symbol. And now this is the tail area where you can provide the message for the manufacturer if any. Suppose I need to say that this welding has been provided by gas welding. So I'll write here as gas welding. Now one note is also been provided in this tail. So this area is tail note. And this area is for the same side of the arrow where we are going to place the arrow. The weld will be provided at that side only. And if I provide the symbol on the upper side, the weld will be provided on the opposite side of the arrow. So if you want, you can add the symbol here also. I'll provide the same values here. Suppose if I want any length also, I can provide the length, the finish, and say OK. Now you can see this symbol here. This is the weld value, that is weld radius. This triangular symbol is representing the type of weld. This line is representing the flatness or counter finish we required after the weld. And this is the value of the length. This flag is presenting that the weld is to be provided not on the machine floor, but on the floor where the assembly is going to be mounted. This is the message in a tail note if you want to provide any message. Both the sides means this weld is to be done on the same side of the arrow, which represent the lower side, and the other side of the part also, which has been represented by the upper side. So this is the weld symbol, and this way you can provide the weld here. So OK and finish. Now the next command we are going to see here is datum feature. Datum features are applied before applying the geometrical tolerances. Datum features are nothing but the references which can be referred so as to put up the tolerances for GD&T. So to start with datum feature, I'll select this option here to represent the three standard planes and constrain the movement of that particular part in three directions. So here are the three basic datums we are going to provide. So the base of this part, I will select it as datum A. As you select the command, you just need to click on the edge where you want to apply the basic datum, the primary datum. So the base face is the primary datum. Second, I'll take this face as it is perpendicular to the datum A. Now you have to keep mind all the basic three datums will be perpendicular to each other. Compulsory they are going to be perpendicular. So I've taken this bottom face as datum A, side face as datum B, and now we are going to take this front face as a datum C. So I cannot put up this front face datum C in this view. So I'm going to refer this view for datum C. So I'll put up the datum here also. Just need and select the datum. Now how to utilize these datums? We are going to see geometrical tolerances here first. So these were the datum features. Now we are going to see datum targets. So to understand datum targets, I'll refer this image here. You can see one image has been shown here. Now one part is kept on a fixture plate and the supports are provided so as to make that part constrain in all three directions. So now whatever these instruments are that are being touching on this part are creating a particular datum target here. You can see this circular part is being touched to this circular rod, vertical rod, and it is being touched by the line reference. So here the datum target is line. Here also you can see this part is kept on this face and there is one pin mounted on this part. You can see here this pin is being shown. So here is the detail view of that particular pin. So this point of that pin that is touching the surface of the part is nothing but datum target of that particular point. So the datum target can be a point or a line. One more type of datum target you can see here, that is datum target of area. Now this part is rested on these two pins having the flat face area above. So where the part is rested, it is shown in detail here. You can see this blue face here, that is flat surface area. So that is datum target area. So datum targets are nothing but some of the special points in a fixture that are used to constrain the part or make the part stable on a fixture. So these are the datum targets. So here we can see datum target option has been given. So I'll select here as this datum target. So now in this part I'm considering this dowel hole as a datum target. Whatever the features placed here, that is the cylindrical shape or the cutouts that are being referred for the position from this dowel hole only. So now this dowel hole becomes the datum target as it will refer all the positions of the other features that are to be placed on the part. So I'll select this hole as a datum target. For that I'll select this option and you just need to put this icon symbol here and just place this icon outside the part area. Say OK. Now when you click on this datum target, you just need to double click and here you need to provide the reference for that datum. That is one initial that is to be provided in capital letters. So I have provided here datum as 8. So now this datum target is named as 8. Here you need to provide the additional information if you want. So we will just check the diameter of this hole. Now this hole is showing as diameter 12. So here I'll double click on this icon and then put up the value here, say 12. It will automatically take the diameter symbol here and say OK. So the dowel hole I have considered here as a datum target for the part. Datum targets are usually placed so as to constrain the parts in a fixture. These were datum features and datum targets. So for applying GD&T commands, we are going to continue in next lecture. Till then, thank you. So now to start with the next command, we are going to see the GD&T and the symbols of GD&T. How to apply GD&T as well as editing the templates. So to start with GD&T, first I am going to refer one image here. Now you can see here, these are the GD&T symbols. These are the characteristics and these are the features. So to start with, first you can see a straightness. One line has been given. It comes under the category of form. Type of control is form. So whatever the characteristics that are coming under form, such as straightness, flatness, circularity and cylindricity, they does not require any datum feature or a reference. Whereas the characteristics that are coming under profile, that is profile of line or profile of surface, they may require datums here. It is optional for them. And after profile, these three controls, that is orientation, location and runout, which are having characteristics such as perpendicularity, angularity, parallelism, symmetricity, position, concentricity, and runout type means circular runout and total runout. Each character requires datum references. So these are the symbols been given. Straightness symbol it is here, flatness, circularity and cylindricity. This arc is for profile of line. The semicircle is for profile of surface. These are the signs for orientation, perpendicularity, angularity and parallelism. And these are the types that are symmetric, positions and concentricity which comes under location. And runout, you can see this one single arrow, that is circular runout and the total runout. It is given here. Now we are going to refer one more image here. So first we are going to understand straightness. You can see here it is given that relative datum is not required. So what is straightness? So straightness is a tolerance that controls the form of a line somewhere on the surface or the feature. Axis straightness is a tolerance that controls how much curve is allowed in the part axis. There are two ways that straightness can be shown by GD&T, that is on the surface straightness as well as the axis straightness. So whenever the axis straightness is being shown, you can see here this modifier has been added, that is maximum material condition. So to understand more about maximum, minimum material conditions and all the modifiers, you can join us at 4 dimensions infotech. Now here you can see one frame has been given showing a cylindrical part, and this surface straightness is measured by a dial gauge indicator by moving the indicator from this end to the other end in a straight way. Here the axis is also been given. You can see this tolerance, this is dimensional tolerance. You can see the diameter plus minus 0.05. It is representing the dimensional tolerance. And this frame is representing the geometrical tolerance. So the main difference between geometrical tolerance and dimensional tolerance is that any tolerance that is controlling only one dimension, it is called as dimensional tolerance. And the tolerances which are applied for the complete geometry as well as dimensions, that is called as geometrical dimensioning and tolerance. In short, GD&T. After straightness, you can see here the image has been shown how the straightness has been calculated here. Next one is flatness. Here it is written that datum is not required here also. Now the flat tolerance refers to two parallel planes. You can see here these two parallel planes that define a zone where the entire reference surface must lie. So it is showing two reference planes or two imaginary planes under which the surface, even after having some waviness, is laid down. So here these two planes are representing the tolerance zone, and the distance between these two tolerance zone is 0.03. This symbol is representing the flatness, and here the arrow is showing the surface which required to be flattened. When you manufacture any part cannot be accurate or precise according to manufacturing. So to compensate the deviations, this JD&T tolerance has been applied here, showing that if the waviness occurs in the flatness, it should not exceed the tolerance zone given here. So these two parallel planes are presenting the tolerance zone. So now talking about the measurement of flatness, can be measured using the height gauge run across the surface of the part if only the reference surface is held parallel. So flatness can be measured using the height gauge. So sometimes it is asked how the flatnesses and other GD&T characters can be measured. So here it is given that it can be measured by using height gauge. Now you should have the knowledge of measuring instruments also to understand the GD&T. Means what is the least count of height gauge and how the height can be calculated by using height gauges. Now the third symbol here, it is given as circularity. It is shown that it is relative to datum. No, means datum is not required in this characteristics also. So the circularity symbol is used to describe how close is the object to be in a true circle, sometimes called as roundness. So now it is saying that a circular symbol has been used to represent this particular circularity or roundness. So you can see here on one cross section this roundness is being measured, and here this is the tolerance zone, the inner blue circle and the outer blue circle, and this curve is representing the actual surface which has been manufactured here. So one zone has been given here also, representing the roundness or cylindricity of any part. Next is cylindricity. Here also datum is not required. One part has been shown, circular part, showing the tolerance zone value or tolerance value of 0.03 with the symbol of cylindricity. Now cylindricity, there are two concentric cylinders shown here, that is these two blue circles, and the actual part is this red circle. So now the cylindricity is measured not only according to cross section but also the total surface of the cylindrical shape. So now cylindricity is referred to the part which needs to be round and straight along its axis, for example such as a sliding shaft. Here it is shown the profile of line, and the datum is optional here, but you can see in this frame the datums are also being shown. Datums are nothing but they represent the planes which are used to constrain the part, or you can say the meaning of datum is nothing but references which are used to constrain the part. So here A and B datums have been given, and here this symbol is representing the profile of line, and this is the value of tolerance zone been given here. So now you can see here these two lines are representing the tolerance zone, that is 0.03, and the actual surface is lying between these two reference lines. If this line exceed above or below these two reference lines, then you can say the profile of line is not up to the mark as we require. So this is the datum A, that is this flat surface, and the side face, that is datum B. The next is given here as profile of surface. Relative datum is still optional. Here is the frame representing the two datums, tolerance zone or tolerance value. The semicircle is the symbol of profile of surface. So here you can see a three-dimensional tolerance zone existing of two parallel surfaces that follow the counter surface, this surface, across the entire length of the surface. So now this tolerance zone is referred following the entire surface. In profile of line, it was only covering one cross section, but in profile of surface, it is covering the entire cross section. So these are the two parallel planes representing tolerance zone in which the surface must lie. When the parts are made of castings, that time the surface profile is very much used to control the amount of variations being made by the time of manufacturing. Usually CMM machine is used to measure the complete surface of the profile, and it is usually used for casting parts. Next one is angularity. Now here the datum is compulsory, you can see. Relative to datum, yes. Now in this character, two parallel planes of line which are oriented at the specified angle, you can see this angle here, and all the points of the reference surface must fall under this tolerance zone. So the points of this reference surface must lie under one tolerance zone which is around this surface, and the size of the tolerance zone is 0.03, you can see here. It is referred with this datum, that is datum A. Now the angle is being measured by this bottom flat surface, that's why it is shown as a datum here, and this surface has been measured. The angle is given and the tolerance zone is also given. So you can see the presentation here. So if the surface vary with the angle, it should vary within this tolerance zone only. You can see here these two parallel planes are representing the tolerance zone for that particular surface. Angularity is measured by using or constraining the part usually with a sine bar tilted to the reference angle so that the reference surface is now parallel to the granite slab. You can see the arrangement here. Next here it is given parallelism relative to datum. Yes, parallelism is fairly common symbol that describes the parallel orientation to one reference feature to the datum surface. So now the bottom surface is the reference surface and this box upper face, that is this red face, should be parallel to the reference surface. If the deviation occurs, it should occur within this tolerance zone that has been given here. Now this parallelism is quite simple to measure, like flatness, a gauge is run across the surface or a feature. Perpendicularity, now this is also related to datum. Now perpendicularity, when reference datum or reference surface has been given, that is referred as a datum. So the bottom surface here, that is horizontal, is a datum surface, and this side face, that is vertical face, it should come perpendicular to this datum reference. So that's why the symbol is being shown here. Now the tolerance zone is also being shown. You can see here, this figure is showing the deviation of the surface with the reference. But this deviation, if it is coming under this tolerance zone, then the surface can be considered as perpendicular to the reference surface. So these are the two parallel planes being shown here in which the surface must lie. If the deviation occurs, that must lie within this zone only. Next is position. So now you can see here, this hole has been placed on this plate, and now here one reference is given, the bottom surface as a datum A and this side right side face as a datum B. So here these two values are also referred by the two datums only. That's what these two datums are being represented in this frame, showing the tolerance zone as well as the diameter symbol. It's been shown only when in the tolerance zone it is going to be circular. In other cases, this tolerance zone was coming in between two parallel lines, but in this case, here the zone is going to be circular, and within that circular zone, the center point of this hole must lie. So that circular zone diameter is showing here as 0.03 with reference to A and B. This A and B are referred only because these values are being referred from that particular surfaces. So this is the symbol here. And it is also being shown that diameter is given with the tolerance value. So this is the dimensional tolerance and this is the geometrical tolerance. Next we are going to see here is concentricity. It is also relative to datum. Now in this backside shaft surface is referred as datum axis, and the front side shaft axis, it should come relative with this datum. So now if the front side shaft axis does not come collinear with the backside shaft axis, then you can say that concentricity has been disturbed. But if the deviation comes under this tolerance zone, that it is shown here, you can see this is the circular tolerance zone, and now here also the value will be represented by diameter symbol showing the tolerance zone, as this tolerance zone is circular. Next is symmetricity here. It is also related to datum. Now one imaginary plane coming across this cut profile in this center is being shown here. So now this two surface, that is the above surface here and the below surface, this surface, both should have equal distances from this center plane so as to apply GD&T. Means these two surfaces must be symmetric with this particular center plane, and if it deviates, means symmetricity has been applied, and if it deviates, then it should lie within the tolerance zone for the tolerance. Next is runout. Datum is required. Runout is combination of concentricity and circularity. It is essentially how much wobble occurs in the part or a feature when the reference part is been rotated. So here you can see these two shafts are being kept, and this backside shaft has been rotated, along with the front shaft is also been rotated. But if the deviations come while rotation by the backside surface of the shaft, then it is called as circular runout. Means the runout is occurring at the cross section of the shaft. That's why this is referred as datum A, and these blue circles are showing the references that are tolerance zone. It is measured using dial gauge. You can see here. This is the gauge block on which the shaft has been rotated, and this dial gauge is counting the wobble that has been occurred in the first shaft with reference to the second shaft, the back shaft. Now that last one is total runout, means it is the combination of concentricity and circularity. Total runout is how much one entire feature or surface vary with respect to the datum when the part is rotated 360 degrees around the datum axis. So now this part is rotated along the datum axis, and this complete feature, how much it varies from this datum axis, that has been measured, showing the wobble moment. And if the wobble moment occurs exceeding this tolerance zone, then we can say that this front shaft is coming with total runout with reference to the back shaft. Now you can see it is measured along the surface with this straightness as well as along the cross sections at regular intervals. So more than one or two readings are being taken here so as to measure the total runout with reference to this straightness also. So these were the symbols. Now we are going to see in SolidWorks how these are being applied. So first we will apply the datum features here. I'll take this as a datum A, the bottom face, this side face as datum B, and this face as datum C. So now datums are being applied. So now we are going to apply geometric tolerances here. So to start with, this option has been given geometric tolerance. You just need to select the surface where you want to apply the geometrical tolerance. So I will select this surface here and I need to show perpendicularity with reference to datum A. So here you need to add the value and then place this box here. It will show the geometrical symbols which are needed to be applied. So I'll apply here perpendicularity. And now this value is coming for the tolerance zone. So I'll take this as 0.2 and also add datum here. I'll say datum A only and say done. So now this option is showing to complete the command. These are the modifiers which may be required in between. You can apply the modifiers also here. I'll say done now. Now this frame is showing that this particular plate is perpendicular to the surface being shown as a datum. Next, we are going to apply positional tolerance. So for that, we are going to refer this hole here. So to start with, I'll select the geometrical tolerance, select the hole, place the box of the geometrical frame, apply the type of tolerance symbol as well as value. I'll say it's 0.02. And now this positional tolerance is usually referred by the circular tolerance zone. That's why I'm going to add diameter symbol also here. So this symbol has been added, you can see here. After that, I'm going to refer the datum. So for datum, you can see here. If I want to place this hole's position, then I will refer the position by giving dimension from this vertical side, this side, taking the reference of datum C here. And next I'm going to show the dimension by the side of this space, representing the horizontal dimension. So for vertical dimension, I'm going to refer datum C. And for a horizontal dimension, I'm going to refer datum B. So for that only, we need to add here two datums. So we will go here and say first datum as C and the other one as B. So to add other one, I need to click on this add new symbol and here you can say the other datum as B. It should come in capital always, and then if you need it, you can add modifiers also here. I'll say done. So in this way, you can apply the GD&T symbols. Now I want to show this inner circle is concentric with the outer circle. So I'm going to take this reference of the outer circle. That's why I need to apply one datum here. So I'll select the datum feature and I'll say this as a datum D. To add GD&T, I'll select this option, place the frame, go for the symbol, I'll say concentricity, apply the value for the tolerance. Now the tolerance zone for concentricity is always circular, that's why I'm going to add the diameter symbol also here. Now add the datum symbol. So I'll say it as a datum D. It is because we are going to refer this circle as a reference datum. That's why we are adding D here, as it was named D. So say done after completing. So in this way we can add GD&T symbols in SolidWorks. Hello everyone, so today we are going to continue the last lecture of drafting, in which we are going to see how to edit the templates or how to customize the templates. So to start with, I'm going to select the drawing tab here, say it OK. And now when you select that tab, you can see one more chart is appearing here. So in this chart you can see all the template sizes are been given, A0, A1, A2, A3 and A4. And the sizes of that particular templates have been highlighted here. You can see this one, A3 size 420 by 297. Suppose I say OK to this template, A3 size, and now this SolidWorks default template has been appearing here. Suppose if I want to edit this template or edit the table inside the template and then save the sheet format. So how to start with doing that? We are going to see that point. So to start editing, I'm going to right click on this sheet and here you have edit sheet format. So I'm going to select this tab here and now you can see you can edit the table here. Now the table lines are being showing in blue color, but as you exit here, these lines are being shown in gray color. So first we are going to make a layer to show the table lines. So I'll again right click, say edit sheet format, and now we are going to create the layer. Select the layer options. I'll add this name here as table only. Then we are going to go for the color option. I'll select this color here. Here I'm going to change the thickness also, as this table line thickness is more. So I'm going to take here 0.5 as a thickness and say it OK. Now you have to select on the sketch tab select the line command, and we are going to draw the lines here. Suppose I have drawn this line. If I want to continue these lines to make these cells, then I'll select the extend feature here. You just need to click on the lines and they will be extended further till the boundary line. Next, we are going to add the text here. I'll select this note option in annotation. We are going to write the text we require. Now, if you want to edit this text, you just need to double click. Suppose if I want to change the size here, say it bold, and now you can place the text here in the cell. I'll decrease the size here again, and now this text has been placed here. Next, I'm going to exit this sketch, and you can see this table or the cells are been added in the continuity of the previous table. And the color, you can see the table color lines are being shown in gray color. That's why we have taken the layer also with the same color, so as to match the layer of the table after exiting the table editing. So in this way you can edit the tables here. Again, I'll right click and say edit sheet format. Suppose if I want to edit the title text here, I'll double click on this and I'll write the text I require. We also sometimes need to write who has drawn the drawing, who has checked the drawing, and who has given the approval of the drawing. Manufacturer and quality checker also. So here I'll double click on this cell and I'm going to add the name here. So in this way you can update the table. Again, say exit sketch. This has been updated. Now after exiting the table editing format, if I double click on the text, I cannot change it here. We just can call the views here and put up the dimensions and start drafting. But if you want to edit the table again, you again need to right click on the sheet and say edit sheet format. And in this zone only you can edit the table or edit the text you require. Now if I want to edit this border, you can see here the offset distance from one side of the border is larger as compared to the other sides. So for that I'm going to right click again on the template and say automatic border. I just need to click on this arrow here, select this arrow as a next, and then you can see the marginal distance, it is shown as 20 from the left side. You can see, and here it is shown 10 at the right side, 10 mm from the top side and 10 mm from the bottom side. So I'll update it and say 5 on all sides. You just need to update the values and then say it OK. Now these borders are coming 5 mm from the main boundary, but still you can see this table is now not connecting to the borders. So I'll again use the extend command here. I'll say extend, and we are going to extend the lines here to match the offset of the border. So in this way, you can edit the borders also here. There are more options given in that. Suppose I want to say again automatic border again. Next, click the arrow, and now there are options given such as double line border. That's why it is showing double line. If I put off this option, then it will show only a single line. If I put on the option again, it will show the double border. Suppose if I want to change the size of the zone border or zone dividers, you can change the or update the value here. I'll say 3 mm. So now this gap is coming 3 mm. I'll say it 5. So it is coming as 5. Now the zone dividers you can see here. These are the zone dividers. I'll say 3 mm. I'll set this one as 7 mm. So now the lower value here it is coming for this line, and the upper value it is coming for this zone dividers. This one, these lines. If you want to change the size of the document font, the sizes, you can also update the document font sizes here. This one showing or representing each border cell here. So if you want to update that, just go to font option, put off this option first and then go to font. Here you can change or update the value. I'll say 12 only. So now this text size is being changed. Then say it OK again. And now after completing all the format, you can go and save this format here. So to save this format and use it again and again, you just need to go for file options, and here you will get the option as save sheet format. I'll select this option here, and in this route you can see this route is being shown. If I backspace, you can see. So in C, program data, SolidWorks 22, and you can move further here by the cursor. In that 22 you have language English, and the last format here is sheet format. So in this folder you need to save this template. So this route is being shown here at the upper side. If you want to save this template on this route, you can go and directly save this template here. But usually if you are doing project for any company, that company will provide you the template required. I'll save this. I'll put up the name first. I'll say it at 4DI. Save this sheet format here and then exit the sheet format. So now whenever if I want to call any part, I can use this template. I don't need to repeat the editing of the template again and again. So here if I want to call a new file here, I'll say new, say drawing and OK. Now, when you go for this sheet format size option, select this browse, and here you have 4DI 24 template, which we have just now customized. So I'll select this template, say open, say OK. Now that same template which we have edited will again appear here. You can use it as many times as you want. Next, we are going to see the file formats. I'm going to open one part first. I'll change the background display. Now, if I want to save this part, now you can see this part is been made by SolidWorks only. These are the features which have been shown while making the part, which we have utilized to make this. Now, if I save this file again, by changing its format, you can change the format while saving the file. Many times you require step file. So if you want to save this format as a step file, you just need to go save as, and then select the save as type here. I'll repeat this again. Select the file option, say save as, and here you need to change the save as type. I'll select this and go and say as step AP214. You can also use 203. These are nothing but two formats of step files only. This is the older version and this one is the newer version. So I'll select this 214. If you want to change the part name, you can change it here. I'll say it's step file, and you need to show the location where you want to save this file as a step. So I'll save it on desktop and say save. Now this file is been saved as a step file also in desktop. So we will open that file and see the difference. You can see when it was in part molding or is a part in a sheet metal, you can see all the features are been shown in that. But when we open this step file now, I'll say open and go to desktop, and on desktop I'll find the file here. You can see this is the step file. I'll say open. So now this step file has been opening here, hydraulic cylinder step file. It will ask you for diagnose. I'll say no. So what is the difference between this step file? You can see it will be shown as a combined body having 21 multi-bodies. These are each bodies which are being shown. You can click and see the bodies, but we cannot edit the features here. So in step files, features are not being shown, only the bodies are being shown. This is the main difference between part molding file and step file. So we cannot edit the file or edit the features of any file. Suppose if you want to forward this file and show the part only, you don't wish to show the features which we have used for making this file, then you can go for step file. And one more advantage of this step file is you can edit this step file in Solid Edge, CATIA or any 3D software. It is compatible to all software files. That's why many times we save the part in step file so that we can utilize in other softwares also like CATIA, Solid Edge, Creo. We can call it directly and use it for the assembly, but we cannot edit that features there. That is the disadvantage of step file. In here I will say I want to save this file as IGS file. So IGS file is also same. I'll say it on desktop, and instead I'll change the name here. I'll say it IGES file and then save this file. Now if I want to open that IGS file, I'll say open, and on desktop you can see here is the IGS file, and this file will be shown as a blank sheet format here. I'll just say open it. It is same as step file only. These files can also be opened in any software, any 3D softwares. Mostly step files, there are not bodies. Here also you can see this body, this complete hydraulic cylinder body is converted into surfaces, and there are total 42 surface bodies here. So in IGS files, your part will be converted into different surfaces instead of bodies. In step file it was bodies, and in IGS file they are surfaces. So this is the major difference. We can also open it in CATIA surfaces and all and utilize it in assemblies where required, but we cannot modify them as a feature. Again, we are going to save this file as an image file now. So for that I'm going to say file, save as, and here I'm going to select format as JPG format, JPEG. At downside of IGS only, you can see here, and then save it as JPG file on desktop. So now this file will be saved as an image only. If I want to change this angle, if I want to show the front view, I'll select, position it normal here. Again I'll say file, save as JPG, select the JPG format first. I'll say to save it as a second file here. And now I'll minimize this SolidWorks, and you can see here these files are being saved as a image first. And now I'll open this file. The format I've saved as JPG. This hydraulic cylinder JPG format file is been opened, and it is saved as an image only. I've taken this image also. So this is the second file of the image as a JPG format. So you can save these files here as a JPG format, step format, IGS format, and any format you require. If I want to take this file to AutoCAD also, I can go for that option also here. I'll place it in isometric view first and then save as. I'll change the format here and save it as DWG file. I'll save it on desktop only. So this were the file formats. And here we end the SolidWorks portion. So please do like, share and subscribe. And for more learning, follow the playlist of SolidWorks. Next software we are going to record here is Solid Edge. We are going to start Solid Edge recording also in some days. Till then, thank you.